Hello, hello. Yes. Hello, everyone, guys. Welcome on YourPedia platform. Yes, good afternoon, all of you guys. And yes, guys, we are discussing important question through this NPTEL assignment series. And in today's session, we are going to discuss 100 best 100 important question from heat transfer. Guys, these questions are very good, very beautiful because these are made by IIT professor for their NPTEL courses. So we picked those. We are picking those NPTEL assignments only, and from those NPTEL assignments, we are picking best questions for this GATE module, GATE course, and we are solving all those questions, guys. So today's session is going to be very, very important for you because every single concept, every different type of question, guys, we are going to discuss from convection heat transfer, radiation, and heat exchanger. Convection ke bacho, you are definitely, I'm very sure, 100% I'm sure, definitely you are going to enjoy this session, and you will find lots of concepts, beautiful concepts in this session, and you will be able to recall some of the concepts, and yes, some of the new concepts also you are going to find. Radiation may also, guys, I found very different question. Like generally we skip those parts, but yes, daily basis, like if you will check the gate scenario in the year 2001 and 2002 to 2021, there are huge changes, guys. Every year they are trying to incorporate into what new questions. Okay, so that and those NPTEL assignments, they can work as a what basis for us, and we can predict something. Like there can be some changes, like there can be some new questions which those professors can frame in the upcoming gate examination. Okay, so all those different type of question, guys, we are going to discuss. Okay, I hope you all got that workbook. So that workbook already we have shared. If you are not having, it's my request to all of you guys, please go to our website and download that workbook so that quickly you will be able to read that question and you will have sufficient time to answer that question. Okay, so guys, let's start because this session is going to be huge, lamba hone wala hai. And I will try to cover this entire 100 questions in a period of duration of 5 hour, 5 to 6 hour. We will complete. Okay, because now we are having some experience, like thermodynamics class we conducted, and yes, now we are having some experience ki how to cover those 100 questions in that period of 4 to 5 6 hours. Okay, so I will try to cover in a minimum duration. So let's start our discussion, guys. Once again, welcome you all and thank you very much for sparing your time. So let's start our discussion, guys. Let me put it here, the question number 1 in front of you. Okay, so this is question number 1 in front of you. Please read this, and then I'm also going to discuss with you. Chaliye. So this is the question, guys. This is a question in front of you. Yes. Chaliye. So guys, let me discuss this. We are going to start with this very simple first question. This is very important concept we are going to discuss through this question. Convection. First 35 question we are going to have from convection. Next 35 from heat exchanger, and last 35 question we will have from radiation. So total 105 question we are going to discuss. So guys, there is a flat plate of width 1 meter is maintained at a uniform temperature of 150 degrees Celsius by using independently controlled heat generation rectangular modules of thickness 10 mm and width 50 mm. Okay, so this is thickness, and this is width of those module. Okay, which are actually generating the heat to maintain some kind of hot surface temperature. Okay, so each module is insulated from its neighbor as well as from its backside. Atmospheric air at 25 degrees Celsius flows over the flat plate at a velocity of 30 meter per second. What is the required power generation? What is the required power generation by that module at a distance of 700 mm from the leading edge? Also find out the maximum temperature in the heat generating module. Guys, if you read this question, you will find it very difficult. Okay, lots of the student, majority of the students, they are going to find out this very difficult. Okay, why? Because some lengthy data is there. Okay, and lots of things are there which are actually confusing us. Like plate case we discussed, convection is there, but what is saying, there is a plate, and in plate there are some heat generating module, and actually this is a real case, because in real case we generally incorporate some kind of module in our plate. So suppose this is our plate, ye hamara koi plate hai, and in this plate we incorporated some module. इसमें हमने कुछ मॉड्यूल लगा दिए. Okay, इसमें हमने क्या लगाया है बच्चों? कुछ मॉड्यूल लगाए हैं which are generating the power. Okay, because we want to maintain some hot surface temperature. Okay, those modules are generating the power. So there are two questions he's asking you. First, what is the heat generated by module at a distance of 700 mm from the leading edge? Okay, at a distance of 700 mm from the leading edge. This is first part. And in second part he is asking you what is the module maximum temperature. ये जो module है, इस module में, okay, what is the maximum temperature in this module? Okay, this module, what is the maximum temperature? Okay, so this is actually a combined question. You need to apply your basic conduction concepts also. So it's a combination of what? Combination of convection, conduction. Okay, so let me give you some idea, because guys, that idea is required for this question. At least remaining question, like you will be able to apply your mind and you will be able to answer. So guys, what you need to understand in this question, if you want to find out here what is the heat generation by this module, so what you can say, in steady state, okay, in steady state, whatever heat is generating, that is equal to Q convected. Yes or no? The rate of heat convection, that is equal to heat generation at a distance of what? 700 mm. So indirectly he is asking you to find out the rate of heat convection at a distance of 700 mm from the leading edge. Are you getting the idea? And how you can find out the convection heat transfer at a distance of 700 from the leading edge? So for that, you can apply Newton's law of cooling. You can apply Newton's law of cooling. Q convection equal to HA delta T. Okay, where H is what? H is your convection heat transfer coefficient at a distance 700 mm from the leading edge. Guys, you need to understand that. You want to find out rate of heat transfer at a distance of what? 700 from the leading edge. So from that module, you need to find out Q convection, H what? H, you can write it as HX, because local convection heat transfer coefficient at a distance of 700 mm from the leading edge, and that easily we can find out because all those relationships are given to us. Okay, area is what? A is the area of the module, surface area of the module, and delta T is the temperature difference. We are maintaining some constant surface temperature, so for that module some constant surface temperature is given to us. So this is module surface temperature. This is module surface temperature, that is known to us. Okay, that is known, given to us. So from that we will have delta T. So indirectly, first you need to find out the convection heat transfer coefficient at a distance 700 mm from the leading edge. So guys, pick up your pen, pick up your notebooks, and try to solve this question. Now I have provided you the hint. So this is the equation, guys. This is the entire data which is given to you. Now he has given you, like, this is the relationship which you can use. And guys, in GATE, what is the in GATE, guys, for convection problem, you need not to worry, because he is going to give you every single data. Yes, he's going to give you every single data. How, like, what correlation you need to use, okay, for laminar flow, turbulent flow. So if you're having some basic understanding, then easily you will be able to answer all convection questions. So he has given you some relationship, Nusselt number equal to hx by x by k, and this is the relationship, guys. So first, from the data which is given to us, you need to find out Reynolds number, you need to find out Prandtl number, and putting those Reynolds number and Prandtl number here, X is what? X क्या हो जाएगा बच्चों? X is 700 mm from the leading edge. We want to find out HX. हमें क्या निकालना है बच्चों? HX. HX means local convection heat transfer coefficient at a distance 700 mm from the leading edge. So now can you tell me what HX value you are getting, guys? Remaining all is a calculation, and I hope you don't want like to from me to carry out that calculation. So I hope you all are having your calculator, your tools with you, because those are required. So please use your calculator and try to find out HX value at a distance 700 mm from the leading edge. Yes, I'm waiting from for your response, guys. Please try to answer. Time is very important, time is very precious for us. आज एक लंबा सेशन जाने वाला है बच्चों, so please keep patient. बहुत अच्छे क्वेश्चन करने वाले हम, so please be patient and try each and every question, because if you will sit idle, guys, you will not be able to explore, and you will not be able to grow. If you will attend each and every session, and if you will apply your mind and you will try, then even if you are getting the answer, if you are not getting the answer, that doesn't matter, but you need to try each and every question. So please try and answer. Abhinav is saying 70.181. So let me check and let me tell you very right, exact. So how many of you are getting H value in the range of 70 point? I got the value 70.26. So if you are getting in the range of this watt per meter square Kelvin, that is very right. So please tell me guys, how many of you got the answer hx in this range? Because after finding out that h value only, we will be able to proceed further. Yes guys. So now can you tell me q value? How many of you are getting the q value guys? How many of you are getting the q value? So hx we know. What is q? What is q guys? Q is, by Newton's law of cooling, we know this is HA delta T. This is HA delta T. So what is H? H we got in the range of 70.26. What is area? Guys, for module, for a single module, because we are treating a module, we are considering a module at a distance of 700 mm from the leading edge. So what is area of that module guys? So from this data which is given to us, what is this? What is this guys? The module, the plate is of 1 meter. Plate कितने का है? 1 meter length. Plate का length कितना है? 1 meter. The module is of 10 mm thickness. Okay, and length 50 mm. Okay, the length of each module is 50 mm. Okay, length of each module is 50 mm. Yes or no guys? Now what is the width? Width क्या लोगे आप? Because this module is something like this. This is a plate, something like this. This is the plate, and in this plate, like these buttons, you can consider as the module. Okay, these buttons, guys, there are different buttons on this remote, and you can consider those buttons as a what? Module. Power heat generating module. So I'm considering a module at a distance of 700 mm from the leading edge. And what is the area of that module guys? So that area will be what? 50 mm, because thickness will not be there. Thickness will go into what? Depth. Thickness kahan pe jayega? Depth mein. So that module is having some thickness. This thickness is 10 mm, and this is not required this time. This thickness of the module is 10 mm. Okay, but this is not required this time because we are interested in area. So area, we can write it as 50 into 1 into 10 to the power minus 3. This is the area. This is the area of the module, one module. Okay, we are considering one module only because we want to find out heat transfer at a distance 700 mm from the leading edge. What is delta T guys? What is the module temperature? Module temperature we are maintaining in the range of 150. Surface temperature of the module we are maintaining 150, and the air temperature is 25 degrees Celsius. So what is temperature difference? What is the temperature difference guys? The temperature difference is 150 minus 25. The temperature difference is 125. So how many of you are getting heat? Convection heat transfer. Convection heat transfer at a distance 700 mm from the leading edge. Yes, please try to answer guys. How many of you got the answer for Q? Yes. So if you solve this, you will get this idea. 439.155 watts. Okay, this is Q convection you are going to get. This is Q convection you are going to get. Q convection equal to 439.155 watts. Yes, very good. Now the question is very easy because you want to find out heat generation, and this is Q convection you are having. So very simple case you can apply here. Sir, we know this very basic. We know this from our basic understanding. Sir, Q convection in steady state, Q convection is equal to Q generation. Okay, Q convection equal to Q generation. Whatever heat is generating, that is equal to Q convection. But he is asking you the volumetric heat generation per unit volume. So means if you want to find out this heat generation per unit volume, तो आपको क्या करना पड़ेगा? When you will be able to equate this? So Q convection equal to Q dot G. This is the heat generation, volumetric heat generation in one module, guys. This is volumetric heat generation in one module. So you need to multiply it with volume of the module. Okay, from this, very simply, you will get the heat generation in the module. What is the volume of module, guys? For that also, you can easily write volume of module is equal to thickness. What is the thickness? 10 mm. 10 into 10 to the power minus 3. What is the length? Length is 50 mm. Okay, 15 to 10 to the power minus 3. What is the width? Width I'm considering it as 1 because for the plate and for the module, the width I'm considering it as 1. So from this, you will get a volume of the module. Okay, and this is convection. Already we got. Now tell me, how many of you are getting this answer? कौन सा आंसर आ रहा है इसका? D. How many of you are getting answer D, guys? Please tell me. Very simple question. Initially, it is looking like very difficult, but it is very easy. I'm getting D option. Abhinav, very good. Abhinav का answer सबसे पहले आया है. Very good, Abhinav. So the question is very easy. Only you need to understand what he want to say. Like in every single question, guys, first you need to analyze the data. Data analyzing is very important, because if you'll analyze the data, easily you will be able to understand what he is asking you. And if you are able to get that idea what he's asking you, then the question will become halwa for you, and easily you will be able to solve that. So I hope all of you are getting the D answer, because the right answer for this question is what? D is the right answer. D is the right answer. Now this is also very important for us, because ये भी हमें निकालना पड़ेगा. Let me check कि ये option same तो नहीं है. Okay, in this case the options are not matching, so we can answer option D. But this is very important, because ये भी अपने को आना चाहिए निकालना, because in heat transfer we need to know each and every concept. Now can you think, guys, how you can find out this temperature? मॉड्यूल के अंदर मैक्सिमम टेम्परेचर कैसे निकाल सकते हो? सो आई एम गोइंग टू अगेन प्रोवाइड यू सम हिंट सो दैट यू विल बी एबल टू आंसर दिस क्वेश्चन. सो गाइस, दिस इज ए मॉड्यूल. मॉड्यूल इज समथिंग लाइक दिस. This is a module. Okay, so module is something like this. This is our module. Okay, power generating module, and this module is having thickness 10 mm. Module का thickness कितना है बच्चों? 10 mm. Okay, and the module surface temperature is 150 degrees Celsius. So this is kind of T wall or T surface. This is for the module T wall or T surface. We know the Q dot G also. Q dot G also we calculated. ये हमने calculate कर लिया है. Okay, what we want to find out? We want to find out maximum temperature in this module. So can you tell me where, at which point you are going to get the maximum temperature? Maximum temperature कहाँ पे मिलेगा? Again, I am putting this question in front of you. Can you think, guys, where you are going to get the maximum temperature? So one point is very, very important for us. What is that? All power generating module are insulated from the backside. Power generating module are insulated from the backside. Are you getting some idea, guys? Each module is insulated, like the module which you are having, those are insulated from the backside. And if you are having module insulated from the backside, so where you are going to get the maximum temperature, guys? The maximum temperature also you are going to get at the insulated surface, because at this temperature, at this surface, del T by what? Suppose this direction is y. आप लिख सकते हो del T by del y या del T by del x लिख लो, because generally we use x only. Del T by del x, this is equal to 0. Okay, I'm writing this as x direction, because this is the insulating surface, and at this insulating surface there is, like, the surface is insulated, there is no heat transfer, there is no convection, so there is no conduction also. So at this surface del T by del x will be 0. This is the condition which we are having, and then easily you can find out the temperature at this surface. So the temperature profile will be something like this. Temperature profile will be something like this, and we are interested in finding out this TO. Now can you find out, guys? Again, I'm providing you hint. क्या निकाल सकते हो? Can you find out this temperature? Very easily you can find out. So guys, if you apply your very simple equation, steady state one dimensional heat conduction with heat generation. Steady state one dimensional heat conduction with heat generation. Steady state hai? So this is the equation, guys. I hope like you are not going to ask me, sir, from where you are writing this equation. This is conduction equation, one dimensional conduction equation with heat generation, but the case is what? Steady state. So this equation you will have. So this equation, after simplification, you can write it something like this: del 2t by del x square equal to minus q dot g by k. If you will integrate this equation, guys, अगर हम इस equation को integrate कर दे, you can write this equation as del t by del x equal to minus q dot g x by k. Okay, plus c1. Plus c1, this is the equation you are going to get. Further, if you will integrate, अगर आप इसको दोबारा से अगर आप इसको करते हैं, तो what you are going to get? You will get T temperature equal to minus q dot g into x square by 2k plus c1x plus c2. This is the equation, guys, which is very, very important for us. Directly also you can use this equation. If you remember the concept, then also you can use this equation directly. Okay, now what is the case, guys? What is the case? Like suppose this is the module, and as I mentioned, I'm considering this as x direction. मैंने इस direction को क्या मान रहा हूँ? मैं x मान रहा हूँ. Okay, so what is the temperature at x equal to 0? What boundary condition we are having? At x equal to 0, the temperature is what? The temperature is TO. This is the first boundary condition, and this is unknown to us because we are interested in finding out this TO only. This is unknown for us. Okay, this is first case. Second boundary condition, at x equal to 10 mm. At x equal to 10 mm, temperature T equal to 150 degrees Celsius. These are the two boundary conditions we are having, and if you'll use these boundary condition, guys, put it here. So if x equal to 0, guys, this will become 0, this will become 0. So we can say TO equal to C2. Yes or no? The maximum temperature equal to C2 Okay, so now can you find out C2 value? Very easily you can find out. kahan se nikaloge? You need to put it here. देखो in this equation del t by del x is 0 at x equal to 0 guys. This is 0 at x equal to 0. So this is 0. This is 0. Del t by del x is 0 at x equal to 0. Why? Because the module bottom surface is insulated, and as we know the bottom surface is insulated, so del t by del x at the bottom is 0. So this is 0 at x equal to 0. This is 0. It means definitely C1 is also 0. Okay, yes or no? So from this we can conclude C1 equal to 0. Yes or no? Yes. So two important conclusion we derived. First, C1 equal to 0. Second, C2 equal to TO. Okay. Now if you'll put here the values at x equal to 10 mm, so temperature T equal to 150, temperature T equal to 150 at x equal to 10 mm minus Q dot G into 10 mm, 10 into 10 की power minus 3 whole square डिवाइड बाय 2k. अब यहां पे कंडक्टिविटी किसका लिखना पड़ेगा बच्चों? कंडक्टिविटी ऑफ मॉड्यूल. देखो यहां पे दो कंडक्टिविटी दिया है बच्चों. इन दिस डेटा देयर आर टू कंडक्टिविटीज गिवन टू अस. There are two conductivities given. Okay, one is the conductivity of the module material. This is the conductivity of the module guys. Okay, these are the conductivities of the air. Okay, so when we solved that problem, like when we solved calculated the Nusselt number, we used this conductivity. But now we need to use conductivity of the module. Okay, so if you put it here, all those values, सारी वैल्यूज अगर आप यहां पुट करोगे बच्चों, बिकॉज ऑल दीज थिंग्स आर गिवन टू अस. दिस वी ऑलरेडी कैलकुलेटेड, ये तो हम कैलकुलेट कर चुके हैं. दिस इज आल्सो गिवन टू अस एंड दिस इज इक्वल टू C2. व्हाई? Because C1 is 0. Okay, now how many of you are getting the C2 value? Because C2 is nothing but TO and this is nothing but T max. Now can you tell me guys how many of you are getting the answer? Please try to answer guys. How many of you are getting the answer? आज किसका हैप्पी बर्थडे? IIT दिल्ली सेइंग हैप्पी बर्थडे. हैप्पी बर्थडे डियर. किसका बर्थडे आज? आईटी दिल्ली का. ग्रेट. चलिए गाइस, इट्स गुड टू वॉच, यू आर एंजॉयिंग. चलिए फाइन. सो आई होप गाइस यू ऑल आर गेटिंग दिस आंसर. बिल्कुल अच्छा क्वेश्चन था, बहुत डिफरेंट जबरदस्त क्वेश्चन था ये. तो मेरे ख्याल से यू आर गेटिंग आंसर दिस 431.4 केल्विन. चलिए, आई एम वेटिंग फॉर 100. चलिए, आज लग रहा है 100 हो जाएगा दोबारा, है ना? चलिए, सो ट्राई टू आंसर गाइस. How many of you got the answer? Yes, 431.4. So again, all the students guys who actually joined late, it's my request to all of you guys, please go to our website, download this workbook so that you will, because each and every time I cannot put that data in front of you. Okay, so if you're having that workbook, because these questions are lengthy, then easily you will be able to analyze the data and you will able to solve with me. Yes, चंदन कह रहा है बहुत अच्छा क्वेश्चन था. चलिए, वेरी गुड चंदन, अच्छा लगा सुन के. चंदन इसको सोल्व कर पाए हैं, बाकी बच्चे भी शायद इसको सोल्व कर पाए होंगे. तो क्वेश्चन बहुत आसान था बच्चों. एंड यस, सेकंड क्वेश्चन आल्सो सिमिलर लाइक दिस ओनली. एंड यस, यू विल बी एबल टू अगेन अप्लाई योर माइंड. तो बहुत अच्छा क्वेश्चन है. अगेन इट्स अ काइंड ऑफ कंबाइंड क्वेश्चन. फिन का और कन्वेक्शन, both concepts you need to apply. Like in first question we applied our concept related to conduction, like heat generation and convection, and now he's asking you some question. बहुत अच्छा question है guys. In this module it is not like that कि all questions are like this. In GATE also you're not going to find out each and every question lengthy or difficult. So in these 100 questions also, some questions are like direct question, like you will read the question and in seconds you will be able to answer. So some questions are like that. Some questions are like if you know the formula, you will use that direct formula, you will carry out the calculation, and in a minute you will get the answer. So some are question you will be able to solve in second, some required some time 1 minute, and some are like they are going to take some kind of 10 minutes or more than that. Okay, so different type of question we are going to discuss. So be motivated, be happy. Don't think sir these are very difficult question and I'm not trying to cover those type of question in my GATE upcoming examination. Don't think it like that, because multiple concepts are there, and those multiple concepts, they are directly indirectly they are going to help you. So if you are sincerely preparing for GATE, so definitely they are going to help you. So please attend and enjoy this session. Air at 27 degrees Celsius and a velocity 5 meters per second passes over a small region AS 20 into 20 mm on a large surface which is maintained at this. So surface temperature is given to us, and this is the heat removed from the surface. So Q is also given to us. Okay, heat removed from the surface. Heat removed from the surface 0.5 watts. Okay, now he is saying as TO is the heat AS removed from the surface AS. Okay, to increase the heat removal rate, ये तो पहले केस था बच्चों, when there is no such fin attached. Okay, the heat removal is 0.5 volts. Okay, but to increase the heat transfer, we attached some stainless steel fins, pin fin. It is a kind of fin which is having circular cross section. Okay, you know pin fin, kind of circular cross section you are going to have. Diameter 5 mm affixed to the AS, which is assumed to at a surface temperature 127 degrees Celsius. So this data is very, very important. The surface temperature is also 127 and the fin is also at the same temperature. Fin, surface, both are at the same temperature. It means we are considering a fin of what, like very high performance, very good efficiency. Okay, why? Because 100% efficiency, what you can say, because we are assuming Q actual equal to Q maximum you are going to have. Why? Because the surface temperature of the fin is at a root temperature. So both are at same temperature 127 degrees Celsius. What is the maximum possible heat transfer? Okay, तो आपको Q निकालना है, Q with fin. You need to find out Q with fin. Okay, but which one? Q with fin maximum, because the entire fin is at root temperature only. So now, can you solve this problem, guys? I'm putting this problem in front of you. So let me give you the hint. Hint क्या है बच्चों? In this question, Q from fin, Q fin. If you will consider, because there is no such length given, fin के लिए कोई length given नहीं है, so we can consider this fin as an infinite long fin. So if you will consider fin as an infinite long fin, Q from the fin is nothing but under root HP Ka theta naught. Okay, and what is theta naught, guys? Can I write theta naught as 127 minus the 27? Yes or no? Can I write this as this? Because this is theta naught. This is a maximum temperature difference. The fin is at temperature 127 and the air is at a temperature 27 degrees Celsius. So the entire question is very easy, very simple. If you are able to find out H, तो पहले आपको H निकालना पड़ेगा, because H is not given to you. Okay, but what he has given you? He has given you some relationship. Okay, this is the relationship which is given to you for the H value. Okay, he's saying that for these conditions, use this relationship for the average convection heat transfer coefficient, H equal to K by D, where K is the conductivity of the air fluid, D is the characteristic dimension. Okay, for fin, what will be the characteristic dimension, guys? Fin के लिए characteristic dimension क्या हो जाएगा? This D is not the diameter, but it is a diameter only. Why? Because if this is the surface, ये कोई surface है, and on this surface you attached some fin, something like this. इसके ऊपर आपने fin attach कर दिया. Okay, so this is the fin you attached over this surface. So air is flowing, air इसके ऊपर flow कर रही है, यहाँ से यहाँ air is flowing. So if air is flowing over this field, over this fin, so what is the characteristic dimension इस case में? It is something like this, cylinder. So there is some cylinder and air is passing through the cylinder. Air is not flowing along its length. Air is flowing across its length. And when the flow is across the cylinder, the diameter of the cylinder is the characteristic dimension. You need to get the idea. But if the flow is along the length of the cylinder, then along what external flow? I'm talking about external flow, guys. For internal flow in the pipe, always the diameter is the diameter for the pipe is your characteristic dimension. But I'm talking about external flow, because in fins the flow is not internal, the flow is external only. And for the external flow, the diameter of the fin is your characteristic dimension. Diameter of the fin is your characteristic dimension, and that is given to us. ये अपने को given है. Okay, so I hope you are able to solve this. K is given to us from this data. If you will check, K is given to us. Okay, diameter is given to us. The fin is of this diameter, 5 mm diameter. Okay, Reynolds number easily you will be able to calculate if you will apply your mind. Basic relationship for the Reynolds number, you will use Reynolds number equal to Vd by nu. Okay, where V is the velocity of the fluid, and is it given to us, guys? Please check velocity of the fluid. Okay, air at a velocity 5 meter per second. Air is flowing at a velocity 5 meter per second. Easily you will be able to calculate the Reynolds number, and then if you will solve this, you will get the H value. Now can you tell me what H value you are getting, guys? What H value you are getting? What H value you are getting, guys? Please try to answer. Yes, how many of you are getting the H value? The data is in front of you. Please try and answer what H value you are getting. Reynolds number will come out 1195. If you will use this data, you will get Reynolds number 1195. Okay, 1195.028. Okay, these are Reynolds number value you are going to get. H value will come out 98.85. Very exact right answer you are getting, guys. H will come out 98.85. Now can you put this value and can you tell me what heat transfer you are getting with the fin? What is the heat transfer you are getting with fin, guys? Because we want to find out this heat transfer with the fin. Okay, this is the initial case. ये तो पहला case था, initial case. This was initial case. Okay, now before attaching the fin, this is the initial case. Now what will be the heat transfer if you are using a fin which is having what some like area is known to us. Area is what? Cross sectional area. Diameter is given to us. Easily you will be able to get the cross sectional area. K is the conductivity of the fin material. तो आपको K किसका यूज करना पड़ेगा? K for AISI. This is kind of coding for a steel, stainless steel. ये क्या होता है? There are different standards we use, so it's a kind of coding for steel. AISI 304 for this steel. The conductivity is this. So when you are putting here, because all these data are related to fin, so don't confuse yourself. Be very clear, crystal clear. This K is the conductivity of the fin, which is given to us. A is the area of the fin, pi by 4 d square. P is the perimeter of the fin, which is pi d. H you calculated, delta t is given to us. So now can you tell me what answer you are getting, guys? Out of these four options, what answer you are getting? Vamshi Sandras. Sorry, please, if I'm not pronouncing it right, Vamsi. Your name is Vamsi. Vamsi का आंसर है 2.19. Vamsi is saying 2.19. Very good, Vamsi. बिल्कुल सही आपका आंसर है. Those are getting 2.19, 2.1958, which is very, very exactly, if you approximate this, which is equal to 2.2 watt. So option A is the right answer for this question. So if you are getting option A, this is the very right answer for this question. Okay, बिल्कुल सही. Those are getting option A, they are very right. ठीक है बच्चों? So देखो ये क्वेश्चन भी अच्छा था, because in this question again he is asking you to apply some multiple concepts. He is asking you heat transfer. So first you need to obtain the convection heat transfer coefficient, guys. I don't know, like you solved those previous year GATE questions or not. If you will solve convection related question, in each and every question, guys, he has provided you the data. Okay, so no correlation you need to remember, but basic understanding you need to have how to calculate Reynolds number, how to calculate Prandtl number, what are the different terms are there in this correlation. So definitely 100% he is going to provide you some kind of correlation, but you need to have some basic understanding what terms are there in that correlation. If you don't know those terms, if you are not having understanding how to find out Reynolds number, then definitely you will face difficulty. Okay, here I'm not calculating all these things. I have written the formula and I hope you all are able to calculate those kind of things. Okay, chaliye. Okay, I hope all of you are getting the answer. 2.19. Very good, Anil. Anil का मंगनाओ रेडी. बहुत सारे बच्चों ने आंसर कर दिया है. वेरी गुड. 4GS टॉक्सिक गेमिंग, ये भी अच्छा. 4SG भी बता रहा है. अभी नए नए बच्चे आ रहे हैं आज, बहुत अच्छा लग रहा है बच्चों. वेरी गुड. 10+2 area of the fin. Guys, this is not cross section. This is not surface area. This is the क्रॉस सेक्शनल एरिया. देखो जितने भी फॉर्मूले होते हैं ना फिन के, इसमें जो ए जब हम लिखते हैं ना, ए ऑलवेज मींस क्रॉस सेक्शनल एरिया, एंड क्रॉस सेक्शनल एरिया ऑफ द फिन इज व्हाट? क्रॉस सेक्शनल एरिया इज पाई बाय 4 d square. So d is given to us 5 mm, so pi by 4 into 5 into 10 की power minus 3 whole square. From this you will get the cross sectional area of the fin. Is there any difficulty, guys, in finding out this area? A is the cross sectional area. This area, guys, एरिया कौन सा लेना पड़ेगा? क्रॉस सेक्शनल एरिया ऑफ द फिन. डोंट टेक इट एज 20 into 20. कुछ बच्चे सोचेंगे कि सर मैं ये ले लूं 20 into 20 surface area. No, this is not the like this is not the fin cross sectional area. We are interested in fin cross sectional area, so that is pi by 4 d square. Okay, चलिए, let us now move to next question number 3. ये थोड़ा सा सिंपल क्वेश्चन रहेगा, and like those students who faced difficulty in answering first question, they can easily answer this and they will have confidence also, and easily you will be able to move yourself, है ना? एक स्टेप आगे बढ़ोगे आप. and all different type of convection question, guys, we are going to discuss. हर तरह का convection question मैंने इसमें solve किया है बच्चों. Please ask. 10 plus I'm not getting your question. चलिए, time is very important. Let's move to this question, guys. Next question number 3. There is an engine oil at 100 degrees Celsius which is having a velocity 0.1 meter per second, flows over both surfaces of a 1 meter long flat plate. एक मीटर लॉन्ग की फ्लैट प्लेट है. देयर इज अ फ्लैट प्लेट व्हिच इज हैविंग लेंथ 1 मीटर. उसके ऊपर ऑयल इज फ्लोइंग व्हिच इज हैविंग दीस कंडीशंस. 100 डिग्री सेल्सियस पे ऑयल फ्लो कर रहा है एंड दिस इज द वेलोसिटी ऑफ द ऑयल. वॉल इज एट मेंटेन्ड एट दिस टेंपरेचर. Okay, the surface temperature of the wall is maintained at 20 degrees Celsius. Local convection heat transfer coefficient और आपसे heat flux पूछ रहा है. पहले पूछ रहा है कि hx बताओ local convection heat transfer coefficient, and he is asking you HL, आपसे पूछ रहा है HL. Okay, चलो पहले तो आपको एक चीज बताता हूं मैं. You know guys, H depends on X, means distance from the leading edge. There can be different values of H. H you can find out at the leading edge, H you can find out at the trailing edge, H you can find out at any distance in between that plate. Okay, that's why we generally write H as HX. HX का मतलब क्या होता है? Local convection heat transfer coefficient. Local convection heat transfer coefficient. Okay, HL का मतलब क्या होता है बच्चों? HL means convection heat transfer coefficient. Convection heat transfer coefficient at trailing edge. Okay, trailing edge means at x equal to L. Okay, Hx at x equal to L. Hx at x equal to L, that is your HL. So in this question he is asking you HL only, because the relationship which is given to you, this is the relationship for what? Local Nusselt number. NUL means local Nusselt number. आप कहोगे सर Prandtl में ऐसा क्यों नहीं है? Because Prandtl number is the only unique number which is a property of a fluid, and it is going to remain constant. It is not going to change with the the distance from the leading edge. So whatever, like if you are at the leading edge, if you are in between at, or if you are at the trailing edge, Prandtl number is going to remain constant. That's why there is no such L mentioned here. So Reynolds number at the leading trailing edge, Nusselt number at the trailing edge, you will get, if you will find out the Reynolds number using x equal to L, means L equal to 1 meter. L is equal to length of the plate, which is 1 meter. Okay, now can you solve, guys? Can you tell me what HL value you are getting? The data is given to you. You need to find out Reynolds number, local Reynolds number, REL equal to VD. D is what? D is not the diameter, D is the characteristic dimension. For the flow or flat plate, the direction, the length of the plate along the direction of the flow, that is your characteristic dimension, and the flow is along the length of the plate, which is 1 meter. That's why this 1 meter is your characteristic dimension. This is your characteristic dimension. So VD by mu. Okay, या इसको आप लिख सकते हो rho VD by mu. Okay, because these your characteristic dimension which is given, all these things are given. Velocity is given to you 0.1 meter per second. Nu is the kinematic viscosity, which is also given to you directly. This is your kinematic viscosity, 86.1 into 10 to the power minus 6 meter square per second. If you will put it here, you will get Reynolds number. Putting here Reynolds number value, Prandtl number is already directly given to you, because for oils Prandtl number is very high. For air, the Prandtl number is in the range of 0.7. For water, it is close to 7. And for heavy oils, it is in the range of 1000 and even more than that. You can have Prandtl number in lakhs also for some very heavy oils. Okay. For liquid metal, the Prandtl number is very, very less. It is even very less than 1, something like 0.001. Getting? So some idea you need to have what is Prandtl number for air, what is Prandtl number for water, what is Prandtl number for what? Those heavy oils and liquid metals. Chaliye. So now can you tell me, guys, what HX value you are getting? कितना आंसर आ रहा है बच्चों? जल्दी से बताओ. Where should I can download the Mohammed Siddiqui? Okay, we will try to share some link with you. Okay, so it's my request. We'll share shortly. You will get some link. Okay, जल्दी से आपको link मिलेगा in this chat box only. You will find some link. Otherwise, if you will go to our website, you will find some link directly. आपको YourPedia education लिखना है Google पे, and you will find some link. You will find the link for the website. And if you go to our website, definitely directly you will find some link to download that workbook. Why negative sign? Negative sign क्यों है बच्चों? Because heat is entering into the plate. Why? Because the engine oil is at high temperature. Engine oil is at high temperature, 100 degrees Celsius. The plate is at low temperature. The heat transfer is not from plate to the oil. Generally, we consider the plate at high temperature and the air, the fluid at low temperature. So that kind of heating case we assume, but it's not a case of heating. It is a case of cooling. So heat is transferring from what? Oil to the plate. That's why that negative sign is there. चलिए. So guys, lots of students, they are answering, and let me tell you what answer you are going to get for this question. बिल्कुल सही. Those are getting HL equal to 16.25. बिल्कुल सही आंसर आएगा बच्चों आपका. HL will come out 16.2569. Now can you tell me heat flux also? HL जो आपका आ रहा है, HL will come out 16.25 watt per meter square Kelvin. Heat flux कहां से आएगा बच्चों? What is heat flux? Heat flux also you can easily calculate using Newton's law of cooling. Q convection equal to HA delta T. So H we are having 16.25. Okay. h we are having 16.25 into area. ओके अब अपने को हीट फ्लक्स निकालना है ना, वी वांट टू फाइंड आउट हीट फ्लक्स. ओके तो एरिया कितना हो जाएगा आपका 1 मीटर स्क्वायर इनटू, बिकॉज दिस इज हीट फ्लक्स, रेट ऑफ हीट ट्रांसफर watt per meter square, so area will be 1 meter square, and the temperature difference is 100 minus 20. The oil is at 100 degree temperature and the wall is at temperature 20 degrees Celsius. If you will solve, you will get answer this. Option A you are going to get. Okay, and I hope all of you are able to solve this very simple question. Yes guys, please tell me how many of you are able to solve. Can we move to next question guys? क्या हम next question पे move कर सकते हैं बच्चों? Yes, Bishwanath, Ranga Naveen, very good guys. Let's move to next question, question number 4. So this is question number 4 in front of you. And again guys, it's my request to you, don't just read the question and don't feel ki sir it is a very lengthy question, difficult question. Convection questions are not difficult, they are lengthy, they are looking like lengthy, but they are very easy, very simple. So you need to read the data and if you apply your mind easily in seconds you will be able to get the idea. देखो पहला क्वेश्चन तो वैसे भी बहुत आसान है, फर्स्ट क्वेश्चन तो आपको दिक्कत होगा ही नहीं, ठीक है. In second part, because ये दो common data question है बच्चों, these are common data question. First part he is asking you the velocity profile and in second case he is asking you the Nusselt number. So this is fifth question. So these are the common data for question number 1 and question number 2. Question number 1 और question number 2 के लिए this is the common data. So guys, you are having a flow inside pipe. आपके पास क्या है? Flow inside pipe, hydrodynamically fully developed flow. Hydrodynamically fully developed flow. Okay, and for the flow inside pipe, hydrodynamically fully developed flow inside pipe, what type of velocity profile you are going to get? Okay, किस तरह का velocity profile मिलता है आपको बच्चों? Initially you will have some kind of entrance length. Initially तो आपको entrance length मिलेगी LE. Okay, where the velocity profile is going to change. Okay, it is developing region. After that, where the boundary layer they will meet and you will have a kind of what? You will have a kind of developed flow. मैं इसको थोड़ा सा आगे तक बढ़ा देता हूँ. So this is your entrance length. Okay, and this is your developed flow. तो वो क्या बोल रहा है कि पाइप में this length is very very small. This is very small. Okay, I have shown you just to give you idea कि there is some kind of entrance length where the velocity profile is going to change. Okay, यहाँ पे velocity profile क्या करती है? Change करती है. Okay, so velocity profile is going to change something like this. This is the reason where there is no such effect is there. Okay, there is no such viscous effects are there in this region. Okay, but in this region, in the entire cross section, the viscous effects are transferred. Entire region viscous effects are transferred. That's why after this the velocity profile is not further going to change. Velocity profile आपका change नहीं करेगा. You will have a uniform velocity profile. Okay, uniform velocity profile. Okay, और किस तरह का velocity profile होता है बच्चों? किस तरह का velocity profile होता है? This is a kind of parabolic velocity profile. Parabolic velocity profile. You are going to have a parabolic velocity profile. So पहले क्वेश्चन के लिए तो आपका आंसर सीधा ही हो जाएगा कि सर for this question the velocity profile will be parabolic. Velocity profile will be parabolic. In second part he is asking you the Nusselt number. The relationship is given to you, and guys don't think of this like this, sir. For hydrodynamically fully developed flow inside pipe, okay, with constant wall temperature, the Nusselt number is what? Nusselt number is 3.66, and for constant heat flux the Nusselt number is 4.36. Yes, those are the case, those you can use if there is no such data given to you, but here he is giving you some data 3.66 something. Okay, 3.66 something. So this is a 3.666 case, constant wall temperature, hydrodynamically fully developed flow inside pipe, but he is giving you this correlation. So don't answer 3.66, that will be wrong actually. Why? Because when he is giving you that relationship, so you need to apply that correlation only and you need to modify that value. So after putting all those things you are going to get some value. Okay, this is very important relationship guys which generally we use. Okay, now can you tell me what Nusselt number value you are getting guys? What is the Nusselt number value you are getting? 3.66 गलत हो जाएगा बच्चों. I already mentioned why that was wrong, because that was there, those are kind of approximation. Okay, generally for constant wall temperature fully developed flow in a pipe we use Nusselt number. equal to 3.66, and with the constant heat flux case we use it as 4.36. But here he mentioned use Edward Adel relationship. बोल रहा है कि जो एडवर्ड ने 1979 में जो रिलेशनशिप डेवलप किया था, you need to use that relationship. Use Edward Adel relationship which was given by those researchers in year 1979. So you need to use that relationship and you need to find out the Nusselt number value. So using that relationship, can you tell me what Nusselt number value you are getting, guys? So D is the diameter of the pipe, which is 10 centimeter. L is the length of the pipe, which is 5 meter. DL is given to you. Reynolds number easily you will get. Data is given to you. Reynolds number easily you can calculate. Prandtl number is also directly given to you, 5.83. So Prandtl number तो आपको directly given है. Now can you tell me what Nusselt number value you are getting, guys? Please try to get some idea. Please try to answer what Nusselt number value you are getting. What is devolved flow, guys? Devolved flow means the region, where after the fluid after traveling some distance, the viscous effect can be influenced throughout the cross section. Okay, after that the flow is going to devolve, but fully devolve. उस flow को हम क्या कहते हैं? Fully devolved flow. So fully devolved flow means when the viscous effect can be analyzed throughout the cross section, that flow is known as fully devolved flow. Okay, and in that fully devolved flow there will not be any change in the velocity profile in the x direction. X direction में velocity profile change नहीं करेगा. But in the devolved region, because the viscous effect cannot be influenced, cannot be analyzed in the entire cross section. In some of the cross section there are viscous effect, because अभी entry पे क्या होगा guys? Fluid is just entering into the pipe, so the viscous effect can be analyzed in a very small cross section. Okay, the reason is what? The developing flow, the velocity profile is going to change. But after traveling to some distance, the viscous effect can be analyzed throughout each and every cross section. That region is known as what? Fully developed region. तो उस region में velocity profile आपका further change नहीं करेगा. But in this region the velocity profile is going to change. That's why this is known as developed region. इसे हम क्या बोलते हैं? Developing. This is known as developing region because the velocity profile is changing. But in this region, because the flow is fully developed, why? Because the viscous effect can be analyzed, can be influenced throughout the cross section, and there is no change in the velocity profile in the x direction. That's why this flow is known as developed flow. Developed flow. Okay, chaliye. So now let me give you the answer. Developed flow. Simple question था बच्चों. Only data लग रहा था कि बहुत ज्यादा है, but very simple question. And lots of students they are answering this question. 8.69 is the right answer, guys. इस क्वेश्चन के लिए if you are getting the answer in this range, अगर आपका आंसर आ रहा है इस रेंज में बच्चों, those of you are getting the answer in this range 8.65 to 8.75, 8.65 to 8.75, Nusselt number अगर आपका इस रेंज में आ रहा है then it is very right. मैंने जब कैलकुलेट किया था तो I got the answer 8.6. okay, तो अगर आपका ये आ रहा है then it is right, otherwise again you need to check your calculation. ठीक है, बिल्कुल आपको अपना कैलकुलेशन दोबारा चेक करना पड़ेगा बच्चों. एवरी सिंगल डिटेल इज गिवन टू यू, ओनली यू नीड टू यूज दिस रिलेशनशिप एंड यू नीड टू फाइंड आउट द नसल्ट नंबर वैल्यू. ओके, एच पूछ लेता तो क्या करते आप? एच पूछ लेता तो इसको लिख देते आप एच नसल्ट नंबर इक्वल टू एच एल बाय के. ओके, एच एल बाय के. वहां पे एल क्या हो जाता है? एल इज इक्वल टू डायमीटर ऑफ द पाइप, बिकॉज फॉर द फ्लो इंटरनल फ्लो here the diameter of the pipe, this will be the characteristic dimension. Diameter will become the characteristic dimension. चलिए, let us now move to next question. next question पे मूव करते हैं. इसी क्वेश्चन के लिए, अभी ये क्वेश्चन थोड़ा सा अच्छा है बच्चों. दिस इज कंपेरेटिवली बेटर क्वेश्चन इन दोनों से. इसी का कॉमन डेटा क्वेश्चन है. देखो होगा क्या, पहले दो क्वेश्चन तो बहुत सारे बच्चों ने आंसर किया है. पहला पैराबोलिक वेलोसिटी प्रोफाइल, सेकंड नसल्ट नंबर, ऑल ऑफ यू आई होप यू कैलकुलेटेड. नाउ ही इज आस्किंग यू व्हाट इज द एग्जिट टेम्परेचर. आपसे टेम्परेचर एग्जिट पूछ रहा है. exit temperature with the same data given in question number 4. What is the exit temperature with the same data given in question number 4? So again I'm putting this data in front of you guys. Please apply your mind and try to calculate the exit temperature. मैं थोड़ा सा इसको नीचे कर देता हूं. He is asking you the exit temperature. वाटर का exit temperature पूछ रहा है आपसे. Yes, please try to answer. ये बहुत अच्छा क्वेश्चन होने वाला है बच्चों. अभी I am waiting for your response and let's see how many of you will be able to answer this question. बच्चों वेलोसिटी मत यूज करना इसमें डायरेक्टली, बिकॉज ही हैज गिवन यू द मास फ्लो रेट. आपको थोड़ा सा ये चेक करना पड़ेगा. ही हैज गिवन यू द मास फ्लो रेट. मास फ्लो रेट इक्वल टू रो एवी. Okay, where rho is the density of the water. Density आपको given है 997, so this is 997. A is the area of the pipe which is pi by 4 d square, pi by 4 d square into v. अब या तो यहां से वेलोसिटी निकाल लो पहले, because he has given you the mass flow rate. रेनॉल्ड्स नंबर निकालने के लिए, for finding out the Reynolds number, he has not given you the velocity directly, he has given you the mass flow rate, okay, which is equal to 0.1 kg per second. तो इसको सिंप्लीफाई करोगे इजीली, you will get the velocity, and then vd by nu you will get the Reynolds number. चलिए, try to answer this question guys, I'm waiting for your response. What is the exit temperature you are getting? What is the exit temperature guys you are getting? क्या क्या हिंट लगाना पड़ेगा? You want some hint guys? कोई हिंट चाहिए आपको? Yes. So guys, what hint? What is the hint required? So what you can do in this case, you can apply some basic formulation. What is that? Q convection equal to what? The change in internal energy of the fluid. Whatever Q is convecting from the surface, because अब देखो यहाँ पे अगर if you will analyze, the surface temperature is what? The surf is, this is wrapped with the electric resistance which is maintaining the surface temperature 60 degrees Celsius. So you are heating the water. आप water को क्या कर रहे हो? Heat कर रहे हो. You are heating the water which is entering at 20 degrees Celsius. Okay. So how much will be the change in the internal energy? Sorry, the enthalpy of fluid. What you can say? Q convection which is equal to HA delta T, that is equal to m dot Cp dt. अब इन दोनों dt में किस फर्क क्या है बच्चों? What is this? This dt is nothing but the surface temperature minus water temperature. This is surface temperature minus water temperature, and this is nothing but the water exit temperature minus water inlet temperature. Are you getting the idea guys? So for water, how much is the Q convection? The heat transfer from the surface of that tube, surface of that pipe by convection, that is equal to the change in enthalpy of the water, which is equal to m dot Cp delta T, the heat taken up by the water. Okay, how much heat the water is taking? That is equal to m dot Cp delta T. So m dot is the mass flow rate of the water, Cp is the specific heat of the water, delta T is the change in temperature of the water, which is nothing but T exit minus T inlet. T inlet is given to us, T inlet अपने को पता है 20 डिग्री सेल्सियस, ये कितना है 20 डिग्री सेल्सियस. रिमेनिंग ऑल थिंग्स आल्सो वी नो, नसेल्ट नंबर वी नो which is equal to h d by k. Okay, from this easily you will get h value आ जाएगी. And for pipe you need not to worry, sir, what h value we need to take, h local or h bar? Guys, for pipe case, the h is in fully developed region, the h is not going to change. In fully developed region, you know guys, for a fully developed flow in laminar flow in pipe, for constant wall temperature we are having a case, Nusselt number equal to what? 3.66. For constant heat flux we are having Nusselt number equal to 4.36. But here we are calculating the Nusselt number using that correlation given by Edward et al, and using that relationship only we find out, we obtain the Nusselt number value. So using that Nusselt number you will be able to calculate that h value. But what is the logic? H is not going to change in the hydrodynamically fully developed flow. So h is a constant. So that h value which you are getting, that is nothing but h average only, because h local is nothing but that is h average. Both are constant. So now can you tell me guys what exit temperature you are getting using this relationship? Yes, what exit temperature you are getting? अभी बहुत सारे बच्चों को इसमें कंफ्यूजन होगा, सर एरिया क्या लेंगे? बच्चों देखो, इसमें समझना क्या है आपको, देखो एक थोड़ी सी बेसिक अंडरस्टैंडिंग आपको डेवलप करनी पड़ेगी. दिस इज पाइप, ये पाइप है आपका, दिस इज योर पाइप. ओके, दिस पाइप इज रैप्ड विद सम काइंड ऑफ, यू नो, आपने इसको रैप कर दिया. मैं उस रैपिंग को कुछ ऐसे दिखा देता हूं. ये आपने रैप कर दिया, काइंड ऑफ रैपिंग, ये आपने रैप कर दिया इसको, और यहां से आप क्या कर रहे हो? हीट सप्लाई कर रहे हो. यू आर सप्लाइंग हीट. ओके, यू आर सप्लाइंग हीट. सो व्हाट इज द एरिया? एरिया हो गया क्या? एरिया इज द एरिया ऑफ द कॉन्टैक्ट. Okay, area of the fluid which is exposed, area of the surface which is exposed to the fluid. And what is that area? That is nothing but pi d into L. Area of the pipe exposed to the fluid, area of the pipe exposed to the fluid, that is pi d, perimeter of the pipe into length of the pipe. Both are given to us. दोनों अपने को given है बच्चों. Diameter पता है 10 mm है, length पता है 5 मीटर है. So you will easily able to get the this area. Delta T मैंने आपको वैसे ही बता दिया है. Cp value, all these things are also given to you. Now please tell me what exit temperature you are getting guys. Everything I already told you guys. बिल्कुल मैंने आपको बता दिया है फ्रॉम वेयर यू आर गोइंग टू गेट द एरिया एच यू विल गेट इफ यू विल कैलकुलेट यू विल गेट एच 52.718 जो नसल नंबर हमारा आया था इस रेंज में जो नसल नंबर आया बच्चों इससे अगर आप एच निकालोगे यू विल गेट द एच इन द रेंज ऑफ 52.718 watt per meter square Kelvin. तो यू कैन मैच योर एच वैल्यू ऑल्सो आप अपना एच वैल्यू मैच कर सकते हो बच्चों यू कैन मैच योर एच वैल्यू और बिल्कुल अगर आप इसको कैलकुलेट करोगे एग्जिट टेम्परेचर यू विल गेट इन द रेंज ऑफ 27.92 डिग्री सेल्सियस तो अच्छा क्वेश्चन था बच्चों बिल्कुल अच्छा क्वेश्चन था पहले दो पार्ट फर्स्ट टू पार्ट्स आर कंपैरेटिवली इजी बट दिस पार्ट इज वेरी वेरी गुड के इज गिवन टू यू गाइस देखो के गिवन तो है आपको के किसका लेते हो इन नशल नंबर के किसका लेते हो के इज द कंडक्टिविटी ऑफ फ्लूइड व्हिच इज गिवन टू यू 0.613 देखो कंडक्टिविटी इज 0.613 वाट पर मीटर केल्विन तभी मैंने आपको बोला है बच्चों please have this data workbook with you so that you will be able to find each and every data so conductivity is this 0.613 watt per meter kelvin conductivity of the fluid is 0.613 watt per meter kelvin yes okay so fourth fifth and sixth these are the three common data questions we have discussed yes Shahrukh very good चलिए let us now move to next question number 7 दिस इज कंपैरेटिवली इजी क्वेश्चन अभी कुछ थोड़ा सा रिलैक्स रहने वाला है थोड़ा टाइम थोड़ा रिलैक्स रहने वाला है सिंपल क्वेश्चन हम डिस्कस करने वाले हैं सो देयर इज ए inside a tube which is having diameter 1 centimeter 130 degree celsius constant wall temperature there is a case of constant wall temperature air is flowing at a mean velocity of 1.5 meter per second fully developed prison mean temperature is measured as 35 degrees celsius determine the flow of the exit temperature of the air is this so inlet temperature is given to you 35 exit temperature is also given to you 105 take property of the fluid at bulk mean temperature देखो पाइप के केस में जो बल्क मीन टेम्परेचर होता है you know in flow over flat plate all the properties we evaluated at film temperature for flow over flat plate the properties of the fluid for calculating the Reynolds number for calculating the Prandtl number we evaluated film temperature क्या होता है surface temperature plus fluid temperature divided by 2 so flow over flat plate के केस में प्लेट के केस में तो हम फिल्म पे करते हैं बच्चों दिस इज फ्लो ओवर फ्लैट प्लेट फिल्म टेम्परेचर क्या होता है दिस इज T infinity this is TS okay and film temperature is T infinity plus TS divided by 2 और जितनी भी सारी प्रॉपर्टीज हम इसी टेम्परेचर पे इवेल्युएट करते हैं इन केस ऑफ फ्लो ओवर फ्लैट प्लेट बट पाइप के केस में all properties we evaluated at bulk mean temperature which is nothing but T in plus T exit divided by 2 okay bulk in mean temperature is 35 is the inlet temperature 105 is the exit temperature divided by 2 that is your bulk mean temperature for case of flow inside pipe okay although this is very complex actually it is not very easy to find out bulk mean temperature but for pipe flow you can write it as like this only okay bulk mean temperature is the average temperature it is also known as mixing cup temperature there are various names of these temperature bulk mean temperature energy average temperature bulk mean temperature mixing cup temperature okay so if you'll take a hot cup of tea and if you'll mix that tea thoroughly because you know like if you are having a cup of tea the temperature is not same at every cross section at top surface there are chances the surface temperature may be you know high at the bottom the temperature may be low why because due to density difference the high temperature tea high temperature water will move upside okay so up temperature will be high lower tea temperature will be low okay but if you mix that tea thoroughly the energy average temperature which you are going to get that is known as bulk mean temperature so in case of flow inside pipe pipe flow we evaluate all properties at bulk mean temperature and that is equal to T in plus T out divided by 2 ओके तो इस टेम्परेचर पे अपने को गिवन दिया ये भी अपने को ज्यादा सोचने का दिक्कत नहीं है आपसे पूछ रहा है कि पहले केस में तो रेनॉल्ड्स नंबर इवेल्युएट करो इन फर्स्ट पार्ट आई थिंक ही इज आस्किंग यू टू इवेल्युएट रेनॉल्ड्स नंबर yes please evaluate this and tell me what answer what option you are getting हाँ यस यस वैभव बिल्कुल सही सोच रहे हैं आप बिल्कुल सही सोच रहे हैं वैभव LMTD आएगा यस what Reynolds value you are getting guys now can you tell me the flow is laminar or turbulent बिल्कुल सही बच्चों Reynolds number is coming out 753.77 753.77, which is less than 2000. So we can say the flow is laminar. The flow is laminar. Yes or no? Flow क्या है बच्चों आपका? Laminar flow है. Okay. The flow is laminar because Reynolds number is less than 2000. Option D is the right answer for this question. Okay. Now in next part we are having two ideas. अभी दो ideas हैं अपने पास. Nusselt number is less than 2000. Okay. और अभी अपने से पूछ रहा है कि इसने जो केस दिया है बच्चों, inside a wall constant wall temperature tube, constant wall temperature tube अपने को दी है बच्चों. He has given you the constant wall temperature tube. So fully developed case with the constant wall temperature, can I write it here? Nusselt number equal to 3.66. क्या लिख सकता हूं मैं? आपको सर अब एडवर्ड का रिलेशनशिप क्यों नहीं यूज कर रहे? Why you are not using Edward relationship? अभी जो पहले था बच्चों, उस केस में he has given you that relationship and he he told you to use that relationship to find out the Nusselt number value, to find out the H value, because this is a general case, because there is no such relationship given. So directly we can apply our relationship because we know the flow is laminar, the flow is fully developed, and for the laminar flow inside pipe with the constant wall temperature, Nusselt number equal to 3.66, which is equal to H D by K. So can you calculate H value, guys? क्या H value निकाल पा रहे हो आप? How many of you are able to find out H value? Because in second part he is asking you that only. Second part में आपसे वही पूछ रहा है वो आपसे. First part में उसने आपसे पूछा कि Reynolds number बताओ. Second part में आपसे पूछ रहा है H value बताओ. What is H value? HD. पाइप के केस में हम इसको बोल देते हैं HD, because that is an average convection heat transfer coefficient you are going to get. Very good, guys. 10.68. Those are getting H value in the range of 10.6872 watt per meter square Kelvin. बिल्कुल सही बच्चों. Very good. H equal to 10.6872. चलिए नेक्स्ट पार्ट में बच्चों आपसे वो कुछ और पूछ रहा है. लेट्स मूव टू दैट ऑल्सो. थर्ड पार्ट ऑफ दिस क्वेश्चन. In this question, he is asking you calculate the length of the tube in centimeter. Length of the tube in centimeter up to first decimal. आपसे length of tube पूछ रहा है अभी. आपसे पूछ रहा है length of tube. The concept, the idea is similar. मैंने जो पहला क्वेश्चन सोल्व किया था बच्चों ट्यूब का, the idea is similar to that only. Can you think? Can you tell me how you are going to calculate that length of the tube, guys? आपसे जो ये ट्यूब है जिसके अंदर फ्लूइड फ्लो कर रहा है, he is asking you that. He's asking you the length of the tube. So guys, there is no need to worry about that. Why? Because what is Q convection? Q convection equal to HA delta T. अब ये A क्या होता है बच्चों? A is perimeter into length. तो ये length क्या है? Length, L is the length of the tube only. So please apply your mind and tell me what value of the length of the tube you are getting. What is the length of the tube, guys, you are getting? Okay. Q convection equal to HA delta T. So H we calculated, area is pi d into L, diameter is already known to us. Diameter is already known to us. Q convection बच्चों देखो similar concept है. Q convection क्या है बच्चों? This is energy taken by the fluid, energy taken by the air. और वो क्या होगी? That is m dot Cp. Air था water था बच्चों. I don't know what he has given you, air or water. क्या केस था? Yes, it's a case of air only. Air flow कर रहा है ना? Air है. Okay. So it's a case of air flow only. तो the Q convection from the pipe, the Q convection from the pipe, कितना Q convection हो रहा है बच्चों? That Q convection is nothing but the change in energy of the fluid. कितना energy fluid carry कर रहा है? That is mc dt. और वहां पे dt क्या होगा बच्चों? What is dt? dt is T exit minus T in. Exit कितना है? Exit is 105, inlet is 35. These two temperatures are given to us. Exit temperature of the air is 105, inlet temperature is 35. Mass flow rate also easily you will be able to calculate. Cp also given to you. H you already calculated. Delta T is what? Is a mean temperature between what? Fluid and this surface. Fluid और surface के बीच में. Okay. So now can you tell me what length of the pipe, length of the tube you are getting, guys? कितना आपका length of the tube आ रहा है बच्चों? बहुत अच्छे क्वेश्चन है बच्चों. बिल्कुल बहुत ब्यूटीफुल क्वेश्चन है. लाइक फर्स्ट 9 क्वेश्चन, लाइक इफ यू सोल्ड, इट मींस योर प्रिपरेशन इज वेरी गुड गाइस फॉर द गेट एग्जामिनेशन. अगर ये पहले 9-10 क्वेश्चन आपने सोल्व किया, इट मींस योर प्रिपरेशन इज वेरी गुड. वेरी गुड अभिनव, बिल्कुल सही अभिनव, आपका आंसर सबसे पहला है और बिल्कुल सही है. 48.6 इज द राइट आंसर फॉर दिस क्वेश्चन. 48.6 इज द राइट आंसर फॉर दिस क्वेश्चन. ओके. अभी जिन बच्चों का आंसर नहीं आ रहा है, एक बच्चे ने मेरे से यहां पूछा था sir, what we need to use that delta T is what we need to use? We need to use the LMTD. मैंने क्या बोला था? Yes, you need to use LMTD only. I don't know you listen to that or not. So this delta T is a mean temperature difference. देखो इनलेट पे इसका टेम्परेचर कितना है? 35 डिग्री सेल्सियस. यहाँ पे कितना है? 105. द सरफेस टेम्परेचर यू आर मेंटेनिंग 130 डिग्री सेल्सियस. अभी इनका मीन टेम्परेचर कैसे निकालोगे? हाउ यू विल फाइंड आउट देयर मीन टेम्परेचर? The fluid inlet temperature is 35, exit temperature is 105, and the surface temperature is 135. How you are able to calculate the mean temperature difference? कैसे निकालते हैं बच्चों? That you generally we calculate by LMTD only. So this temperature is 130 degree Celsius. This is your water temperature 35, 105. And can you calculate LMTD बच्चों? क्या इसके लिए delta T हम निकाल सकते हो? That delta Tm is nothing but this delta Tm, LMTD, average temperature difference between fluid and surface. एवरेज टेम्परेचर डिफरेंस बिटवीन फ्लूइड एंड सरफेस. तो आप इसको ऐसे लिख सकते हो बिकॉज ये तो आपका सरफेस टेम्परेचर है. दिस इज योर सरफेस टेम्परेचर 130. दिस इज योर फ्लूइड टेम्परेचर. ओके, दिस इज योर फ्लूइड टेम्परेचर. तो अगर आप इसको सोल्व करोगे डेल्टा टीएम यू विल गेट 52.433 सेंटीमीटर. 52.433 सेंटीमीटर. बिल्कुल सही बच्चों. 48 के आसपास भी जिनका आ रहा है बच्चों, दोज आर गेटिंग दिस लेंथ ऑफ द पाइप इन द रेंज ऑफ, मैं इसको यही लिख देता हूं. कितनी बार लिखेंगे हम? बहुत बार लिख चुके हैं ना. चलिए यहां लिख देते हैं. सो लेंथ ऑफ द पाइप यू आर गेटिंग 48.61 सेंटीमीटर. सेंटीमीटर में पूछ रहा है, आपसे पूछ रहा है ट्यूब लेंथ इन सेंटीमीटर, तो सेंटीमीटर में आंसर करना पड़ेगा आपको. ट्यूब लेंथ इन सेंटीमीटर you need to answer. Like after solving this, initially you are going to get the answer in meter. So but you need to convert that into centimeter. उसको आपको सेंटीमीटर में कन्वर्ट करना पड़ेगा बच्चों. ठीक है, वेरी गुड. वैभव, शाहरुख का आंसर भी आ गया है. चंदन का एनर्जी बैलेंस का कंफ्यूजन था. चंदन, इज दैट क्लियर हाउ टू राइट द एनर्जी बैलेंस इक्वेशन? What I told you, like in the start only, I have given you idea. The energy balance is very much similar to the earlier case. We have solved one question based on that similar type of concept only. In the earlier case, he asked you about the exit temperature. Now he is asking the length of the pipe. So the case is same, more or less it is same. Okay, chaliye. So I hope you got some basic understanding for the pipe flow, how to calculate that, exit temperature, these kind of stuff. तो ये क्वेश्चन बहुत अच्छे थे. आई होप यू आर एंजॉइंग, यू आर एबल टू सोल्व दिस टाइप ऑफ क्वेश्चन. ओके, फर्दर इफ यू आर हैविंग एनी क्वेरी डाउट, यू आर फ्री टू पुट योर क्वेरी. व्हाट इज द यूज ऑफ बल्क मीन टेम्परेचर? विश्वनाथ, बल्क मीन टेम्परेचर पे हम क्या करते हैं? प्रॉपर्टी इवेल्युएट करते हैं. यू नो, लाइक द प्रॉपर्टी ऑफ द फ्लूइड which you are going to evaluate, like which you are going to put to calculate Reynolds and Prandtl. So where you are going to evaluate those property? You know, like the viscosity, the density of the fluid, the thermal conductivity. These things are very much, depends on temperature of the fluid. Viscosity is the one which is very highly sensitive to temperature. Like density also, density, conductivity, they all depends on the temperature. फ्लूइड्स के लिए डेंसिटी क्या करते हैं? डेंसिटी के साथ, टेम्परेचर के साथ साथ डेंसिटी चेंज करता है ना. यस, टेम्परेचर के साथ साथ कंडक्टिविटी चेंज करता है, टेम्परेचर के साथ साथ विस्कोसिटी चेंज करता है. एंड विस्कोसिटी तो बहुत फ्रीक्वेंटली चेंज करता है. हाउ यू कैन से, सर बटर लो, एक बटर लो, बटर को पराठे पे रखो. जैसे ही आप क्या करोगे, यू विल पुट इट ऑन हॉट, पराठा, तो वो क्या करेगा? उसका विस्कोसिटी जो है, फ्लो क्या हो जाएगा? फ्लो रेजिस्टेंस विल बिकम वेरी लेस. विस्कोसिटी क्या कर जाएगी? उसकी डिक्रीज कर जाएगी. आर यू गेटिंग सम आइडिया? तो विस्कोसिटी इज वेरी मच सेंसिटिव टू टेम्परेचर. So at what temperature you are going to have those property? That's why people, researcher, they define that temperature, bulk mean temperature. It is energy average temperature. Like suppose if you are having a hot cup of tea, in इसमें आपको कोई टी है, अब टी है तो वो किस टेम्परेचर पे आप उसका प्रॉपर्टी वैल्यू करोगे? ऊपर वाले सरफेस टेम्परेचर पे, नीचे वाले पे? तो किसी ने कहा कि क्या क्या करो? इट इज गुड टू मिक्स दैट एंटायर टी थोरोली, उसको थोरोली मिक्स कर दो एंड देन इवैल्यूएट the properties at that temperature, because that is the energy average temperature, that is a bulk mean temperature. That's why they given that name to that energy average temperature, mixing temperature, and the name of that temperature is bulk mean temperature. That's why all properties of the fluid we generally evaluated that. अब आप कहोगे सर यहाँ पे आपने bulk mean temperature T in plus T in minus T exit करके कैसे निकाल लिया? Because guys we approximate. अब उसका बहुत बड़ा कॉम्प्लेक्स फॉर्मूला है, इंटीग्रेशन वगैरह करके बहुत डिफिकल्ट उसको निकालना पड़ता है बल्क मीन टेम्परेचर. Are you getting? Rarely there is no chance you are going to have some question कि वो बल्क मीन टेम्परेचर आपसे पूछ ले निकालो, बिकॉज उसका बहुत इंटीग्रेशन वगैरह आपको करना पड़ेगा. Are you getting? बट पाइप के केस में you can write that bulk mean temperature approximately by what? Taking the mean of in temperature, exit temperature divided by 2. That's why in temperature कितना था 35, exit था 105, 105 plus 35 you will have 140, 140 divided by 2 you will have 70. तो देखो उसने लिखा होगा कहीं ना कहीं पे, किस पे उसने इवेल्युएट किया है, देखो he evaluated all properties at 70 डिग्री सेल्सियस. उसने जितनी भी प्रॉपर्टी इवेल्युएट की, डेंसिटी, काइनेमेटिक विस्कोसिटी, कंडक्टिविटी, स्पेसिफिक हीट, all those property, the data which you are having, those are evaluated at 70 degree Celsius. Is that clear guys? चलिए, very good. चलिए, तो मेरे ख्याल से सब बच्चों का आंसर ये आ गया है. लेट अस नाउ मूव टू नेक्स्ट क्वेश्चन. अभी ये है डायरेक्ट क्वेश्चन, 1 मार्क्स क्वेश्चन है, हलवा क्वेश्चन है, और लेट्स सी हाउ मेनी ऑफ यू आर एबल टू रिकॉल दिस कंसेप्ट. फॉर Prandtl नंबर लेस देन यूनिटी, व्हाट इज विच वन इज करेक्ट? बहुत फेमस क्वेश्चन है गेट का. गेट वालों को बड़ा प्यार है इस क्वेश्चन से, बहुत बार आता है गेट में, पहले कई बार पूछा गया है. वैभव यू नो अभी 10 क्वेश्चन हुए हैं, 35 क्वेश्चन वी आर गोइंग टू डिस्कस फ्रॉम कन्वेक्शन, सो हैव पेशेंट. हर क्वेश्चन हम सोल्व करेंगे कन्वेक्शन का, फ्री कन्वेक्शन, फोर्स कन्वेक्शन, पाइप, फ्लोवर, फ्लैट प्लेट, हर कुछ नहीं छोड़ेंगे बच्चों. देखो जितनी भी एनपीटीईएल असाइनमेंट थी उसमें से जो अच्छे क्वेश्चन मिले मेरे को, ऑल दोज आई पिक्ड. ऐसा नहीं है कि मैंने कुछ हलवा क्वेश्चन पकड़ लिया, आप देख सकते हो. इसके बाद आप कभी भी जीवन में एनपीटीईएल असाइनमेंट अभी तक का, आज तक का डाउनलोड कर लेना, you will be easily able to solve each and every question from those NPTEL assignments also. ठीक है, तो बहुत हलवा क्वेश्चन है, और मेरे ख्याल से आप थोड़ा सा पेशेंस रखोगे तो हम हर क्वेश्चन सोल्व करेंगे. हीट एक्सचेंजर भी करेंगे, तो थोड़ा सा देखो क्या है, आपको कूल होके बैठना पड़ेगा, रिलैक्स होके बैठना पड़ेगा, टाइम निकाल के बैठना पड़ेगा, बिकॉज दिस सेशन इज गोइंग टू बी लॉन्ग. हर तरह का क्वेश्चन डिस्कस करेंगे, बट यस आई कैन नॉट डायरेक्टली जंप to 30th or 35th question. Slowly, gradually we need to move. चलिए, बोल रहा है Prandtl number is less than unity. Prandtl number क्या होता है बच्चों? It is the ratio of nu by alpha. ओके, तो तीन केसेस होते हैं अपने पास. अगर बोल रहा है Prandtl number nu is less than alpha, if nu is less than alpha it means Prandtl number is less than alpha, less than 1. तो ये कौन सा केस होता है बच्चों? ये कौन सा केस होता है? It's a case where the delta thermal is very very high as compared to what? As compared to hydrodynamic boundary layer thickness. तो ये केस होता है किसका? The case of what? Because alpha is related to fluids, metals which are having very high alpha value. तो इस केस में जो डेल्टा थर्मल होता है ना बच्चों, ये बहुत हाई होता है एज कंपेयर टू डेल्टा. डेल्टा थर्मल इज वेरी वेरी हाई एज कंपेयर टू डेल्टा. एक रिलेशनशिप भी होता है इसमें. ओके, यू नो दैट रिलेशनशिप, डेल्टा बाय डेल्टा थर्मल इक्वल टू Prandtl number की पावर 1/3. there is one relationship also, delta by delta thermal equal to Prandtl number की power 1/3. so if nu is less than alpha means Prandtl number is less than 1, तो डेल्टा थर्मल क्या हो जाएगा? इट विल बी वेरी वेरी हाई एज कंपेयर टू डेल्टा. सेकंड केस, इफ न्यू इज वेरी वेरी हाई एज कंपेयर टू अल्फा, इट मींस Prandtl number इज वेरी वेरी हाई. तो ये केस कौन सा होता है? जिसमें डेल्टा इज वेरी वेरी हाई एज कंपेयर टू डेल्टा थर्मल. तीसरा केस क्या है? न्यू एंड अल्फा बोथ आर कंपेरेबल. Nu and alpha both are comparable, it means Prandtl number is close to 1, and in this case delta is approximately equal to delta thermal. Okay, अब ये भी देख लेते हैं किसके लिए होगा बच्चों, ये भी देख लेते हैं किसके लिए होगा. देखो ये केस होगा किसके लिए? This is a case for liquid metals. This is a case for liquid metals. Okay, ये किसके लिए होगा? लिक्विड मेटल्स के लिए. ये किसके लिए होगा? दिस इज फॉर हैवी ऑयल्स. वाटर के लिए भी होगा, वाटर हैवी ऑयल्स. Okay, water heavy oils, because heavy oils water they are having very high Prandtl number. उनका Prandtl number अभी देखा आपने, Prandtl number कितना था? एयर के लिए 0.7, वाटर के लिए 7, heavy oils 1000, very high Prandtl number. Prandtl number close to 1 किसके लिए था? This is for gases, for most of the gases. अब आप कहोगे सर अभी तो आपने बताया एयर के लिए 0.7 होता है, तो एयर के लिए 0.7 होता है, बट फॉर मोस्ट ऑफ द गैसेस इट इज इन द रेंज ऑफ 1 ओनली. For most of the gases, Prandtl number is close to 1. That's why nu and alpha they are comparable. That's why delta and delta thermal they are comparable. So these are very important cases. इसको समझ लो, हर क्वेश्चन आप इससे आंसर कर पाओगे. बोल रहा है Prandtl number is less than unity. तो ये जो दो मैंने आपको बाउंड्री लेयर थिकनेस दिखाई, देयर आर टू बाउंड्री लेयर थिकनेस. एक तो बाउंड्री लेयर थिकनेस होती है, क्या होता है? एक रीजन, ए स्मॉल रीजन ओवर द प्लेट वेयर वेलोसिटी ग्रेडियंट्स आर एग्जिस्टिंग, दैट इज नोन एज डेल्टा. उसे हम बोल देते हैं डेल्टा. Small region over the surface where velocity gradients are existing, that region is known as hydrodynamic boundary layer thickness. Similarly, a small region close to the vicinity of the plate where thermal gradients are existing, that is known as thermal boundary layer. आप कहोगे सर आपने इसको बड़ा क्यों बनाया? भाई मैंने मान लिया ये केस कौन सा है? दिस इज अ केस ऑफ, ये फर्स्ट केस है, मैंने मान लिया कि ये कौन सा केस है? फर्स्ट केस. ओके, दिस इज केस 1. आई एम कंसीडरिंग केस 1 वेयर यू आर हैविंग सम काइंड ऑफ लिक्विड मेटल फ्लो आपके पास क्या है, लिक्विड मेटल क्या कर रहे हैं, फ्लो कर रहे हैं, सम काइंड ऑफ फ्लूइड विच आर हैविंग वेरी लो प्रांड्टल नंबर, ऐसा कोई फ्लूइड फ्लो कर रहा है जिसके लिए प्रांड्टल नंबर क्या है, close to less than 1 है, very very less than 1. So delta thermal will be higher than delta. That case I am writing. So there can be different cases. अगर आप चाहो तो आप इसको ड्रॉ भी कर सकते हो. This is case 1. Similarly here you can draw case 2 also. आप यहाँ पे case 2 भी कर सकते हो, something like this. Okay. तो क्लियर आइडिया आपको होना चाहिए. दिस इज केस 2 जहां पे ये हो जाएगा आपका डेल्टा थर्मल, दिस इज डेल्टा, तो ये हो जाएगा डेल्टा अपर वन एंड दिस लोअर वन इज व्हाट, डेल्टा थर्मल. दिस इज व्हाट, दिस इज केस 2. ये कौन सा आपका केस 2. केस 3 कौन सा हो जाएगा, केस 3 में दोनों ही क्या है, कंपेरेबल है. डेल्टा एंड डेल्टा थर्मल बोथ आर अप्रोक्सीमेटली सेम, तो एक ही बाउंड्री लेयर थिकनेस मिलेगी. दैट्स व्हाई फॉर द केस ऑफ एयर फ्लोअर फ्लैट प्लेट, for the case of air flow flat plate generally we draw one thickness only, boundary layer thickness, hydrodynamic and thermal boundary layer thickness. तो इस क्वेश्चन का आंसर क्या हो जाएगा बच्चों, प्रांड्टल नंबर क्या है, लेस देन 1 है, दैट्स व्हाई द थर्मल बाउंड्री लेयर थिकनेस विल बी मोर, द मोमेंटम बाउंड्री लेयर थिकनेस रिमेन्स विद इन द थर्मल बाउंड्री लेयर. बिल्कुल सही. तो इसको समझ लेना, इसका मतलब क्या है, द मोमेंटम बाउंड्री लेयर थिकनेस, द मोमेंटम केस 1, the momentum boundary layer thickness will remain inside the thermal boundary layer thickness. It means the thermal boundary layer thickness is huge, hydrodynamic boundary layer thickness is less, and hydrodynamic thickness, momentum boundary layer thickness remains within the thermal boundary layer thickness. So option A itself is the right answer. तो थोड़ा घुमा के पूछा था, but question is very easy. ठीक है बच्चों, तो मैंने थोड़ा सा रिलेटेड थ्योरी भी आपसे डिस्कस कर लिया है, because this question is very very important. Is that clear guys? क्लियर है आपको? ठीक है, चलिए लेट अस नाउ मूव टू नेक्स्ट क्वेश्चन. तो ये भी थोड़ा सा डायरेक्ट क्वेश्चन है. वी आर हैविंग नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 11. कैन यू आंसर दिस क्वेश्चन गाइस? क्या इसको आप आंसर कर सकते हो? विच ऑफ द फॉलोइंग डिस्क्राइब द एक्सटेंट टू विच विस्कस हीटिंग इज इंपॉर्टेंट. देखो यू नो जनरली फॉर फ्लो एट लो वेलोसिटीज, लो वेलोसिटीज पे हम विस्कस हीटिंग को क्या कर देते हैं, नेग्लेक्ट कर देते हैं. विस्कस हीटिंग को हम क्या कर देते हैं, नेग्लेक्ट कर देते हैं. विस्कस हीटिंग क्या होता है सर, ये तो हमने पहली बार सुना है. गाइस व्हेन फ्लूइड इज फ्लोइंग, you know fluids are having some kind of viscosity, and due to that viscosity within the fluid they produce some kind of heat. Okay, because they are going to do some kind of work against that friction, because due to the viscosity is nothing but friction only guys, there is a resistance to the flow, so there is a friction. So उस friction की वजह से, viscosity की वजह से fluids they are going to you know they are going to do some kind of work, and due to that work they are going to generate some heat. That heat generated due to the friction inside the fluid, due to the viscosity of the fluid, that is known as viscous dissipation. Generally हम इसको क्या कर देते हैं, neglect कर देते हैं. Okay, heat generation due to the viscous nature of the fluid generally we neglect because that amount is very very less at low velocities, but इसको अपने को consider करना पड़ता है high velocities पे. At high velocities पे you cannot neglect viscosity, but at low velocities most of the cases, like suppose you are having 50 meter per second flow, 70 meter per second, close to that you can neglect very accurately that viscosity, but at very very high velocity you need to consider viscosity. like कोई सैटेलाइट जा रहा है बहुत हाई वेलोसिटीज पे ऊपर, तो वहां पे विस्कस हीटिंग वगैरह भी आपको कंसीडर करनी पड़ेगी. ओके, तो एक नंबर होता है ब्रिंकमैन नंबर. दिस इज अ नंबर व्हिच इज एसोसिएटेड विद व्हाट, विस्कस हीटिंग, जो अपने को बताता है इट्स अ नंबर व्हिच इज गिवन एज द रेशियो ऑफ द क्यू एनर्जी. ब्रिंकमैन नंबर जो होता है ये अपना ब्रिंकमैन नंबर, बस थोड़ा सा याद रखो अगर कहीं पूछ ले आपसे. ब्रिंकमैन नंबर, इट इज द रेशियो ऑफ द एनर्जी प्रोड्यूस्ड बाय विस्कस हीटिंग, एनर्जी हीट प्रोड्यूस्ड बाय विस्कस हीटिंग, heat produced by viscous heating, produced by viscous heating. अभी थोड़ा सा और इसके बारे में आएगा, अपन डिस्कस करेंगे. heat produced by viscous heating divided by energy transported, heat transported by conduction, heat transported by conduction, heat transported by conduction. तो इसका रेशियो होता है और अपने को बताता है कि हाउ मच इट इज देयर, कितना है यहाँ पे. तो अगर ब्रिंकमैन नंबर ये क्या होगा, अगर ब्रिंकमैन नंबर अपने को बताता है कि हाउ मच इज द हीट प्रोड्यूस्ड बाय विस्कस जनरेशन. ओके, विस्कस हीट जनरेशन. ठीक है बच्चों, चलिए एक और अगर लाइन आप लिखना चाहो यहाँ पे नोट डाल के, अगर आप एक लाइन लिखना चाहो, अगर ब्रिंकमैन नंबर बहुत ज्यादा है, इफ ब्रिंकमैन नंबर इज वेरी वेरी हाई, अगर ब्रिंकमैन नंबर बहुत ज्यादा है तो क्या आइडिया मिलेगा आपको उससे. इफ दिस इज वेरी हाई इट मींस viscous heat dissipation is very high, विस्कस हीट जनरेशन तो क्या है बहुत ज्यादा है, बट कंडक्शन इज वेरी वेरी स्मॉल, सो इन दैट केस द फ्लूइड टेम्परेचर विल इंक्रीज, बहुत ज्यादा उसका कंडक्शन नहीं होगा बिकॉज फ्लूइड हीट कैरी नहीं करेगा, बट जनरेशन हो रहा है उसमें इनसाइड जनरेशन इज हाई, सो द फ्लूइड टेम्परेचर विल इंक्रीज, फ्लूइड का टेम्परेचर क्या हो जाएगा, इट विल इंक्रीज टू अ वेरी हाई वैल्यू. ओके, सो इफ ब्रिंकमैन नंबर इज वेरी वेरी हाई, heat generation by viscous heat generation will be very high, conduction will be less, so the fluid temperature will increase. वो नोट बना के आप चाहो तो लिख सकते हो. ओके, सो दिस इज डायरेक्ट थ्योरी क्वेश्चन जो आपको समझ में आया होगा, आई होप. नेक्स्ट क्वेश्चन में मूव करते हैं बच्चों. क्वेश्चन नंबर 11, क्वेश्चन नंबर 12 नाउ. क्वेश्चन नंबर 12 ये भी बहुत डायरेक्ट क्वेश्चन है एंड आई थिंक इजीली यू विल बी इजीली एबल टू आंसर. यस वैभव, वेरी गुड. कंडक्शन बिल्कुल नेग्लिजिबल होगा, ब्रिंकमैन नंबर अगर कम है कंडक्शन क्या होगा, कम होगा, विस्कस डिसिपेशन ज्यादा है तो टेम्परेचर फ्लूइड का क्या हो जाएगा, इट विल इंक्रीज. ओके, चलिए. When the hydrodynamic boundary layer thickness delta at a distance local velocity u becomes 99 of the free stream velocity, which of the following equation we use? कौन सा इक्वेशन हम यूज करते हैं बच्चों? यू नो व्हाट ब्लोजियस एग्जैक्ट सॉल्यूशन, फ्लूइड मैकेनिक्स, ये तो फ्लूइड मैकेनिक्स का क्वेश्चन है बच्चों, ये तो फ्लूइड मैकेनिक्स का क्वेश्चन है, आपने बिल्कुल पढ़ा होगा. डेल्टा इक्वल टू 5x बाय आर ई एक्स की पावर 1/2 या अंडर रूट आर ई एक्स, देखा है, सुना आपने, ये रिलेशनशिप बिल्कुल पढ़ा होगा. सो दिस रिलेशनशिप वी यूज टू कैलकुलेट द हाइड्रोडायनामिक बाउंड्री लेयर थिकनेस, वेयर डेल्टा इज द हाइड्रोडायनामिक बाउंड्री लेयर थिकनेस. ओके, ये x क्या है आपका, जिस डिस्टेंस पे आप ले रहे हो, एट अ डिस्टेंस फ्रॉम द लीडिंग एज, x is the distance from the leading edge. Okay, so this distance, x is the distance from the leading edge. Okay, यहाँ पे suppose you want boundary layer thickness at a distance x, यहाँ पे आपको boundary layer thickness चाहिए, ये डेल्टा चाहिए, this is delta at this. So यहाँ पे आपको रेनॉल्ड्स नंबर निकालना पड़ेगा, REX लोकल रेनॉल्ड्स नंबर, x आपको पता है, this is x कुछ भी 10 mm 15 mm from the leading edge, so that x is the distance from the leading edge, REX is the local Reynolds number at that point where you want to evaluate your boundary layer thickness, because at the leading edge delta will be 0. Delta is 0 at what, leading edge, because x is 0, x को 0 put करोगे, delta will be 0 at the leading edge. Okay, so this is the formula which generally we use to calculate delta. Okay, चलिए तो next question में move करते हैं बच्चों. ये बहुत अच्छा क्वेश्चन है, lots of students they will actually, you know, first time they are going to read these kind of things. बहुत अच्छा क्वेश्चन है, पूछ सकता है आपसे गेट पे. द लेयर अबव द लैमिनार सब, अच्छा मैंने इसको चेंज नहीं किया, चलो अब आप इसको आंसर कर दो. द लैमिनार अबव द लैमिनार सब लेयर व्हिच एक्सपीरियंस द इफेक्ट ऑफ बोथ विस्कस फोर्सेस एंड टर्बुलेंस. कैन यू आंसर दिस क्वेश्चन गाइस? सो आई एम पुटिंग दिस क्वेश्चन इन फ्रंट ऑफ यू, प्लीज ट्राई टू आंसर. चलिए, सो गाइस अभी हम इसको लगातार रखेंगे नेक्स्ट 1.5 आवर ऑल्सो. 5 बजे हम ब्रेक लेंगे एंड बिफोर 5 वी विल ट्राई टू कवर एट लीस्ट 40 क्वेश्चंस. ठीक है, तो 5 बजे कुछ ब्रेक लेंगे 10-15 मिनट का एंड देन वी विल मूव टू नेक्स्ट क्वेश्चन ऑल्सो. lots of students they are answering A. बहुत सारे बच्चे A आंसर कर रहे हैं. yes, which is actually not right for this question, जो कि इस क्वेश्चन के लिए सही नहीं है. Yes, C is the right answer. तो मैं भूल गया बिकॉज NPTEL असाइनमेंट में ऐसे ही था, मैं एक्चुअली इसमें एक चेंज करने चाह रहा था. मैं चेंज क्या करना चाह रहा था, द लेयर विच एक्सपीरियंस, मैं सिर्फ ये हटाना चाह रहा था एक्चुअली, क्योंकि इससे तो बहुत क्लियर हो जाता है. जब इसमें आपको ये मिल गया ना, द लेयर अबव द लैमिनार सब लेयर, इट मींस एक आंसर तो मिल गया कि दिस इज नॉट लैमिनार सब लेयर, यस और नो. एंड देन आल्सो इफ यू आर आंसरिंग ऑप्शन ए, इट मींस यू आर नॉट रीडिंग दैट क्वेश्चन कंप्लीटली. उसने एक चीज तो बोली दी आपको, लेयर अबव द लैमिनार सब लेयर. लैमिनार सब लेयर कहां होता है बच्चों? लैमिनार सब लेयर एग्जिस्ट इन द टर्बुलेंट रीजन. टर्बुलेंट रीजन में क्या होता है आपका, लैमिनार सब लेयर होता है. देखो ये आपका होता है टर्बुलेंट रीजन, ये आपका लैमिनार रीजन होगा एंड दिस इज योर टर्बुलेंट रीजन, समथिंग लाइक दिस. इन दिस टर्बुलेंट रीजन एक बहुत स्मॉल लेयर होता है क्लोज टू द सरफेस, जिसे हम बोलते हैं लैमिनार सब लेयर. लैमिनार सब लेयर, ओके, लैमिनार सब लेयर. ओके, टर्बुलेंट रीजन के अंदर एग्जिस्ट करता है लैमिनार सब लेयर एग्जिस्टिंग द टर्बुलेंट रीजन, वेयर the viscosity क्या करती है, डोमिनेट करती है. विस्कस फ्लो क्या करता है, डोमिनेट करता है. ओके, दिस इज द स्मॉल लेयर इन द टर्बुलेंट रीजन क्लोज टू द सरफेस वेयर विस्कस फोर्सेस डोमिनेट्स. विस्कस फ्लो, ओके, विस्कस फ्लो क्या करता है, डोमिनेट करता है. That's why it is known as laminar sublayer. Because laminar का दूसरा नाम क्या होता है? Laminar means viscous flow. Turbulent means in viscous, kind of what mixing will be there. So viscosity is, when viscosity is very very high, so you're going to have laminar flow. The flow will be layer by layer. Okay. Actually में boundary layer से बाहर flow क्या आता है? In viscous. इसे हम क्या बोलते हैं? In viscous. So turbulent को in viscous बोलना is not right. Okay, that's why I'm correcting it. So this is your viscous flow. Viscous flow लेयर बाय लेयर फ्लो होता है, एंड दिस इज योर मिक्स्ड फ्लो. ये आपका क्या हो जाएगा? मिक्स्ड हो जाएगा, लैमिनार टर्बुलेंट, एंड दिस इज योर टर्बुलेंट फ्लो. तो टर्बुलेंट में इनिशियली तो एक लेयर मिलेगी जहां पे विस्कस डोमिनेट करेगा, फिर एक मिलती है बफर लेयर. ये क्या मिलती है? बफर लेयर. बफर लेयर थोड़ा सा लैमिनार सब लेयर से ज्यादा थिक होती है, बफर लेयर. ओके, इस बफर लेयर में क्या होता है? यू आर गोइंग टू हैव टर्बुलेंट फ्लो, टर्बुलेंट फ्लो इज आल्सो गोइंग टू डोमिनेट, एंड विस्कस फ्लो इज आल्सो गोइंग टू डोमिनेट. बोथ आर कंपेरेबल, both are comparable to each other. That's why this is known as buffer layer. और buffer layer के ऊपर क्या होता है आपके पास? turbulent flow. इसके ऊपर क्या होता है आपका? turbulent region. This is your turbulent region. Okay, turbulent region. So in turbulent region, entire turbulent region, we are having three layers. One is the lower layer, which is known as laminar sublayer, जहां पे viscous flow dominate करेंगे. उसके बाद क्या होगा? buffer layer होंगी, जिसमें laminar और turbulent दोनों क्या होंगे? दोनों डोमिनेट करेंगे. तो उससे पूछा भी आपसे, विच एक्सपीरियंस द इफेक्ट ऑफ बोथ विस्कस फोर्सेस एज वेल एज टर्बुलेंस फोर्सेस. ऐसी कौन सी लेयर है जिसमें विस्कस भी होता है और टर्बुलेंस भी होता है? दैट लेयर इज नोन एज बफर लेयर. विस्कस लेयर में तो लैमिनार सब लेयर में विस्कस फोर्सेस दे आर गोइंग टू डोमिनेट, टर्बुलेंट में टर्बुलेंट फोर्सेस दे आर गोइंग टू डोमिनेट, एंड इन दिस बफर लेयर विस्कस फोर्सेस एज वेल एज टर्बुलेंट फोर्सेस दे आर कंपेरेबल टू ईच अदर. दैट्स व्हाई दैट लेयर इज नोन एज बफर लेयर. ओके, हालांकि इसको बहुत बार इसको सेग्रीगेट करना भी बड़ा डिफिकल्ट होता है. It is not very easy. Laminar sublayer को ऑब्जर्व करना भी is very difficult. You will be easily able to analyze the laminar sublayer अगर आपके पास क्या होता है? बोलते हैं ना स्मूथ फ्लो. ओके, स्मूथ फ्लो होता है. लाइक इफ यू आर हैविंग ए बाउंड्री, आपने सुना होगा निकोल्डस क्राइटेरिया इन समवेयर इन फ्लूइड डायनामिक्स. यू स्टडीड अबाउट निकोल्डस क्राइटेरिया. लाइक सपोज इफ द सरफेस रफनेस, हाइट ऑफ द सरफेस रफनेस इज वेरी लेस, height of the surface asperties are very less as compared to the thickness of the laminar sublayer. जो surface की जो asperties है वो क्या है? बहुत कम है. Like suppose this is any surface, ये कोई surface है और इस surface के ऊपर this is your laminar sublayer. Okay, ये क्या है आपका? laminar sublayer. Okay, these are your surface asperties and this is your thickness of laminar sublayer. Thickness of laminar sublayer. So if thickness of laminar sublayer is more than the thick, surface irregularities, surface asperties, तो वहां पे आपको flow कैसा मिलता है? आपको यहां पे आपको थोड़ा सा स्मूथ फ्लो मिलेगा, एंड दिस लैमिनार सबलेयर विल एग्जिस्ट. बट इफ द सरफेस asperties are very high, roughness is very high, and even that surface thickness, laminar sublayer thickness is high, laminar surface thickness is high, but the surface irregularities are very high. In that case, due to the penetration of the fluid, they will sweep that laminar sublayer. The fluid is going to sweep the laminar sublayer, तो वहां पे आपको laminar sublayer नहीं दिखेगा. So it depends on the flow. So if you are having a hydrodynamically smooth boundary, if you are having a hydrodynamically smooth surface, then you are going to observe this laminar sublayer. तो एक criteria होता है ना बच्चों, I think somewhere in fluid you studied Nicoldus criteria. What is hydrodynamically smooth? What is hydrodynamically rough surface? Okay, that segregation I think you know. So for this question, the answer is option C. चलिए next question में move करते हैं. चलिए, let's read this and try to answer this question. Please read and answer, guys. Yes, Chandan, very good. For the case of fluid flowing inside a cylindrical pipe, the term hydrodynamically region refers to. Hydrodynamic region किसको refer करता है? Can you answer this question, guys? Hydrodynamically region refers to what? किसको रेफर करता है बच्चों? बिल्कुल सही, बस इसको फुली ना करके फुल्ली कर लेना, ये थोड़ा सा मिस्टेक है. फुल्ली डेवलप्ड. Okay, already I explained, guys, in a case of pipe flow, initially when the fluid will enter into the pipe, the viscous effect cannot be influenced throughout the cross section. Initially तो पूरे cross section पे उसको feel नहीं किया जा सकता. So outside the fluid you will have a velocity profile something like this. Okay, road like shape है ना, ऐसा कुछ velocity profile मिलेगा आपको. Everywhere the velocity profile will be same, something like this. The velocity profile will be something like this before entering into the pipe. After entering also, like small region पे क्या करेगा आपका? Because boundary layers they are going to grow something like this. Okay, something like this. तो यहाँ पे क्या होगा? In this region देयर विल बी नो इफेक्ट ऑन द वेलोसिटी प्रोफाइल। यहाँ पे तो वेलोसिटी प्रोफाइल पे कोई ज्यादा इफेक्ट नहीं आएगा, यहाँ पे आएगा, यहाँ पे आएगा, एंड आफ्टर दैट ऑल्सो अगेन द वेलोसिटी प्रोफाइल इज गोइंग टू बी चेंज, समथिंग लाइक दिस। बट आफ्टर बिकमिंग द फुल्ली डिवेल्प फ्लो, फुल्ली डिवेल्प फ्लो में वेलोसिटी प्रोफाइल क्या हो जाएगा आपका, इट विल डिवेल्प फुल्ली एंड इट इज नॉट गोइंग टू चेंज। वेलोसिटी प्रोफाइल आपका क्या करेगा, चेंज नहीं करेगा। आपको सर आपका तो चेंज कर रहा है, आई एम ड्राइंग दीज वेरी क्विकली, वेरी फास्टली। इफ यू विल रेफर टू योर स्टैंडर्ड टेक्स्ट बुक यू विल फाइंड क्लियर कट सेग्रीगेशन। अभी मैं उतना एक्यूरेसी से इसको ड्रॉ नहीं कर सकता, यू नो, टाइम इज वेरी इंपॉर्टेंट। सो आई होप यू आर गेटिंग द डिफरेंस। यहाँ पे वेलोसिटी प्रोफाइल क्या करता है, दिस इज नोन एज डेवलपिंग फ्लो, डेवलपिंग फ्लो। ओके, विस्कस इफेक्ट को आप पूरे क्रॉस सेक्शन पे इन्फ्लुएंस एनालाइज नहीं कर सकते, वेलोसिटी प्रोफाइल क्या करेगा, चेंज करेगा। ओके, वेलोसिटी प्रोफाइल इज चेंजिंग, वेलोसिटी प्रोफाइल changes. Okay, and when the boundary layers they meet, the velocity profile will become uniform, velocity profile uniform. Okay, इसे हम बोलते हैं developed flow, hydrodynamically developed flow, developed flow. ओके, जनरली तो हम इसी को ट्रीट करते हैं। और इस लेंथ को क्या बोलते हैं बच्चों, दिस डेवलपिंग फ्लो, ये जो होता है इस लेंथ को बोलते हैं एंट्रेंस लेंथ। दिस लेंथ इज नोन एज एंट्रेंस लेंथ, एल इज नोन एज एंट्रेंस लेंथ। Okay, it is a length, it is a distance traveled by the fluid from the leading edge of the pipe up to which the fluid is developing, fluid flow is developing, entrance length। इस लेंथ को हम क्या बोलते हैं, एंट्रेंस लेंथ। ठीक है, चलिए, तो टर्बुलेंट में ज्यादा होगी एंट्रेंस लेंथ या इट विल बी मोर इन लैमिनार? एंट्रेंस लेंथ विल बी मोर इन लैमिनार और टर्बुलेंट बच्चों, किसमें ज्यादा होगी? फॉर दिस क्वेश्चन बी इज द राइट आंसर। कैन यू कमेंट, आई एम वेटिंग फॉर योर आंसर। एंट्रेंस लेंथ इन जनरल entrance length will be more in laminar or turbulent? चलिए, try to answer. Let's move to this question also. Please read and answer this question. बिल्कुल सही राहुल विश्वनाथ, एंट्रेंस लेंथ विल बी मोर इन लैमिनार, बिल्कुल सही। टर्बुलेंट में एंट्रेंस लेंथ विल बी लेस बिकॉज ड्यू टू इंटरमिक्सिंग ऑफ द फ्लूइड the very quickly the viscous effect can be enhanced, can be influenced throughout the cross section। पूरे के पूरे देखो, एक बच्चा है जो हर जगह, अभी कोरोना में क्या हो रहा है, कोरोना में अगर आप बहुत जगह घूम रहे हो, इधर उधर हर जगह घूम रहे हो, तो पेनिट्रेशन क्या हो जाएगा, ज्यादा हो जाएगा, कोरोना होने के चांसेस क्या रहेंगे, ज्यादा रहेंगे, है ना। तो लैमिनार में ऐसा होता है कि लेयर बाय लेयर मूव करता है, तो पेनिट्रेशन बहुत कम होता है, विस्कस इफेक्ट बहुत स्लोली डिसिपिएट करता है, तो एंट्रेंस लेंथ कंपैरेटिवली ज्यादा होता है। टर्बुलेंट में ड्यू टू इंटरमिक्सिंग ऑफ द फ्लूइड एंट्रेंस लेंथ इज कंपैरेटिवली लेसर एज कंपेयर्ड टू द लैमिनार फ्लो। चलिए, इसको आंसर करो। A boundary layer exists over an isothermal flat plate assuming these kind of velocity profile। ये किसके लिए होता है बच्चों, these kind of velocity profile कहाँ अपने को ऑब्जर्व करते हैं हम, इस तरह का velocity profile और temperature profile हम कहाँ ऑब्जर्व करते हैं, turbulent flow में। तो ये ध्यान, बस थोड़ा सा ऑब्जर्वेशन रखना, turbulent flow में इस तरह का velocity profile होता है अपना। ओके, पावर लो, टर्बुलेंट में दिस काइंड ऑफ वेलोसिटी प्रोफाइल, टेम्परेचर प्रोफाइल वी आर गोइंग टू हैव। लैमिनार फ्लो में कैसा होता है बच्चों, इन लैमिनार फ्लो वी आर हैविंग u by u infinity equal to 3/2 y by delta minus 1/2 y by delta cube। लैमिनार में कुछ ऐसा होता है, बस थोड़ा सा ऑब्जर्वेशन रखना बस। दिस इज द वेलोसिटी प्रोफाइल इन केस ऑफ लैमिनार फ्लो, लैमिनार फ्लो। ओके, ये तो होता है, याद नहीं रखना, बस थोड़ा सा याद रखना है, डिफरेंस होना चाहिए कि ये सर दिस इज फॉर टर्बुलेंट, ऐसा कुछ टर्बुलेंट में होता है और ऐसा कुछ किसमें होता है, लैमिनार में। लैमिनार में अगर टेम्परेचर लिखना चाहो तो टेम्परेचर होता है T इंफिनिटी माइनस TW। ओके, यहाँ पे हो जाएगा T माइनस T इंफिनिटी लिख देते हैं, T माइनस T इंफिनिटी, T माइनस TW by T इंफिनिटी माइनस TW that is equal to 3/2। only the difference is what, यहाँ पे इसमें डिफरेंस क्या है, डेल्टा की जगह क्या आ जाएगा, डेल्टा थर्मल, y बाय डेल्टा थर्मल माइनस 1/2 y बाय डेल्टा थर्मल क्यूब। ओके, पैराबोलिक होता है, कैसा होता है आपका, पैराबोलिक। ओके, पैराबोलिक, लैमिनार फ्लो टेम्परेचर प्रोफाइल, लैमिनार फ्लो वेलोसिटी प्रोफाइल। ओके, टेम्परेचर प्रोफाइल एंड वेलोसिटी प्रोफाइल फॉर लैमिनार फ्लो। ये जनरली हम एज्यूम करते हैं, इस तरह का वेलोसिटी प्रोफाइल हम क्या करते हैं, एज्यूम करते हैं। ओके, चलिए, एंड दिस इज फॉर टर्बुलेंट फ्लो। तो इस टर्बुलेंट फ्लो के लिए पूछ रहा है आपसे कि क्या रिलेशन है, कौन सा रिलेशन हम यूज करते हैं, which relationship we use for this turbulent flow। तो now can you answer this question guys, can you answer this question? तो कौन सा आंसर होगा आपका, let me check your answer। C, बिल्कुल सही बच्चों, those are answering C इस केस के लिए। अभी देखो, इस केस में आपको बिल्कुल सोचना है, दिस इज अ केस ऑफ टर्बुलेंट फ्लो, बिल्कुल सही। ओके, सो नसेल्ट नंबर इक्वल टू दिस 0.00292 रेनॉल्ड्स की पावर 4/5 into Prandtl number। This is because he mentioned Prandtl number is close to 1। उसने बता दिया कि Prandtl number क्या है, this is close to 1. So C is the right answer. तो देखो कुछ रिलेशनशिप आप याद रखना. This is a relationship which you can remember for the turbulent flow. Okay. देखो चार केसेस मैं आपको बता रहा हूं. Laminar flow inside pipe, turbulent flow inside pipe. Laminar flow inside pipe के लिए क्या था? Nusselt number equal to 3.66 constant wall temperature. Nusselt number equal to 4.36 constant heat flux. Turbulent flow inside pipe, Dietz-Boelter equation. टर्बुलेंस फ्लो इन पाइप के लिए क्या यूज करोगे आप? डिटेस-बोल्टर इक्वेशन लिखेंगे हम, याद करेंगे उसको भी. और लैमिनर फ्लो ओवर फ्लैट प्लेट के लिए दोज टू इक्वेशन, लैमिनर फ्लो ओवर फ्लैट प्लेट एंड टर्बुलेंट फ्लो ओवर फ्लैट प्लेट. सो दिस इज फॉर टर्बुलेंट फ्लो ओवर फ्लैट प्लेट. चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं. तो अभी ये पूछ रहा है आपसे NUX. नेक्स्ट क्वेश्चन मूव करते हैं बच्चों. अभी आपसे पूछ रहा है इस क्वेश्चन में व्हाट इज द लोकल कन्वेक्शन हीट ट्रांसफर कोएफिशिएंट HX. तो उसी रिलेशनशिप को यूज करके कैन यू टेल मी व्हिच वन इज राइट गाइस? अभी थोड़ा सा सिंपलीफिकेशन है. इट्स लाइक सिंपलीफिकेशन. हाँ बिल्कुल होगा वैभव, बिल्कुल होगा. बट ही मेंशन्ड कि कंसीडर दैट Prandtl नंबर क्लोज टू 1. ओके, कंसीडर Prandtl नंबर क्लोज टू 1. अगर एग्जैक्ट रिलेशनशिप आप उसका चाह रहे हो तो यू कैन राइट. ओके, सो देयर इज Prandtl नंबर आल्सो. Prandtl नंबर भी होगा वहां पे. Okay, we will have Prandtl number also, and generally we take power 1/3 only for the turbulent flow over flat plate. चलिए, can you answer this question guys? Is asking you HX. तो नसल नंबर क्या था बच्चों? नसल नंबर NUX equal to 0.0292 REX की पावर 4/5 into Prandtl नंबर. आपसे पूछ रहा है HX क्या होगा? What is HS? तो क्वेश्चन सिंपल है बट आपको थोड़ा सा इसको सोल्व करना है. Yes, try to answer this question guys. नहीं C गलत है बच्चे. C is not right. Please check it again. C is not right for this question guys. देखो नसल नंबर क्या होता है? दिस इज HX into X by K. HX into X by K. तो देखो इसको इधर ले लो यार, थोड़ा सा सिंप्लीफिकेशन करते हैं. देखो HX equal to K by X into 0.0292 RE की पावर 4/5 into Prandtl नंबर. ओके, देखो अभी क्या करते हैं, यहां पे कुछ दिख रहा है? रो CP दिख रहा है ना? रो म्यू CP U इन्फिनिटी दिख रहा है. तो हम क्या करते हैं, इसको मल्टीप्लाई कर देते हैं. रो CP U इन्फिनिटी. ओके, रो CP U इन्फिनिटी. रो CP U इन्फिनिटी से डिवाइड कर दिया एंड वी मल्टीप्लाइड बाय रो U C इन्फिनिटी. रो CP U इन्फिनिटी. ओके, अभी देखो व्हाट इज दिस? ये क्या हो जाएगा बच्चों? देखो व्हाट इज दिस? रेनॉल्ड्स नंबर क्या होता है आपका? रेनॉल्ड्स नंबर इज रो V X by mu. Okay, रो V X by mu. रो V X by mu. ठीक है, रो V X by mu. हम इसको म्यू CP से करते हैं बिकॉज अपने को तो म्यू CP चाहिए ना, वी वांट म्यू. तो हम इसको करते हैं म्यू CP से. सो दिस इज यस, वी वांट इट हियर म्यू आल्सो. अपने को यहां पे चाहिए म्यू, तो म्यू पर चाहिए अपने को. Prandtl नंबर तो है अपने पास, चलो ठीक है. Prandtl नंबर को हटा देते हैं बिकॉज वी वांट म्यू. अपने को म्यू चाहिए. सो लेट मी रिमूव दिस Prandtl number. लेट मी राइट Prandtl number as mu CP by K. ओके, mu CP by K. ओके, सो K से तो K कट जाएगा अपना. एंड नाउ वी वांट इट हियर रेनॉल्ड्स नंबर. X है हमारे पास, सो नाउ वी कैन राइट इट हियर V मींस U इन्फिनिटी. U इन्फिनिटी यहां लिख देता हूं मैं, U इन्फिनिटी यहां लिख देता हूं मैं. CP तो ऑलरेडी हमारे पास आ गया है. ओके, एंड वी वांट व्हाट? म्यू. तो म्यू भी आ गया अपने पास. ठीक है, तो U भी आ गया. नाउ यू कैन रिप्लेस. अब इसका आप रिप्लेस कर सकते हो. सो V रो आल्सो यू कैन राइट रो आल्सो हियर एंड हियर आल्सो यू कैन राइट रो. नाउ इजीली यू विल गेट. चलिए देखो व्हाट इज दिस रो UX by mu. What is rho mu X by mu? This is Reynolds number. So this entire relationship we can write it something like this: rho U infinity into CP into 0.0292 into Reynolds की power 4/5 divided by Reynolds की power Reynolds. Okay. Further, if you will carry out the simplification, you will get rho mu CP, rho U infinity CP into 0.0292 Prandtl number की power 4/5 minus 1. तो क्या हो जाएगा बच्चों? It will be minus 1/5. Okay, Reynolds की पावर -1/5. So this is your hx, relationship for hx. ठीक है, this is relationship for hx. इसको मैं ऊपर लिख देता हूं ताकि हम इसको थोड़ा सा सेग्रीगेट कर पाए. This is your re something like this. ठीक है, so which one is matching guys? कौन सा मैच कर रहा है आपका ऑप्शन? बिल्कुल आपका मैच कर जाएगा, ऑप्शन 1 will match and this is the right answer for this question. Okay, ऑप्शन ए इज द राइट आंसर फॉर दिस क्वेश्चन. तो कई बार वो इस तरह के सिंपल क्वेश्चन भी पूछ लेता है, सो ओनली यू नीड टू कैरी आउट द सिंप्लीफिकेशन. सो ही इन फर्स्ट क्वेश्चन ही आस्क्ड यू like what relationship we use for the turbulent flow. So we answered this question. This is a relationship for the Nusselt number for the turbulent flow over flat plate. And now in second case he asked you the relationship for local convection heat transfer coefficient. So only we carry out the simplification, some terms we removed and we got the answer hx equal to this. Okay, chaliye let's move to next part. Also in next part he is asking you, this is comparatively more good question, bahut acha question hai. In this question he is asking you nu bar. What is this nu bar guys? This is average Nusselt number. Average Nusselt number. Average Nusselt number. आप सब कहो सर एवरेज क्या होता है? You know guys, hx we can find out at leading edge, hx we can find out at trailing edge, hx we can find out at any distance from the leading edge. In this question is asking you what is average Nusselt number. तो average कैसे निकालोगे बच्चों? How you are going to find out average Nusselt number? For that you need to check first hx is a function of what? x का कितना function है? So ये आपको चेक करना पड़ेगा. First you need to check like h bar. What is the relationship between h bar and hl? Okay, what is the relationship between h bar and hl? h bar में और hl में क्या relation है? If you are able to calculate that relationship between h bar and hl, h bar और hl में अगर आपने relationship निकाल लिया, इन दोनों के बीच में क्या relationship है, then easily you will get the answer. तो ये कहां से आएगा बच्चों? From where you will get the answer? देखो थोड़ा सा सिंपल एक अप्रोच होती है, वो मैं आपको यहाँ पे बता देता हूँ. Let me tell you that very simple concept. मैं यहाँ पे इसको यूज करता हूँ because this is more useful. ये बहुत ज्यादा important है हमारे लिए, इसको यूज करता हूँ मैं. Okay. You know guys, this relationship we know for this turbulent case, Nusselt number NUX equal to 0.0292 RE की power 4/5 into Prandtl. Yes or no guys? This relationship we are having. अब इस relationship को अगर मैं ऐसा लिखता हूँ HX by K is equal to 0.0292 Reynolds is rho Vx by mu की power 4/5 into Prandtl number. Yes or no? क्या लिख सकता हूँ ऐसा? Yes, very easily we can write. Now from this entire relationship, can you tell me this hx is a function of, hx is directly proportional to x की power 4/5 divided by x. Yes or no? Can you tell me? Can you conclude guys? From this relationship, can you conclude hx, this local convection heat transfer coefficient, this is directly proportional to x की power 4/5, but this x also you are having, so this is directly proportional to x की power 4/5 by x. Okay, so if you will consider all different terms as constant, other terms as constant, we can write hx equal to some constant into x की power -1/5. क्या ऐसा लिख सकते हैं बच्चों? लिख सकते हैं? Okay, 4/5 minus 1, तो क्या हो जाएगा? Yes, it will be -1/5. It will be -1/5. This is very important relationship. ये बहुत इंपॉर्टेंट रिलेशनशिप है. अब इसको रिलेशन को यूज करके we can find out the relationship between h bar and hx. c into x की पावर -1/5. अब देखो इनका रिलेशनशिप क्या होता है बच्चों? h bar is nothing but 0 to L 1/L 0 to L hx dx. I think somewhere in heat transfer you studied about this. H bar equal to 1/L integration 0 to L hx dx. Yes or no? Now you can write it here 1/L integration 0 to L. What is hx? क्या hx को मैं can I write it as c into x की पावर -1/5 dx? क्या लिख सकता हूँ? Yes or no guys? Can I remove this hx? Can I write this hx as c into x की power -1/5? Yes, we can write it very simply. And then you can write it as 1/L into, if you will carry out the integration, अगर आप थोड़ा सा इंटीग्रेशन करते हो बच्चों, अगर आप इंटीग्रेशन करते हो, so this is c you can take it outside, x की power -1/5 plus 1, -1/5 plus 1, so it will become x की power 4/5 divided by 4/5. Limit 0 to L. Yes or no? चेक भी कर लेते हैं. 1/5 plus 1, तो ये हो जाएगा 1/5, 5 will be LCM, so 1 plus 5 minus 1 plus 5, yes, it will be 4/5, बिल्कुल सही. ठीक है, चलिए कुछ रट्टा नहीं मारना चाहिए, अपने को सोल्व करके देखना चाहिए. So this you will get. So if you will further put the limit, h bar will come out c by L into L की power 4 by 5, and this 4 by 5 you can write it as 5 by 4. This you can write it as 5 by 4. Yes or no? Very easily you can write it something like this. Further, if you will remove this C, because C को, can I write this C as, C क्या था बच्चों मेरा, hx equal to C into x की power minus 1 by 5. तो क्या मैं इसको ऐसा भी लिख सकता हूँ, HL equal to C into L की power minus 1 by 5? Yes or no? C is constant. C क्या है, constant है. hx equal to C into x की power minus 1 by 5. H at x equal to L. What is H at x equal to L? That is HL. So HL equal to C into x will become L, L की power minus 1 by 5. So this value, if you'll put it here, C equal to HL divided by L की power minus 1 by 5. So if you'll remove this C here, you will get HL divided by L की power minus 1 by 5 into L की power 4 by 5 into 5 by 4. Yes or no guys? This you are going to have. And what is this? 1 into this. इन दोनों को अगर आप मल्टीप्लाई करोगे, so power will become addition, power add हो जाएंगी, and you are going to get this L की power 4 by 5 only. So this will cancel out. So you will get H bar equal to 5 by 4 HL. H bar equal to 5 by 4 HL. So how many of you are getting this idea, guys? How many of you are getting this relationship? For the turbulent flow over a flat plate, turbulent flow over a flat plate, if you want to calculate average convection heat transfer coefficient, so just calculate HL. पहले क्या कर लो, HL calculate कर लो, and then multiply that HL with 5 by 4. Okay, but this same approach you cannot apply for laminar flow. Laminar के लिए नहीं कर सकते इसको. Laminar के लिए I'm giving you exercise. Can you tell me, अगर आपको याद है तो क्या मेरे को relationship बता सकते हो बच्चों? Can you get that relationship? क्या निकाल सकते हो आप H bar and HL का relationship? H bar and HL का relationship. Can you tell me for the laminar flow? Laminar flow. Yes. ठीक है, बिल्कुल सही, very good. Laminar, it is very easy. Only you need to take 2 times. HL, average convection heat transfer, is 2 times of the HL. Laminar के लिए just calculate HL. HL means calculate convection heat transfer coefficient at the trailing edge. Multiplied by 2, you will get average convection heat transfer coefficient for the laminar flow over flat plate. But for the turbulent flow over flat plate, first you need to calculate HL at the trailing edge, then you need to multiply by that 5 by 4. बिल्कुल सही बच्चों. तो अभी इस क्वेश्चन को आंसर कर सकते हो आप. H बार अपने को पता चल गया. तो अभी जो रिलेशनशिप था हमारे पास, इससे पहले वाला जो रिलेशनशिप था, ये वाला जो रिलेशनशिप था, इस रिलेशनशिप को अगर मैं, ये जो रिलेशनशिप था हमारे पास, दिस इज अ रिलेशनशिप फॉर लोकल, यू नो, दिस लोकल नसेल्ट नंबर, दिस रिलेशनशिप फॉर लोकल नसेल्ट नंबर. बट अपने को रिलेशनशिप चाहिए एवरेज नसेल्ट नंबर के लिए. दिस रिलेशनशिप फॉर लोकल नसेल्ट नंबर. तो एवरेज का क्या रिलेशनशिप हो जाएगा बच्चों? तो यू नीड टू मल्टीप्लाई दिस एंटायर टर्म विद 5 by 4. इसको क्या कर दो आप, 5 by 4 से मल्टीप्लाई कर दो. 5 by 4 into, तो आपको रिलेशनशिप एक ही याद रखना होता है, बाकी तो अपने आप आ जाते हैं. 5 by 4 मल्टीप्लाई बाय 0.0292 into RE की पावर 4 by 5 into Prandtl नंबर. ठीक है बच्चों, तो बस आपको ये कैलकुलेट कर लो, इसको देखो क्या आ रहा है, एंड दैट विल बी योर आंसर. तो कंसेप्ट इज वेरी सिंपल, बहुत चीजें बहुत सिंपल है, बस आपको समझना है. ठीक है, आई होप यू गॉट द पॉइंट. व्हाई एक्चुअली आई एम मल्टीप्लाइंग इट विद 5 by 4. लैमिनार में क्या होता है बच्चों? लैमिनार में हमारे पास नंबर क्या होता है? 0.332. आई थिंक यू विल बी एबल टू रिकॉल. 0.332, उसको हम क्या मल्टीप्लाई करते हैं? व्हेन वी मल्टीप्लाई बाय 2, तो एवरेज नसेल्ट नंबर में क्या आ जाता है? 0.664. ठीक है, बिल्कुल सही. उसमें क्या हो जाता है? 0.664, बिकॉज वी मल्टीप्लाइड बाय 2. Why? Because average Nusselt number is 2 times of the local Nusselt number at the trailing edge. चलिए, तो इसको आंसर करते हैं, and then we will move to the next question. तो इस क्वेश्चन के लिए आंसर हो जाएगा मेरे ख्याल से ऑप्शन ए. You can calculate and that will be the right answer for this question. बिल्कुल सही, ऑप्शन ए क्या हो जाएगा? This will be the right answer for this question. चलिए, let us now move to next question, guys. Next question move करते हैं. This is comparatively simple question and you can answer this question. So for a Prandtl number 1.3, density 1000, U infinity 1 meter per second, dynamic viscosity, conductivity Cp, the local Nusselt number at a distance 1 centimeter from the leading edge. He is asking you Nusselt number at a distance 1 centimeter from the leading edge. Typical GATE question, guys. Typical GATE question. ठीक है, चलिए, please try to answer this question, guys. I am giving you some time, please answer. There are 4 options. You need to answer this question. Yes. What you are getting, guys? Option A. How many are getting option A? बिल्कुल सही बच्चों. Those are getting option A. They are very right. Option A is the right answer for this question. So only you need to calculate Reynolds number, rho Vx by mu. Okay, या इसको आप लिख सकते हो Vx by mu. V is given to you 1 meter. X is what? At a distance 1 centimeter. So 1 into 10 की power minus 2 divided by nu. Okay, nu is given to us. Mu is only directly given to us. तो इसको लिख लो आप. ये लिख लो 0.001 divided by 1000. Okay, तो इसको मैं multiply by 10 की power minus 3 कर देता हूँ, है ना. So this is your nu. Okay, so from this you will get the Reynolds number. From this you will get the Reynolds number. कितना वैल्यू आ रहा है बच्चों? What is the value you are getting? क्या आंसर आ रहा है आपका? कितना वैल्यू आपका आ रहा है इसमें? Reynolds number. What value of Reynolds number you are getting in this question? तो अगर आप इसको सोल्व करोगे you will get 10,000, close to 10,000. So 10,000 you will get, and 10,000 is less than 5 into 10 की power 5. Okay, 10,000 is less than 5 into 10 की power 5 means the flow is laminar. फ्लो इज लैमिनार. अभी तक हमने टर्बुलेंट का डिस्कस किया था. अभी हमारे पास एक केस आ गया जिसमें फ्लो क्या है? टर्बुलेंट. बिकॉज रेनॉल्ड्स नंबर फॉर द फ्लो इनसाइड पाइप, इफ रेनॉल्ड्स नंबर इज लेस देन 2000, फ्लो इज लैमिनार. द रेनॉल्ड्स नंबर इज बिटवीन 2 to 4000, the flow is in transition. If the Reynolds number is more than 4000, the flow is turbulent for flow inside pipe. But for flow over flat plate, if the Reynolds number is less than 5 lakhs, the flow is laminar. If it is more than 5 lakhs, the flow is turbulent. As it is very less than 5 lakhs, the flow is laminar. And then you need to use this relationship. Laminar के लिए कौन सा relationship use करते हैं बच्चों? अभी मैंने आपको hint दिया भी था. NUX equal to 0.332 Reynolds की power 1 by 2 Prandtl की power 1 by 3. Okay, this is the relationship which you need to use. Because आपको local पूछ रहा है वो, he is asking you local only. He is asking you local Nusselt number, so you need to use this equation. Don't use this. इसको use नहीं करना. 0.664 Reynolds की power 1 by 2 Prandtl की power 1 by 3. This you can use for finding out average convection heat transfer coefficient. Okay, this is for average. This one is for average. This one is for local Nusselt number. So everything is given to you. Like we calculated this. Prandtl number is directly given to you. So if you put all these values, ये सारी values अगर आप put करोगे, Reynolds number put करोगे, Prandtl number put करोगे, multiply by 0.332, you will get this Nusselt number 60.16. Option A, you will get the answer. Yes, Prandtl number की power 1 by 3. बिल्कुल सही विश्वनाथ. Prandtl power 1 by 3. अभी करते हैं नेक्स्ट क्वेश्चन पे मूव, जो कि बहुत अच्छा क्वेश्चन होने वाला है. बिकॉज ये भी गेट के स्टैंडर्ड का क्वेश्चन है. बिल्कुल गेट वाला क्वेश्चन है बच्चों. अभी पूछा नहीं गया ऐसा क्वेश्चन, बट बहुत अच्छा क्वेश्चन है. सिंपल है बट थोड़ा सा लगे हटके है, तो यू नीड टू अप्लाई योर माइंड. देयर इज अ फ्लो इन अ फ्लो ऑफ अ फ्लूइड थ्रू अ ट्यूब इफ द वेलोसिटी इज डबल्ड. For the flow inside a tube, flow inside tube, if the velocity is doubled, what will be the effect on average heat transfer coefficient? It may be presumed that there is no change in the temperature, liquid and tube wall, and the flow is turbulent. ये है बोलते हैं ना जो मास्टर क्वेश्चन है, जो क्या बोलते हैं, छोटा क्वेश्चन बट बड़ा धमाका है ना. सो बहुत छोटा क्वेश्चन लग रहा है बट इट इज वेरी ब्यूटीफुल क्वेश्चन. सो आई एम वेटिंग फॉर योर रिस्पॉन्स गाइस. प्लीज ट्राई टू आंसर. मैं आपको चलो एक हिंट दे देता हूं. Okay, as it is given, the flow is turbulent. मैंने आपको 4 इक्वेशन बताई थी बच्चों जो आपको याद रखनी है. फर्स्ट इज लैमिनार फ्लो इनसाइड पाइप, उसके लिए तो डायरेक्ट नसल नंबर क्या होता है, कांस्टेंट होता है, दैट यू नीड टू रिमेंबर. सेकंड, टर्बुलेंट फ्लो इनसाइड पाइप, उसके लिए हम यूज करते हैं डिटस बोल्टर इक्वेशन. डिटस बोल्टर इक्वेशन. क्या होता है बच्चों, इसमें क्या होता है नसेल्ट नंबर रिलेशनशिप, नसेल्ट नंबर इक्वल टू 0.023 ओके इनटू रेनॉल्ड्स की पावर 0.8 इनटू प्रिंडेल्ट की पावर n। दिस इज द रिलेशनशिप व्हिच वी यूज, ये वाला रिलेशनशिप हम यूज करते हैं। 0.023 रेनॉल्ड्स की पावर 0.8 इनटू प्रिंडेल्ट की पावर n, दिस इज द रिलेशनशिप वी नीड टू यूज। अब आप यहां से आप बड़ा इजीली आप आइडिया लगा सकते हो। आपसे पूछ रहा है hx पे क्या फर्क पड़ेगा, h पे क्या फर्क पड़ेगा बच्चों, h dy के। तो वेलोसिटी टर्म कहां आ रही है, देयर इज ओनली वेलोसिटी टर्म इन रेनॉल्ड्स नंबर। वेलोसिटी टर्म तो रेनॉल्ड्स नंबर में ना, रिमेनिंग ऑल थिंग्स आर सेम, रिमेनिंग ऑल थिंग्स आर सेम, देयर इज ओनली वेलोसिटी टर्म इन द रेनॉल्ड्स नंबर एंड इजीली। अब आपको इसको पूरे को नहीं देखना है, ओनली यू नीड टू एनालाइज दिस। आपको देखना क्या है बच्चों, देखो आपको देखना है कि सर ये मेरा NU1 है, इसको मैं बोल देता हूं NU1, ये जितना भी है मेरा, मेरे को नहीं पता ये मेरा जो भी है। NU2 क्या होगा, NU2 विल बी, मैंने इसको वेलोसिटी को डबल कर दिया एंड इफ वेलोसिटी इज डबल तो रेनॉल्ड्स नंबर कितना हो जाएगा बच्चों, रेनॉल्ड्स नंबर विल बी rho VD by mu, so can I take it as 2 की पावर 0.8, 2 की पावर 0.8, yes or no? So NU2 will become 1.741 NU1। क्या ये आइडिया आ रहा है आपको, फ्रॉम वेयर एक्सेप्ट। अब ये सारा कुछ आपको दिमाग में करना है, कैसे सर, रेनॉल्ड्स नंबर इक्वल टू रो वी डी बाय म्यू। आपने वेलोसिटी को डबल कर दिया, बट डबल किया है, बट डबल के पास क्या है, पावर क्या है बच्चों, पावर इज 0.8। सो इफ यू विल टेक पावर 0.8 यू विल गेट NU2 इक्वल टू 1.741 NU1। तो वही तो पूछ रहा है भाई, पहले था 100, ये था मेरा 100, ये था मेरा 1, ये था 1, ये हो गया 1.741, this is 1, this is 1.741, so how much is the increase, the increase is 74.1% increase, this is the increase in the Nusselt number। velocity बढ़ाने से हमारा Nusselt number क्या हो गया, बढ़ गया, it increased by 74.1%। तो बहुत छोटा क्वेश्चन है, सिंपल क्वेश्चन है, बट बड़ा यूनिक डिफरेंट क्वेश्चन है बच्चों। Okay, many times he can ask you, like he can ask you what is the effect of density on the Nusselt number, what is the effect of viscosity on the Nusselt number, what is the effect of velocity on the Nusselt number. So you need to realize, you need to analyze this relationship, you need to just carry out the calculation, like after taking the power what final result you are going to have। Okay, remaining all terms को आप neglect कर सकते हो, only you need to focus on velocity। He's saying very clearly, saying other things are same, only there is an increase in the velocity, velocity becomes 2 times। Yes, velocity becomes 2 times, very good Chandan, good, velocity becomes 2 times, so D is the right answer for this question। चलिए let us now move to next question। ये डायरेक्ट क्वेश्चन है, अभी हमारे 20 क्वेश्चन हो जाएंगे तो 2 घंटे में ना, चलिए कोशिश करेंगे आगे। देखो हीट एक्सचेंजर के क्वेश्चन आर लाइक टिपिकल गेट क्वेश्चन, दे आर नॉट गोइंग टू टेक मच टाइम, थोड़ा सा कैलकुलेशन रहेगा बट इजीली यू विल बी एबल टू सोल्व। ओके, रेडिएशन में अगेन वी आर गोइंग टू स्पेंड मच टाइम बिकॉज वेरी यूनिक डिफरेंट क्वेश्चन वी आर गोइंग टू सोल्व इन रेडिएशन। तो बाउंड्री लेयर फ्लो क्या होता है बच्चों, बाउंड्री लेयर फ्लो इज कैरेक्टराइज्ड बाय व्हाट, बाउंड्री लेयर फ्लो में रेनॉल्ड्स नंबर इज ग्रेटर देन 1 एंड फ्लो क्या होता है, डी एक्सेलरेटिंग फ्लो होता है। Boundary layer flow is known as de-accelerating flow। Boundary layer theory it was given by Prandtl, L Prandtl ने थ्योरी दी थी बाउंड्री लेयर थ्योरी, बाउंड्री लेयर थ्योरी which was given by L Prandtl in 1904। ओके, और इस थ्योरी में हम क्या मानते हैं कि इन द बाउंड्री लेयर रीजन रेनॉल्ड्स नंबर इज ग्रेटर देन 1। ओके, विस्कस फ्लो होता है बच्चों इन बाउंड्री लेयर में, विस्कस फ्लो का बाउंड्री लेयर इज ओनली गोइंग टू फ्लो इफ द फ्लूइड इज नॉट हैविंग एनी काइंड ऑफ वेलोसिटी। अगर फ्लूइड में विस्कोसिटी ही नहीं है, इफ द फ्लूइड इज फ्लो इज इन विस्कस देन देयर विल बी नो बाउंड्री लेयर फॉर्मेशन गाइस। Why? Because in viscous flow there will be no resistance offered by the fluid layer, there will be no velocity gradient, so there will be no boundary layer formation। Are you getting? So for the boundary layer formation the fluid is having some viscosity, it means Reynolds number is greater than 1, viscous flow होगा and the flow is de-accelerating type। बाउंड्री लेयर में फ्लो कैसा होता है, de-accelerating टाइप। तो ये मत आंसर कर देना सर बाउंड्री लेयर में तो रेनॉल्ड्स नंबर बहुत कम होगा, विस्कस फ्लो विस्कोसिटी की वजह से बाउंड्री लेयर फॉर्मेशन होता है बच्चों। फॉर आइडियल फ्लूइड फ्लो और फ्लैट प्लेट देयर विल बी नो बाउंड्री लेयर फॉर्मेशन बिकॉज़ आइडियल फ्लूइड्स आर इन विस्कस। ओके, इन विस्कस होगा तो देयर विल बी नो बाउंड्री लेयर फॉर्मेशन, देयर विल बी नो वेलोसिटी ग्रेडियंट्स। वेरी गुड, वेरी गुड, वेरी हेल्पफुल, यस गुड। चलिए इट्स गुड बच्चों, ये सुन के अच्छा लगता है इफ लाइक वी आर लाइक सम मेंटर्स दे आर सॉल्विंग सम क्वेश्चन एंड इफ इट इज हेल्पिंग दिस स्टूडेंट कम्युनिटी दैट इज वेरी गुड टू लिसन। चलिए नेक्स्ट क्वेश्चन पे हम मूव करते हैं बच्चों। दिस इज नेक्स्ट क्वेश्चन इन फ्रंट ऑफ यू, क्वेश्चन नंबर 21 से 23 दीज आर कॉमन डेटा क्वेश्चन, रीड दिस एंड ट्राई टू आंसर। क्वेश्चन नंबर 21 टू 23 दीज आर ऑप्शन, अच्छा ऑप्शन रॉन्ग। 18th में मैं क्या चेक करता हूं, 18th क्वेश्चन में क्या रॉन्ग हो गया भाई, क्या रॉन्ग है? अच्छा ऑप्शन, यू आर नॉट गेटिंग दिस आंसर, प्लीज चेक गाइस, बच्चों ने आंसर किया है, आई ऑल्सो कैलकुलेटेड, सो यू नीड टू अगेन चेक योर कैलकुलेशन गाइस, विश्वनाथ चेक करना अपना कैलकुलेशन, चलिए प्लीज ट्राई टू आंसर दिस क्वेश्चन गाइस, क्वेश्चन नंबर 21 to 23. ऑप्शन नहीं आ रहा है, 32.6 आ रहा है, ओके चलिए मैं आपके लिए कैलकुलेट करता हूं बच्चों, आई एम गोइंग टू कैलकुलेट दैट एंटायर डेटा, क्वेश्चन नंबर 18 you are mentioning, so plus first read this, okay, first read this, हाँ बिल्कुल सही बच्चों, मैंने भी इसको जब कैलकुलेट किया था तो उसमें थोड़ा गलती है, दिस एक्चुअली रॉन्ग ऑप्शन, इसमें जो आंसर आएगा आपका नसेल्ट नंबर यू विल गेट 36.234, अब उन्होंने ऑप्शन ए दिया था विच इज एक्चुअली रॉन्ग, दे एक्चुअली मेंशन्ड ऑप्शन ए एज द राइट आंसर बिकॉज एनपीटीईएल में, एनपीटीईएल असाइनमेंट में दे ओनली यू नो मोस्ट ऑफ द टाइम दे डोंट प्रोवाइड एनी काइंड ऑफ सॉल्यूशन, they only provide कि this is the right answer for that, okay, so they mentioned this as right answer which is actually wrong, so I think there is some kind of some kind of typing mistake, okay, कुछ किसी तरह का typing mistake है because question is very easy and we are getting this answer 36.234, क्योंकि आपसे वो NUX पूछ रहा है, NUX is 36.234, this is the answer you are going to get for this question, चलिए please read this and try to answer this question, 21 to 23 these are common data question, please read this guys and try to answer, क्वेश्चन नंबर 16 का NUX यूज किया है, हाँ बिल्कुल सही, देखो बच्चे ने यूज किया बट दैट इज एक्चुअली रॉन्ग ना, उसको यूज करना गलत है, ठीक है कई बार जल्दी जल्दी में हो जाता है, अभी वो गलत है, लेकिन अभी एक बच्चे ने अच्छा पकड़ा है, वो कह रहा है सर कि उन्होंने क्या किया, दे यूज्ड दिस रिलेशनशिप, उन्होंने ये वाला रिलेशनशिप यूज कर लिया, ये वाला रिलेशनशिप यूज कर लिया, व्हिच इज एक्चुअली रॉन्ग, व्हाई, दिस इज फॉर टर्बुलेंट फ्लो गाइस, दिस इज फॉर टर्बुलेंट फ्लो, ये तो टर्बुलेंट फ्लो के लिए है ना, this is for the turbulent flow, this type of flow velocity profile, so this is for turbulent flow, but when we calculated Reynolds number, we got the Reynolds number this, क्या सबका Reynolds number 10,000 आ रहा है, yes, and if you're getting Reynolds number 10,000 then how you can use that turbulent relationship, so they use that relationship and they answered this, but that is actually wrong, ये बिल्कुल गलत है, आपको यूज करना चाहिए laminar relationship which is this, and for this relationship the Nusselt number value will come out 36.234, is that fine guys, बिल्कुल सही, देखो बच्चे कितना बढ़िया है ना, उन्होंने मैच भी कर लिया कि वो वाला रिलेशनशिप अप्लाई, ठीक है, आई थिंक इज दैट क्लियर गाइस व्हाई दैट रिलेशनशिप वाज रॉन्ग, वो गलत क्यों है, बिकॉज वी कैन नॉट यूज टर्बुलेंट रिलेशनशिप फॉर Reynolds number less than 5 lakhs because the flow is laminar, we can easily say by observing this data we can say the flow is laminar, okay चलिए yes, a flat plate boundary layer equation for forced convection are given as mass del u by del x, देखो कई बार ऐसा होता है NPTEL assignments में भी मिस्टेक हो जाती है because they are also human being, sometime like suppose some PhD scholar, some MTech scholar, they are like helping their professors, sometimes these type of mistakes are there, okay, so we all are human being and we need to manage, चलिए, so for this question flat plate boundary layer, this is the equation which is given to us, where x is the axial direction, y is the transverse direction, other symbols have their usual meaning, the dependence of Nusselt number on Reynolds number and Prandtl number can be determined of the order magnitude analysis, this is very important guys, he is saying कि in general we are having some correlationship for laminar flow, turbulent flow, but he is saying कि if we will develop some kind of magnitude analysis, and on that magnitude analysis what is the relationship between Nusselt and Reynolds and Prandtl, तो बच्चों उसके लिए अगर आप थोड़ा सा एनालिसिस करते हो, ओके देखो अगर आप यहां पे करते हो, इफ यू एनालाइज इसको हम ऑर्डर मैग्नीट्यूड एनालिसिस में वी कैन अप्रोक्सीमेट इट एट u by x प्लस v by डेल्टा दैट इज इक्वल टू 0, तो हम इसमें क्या लिख सकते हैं, वी कैन राइट v इक्वल टू u डेल्टा by x, हम ये लिख सकते हैं मैग्नीट्यूड एनालिसिस, ऑर्डर एंड मैग्नीट्यूड एनालिसिस से। दूसरी तरह भी अगर हम u वाला रिलेशनशिप यूज करते हैं, ओके तो u के लिए अगर हम यूज करते हैं तो यहां पे हमारे पास हो जाएगा u del u by del x प्लस v del u by del y, ओके प्लस इक्वल टू अल्फा न्यू काइनेमेटिक विस्कोसिटी, ये v है आपका, ये न्यू है, दिस इज v, दिस इज v, मैं इसको v ही लिख देता हूं, दिस इज v एंड दिस इज योर न्यू, ओके, दिस इज न्यू, ओके, दिस इज योर न्यू, तो ये क्या होगा अपना डेल टू, यस, डेल टू u बाय डेल y स्क्वायर, ओके, डेल टू u बाय डेल y स्क्वायर, दीज आर द रिलेशनशिप। तो यहां पे अगर हम मॉडल एनालिसिस अगर हम करते हैं तो फर्दर यू कैन राइट इट हियर u into u infinity square by x plus v into u infinity by delta equal to nu into u infinity square by delta square, okay, by delta square। तो इससे अगर मैं v को भी रिप्लेस कर दूं, यहां से अगर मैं v को रिप्लेस कर दूं, बिकॉज दिस इज v, दिस इज v, तो यहां पे हम क्या लिख सकते हैं बच्चों, वी कैन राइट इट हियर, वी कैन राइट इट हियर u infinity square डिवाइड बाय x प्लस v को मैं लिख सकता हूं u infinity, दिस इज u infinity आई एम राइटिंग गाइस, दिस इज u infinity आई एम राइटिंग, ओके, u infinity into u infinity डिवाइड बाय into delta, because v equal to u infinity delta by x, okay, x into delta equal to nu u infinity square by delta square, ठीक है। तो यहां से अगर आप थोड़ा सा एक्सरसाइज करोगे बच्चों, you will get the relationship for the delta by x, that is a function of 1 by rex की power 1 by 2, ये होता भी है अपने पास, this also you know also, okay, ये आपको पता भी है, delta which is equal to what 5x by rex की power 1 by 2, ये सुनो, ये पता है आपको, okay। So magnitude analysis से, from magnitude analysis if you will carry out here, we can write these terms something like this, this is your conservation of mass equation, this is your energy equation, okay, this is conservation of mass equation, this is your energy equation, okay, this is your momentum equation, ये तीन इक्वेशन हम यूज करते हैं बच्चों, कंजर्वेशन ऑफ मास, कंजर्वेशन ऑफ एनर्जी एंड कंजर्वेशन ऑफ मोमेंटम, ओके। तो यहां से एक अपने को रिजल्ट निकलता है, व्हाट इज दैट रिजल्ट, कि जो अपना नसेल्ट नंबर होता है, व्हाट इज द रिजल्ट गाइस, नसेल्ट नंबर is of the order of, you know, Reynolds की पावर 0.5, okay, Reynolds की पावर 0.5, okay, similarly Nusselt number is of the order of Prandtl number की पावर 0.5। अगर हम order and magnitude analysis की बात करते हैं, if you will use this order and magnitude analysis, we can write Nusselt number, Prandtl number, they are of the order of 0.5। चलिए मैं आपको दोबारा बताता हूं बच्चों, let me again tell you। So what is this question? In this question he has given you this mass balance equation, उसने अपने को mass balance equation दे दिया, he has given you the energy balance equation, okay, and he is saying using the order and magnitude analysis, what is the relationship between Nusselt and Prandtl number, okay, that he is asking you, okay। So this is the u by u del u by del x, so if you write it in on you know, approximate term using this magnitude analysis, we can write u as u infinity by x, v as v by delta, because in y direction this I am writing it as delta, okay, so this is u infinity by x, this is v by delta, so from this you will get some relationship for v equal to u infinity delta by x। Similarly here if I will write, like if I will use this momentum equation, you can write it as u into u infinity square by x plus v into u infinity by what, by delta, okay, equal to nu u infinity square by delta square, yes or no। and in this relationship if you will replace this v, अगर आप इस v को replace कर दे बच्चों, okay, if you will replace this v somewhere here, u infinity by x, u infinity square by x plus this v is nothing but u infinity delta by x, so u infinity delta by x, this I am putting for v, remaining terms u infinity by delta is there already, okay, so this term will also be there। तो यहां पे अगर हम इसको सिंप्लीफाई करते हैं, easily you will get some relationship between delta by delta x equal to 1 by rho in Reynolds की power 1 by 5, easily you can get this, आप इससे ले सकते हो, yes or no guys, so this term will be cancelled out, okay। Please carry out the simplification and tell me how many of you are getting this relationship, okay। So from that easily you can say Nusselt number using magnitude analysis, we can say Nusselt number is a function of Reynolds की power 0.5 and Prandtl number की power 0.5 using modal analysis, using Reynolds magnitude analysis. Okay, and if this is a relationship, this is a dependence, then he is asking you, these are common data question, so these are the prior information which you need to know. ये कुछ prior information है जो आपको पता होनी चाहिए for this relationship. And now he is asking you, if the fluid viscosity is doubled, keeping all other parameters same, then what will be the change in Nusselt number? What will be the change in Nusselt number? Okay, what will be the change in Nusselt number? Now can you answer this question, guys? Can you answer this question? देखो ये थोड़ा सा ही चीजें ऐसी होती है जो हम नहीं पढ़ते जनरली, लाइक मैग्नीट्यूड एनालिसिस, ये चीजें हम स्किप कर देते हैं. ओके, so what will be the, using that magnitude analysis, he is asking you if Nusselt number is a function of Reynolds की power 0.5, Prandtl की power 0.5, then if you double the viscosity, then what is the effect on Nusselt number? बच्चों आपको पता है Reynolds number is what? It is a rho v d by mu. Okay, this is mu cp by k. Okay, mu cp by k. You are doubling the viscosity, but they are in reverse order, guys. दोनों किस में है? This is की power 0.5, similarly mu cp by k की power 0.5. Yes or no? So if you are doubling the viscosity, अगर आप viscosity को double कर रहे हो, if you are doubling the viscosity, that is not going to affect the Nusselt number. Why? Mu की power 0.5, 2 की power 0.5. Here 2 की power 0.5. This is in the numerator, this is in the denominator. So there will be no effect on the Nusselt number, remains the same. This is the answer for this question. So first, from this relationship, you need to realize कि the Nusselt number and Reynolds number dependency using magnitude analysis is what? Nusselt number is a function of Reynolds की power 0.5. Nusselt number is a function of Prandtl की power 0.5, and using that easily you can answer this question. Okay, चलिए एक similar line of question है, like this question. Can you answer this also, guys? If the fluid density and thermal conductivity both are doubled, बोल रहा है density भी आपने double कर दिया, conductivity double कर दिया, then what will be the effect on Nusselt number? You know, Nusselt number is a function of Reynolds की power 0.5, अभी हमने discuss किया, Prandtl की power 0.5. It is a function of Reynolds की power 0.5, Prandtl की power 0.5. Okay, so if you are doubling the density को double कर रहे हो, and at the same time you are doubling the conductivity also. So Reynolds number is rho Vd by mu, this power 0.5. Prandtl number is mu Cp by k power 0.5. You are doubling the density. This you are doubling, and you are doubling the conductivity. Again, what will be the answer, guys? बिल्कुल सही. C is the right answer. Again, it is going to remain same. ये change नहीं करेगा. Why? Because here you are doubling this, so you will have 2 की power 0.5, 2 under root, and here also because this is in the numerator, this is in the denominator, so the net effect will be what? Net effect is going to remain same for this question. Okay, थोड़ा सा theory question है, you need to answer, you need to think and you need to answer. एक और question इसमें answer करते हैं बच्चों on the same line. And now you can ask me, sir, how they can ask you question? They can give you some kind of relationship. If they are giving you some relationship, based on that relationship they can ask you like how the Nusselt number is changing. So by realizing that relationship, you will be easily able to answer. But here actually, you know, guys, these are theoretical thing. Like if you refer to any standard textbook, in the first or second convection chapter only, you will find that magnitude analysis details. So using that equation, we can easily develop that relationship. Reynolds number, Nusselt number is a function of Reynolds की power 0.5, and Nusselt number is a function of Prandtl number की power 0.5. Yes, first for this case, because in this case we are not having any correlation, that's why first we develop that relationship. Nusselt number is a function of Reynolds की power 0.5 using that magnitude analysis. But in most of the cases here, he is going to provide you that relationship, and if you're having that relationship, then there is no such difficulty in using that. Okay, now in next case, question number 23, he is asking you if the density and specific heat both are doubled. अभी देखो Nusselt number क्या होता है? Reynolds power 0.5 using magnitude analysis we concluded that Prandtl power 0.5. Okay, तो अभी क्या करोगे आप? Both you are density और आप specific heat को double कर रहे हो. So this is rho v d by mu, and this is mu cp by k. Now you are doubling both. इसको भी आपने double कर दिया, density को आपने double कर दिया, and you are doubling specific heat, and both are in the numerator. Both are in the numerator, guys. Okay, both are in the numerator. This is in the numerator, this is in the numerator. So in this case they are not going to, they are not going to cancel out. So the effect will become what? Double. अभी effect क्या हो जाएगा? Double हो जाएगा. Why? Because यहाँ पे क्या है? 2 की power 0.5, 2 की power 0.5. Okay. So if you will take add, because they are in multiplication, so power even add, you will have 2 की power 1. Okay. So the effect will be what? The Nusselt number will become 2 times. Nusselt number will become 2 times. So I hope these three questions are very much clear. Let me again tell you, because thoda sa ye different question hai. Let me again tell you guys from where actually I am writing all these things. So yes. So first he has given you this relationship. आप इसको डायरेक्ट भी याद कर सकते हो. Using this relationship, del U by del X, mass balance, energy balance, and what the momentum balance, momentum equation which we are having. Using these three equations, okay, if you will write the modal magnitude analysis, so you can replace these terms: U by U infinity, X by X, delta X by X, V by V, and Y by delta. So we develop some relationship for V. Similarly here in this relationship, U is U, U is equal to U infinity square, X is X, V is V, and V we replaced here, and del U is V, del U infinity, and Y is what? Delta. So we got this relationship, and based on that we concluded Nusselt number depends on the Reynolds की power 0.5 and Nusselt number depends on Prandtl की power 0.5, and based on that we answered these three questions. Okay, ये सारे के सारे क्वेश्चन कॉमन डेटा थे बच्चों. These are the three common data questions we have answered. एक और सिमिलर लाइन पे क्वेश्चन है, and those also easily you will be able to analyze if you will observe this. ठीक है, अगर ये समझ में नहीं आया then you can observe this. Okay, if these questions are not clear, you can observe this. Okay, and then again if you will refer to those questions, easily you will be able to clear. चलिए अभी इसको मेंशन करते हैं. So there is a flat plate boundary layer equation given by this: del U by del S, this is mass balance, this is energy balance, this is momentum balance. Okay, mass balance, energy balance, and momentum balance equation. Okay guys, there is this additional term. ये जो additional term दिख रहा है ना आपको, this additional term. So the dependence of Nusselt number on various fluid properties as a function of Rayleigh number. Nusselt number किसका function है? Rayleigh number का. किसमें बच्चों? Free convection में. This is a case of free convection. This is a case of free convection. Okay, can be determined by order and magnitude analysis. So guys, is similar kind of analysis. Guys, actually there is no need to carry out that. There is no need to carry. You can remember. So for this case, Nusselt number is a function of Rayleigh number for the free convection case, and is a function of Rayleigh number की power 1/4. Rayleigh number की power 1/4. So that will be Rayleigh number की power 0.5. So Nusselt number is a function of Rayleigh number की power 0.25. Okay, 0.25. चलिए वैभव अभी थोड़ा स्पीड अप करेंगे इसको. The dependency of Nusselt number on Rayleigh number is given as this for the case of free convection. Nusselt number is a function of what? Rayleigh number की power 0.5. 1/4 means Rayleigh is nothing but a product of Grashof into Prandtl. The product of Grashof into Prandtl. Okay, so this we know, and that you need not to prove, because this time we are not having that much sufficient time, and that is not required, guys. If you are like, if you hope you can understand that is not required. So you need to remember that, like earlier case also, like I have given you the hint how you can get that relationship. Similarly here also, for the free convection case, how to observe that relationship, that this is a case of free convection. Now can you answer these three questions, guys? These are the common data question. Based on that, this only इसी के ऊपर based है. Now can you answer this question, guys? What hint I am giving you? Nusselt number is a function of Rayleigh number की power 1/4. Can you answer these question, guys? Can you answer these question? Yes. क्या इसको आंसर करोगे आप? This is nothing but it's a function of some constant. You can write some constant. You can write it here. इसको आप यहाँ पे constant लिख सकते हो, which is Grashof into Prandtl की power 1/4. क्या इसको आंसर कर सकते हो? He is saying length scale is increased by 2 factor. The thermal diffusivity is halved. Length scale increased by 2 factor. Thermal diffusivity is halved. Then what is answer? तो बच्चों क्या करोगे आप? This is C into Grashof is nothing but G beta delta T L cube by nu square. This is your Grashof number. Prandtl number is nu by alpha. Okay, Prandtl number is nu by alpha. He is saying length scale is increased by 2. Length scale को आपने 2 से बढ़ा दिया. So if length scale is increased by 2, so this factor will become 2 into 2, 8 times. This factor will become 8 times. Are you getting the idea, guys? This is 2 ka cube. If you are taking the cube of 2, you will have 8. Okay. Now, thermal diffusivity is half. Where you are having thermal diffusivity, guys? This is your thermal diffusivity alpha. इसको आपने कर दिया आधा. इसको आपने कर दिया आधा भाई. This is alpha by 2. So again in the numerator it will become this. So this की power 1 by 4, it means 16 power 1 by 4. What you will have? You will have 2. 16 power 1 by 4, you will have 2. So can you answer this question, guys? What will be the effect on Nusselt number? Nusselt number will become double. Nusselt number क्या हो जाएगा बच्चों? It will become double. Are you getting the answer, guys? Nusselt number will become double. तो इस तरह का थोड़ा सा ऑब्जर्वेशन आपको होना चाहिए, बिकॉज गेट में कई बार ऐसे क्वेश्चन में पूछता है. Okay, many times he asks you these type of question. So some relationship given, or like some kind of basic cases are given to you, forced convection, free convection. So then he is asking you the dependency of some, like Nusselt number on some of the property. Then easily how to answer that question, you need to analyze. One more question, guys, in front of you. एक और क्वेश्चन आपके पास है. अगर आपको अभी तक ये क्वेश्चन नहीं आंसर हुआ है तो अब इसका आंसर जरूर आना चाहिए. If the length scale is increased by 2 factor, length scale को आपने 2 factor से बढ़ा दिया, kinematic viscosity is increased by 4 factor. Kinematic viscosity is increased by 4 factor. Then what is the effect, guys? And thermal diffusivity is doubled. पूरा पढ़ना है. Length scale को 2 बढ़ा दिया तो डायरेक्टली मैं लिख रहा हूं, it is 8. Viscosity को आपने 4 बढ़ा दिया तो kinematic viscosity nu by alpha, so kinematic viscosity is 4, so इसको 4 बढ़ा दिया. Thermal diffusivity is doubled. थर्मल डिफ्यूजिविटी को आपने क्या कर दिया? डबल कर दिया. तो अगेन इट विल बी 16 की पावर 1 by 4. सो अगेन द आंसर इज व्हाट? डबल्ड. अगेन द आंसर इज डबल्ड. बी इज द आंसर. रिमेन सेम क्यों बोल रहे हो बच्चों? नो, मैं दोबारा चेक कर लेता हूं बच्चों. चलिए दोबारा देखते हैं इसको. आई एम गेटिंग बी डबल्ड. व्हाई? बिकॉज नसेल्ट नंबर इज ए फंक्शन ऑफ ग्रेशोव इनटू प्रिंडल की पावर 1 by 4. लेंथ स्केल को उसने डबल कर दिया. लेंथ स्केल को डबल कर दिया तो L की पावर 3, सो इट विल बिकम 8. लेंथ स्केल में L की पावर 3 होता है ना बच्चों, यू नो दिस. ग्रेशोव L की पावर 3, सो 2 की पावर 3 इट विल बिकम 8. फाइन, पहला हो गया. दूसरा, काइनेमेटिक विस्कोसिटी इंक्रीज बाय फैक्टर 4. काइनेमेटिक विस्कोसिटी कहां होता है बच्चों? दिस इज काइनेमेटिक विस्कोसिटी. ओके, देखो काइनेमेटिक विस्कोसिटी को बिल्कुल सही, बहुत बच्चे ने अच्छे से पकड़ा है. दिस इज न्यू, दिस विल बी कैंसल आउट. सो यू आर हैविंग वन न्यू ओनली, और इसको आपने क्या कर दिया? 4 फैक्टर से बढ़ा दिया. सो इट विल बी इन द डिनोमिनेटर. It will be in the denominator. Very good. Nu is increased by 4 factor. It is in the denominator. मैंने इसको पहले numerator में लिख दिया था, but it will be in the denominator. Very good. And the thermal diffusivity is doubled. तो कुछ terms को आप लोग देखना पड़ेगा. The terms like you need to observe which are actually cancelling each other. So here this new they are cancelling each other. तो यहाँ पे भी देख लेते हैं. हाँ, इस केस में तो थर्मल डिफ्यूजिविटी था, विस्कोसिटी नहीं था. दैट आंसर इज राइट. ओके, इस केस में उसने आपको बोला है कि विस्कोसिटी यू आर इंक्रीजिंग बाय 4 फैक्टर. सो दिस विस्कोसिटी विल कैंसल आउट. सो यू विल हैव अ विस्कोसिटी टर्म इन द डिनोमिनेटर ओनली, एंड दिस यू आर इंक्रीजिंग बाय फैक्टर 4. सो इन द डिनोमिनेटर you will have 4, and now you are increasing the diffusivity by double. डिफ्यूजिविटी को आपने क्या कर दिया? डबल. सो 8 by 8, 1 की पावर 1 की पावर 1 by 4, it will be 1 only. So it is going to remain same. Nusselt number will remain same. So note B, C is the right answer. Very good, guys. बिल्कुल सही. Those are getting C. This is the right answer for this question. So I hope these type of questions are very much, clear and easy for all of you. बिल्कुल हलवा है चंदन. Yes. So different type of question we are having. चलिए let's move to next question. Question number 27. चलिए. So let me put it here. Air at 27 degrees Celsius with a free stream velocity 10 meter per second is used to cool electric device mounted on a printed circuit board. So there is a printed circuit board. उसके ऊपर आपने कुछ इलेक्ट्रॉनिक डिवाइसेस को माउंट किया है. Each device is this. हर डिवाइस का एरिया कितना है? 4 into 4 mm, and it is having 40 milliwatt heat you want to remove. आपको कितना हीट रिमूव कर रहा है? You want to remove 40 milliwatt heat. Okay, from the top surface. Estimate the Nusselt number at a location 15 mm from the leading edge and the rate of the leading edge for the cooling process. Okay, आपसे Nusselt number पूछ रहा है. In first question he is only asking you the Nusselt number at a location. NUX पूछ रहा है आपसे. NUX at x equal to what? 15 mm. In first question he is only asking you Nusselt number. Relationship is given to you. So very typical GATE standard question. All things are given to you. In first part he is asking you Nusselt number at a distance 15 mm from the लीडिंग एज। कैन यू आंसर दिस क्वेश्चन गाइस? चंदन ने तो आंसर भी कर दिया है। चंदन प्लीज पहले कैलकुलेट करो, यू कैलकुलेटेड और नॉट? दिस इज क्वेश्चन नंबर 27। ठीक है, 50 क्वेश्चन पे हम ब्रेक ले लेंगे बच्चों, 50 क्वेश्चन पे। यस यस, 50 क्वेश्चन पे वी विल टेक ब्रेक। हीट एक्सचेंजर में इतना टाइम नहीं लगेगा। कन्वेक्शन क्वेश्चन, यू नो, दे आर कंपैरेटिवली स्टूडेंट, दे आर, यू नो, comparatively they are having some kind of fear in mind also related to those convection questions, so that's why I'm discussing in slightly detail. Okay, but heat exchanger में ऐसा कुछ नहीं है। heat exchanger में easily we will be easily able to answer those questions, so please try to answer this first part. अभिनव ने आंसर किया 69.04, वेरी गुड, सही, सभी बिल्कुल सही आंसर है बच्चे आपका। ऑप्शन डी इज द राइट आंसर फॉर दिस क्वेश्चन। Option D is the right answer for this question. So every data is given to you: conductivity, Prandtl number. This is what, this is meter square per second. तो ये क्या आपका, this is, you know, this is alpha. This is alpha value. Okay, this is alpha thermal diffusivity. This is not nu guys, ये alpha है, A है ना, तो ये typing mistake है. This is alpha thermal diffusivity, because you know nu and alpha both are having same unit, मीटर स्क्वायर पर सेकंड। न्यू और अल्फा का दोनों का यूनिट क्या होता है? सेम, दैट्स व्हाई Prandtl number is dimensionless. Okay, न्यू बाय अल्फा। दिस इज थर्मल डिफ्यूजिविटी, थर्मल डिफ्यूजिविटी। Okay, और क्या होती है? दिस इज नथिंग बट K बाय रो Cp, K बाय रो Cp। ठीक है, K बाय रो Cp। एंड Prandtl नंबर क्या होता है बच्चों? Prandtl number which is equal to 0.7505, this is equal to nu by alpha. तो अल्फा आपको दिया, यहां से आप न्यू भी निकाल सकते हो। अगर आपको न्यू चाहिए ना, suppose for calculating Reynolds number you want new, so you can calculate that very simply. Alpha is given to you, K by rho Cp. Alpha, Prandtl number is nu by alpha, so alpha is given to you, nu easily you can calculate, and then easily you can calculate Reynolds number, Prandtl number, you can calculate Nusselt number value. Now next part, second part, he is asking you, for the above same problem, if the surface temperature of the electronic device at a location of 15 mm from the leading edge, आपसे पूछ रहा है surface temperature at a location 15 mm from the leading edge. What is the surface temperature of the electronic device? What is the surface temperature of the electronic device at a distance 15 mm from the leading edge? जिस distance पे हमने h calculate किया ना बच्चों, जिस डिस्टेंस पे हमने h कैलकुलेट किया है, यहाँ पे x 15 mm, ओके, जहां पे हमने h कैलकुलेट किया, यहां से हीट क्या हो रहा है बच्चों? हीट इज कन्वेक्टिंग, हीट कन्वेक्शन हो रहा है। कितना हो रहा है कन्वेक्शन हीट ट्रांसफर? कितना कन्वेक्शन हीट ट्रांसफर होगा? दैट विल बी HA डेल्टा T। h क्या है हमने कैलकुलेट कर सकते हैं, Nusselt number वी नो, Nusselt number अपने को पता है, तो फ्रॉम दैट इजीली वी कैन कैलकुलेट hx एट ए डिस्टेंस x मींस 15 mm फ्रॉम द लीडिंग एज। ओके, सो hx आपके पास आ जाएगा, एरिया क्या है? एरिया ऑफ द इलेक्ट्रॉनिक डिवाइस, सरफेस एरिया ऑफ द इलेक्ट्रॉनिक डिवाइस। डेल्टा टी क्या हो जाएगा? सरफेस टेम्परेचर ऑफ द इलेक्ट्रॉनिक डिवाइस माइनस फ्लूइड टेम्परेचर। ओके, और ये कितना दिया है बच्चों? दिस इज गिवन टू अस इक्वल टू 40 मिलीवॉट। ओके, दिस इज 40 milliwatt. So solving this easily you will get. Unit will be taken. कौन सा यूनिट बच्चे? देखो, this we want to find out. This is given to us. This is actually a electronic device which is having area 4 into 4 mm, dissipates 40 milliwatt. Okay, so this is the heat dissipation by the electronic device. Okay, so heat dissipation is given to us at a distance of 15 mm from the leading edge. देखो यहाँ पे कोई डिवाइस लगा है बच्चों, यहाँ पे कोई डिवाइस लगा है, छोटा सा डिवाइस लगा है यहाँ पे। आप कहोगे सर व्हाई यू आर नॉट टेकिंग एवरेज कन्वेक्शन हीट ट्रांसफर कोएफिशिएंट? आई एम नॉट कैलकुलेटिंग एवरेज हीट ट्रांसफर, आई एम कैलकुलेटिंग द हीट ट्रांसफर फ्रॉम दिस स्मॉल, यू नो, इलेक्ट्रॉनिक डिवाइस। दैट स्मॉल इलेक्ट्रॉनिक डिवाइस व्हिच इज हैविंग एरिया, जिसका एरिया कितना है? सरफेस एरिया 4 into 4, 16 into 10 की पावर माइनस 6 मीटर स्क्वायर। Okay, 16 into 10 की power 6 meter square. This is small chip, small electronic device which is having this much area. Okay, and the heat transfer from that electronic device is this, and we know the convection heat transfer is HA delta T. अब H कौन सा लोगे बच्चों? You are going to take average or local? Local, obviously. Why? Because we are not calculating average heat transfer. We are calculating heat transfer at that distance. Okay, so Hx you need to take local heat transfer coefficient, area of the that electronic device. Ts we want to calculate. तो इसको अगर आप simplification करोगे, easily you will get the surface temperature of the electronic device. Yes, Newton's law की कहाँ जरूरत पड़ेगी बच्चों? Yes, Newton's law of cooling. Yes, you are saying about Newton's law of cooling, बिल्कुल सही. Newton's law of cooling. तो अगर आप इसको सोल्व करोगे बच्चों, आपका आंसर आ जाएगा 46.82. Option B will be the right answer for this question. Option B is the right answer for this question. चलिए, now next 5 questions अभी जो हमारे आने वाले हैं, we are going to solve from what comparatively convection. I think convection के क्वेश्चन आने वाले हैं. चलिए नेक्स्ट क्वेश्चन मूव करते हैं. 30 के बाद आई थिंक लास्ट 5 क्वेश्चंस विल बी फ्रॉम कन्वेक्शन. कन्वेक्शन अभी भी हम कर ही रहे हैं, बीच में मिक्स. चलिए, फॉर कूलिंग एंड इलेक्ट्रिकल पेन, there is a for cooling and electrical pain, air at 25 degrees Celsius flows over a 0.6 meter long panel at 2 meter per second. Panel is releasing heat at the rate of 500 watt per meter square to the air. What can be the maximum temperature of the panel? Use correlation. Nusselt number NUX equal to 0.453, Reynolds की power 1/2, Prandtl की power 1/3. Use this relationship and all the properties you need to use these. Prandtl number, kinematic viscosity, thermal conductivity, use this. Okay, and you need to find out the maximum panel temperature. Panel temperature or surface temperature. The concept is very much similar, guys. Concept is very much similar. Can you solve this answer? Can you solve this question, guys? कुछ बन गया, मिक्स करके देना. देखो, इस केस में अगर हम यहां से रियलाइज करें, दिस इज अ केस फॉर दिस इज अ केस फॉर लैमिनार फ्लो. लैमिनार फ्लो का केस है, and you can realize what this relationship also. Otherwise, when you will calculate the Reynolds number, जब आप Reynolds number भी calculate करोगे, you can check it will come out less than 5 into 10 की power 5. Okay, it will come out 5 into 10 की power 5 means the flow is laminar. फ्लो क्या है बच्चों? लैमिनार है. ओके, फ्लो कितना है आपका? लैमिनार. तो यहां पे कैन आई से h bar equal to 2 times of HL? Can I write h bar equal to 2 times of HL? You can write, observe from this also. यहां से भी आप observe कर सकते हो आप easily. From this also, like similar kind of analysis which we carried out for turbulent flow. जो हमने turbulent flow के लिए analysis किया था ना बच्चों, same if you will carry out here laminar flow, you will get the idea h bar equal to 2 times of HL. So from this, first you can calculate, HL निकाल लो, convection heat transfer coefficient at the trailing edge, and then if you will double that, अगर आप उसको double करते हो, you will get h bar. Okay, आपके पास क्या आ जाएगा? h bar. And that h bar से क्या आ जाएगा? Then you can write it here. आप आंसर क्या लिख सकते हो? Q heat transfer is equal to h bar area of the pane. Now we are writing average heat transfer. We are writing the average heat transfer. Okay, so HA delta T. तो ये आपका ऐसे करके अगर आप एनालिसिस करोगे, then I think you will get the answer. And yes, option C, some of the students they start answering also. Option C close to that is the right answer for this question. बिल्कुल सही, साकेत भी आंसर कर रहे हैं और कोना इज आल्सो आंसरिंग दिस क्वेश्चन. So guys, only you need to observe the data which is given to you. Okay, the data which is given to you, and then you need to answer that. So actually they used, like when you are getting this answer, actually I think they used h bar only. उन्होंने HL जो है, HL को ही यूज करके they used HL only. उन्होंने HL को ही यूज किया है. ओके, बट आई थिंक दैट इज नॉट राइट. आपको उसको डबल करना चाहिए, बिकॉज दिस इज नॉट हीट ट्रांसफर गिवन एट ट्रेलिंग एज. दिस इज द हीट ट्रांसफर, दिस इज द एवरेज हीट ट्रांसफर फ्रॉम द पैनल. This is the average heat transfer from the panel. So you need to use h bar, and h bar will be 2 times of HL. तो ये right approach है. देखो, as a teacher guys, I need to tell you both the ways. That like the way which I feel is comparatively right, better. ओके, एंड द वे दे आंसर्ड दिस क्वेश्चन, कुछ एक दो क्वेश्चन में कॉन्फ्लिक्ट रहता है। ओके, सो कॉन्फ्लिक्ट क्या है आपको मिल सकता है, व्हेन आई कैलकुलेटेड एच, अभी इसमें जो आप एच निकालोगे, एच बार व्हेन यू विल कैलकुलेट, सो एच एल विल कम आउट, एच एल आपका आएगा 4.85456। मेरे ख्याल से इससे अगर आप निकालोगे इसको यूज करके, देन यू विल गेट द एग्जैक्ट आंसर 128। ओके, इन दैट केस यू विल गेट द एग्जैक्ट आंसर, बट आई थिंक इफ यू विल डबल यू आर नॉट गोइंग टू गेट द आंसर। यस, बिल्कुल सही चंदन। तो पहले आप एच निकाल लो, लोकल कन्वेक्शन हीट ट्रांसफर कोएफिशिएंट एट द ट्रेलिंग एज, then using that relationship q equal to ha delta t, and this q is given to us, 500 watts. This is 500 watts per meter square, it means area is 1 meter square. अब एरिया को पेन का एरिया मत पुट करना, because he is giving you heat transfer watt per meter square. Okay, and in that case, yes, that is also right, because he is giving you heat transfer in watt per meter square, then you can write it here 500 into hl. HL अपना कितना आया, बिकॉज उसने आपको टोटल हीट ट्रांसफर नहीं दिया, ही हैज गिवन यू हीट ट्रांसफर इन वॉट पर मीटर स्क्वायर, देन आल्सो इट इज राइट टू यूज HL 4.85456 into area is 1 and the surface temperature minus the fluid temperature which is 25 degrees Celsius. Okay, 25 degree Celsius. तो इसको करोगे तो आई होप यू ऑल विल गेट आंसर 128 डिग्री सेल्सियस। ठीक है, तो सिंपल क्वेश्चन है, ओनली यू नीड टू अवेयर अबाउट बेसिक फॉर्मुलेशन रिलेटेड टू कन्वेक्शन। चलिए, वेरी गुड गाइस, दोज हु एक्चुअली गोट द आंसर and others they are also trying, it's good to try guys, keep trying and surely you will get answer. Kinematic viscosity and thermal diffusivity of an engine oil are these. So आपको दिया है kinematic viscosity दिया है आपको nu which is 200 mm square per second, and the thermal diffusivity alpha is 0.0738 mm square per second. If the engine oil is allowed to flow over a heated plate, comment on the boundary layer. तो इनडायरेक्ट क्वेश्चन है बच्चों, इनडायरेक्ट क्वेश्चन है, तो आपसे पहले पूछ रहा है कि प्रेंडल नंबर निकालो, प्रेंडल नंबर इज न्यू बाय अल्फा, न्यू इज 200, दिस इज 0.0738, तो प्रेंडल नंबर तो बहुत हाई आएगा, प्रेंडल नंबर विल कम आउट वेरी वेरी हाई, इट मींस डेल्टा इज वेरी वेरी हाई एज कंपेयर टू डेल्टा थर्मल. Okay, so which one will be thicker? Obviously the hydrodynamic boundary layer will be thicker. Option C is the right answer for this question. Option C is the right answer for this question. Very good Abhinav, बिल्कुल सही. ठीक है, चलिए लेट अस नाउ मूव टू नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 31. He is asking you choose the correct option. Choose the correct option. If the Grashof number is equal to 1, forced convection and natural convection effects will be comparable. If the Reynolds number is equal to 1, forced convection and natural convection effect will be comparable. If the Richardson number is equal to 1, forced convection and natural convection effect can be comparable. None of the above. So which one is right, guys? Which one is right? Option C is the right answer. Why? There is a number which is known as Richardson number. Richardson number. What is that? What is that number, guys? It's a number of Grashof number divided by square of Reynolds number. Grashof divided by square of Reynolds number. Okay, what is Grashof number, guys? It is inertia force into buoyancy force divided by square of viscous forces. Inertia, this is your Grashof number. Okay, this is your Grashof. Inertia into buoyancy divided by viscous forces. Generally in we say it is a ratio of the inertia by viscous, but buoyancy by viscous in general we say, but mathematically we write this Grashof number something like this, and Reynolds number is a ratio of inertia by viscous, so it is inertia square by viscous forces square. Okay, so further simplification if you will carry out this will cancel out, this will cancel out, so Richardson number is nothing but the ratio of buoyancy force by inertia forces. Richardson number is the ratio of buoyancy force by inertia forces. Okay, and Richardson number tells us about the dominancy of buoyancy over inertia. So guys, if buoyancy forces are very very high as compared to inertia forces, it means the flow is buoyancy driven. Flow is buoyancy driven. Flow is buoyancy driven. Okay, if the flow is buoyancy driven, it means buoyancy forces are very very high as compared to the inertia forces, means Richardson number is very very high, greater than 1. and that is a case of what? It's a case of natural convection. It's a case of natural or free convection. Natural or free convection. It's a case of natural or free convection. Yes, but if the buoyancy forces, they are less, very very less as compared to the inertia forces, the flow is what? The flow is viscous forces, viscous flow. Okay, viscous flow, force driven, external force driven, external force driven. Okay, this is a case where the Richardson number is very very less as compared to 1. This is a case of forced convection. Forced convection. Okay, and if Richardson number, buoyancy forces, they are comparable to the inertia forces, this is known as mixed flow. Mixed flow. And the case where Richardson number is approximately equal to 1, इसे हम क्या बोलेंगे? Mixed flow. Okay, mixed flow, mixed convection. Mixed convection. So in real case, you will have forced convection dominating also, free convection dominating also, or you can have mixed convection also. Okay, that generally, like, which one is dominating? Forced convection is dominating, free convection is dominating. That idea we get from the Richardson number, which is nothing but the ratio of Grashof by Reynolds square, or which is nothing but the ratio of buoyancy force by viscous forces. Okay, Richardson number is a ratio of buoyancy force by viscous forces. So he is asking you, for if the Richardson number is equal to 1, the forced convection and natural convection effect will be comparable. बिल्कुल सही. So option C क्या हो जाएगा बच्चों? This is the right answer for this question. Richardson number equal to 1, both are comparable. Not A, C is the right answer, guys. Grashof number is not going to tell us about the flow, which one is dominating, natural or free, natural convection or forced convection. It is Richardson number which tells us about the which one is dominating, natural convection or forced convection. चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं बच्चों. Question number 32. Last 3 problems from convection, then we will move to heat exchanger. Water is heated by a 200 mm into 200 mm vertical plate which is maintained at 60 degrees Celsius. Find the following quantities. When the water is at 60 degrees Celsius, find the average convection heat transfer coefficient. आपसे average convection heat transfer coefficient पूछ रहा है. Water is at 20 degrees Celsius, so T infinity is 20 degrees Celsius. TW is equal to 60 degrees Celsius. Constant surface condition are given to you. Water is heated by this much of the plate. So area of the plate is given to you. Okay, area of the plate is also given to you. At film temperature, this all properties are given to you. Okay, properties are given to you, and nu is given to you, beta is given to you directly. Nusselt number relationship is also given to you. NUL equal to 0.1 into Grashof Prandtl की power 1/3. Okay, this is a case of turbulent flow. You know, this is a case of turbulent flow. Turbulent flow over turbulent convection. In case of free convection also we can have laminar flow, turbulent flow, guys. Convection is there, but the flow is not governed by external agency. The flow is due to the density difference. Okay, so this is a case of what? Free convection. As you can realize, देखो यहाँ से आपसे पूछ रहा है क्या, he is asking you average convection heat transfer coefficient, H average पूछ रहा है. आप कहोगे सर रिलेशन तो दिया लोकल के लिए, and he is asking you average. So we need to have some kind of relationship between average and this local heat transfer coefficient. So guys, here if you analyze, अगर आप यहाँ पे analyze करते हो, and directly also you need to remember, for the laminar flow, turbulent flow, I discussed with you, like for the flow over a flat plate, what is the relationship? For the laminar flow over flat plate, H bar equal to 2 times of HL. For the turbulent flow over flat plate, H bar equal to 5/4 HL. For the laminar flow inside pipe, the H will be constant. It is not going to change. Okay. Similarly, for the flow over flat plate, इस flat plate के लिए, for the turbulent flow, अगर इसके ऊपर क्या है, flow कैसा है? Turbulent. Okay. मान लीजिए कैसा flow है? Turbulent. Turbulent. Natural convection, it is a natural convection, case of natural convection. Okay, because you can realize from this relationship, इस relationship से आप देख सकते हो बच्चों, this is power n, this is power n, this is equal to 1/3 for the case of turbulent, and it is 1/4 for the case of laminar. ये जो term होती है ये 1/3 होती है for the case of laminar, for the case of turbulent, and this is what 1/3 for turbulent. You know, Nusselt number is a function of Rayleigh की power 1/3. This is a case of turbulent. Nusselt number equal to Rayleigh की power 1/4. That is a case of laminar flow. Okay. और यहाँ पे अगर आप realize करोगे, Nusselt number is HL into L divided by K is equal to 0.1 into Grashof is G beta delta T L cube by nu square into nu by alpha whole power 1 by 3. Okay, so if we'll consider other things as constant, अगर हम बाकी सारी चीजों को constant मान लें, and if I'll ask you HL is a function of what, L पे कैसे depend कर रहा है, how HL is depending on L, so HL equal to L की power 3 whole power 1 by 3, so it is equal to L by L, means HL equal to HX equal to H bar. That easily we can conclude from this. Are you getting the idea, guys? H is not depending on L. H is not changing with L. Are you getting the idea? How we can say? Because our HL equal to L by K, this is Nusselt number, this is equal to 0.1 into G beta delta T L cube by nu square into nu by alpha. So if we'll consider all other things as constant, L की power 3 whole power 1 by 3, 3 will cancel out, you will have L divided by L means HL is independent of L, means everywhere, here, everywhere H is same, H is constant, H is not changing. So you can calculate HL, that HL from this, the HL which you are going to get from this relationship, that is nothing but that is H bar. वही आपका H bar है. For the case of turbulent flow over vertical plate, H is constant. Got the idea? How to analyze from this relationship? तो आपको H bar, HL ही निकालना है. That HL is nothing but that HL is H bar. ठीक है बच्चों? That HL is nothing but H bar. So now it is very easy. Because all these relationship are given to you, only you need to put the values. आपको values put करनी है बच्चों. Grashof number मैंने लिख ही दिया. क्या है Grashof number? G beta delta T. G आपको पता है 9.81. Beta is given to you 3 into 10 की power 4 per Kelvin. Delta T is a temperature difference 40. 60 minus 20 40. L is what? Length of the plate, which is 0.2 meter. So 200 into 200. This is the length and width. So the length, dimension of the plate along the this, because we want to calculate HL. अपने को क्या निकालना है? HL. This. Okay. This L, and this L is nothing but 0.2 meter. ठीक है बच्चों? चलिए. So putting all these values, you will get the H value. Now can you tell me guys what answer you are getting? Question number 32. So those are getting answer in the range of 660. ये कौन सा क्वेश्चन था? Yes. 660 to 670. आपका आंसर इस रेंज में आना चाहिए. आप कुछ ना कुछ मिस्टेक कर रहे हो बच्चों. यू आर मेकिंग सम काइंड ऑफ मिस्टेक. 65 डिफरेंट. अभी तक कोई आंसर ही नहीं आया बच्चों. इट्स वेरी ग्रेट दिस टाइम. Nobody has answered this question. For this question, let me write it here. What Grashof number? Grashof number पहले तो निकालना पड़ेगा आपको. Grashof number L, G, which is equal to 9.81, beta 3 into 10 की power minus 4, G beta delta T, which is 40 into L square, L cube, so 0.2 cube divided by nu square. Okay, nu कितना आएगा आपका? 6.58. 0.658 into 10 की power minus 6 whole square. ये स्क्वायर आप शायद भूल गए हैं. ओके, आई थिंक यू फॉरगॉट. अभी एक आंसर आया हमारे पास वामशी का. वामशी, योर आंसर इज राइट, एग्जैक्टली राइट, बिल्कुल सही वामशी, आपका आंसर बिल्कुल सही है. Vamshi Sandras, 663 is the exact answer. So guys, if you are getting the answer, you need to very careful about the calculation. If you are getting answer in this range 660 to 667, they mentioned this range. अगर आपका आंसर इस रेंज में आ रहा है, okay, then your answer is right. If you're getting answer in this range, your answer is right. आपका क्या आएगा? HL. This is HL or this is H bar. So please carry out the calculation again, guys, and tell me how many of you are getting the answer. How many of you are getting the answer? Don't do those kind of silly mistakes in calculation, guys. You need to be very careful about calculation. Now can you calculate the heat transfer also, average heat transfer, because it's a common data question. अभी एक convection का question था. It's a question from free convection. Okay, now second part of this is asking you the average heat transfer. What is the average heat transfer? What estimate the heat transfer in watts? ये watts में पूछ रहा है आपसे. Estimate the heat transfer in the previous question. यही जो previous question है उसमें आपसे heat transfer पूछ रहा है. HA delta T, सब तो दिया है. Delta T क्या है? Constant temperature difference, because wall temperature is constant. H already we calculated. Area is 0.2 into 0.2. The temperature difference is 40. There is no such difficulty in calculating. Sir, इसमें तो हम master हैं. ये तो कुछ भी नहीं है ना? So in next part he is asking you the heat transfer. The heat transfer, rate of heat transfer in watts. rate of heat transfer in watts. Now can you tell me guys what is the answer you are getting? Rate of heat transfer in watts. So this is the data. Let me put it here in front of you. Okay, please tell me what is the rate of heat transfer you are getting. Again, Vamshi, your answer is right. So those are getting answer in the range of 1050 to 1070. They have given the range for this question 1050 to 1070. If you are getting answer in this range, your answer is very right. बिल्कुल सही बच्चों, बिल्कुल सही. Now let us move to last two questions. Last के दो क्वेश्चंस पे मूव करते हैं बच्चों. इसमें थोड़ा बाद में आएंगे. ओके चलो इसको अभी देख लेते हैं. चलो इसको अभी देखते हैं. चलो दिस इज सेकंड लास्ट क्वेश्चन और इसके बाद हमारा लास्ट क्वेश्चन आएगा एंड देन वी विल मूव टू हीट एक्सचेंजर. हीट एक्सचेंजर के 15 क्वेश्चन करेंगे धड़ाधड़ एंड देन वी विल टेक ब्रेक. ठीक है, टारगेट रहेगा कि अगले आधे घंटे में हम वो 15 क्वेश्चन निपटा दें. ठीक है बच्चों, because then we will have some kind of confidence कि yes we done with 50 questions remaining and easily we will be able to cover those also. चलिए, so it's a case, there is a plate, vertical plate with 0.2 into 0.2 meter kind of data is same. 0.2 into 0.2 meter vertical plate has a constant surface temperature which is maintained at 40 degrees Celsius. Air at 20 degrees Celsius is flowing over the parallel plate. अभी क्या बोल रहा है, एयर फ्लो कर रहा है बच्चों. यहाँ पे केस इज ऑलमोस्ट सेम बट यहाँ पे एयर फ्लो कर रहा है. एयर क्या कर रहा है, फ्लो कर रहा है. ओके, एयर क्या कर रहा है, फ्लो कर रहा है. नसेल्ट नंबर शोन इन द फिगर. पहले तो पूछ रहा है पहले इसका नसेल्ट नंबर बताओ. फॉर दिस अरेंजमेंट is asking you the Nusselt number. Nusselt number. ठीक है, अब देखो इस क्वेश्चन में होगा क्या. देखो he has given you all these data. बीटा वैल्यू भी दे दिया उसने आपको, ये भी दे दिया. गाइस अगर आप यहां पे रिचर्डसन नंबर कैलकुलेट करोगे, कैन यू कैलकुलेट रिचर्डसन नंबर गाइस? क्या आप रिचर्डसन नंबर कैलकुलेट कर सकते हो? एक्चुअली इट्स अ केस ऑफ मिक्स्ड कन्वेक्शन. ये किसका केस है? इट्स अ केस ऑफ मिक्स्ड कन्वेक्शन. ये किसका केस है बच्चों? इट्स द केस ऑफ मिक्स्ड कन्वेक्शन. ओके, इट्स द केस ऑफ मिक्स्ड कन्वेक्शन एंड फॉर दिस यू कैन चेक द रिचर्डसन नंबर. आप चेक कर लो इसको. ओके, इसको चेक कर लो आप. ग्रेशोफ बाय स्क्वायर ऑफ रेनॉल्ड्स निकाल लो यार. ग्रेशोफ नंबर निकाल लो फॉर ऑल दिस गिवन डेटा. कैलकुलेट रेनॉल्ड्स नंबर आल्सो. टेक दिस रेशियो. कैलकुलेट व्हाट रिचर्डसन नंबर you are getting. You are getting this Richardson number very very high. If you are getting it very very high, it means the what you can say your natural convection is dominated. If it is very very low, it means the forced convection is dominated. If it is coming out close to 1, it means the flow is mixed convection. You can check. अब इसको check करो and then you can try to solve. Okay, if it is a case of natural convection में what Rayleigh number value you are getting, you can calculate the Rayleigh number value also. Rayleigh number. Okay, और अगर Rayleigh number क्या आ रहा है, if it is coming out 10 की power 9 से कम आ रहा है, okay, इससे कम आ रहा है, then you can go with laminar flow. Okay, Nusselt number equal to some constant into Rayleigh की power 1/4. Then you can go with this. Okay, you don't have to worry. You can refer to your any standard data textbook and then you can use that relationship. Any keyword which is identifying what keyword guys, let me tell you. देखो अभी एक तो इसने केस दे दिया वर्टिकल प्लेट एंड ही हैज गिवन यू दिस डेटा. तो अपने को चेक करना पड़ेगा बिकॉज दीज आर नॉट गेट प्रॉब्लम्स बच्चों. ये गेट का प्रॉब्लम नहीं है. दीज आर फ्रॉम एनपीटीएल असाइनमेंट. सो he has not given you any clue. He is not giving you any idea. He is insisting you to calculate that Richardson number, calculate the Reynolds number, Grashof number. Then you need to calculate. You need to analyze ki yes, that is a case of mixed convection. It's a case of forced convection or free convection. If you can easily analyze by Richardson number, that you can easily calculate. How many of you are calculating Richardson number, guys? Calculating Richardson number will give you idea the case, the heat transfer is free convection or forced convection. Based on that, you can apply the corresponding relationship. You got the idea? Yes, Vamshi, is that clear? वैभव जल्दी से बताओ. तो इसको अभी सोल्व करना. Okay, I'm not coming to this. Let me move to this question first. This is last question from convection. Okay, this is last question from the convection. देखो चंदन ने कहा हाइब्रिड है, बिल्कुल सही. Because yes, Richardson number is coming out 0.8. That's why I mentioned, because I calculated ना, मैंने तो calculate करके मैंने देखा था कि it is coming out this. show if it is coming out close to 1. अब ऐसा नहीं कि exact 1 आना चाहिए. If it is coming out 0.5, it is coming out 1.5, it is coming out 2, then also you can say कि both are comparable. If both are comparable, you need to go with mixed convection. Mixed convection का आपको correlation लगाना पड़ेगा बच्चों here. यहाँ पे if I will give you some kind of correlation for the mixed convection, the question will become halwa for you. Why? Because if you are having some relationship for the Nusselt number, dependency of Reynolds standard, then you need to put all those values, you will get that value. Are you getting the idea? So the question is very easy. Only you need to think. Don't blindly don't start like applying with forced convection relationship, free convection relationship. You need to analyze. And why actually from where I got the idea? Because he has given you some value. देखो यहाँ पे अगर आप देखोगे, he has given you beta value also, जो कि generally हमें forced convection में जरूरत नहीं पड़ती. Forced convection में इसकी जरूरत नहीं पड़ती. He has given you a case of vertical plate also. अगर generally अगर forced convection का case होता, most of the time we have a case of horizontal plate, something like that. So he has given you a vertical plate, and this is boundary layer is something like this, and he has given you some kind of fan also. Means very clear this is a case of forced convection because some fan is there, and at the same time he is giving you some data which is required for solving free convection problem. It means some this case is of some mixed type. Then that's why you need to first calculate the Richardson number, and then only you need to analyze. yes चंदन, तो वहां से थोड़ा सा अपने को आइडिया मिलेगा. सो इट्स अ केस ऑफ मिक्स्ड कन्वेक्शन का फार्मूला लगाएंगे, इजीली यू विल बी एबल टू गेट द आंसर. तो उन्होंने इसके लिए आंसर दिया भी नहीं था मेरे ख्याल से. यू कैन चेक, अभी इस पे दोबारा आएंगे. एंड फर्स्ट इसको सोल्व करते हैं. दिस इज क्वेश्चन नंबर 35 एंड लास्ट क्वेश्चन फ्रॉम द कन्वेक्शन. There is a metal plate 0.609 meter in height forms the vertical wall of an oven at a temperature of 117. So there is a wall, एक wall है which is at a constant wall temperature 171 degree Celsius. Okay, which is in the oven. The oven air is at a temperature 93.4 degree Celsius. Atmospheric pressure assuming natural convection condition. अभी उसने बोल दिया कि नेचुरल कन्वेक्शन कंडीशन को क्या करो, यही प्रिवेल करेंगे. नेचुरल कन्वेक्शन इज देयर एंड दिस इज द रिलेशनशिप ही हैज गिवन यू. नसेल्ट नंबर इज इक्वल टू 0.548 Grashof into Prandtl की पावर 1/4. मींस इट्स अ केस ऑफ व्हाट, लैमिनार फ्लो. ओके, ये जनरली हमारे पास 1/4 किसमें होता है? इट्स अ केस ऑफ लैमिनार. ओके, द एवरेज हीट ट्रांसफर कोएफिशिएंट, ही इज आस्किंग यू द एवरेज हीट ट्रांसफर कोएफिशिएंट. एवरेज हीट ट्रांसफर कोएफिशिएंट ही इज आस्किंग यू. कैन यू कैलकुलेट गाइस? Average convection heat transfer coefficient, H bar. Can you calculate H bar guys? Now first calculate HL. अभी H bar से confuse मत करो. First calculate HL. HL, the convection heat transfer coefficient at the trailing edge. Convection heat transfer coefficient at the trailing edge. Can you calculate guys? Convection heat transfer coefficient at the trailing edge. So plate is given, it is a hot plate case, the boundary layer formation will be something like this. Okay, it is a case, it is a flow, laminar flow initially, then it will be mixed flow, something like this, then the flow will become turbulent. So I'm asking you, this is the distance x, ये वाला जो distance है x means HL, this is L. Okay, and L is nothing but L कितना आपका? L is 0.609 meter length of the plate, and this is the characteristic dimension. For the natural convection, the dimension of the plate, okay, along the flow, that is known as a characteristic dimension. तो यही आपकी क्या है? This is characteristic dimension. This length of the plate is nothing but this is your characteristic dimension. तो निकाल सकते हो आप. आपसे relationship पूछ रहा है HL first. तो easily you can calculate Grashof number G beta delta T L cube by nu square. Every data is given to you. You can calculate that. Prandtl number is directly given to you. 0.72. So what value of HL you are getting guys? Please tell me. Please give me some answer. Very good. बच्चे का आंसर आया 4.3. साइक का चक्रवर्ती, बिल्कुल सही आंसर है बच्चे आपका. HL you will get, HL जो आपका आएगा 4.3049. Okay, 4.3049 आंसर. बट मेरे हिसाब से ये आंसर नहीं होना चाहिए. दे मेंशन दिस एज आंसर. व्हाई? बिकॉज थोड़ा हो जाता है, बिकॉज उन्होंने इसको आंसर कर दिया, बट दिस इज नॉट द आंसर. अब इसमें एक चीज होना चाहिए, बिकॉज मैंने इसमें कोई क्वेश्चन में चेंजेस नहीं किए हैं. वन थिंग इज देयर, लाइक गाइस, व्हेन वी आर पिकिंग क्वेश्चंस फ्रॉम एनपीटीईएल असाइनमेंट, real data as it is we are picking. If there is some mistake, there is mistake. Okay, we are not correcting those mistakes by our own. So what I feel, इन दिस केस ही मेंशन्ड एवरेज हीट ट्रांसफर कोफिशिएंट। अब या तो उसको एवरेज नहीं लिखना था, ओके, या तो उसको एवरेज नहीं लिखना था, एवरेज लिख दिया, दिस इज नॉट एवरेज, आई कैन नॉट से दिस इज एवरेज कन्वेक्शन हीट ट्रांसफर कोफिशिएंट, दिस इज हीट ट्रांसफर कोफिशिएंट एट द ट्रेलिंग एज। एवरेज के लिए तो आपको क्या करना पड़ेगा बच्चों, एवरेज के लिए तो आपको देखो ये एक्सरसाइज करनी पड़ेगी। अब दिस इज द केस ऑफ लैमिनार फ्लो। टर्बुलेंट के लिए क्या केस था बच्चों, टर्बुलेंट के लिए टर्बुलेंट फ्लो ओवर टर्बुलेंट फ्री कन्वेक्शन ओवर वर्टिकल प्लेट, h bar is constant, h bar is not changing, and here if you will calculate, carry out some analysis, Nusselt number, ओके अभी देखो एक हिंट अपने को यहां से मिल गया है, एक हिंट अपने को क्या मिल गया, व्हाट हिंट एक्चुअली वी आर गेटिंग, व्हाट हिंट वी आर गेटिंग, उसने यहां पे NU बार लगा दिया बच्चों, NU बार लगा दिया, देन यस इट इज फाइन, देन फाइन, तब हम इसको H बार भी बोल सकते हैं और इसको HL भी बोल सकते हैं। बट एक्चुअल में अगर वो यहां पे N बार नहीं लगाता, फॉर एग्जांपल यहां पे NU बार नहीं लगाता, then you are going to get HL and then you need to multiply it with that some kind of relationship, and from that only you are going to get the H bar. There is a difference between H bar and HL, but how we can say कि this HL is H bar? Why? Because he mentioned NU bar. अब उसने कुछ ना कुछ constant में कुछ changes कर दिए, like some kind of correlation he is using, and from that correlation directly we are getting H bar. तो फिर अपने को वो बेसिक अप्रोच नहीं लगानी है कि we are going to get some HL and then you need to multiply it with some kind of constant to get the H bar. You got the point guys? अभी मैंने भी इसको यहाँ एनालाइज किया, दिस इज NU बार मींस डायरेक्टली वी आर गोइंग टू गेट H bar only from this, ठीक है, दैट्स व्हाई दिस आंसर दे हैव गिवन दिस इज राइट, बिल्कुल सही हो जाएगा ये, ठीक है। बट अगर यहाँ पे NU खाली NU होता बच्चों, अगर यहाँ पे खाली NU होता, देन इनिशियली यू आर गोइंग टू गेट HL एंड फ्रॉम दैट यू नीड टू गेट द आइडिया अबाउट द HL, ओके, H bar कैसे, देखो वही चीज हो जाती। अभी ये क्या है, सपोज ये NUL होता, ओके, तो दिस इज सम कांस्टेंट इनटू ग्रेशोफ इनटू प्रेंडल्ट की पावर 1/4, तो यहां पे फिर रिलेशनशिप अलग हो जाता, तो दिस इज HL इनटू L बाय K इनटू G बीटा डेल्टा TL क्यूब बाय न्यू इनटू न्यू बाय अल्फा पावर 1/3। तो यहां से अगर हम रिलेशनशिप निकालते ना, तो HL इज ए फंक्शन ऑफ L की पावर 3/4 डिवाइड बाय L, मींस HL इज डायरेक्टली प्रोपोर्शनल टू L की पावर, ये कितना हो जाता, ये ऊपर जाता है तो माइनस, ये हो जाता -1/4, -1/4। अब इसका इंटीग्रेशन करेंगे तो -1/4 + 1, सो इट विल बिकम व्हाट, -1/4 + 1 4/3। तो यस, तो आपका रिलेशनशिप क्या आएगा, H bar इक्वल टू 4/3 HL, H bar इक्वल टू 4/3 HL। दिस इज अ केस ऑफ व्हाट, लैमिनार फ्री कन्वेक्शन, this is a case of laminar free convection, laminar free convection, okay, but यहां पे ये करने की जरूरत क्यों नहीं है बच्चों, in this case this is not required, yes what I am saying, in this case this is not required, in this case this is not required, why, because he has not given you case relation for NUL, उसने अपने को NUL का रिलेशन नहीं दिया था, he has directly given us the relationship for NU bar and the H which you are going to calculate from that is going to give us H bar, so the value which you are getting that is HL, that is nothing but H bar, यही हमारा H bar है, यही हमारा क्या है HL है, okay, but I discussed with you the basic concepts, you got the idea Chandan? Yes Abhinav, very good Chandan, Abhinav, okay, fine guys, in 3 hours we covered those questions. Now next question in front of you from the heat exchanger, अगले 35 क्वेश्चन बच्चों वी आर गोइंग टू सोल्व फ्रॉम द हीट एक्सचेंजर, ठीक है, नेक्स्ट 35 क्वेश्चंस वी आर गोइंग टू सोल्व फ्रॉम द हीट एक्सचेंजर। तो हीट एक्सचेंजर में इतने ज्यादा डिफिकल्ट क्वेश्चन नहीं होंगे बच्चों, टिपिकल गेट लेवल क्वेश्चन, इफ यू नो द बेसिक फॉर्मूलाज you will be easily able to answer those questions, but all different type of question related to NTU energy balance, effectiveness of a heat exchanger, all different type of questions we are going to discuss. चलिए, this is first question in front of you from the heat exchanger. बिल्कुल सही, फर्स्ट क्वेश्चन का आंसर क्या है, बिल्कुल सही, LMTD में हम करेक्शन फैक्टर लेते हैं, बिकॉज LMTD we cannot calculate for all the cases, LMTD हम कैलकुलेट कर लेते हैं, काउंटर फ्लो के लिए कर सकते हैं, काउंटर फ्लो, ओके, पैरेलल फ्लो के लिए कर लेते हैं, अब क्रॉस फ्लो के लिए कैसे करोगे, हाउ यू विल कैलकुलेट दिस फॉर क्रॉस फ्लो, ओके, तो हर केस के लिए हम इसको नहीं कर सकते, दैट्स व्हाई ऑप्शन सी इज द राइट आंसर। हम क्या लेते हैं, करेक्शन फैक्टर लेते हैं। चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं। When TC1 and TC2 are the temperature of cold fluid at entry and exit respectively, THI and TH2 are the temperature of hot fluid at the entry and exit respectively, and cold fluid has lower heat capacity rate compared to hot fluid than effectiveness। आपसे बोल रहा है कि जो cold fluid है, cold fluid has lower heat capacity rate, तो आंसर बहुत आसान हो जाएगा। इफेक्टिवनेस ऑफ हीट एक्सचेंजर इज नथिंग बट m डॉट cp m डॉट h cph thi माइनस the, या तो ये ले लो, या दूसरा क्या ले सकते हो, m डॉट c cpc इंटू tce माइनस tci। ऊपर तो न्यूमरेटर में तो कुछ भी ले सकते हैं, डेनोमिनेटर में हम क्या लेते हैं, m डॉट cp स्मॉल, m डॉट cp m dot cp small into thi minus tci. This is q actual by q maximum, the ratio of q actual by q maximum. This is known as effectiveness of a heat exchanger, effectiveness of a heat exchanger. So as he is saying कि cold fluid is having low heat capacity rate, means this is small, ये small है, so you need to take this only, so this will cancel out, so effectiveness equal to tce minus tci divided by thi minus thci tci. So let's see which one is matching। तो कौन सा मैच कर रहा है बच्चों, you can check tce tc2 minus tc1 divided by thi minus tc1 means option D is the right answer। option D क्या हो जाएगा बच्चों, this is the right answer for this question। don't say C guys, वैभव C गलत हो जाएगा बच्चों, D is the right answer for this question। ठीक है, मंगना रेड्डी योर आंसर इज राइट, वेरी गुड। तो थोड़ा सा केयरफुल रहना है बच्चों। यस कोना योर आंसर इज ऑल्सो राइट, वेरी गुड। चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं। In a heat exchanger, if one of the fluid undergoes change of phase, then performance of it is independent of the orientation of the fluid. Performance of it is best for the counter flow, cross flow, or parallel flow. What you will answer? Guys, you know, when if one of the fluid is going to change the phase, like if it is a case of what, like something like this, it is a case of suppose condenser, ये condenser है, this is a case of condenser, okay, parallel flow condenser, okay, or suppose you are having a case of boiler, this is a case of parallel flow boiler, this is boiler। if one of the fluid is changing phase, अगर कोई ना कोई fluid change phase change कर रहा है, तो हमेशा क्या होता है बच्चों, डेल्टा tm, this is for condenser, parallel, this is parallel। काउंटर में कैसे बनाओगे बच्चों, काउंटर में it will be something like this, this is counter, okay, this is counter for condenser only, and for boiler the counter arrangement will be something like this, okay, this is counter flow arrangement for boiler, this is parallel flow, this is counter flow, this is also parallel flow, these both are for condenser, these both are for boiler, okay, these are the temperature profile। and you know guys, when one of the fluid is changing phase, हमेशा क्या होता है, delta tm parallel that is equal to delta tm counter, और वहां पे it is immaterial to say which type of heat exchanger you are using, both are going to give you same performance। option A क्या हो जाता है वहां पे, right answer हो जाता है। the performance is independent of the direction of the orientation of the flow, like you can take parallel arrangement, you can take counter arrangement, in both the cases the heat transfer, delta tm will be same if you are having same kind of area, so the heat transfer will also be same and performance will also be same। okay, chaliye let us now move to next question, question number 39। अभी आ गया हमारे पास पहला क्वेश्चन। there is a condenser is required for a organic vapor having latent heat। a condenser is required for a organic vapor which is having latent heat, this flowing at a rate of 6 kg per second, the vapor is pure and may be assumed to be condensed at the saturation temperature of 60 degrees Celsius। the condenser is cooling by side cooling water which is having specific heat, this with an inlet temperature 15, exit temperature 35, overall heat transfer is this, calculate the cooling water flow rate. बिल्कुल हलवा क्वेश्चन है बच्चों, very easy simple question. Can you answer this question, guys? He's asking you the cooling rate. So guys, heat transfer in steady flow energy equation for the heat exchanger. Steady flow energy equation for the heat exchanger is what? The decrease in enthalpy, change in enthalpy, the decrease in enthalpy of the hot fluid is equal to increase in enthalpy of the cold fluid. This is the energy balance equation for the heat exchanger, steady flow energy equation, you know. And from that we can write for hot fluid is the fluid which is condensing, ये fluid जो condense कर रहा है, अब phase change हो रहा है, so उसका enthalpy change क्या होगा, that will be mass flow rate of the fluid, mass flow rate of the hot fluid into HFG. Okay, this is equal to mass flow rate of the cold fluid into Cp of the cold fluid into change in temperature of the cold fluid. So mass flow rate of the hot fluid means the fluid which is condensing is 6 kg per second vapor. The latent heat of vaporization is 250 kilojoule per kg. Mass of the cold fluid you want to find out. Cp is given to you 4.2 kilojoule. Okay, kilojoule it will be cancelled out. Change in temperature of the hot fluid is 15 पे आ रहा है, 35 पे जा रहा है, so it is 20. So solving this easily, you will get mass flow rate of the cold fluid. Easily you will get a mass flow rate of the cold fluid. बिल्कुल सही बच्चों, those are getting option D, they are very right. बिल्कुल सही, D is the right answer for this question. थोड़ा जल्दी करेंगे बच्चों, अभी 50 क्वेश्चन पे we will take break. 50 क्वेश्चन टारगेट करेंगे कि 50 5:30 तक हो जाए हमारे, है ना? ओके, चलिए, D is the right answer for this question. Can you tell me the area also, guys? इस केस के लिए क्या एरिया बता सकते हो मेरे को? Can you tell me the area of heat exchanger? Can you tell me the area of heat exchanger, guys? Yes. Can you tell me the area of heat exchanger, guys, for this question? Area and delta Tm. For this case, because in next part he is asking you these two things only. अगले पार्ट में आपसे यही दो चीजें पूछ रहा है. अगले पार्ट में आपसे दो ही चीजें पूछ रहा है. LMTD पूछ रहा है आपसे, डेल्टा Tm for the same case, and area मैंने ऐड कर दिया है, area of heat exchanger. Area of heat exchanger. So can you tell me these two things, guys, for the same case which we have solved? For the same case, can you tell me what is the LMTD? What is the LMTD value you are getting, and what is the area of heat exchanger? बिल्कुल बच्चों, LMTD value will be 34, so D is the right answer for LMTD. D is the right answer for LMTD. बिल्कुल सही. And the area is not right, आशीष. Area calculate करो दोबारा. 98 is not right, I think. 98.68 is not right. Ashish, check your calculation. LMTD is 34. बिल्कुल सही. For LMTD, D is the right answer. बिल्कुल सही बच्चों. Calculate the area of heat exchanger also. नहीं नहीं नहीं, वैभव गलत हो जाएगा. देखो Q कितना है? Q is equal to 6 into HFG. HFG कितना था? 6, 250. This is HFG, 250 किलो जूल पर केजी. तो इसको 10 की पावर 3 से मल्टीप्लाई कर दो. अपने को तो ऐसा यूनिट यूज करना ना, तो वहां पे तो कैंसिल आउट हो जाता है, बट यहाँ पे अपने को 10 की पावर 3 भी लिखना पड़ेगा. दिस इज Q, दिस इज UA डेल्टा Tm. U इज गिवन टू अस. U कितना दिया है? U इज 760. U is 760. तो 760 into area we want to find out, and delta Tm is 34. So now can you tell me what is the area value you are getting, guys? Don't do mistake, guys. Mistake क्यों कर रहे हो? अभी देखो कुछ बच्चे कह रहे हैं 0.048, कहीं कह रहे हैं 98, 58, कुछ कह रहे हैं 5.8. बच्चों देखो इतने यूनिक आंसर कैसे कर रहे हो आप? 58 is the right answer, guys. You are making some kind of calculation mistake. Don't do these kind of things. 58.049 meter square. This is the answer for this question. 58.04. 58.049 meter square. This is the right answer for this question. LMTD 34 and the area is 58.049. चलिए नेक्स्ट क्वेश्चन पे आते हैं। इसमें थोड़ा सा क्या है, डेटा रॉन्ग है, तो मैं आपको बता देता हूं, बिकॉज दिस पीडीएफ यू आर हैविंग, यू विल लेटर स्टेज यू विल रियलाइज दैट। देखो इस केस में उसने क्या दिया, आपसे पूछ रहा है डिटरमाइन द रिक्वायर्ड हीट एक्सचेंजर एरिया, आपसे पूछ रहा है हीट एक्सचेंजर एरिया बताओ, is asking you the heat exchanger area, is giving you answer in what, kilowatt। तो ये मैंने असाइनमेंट भी चेक की, इन दैट असाइनमेंट आल्सो देयर वाज दैट मिस्टेक। तो आपका आंसर कोई मैच नहीं करेगा, यू कैन ट्राई टू आंसर दैट क्वेश्चन बट यू आर नॉट गोइंग टू मैच योर आंसर, ठीक है, बिकॉज ही इज आस्किंग यू डिटरमाइन द एरिया एंड ही इज गिविंग यू ऑप्शंस फॉर द हीट ट्रांसफर, और वो भी मैच नहीं कर रहा है, हीट ट्रांसफर इज आल्सो नॉट गोइंग टू मैच, ठीक है। 2 शेल 4 पासेस दिए, ठीक है, बट उसने आपको करेक्शन फैक्टर भी दे दिया है, सो यू कैन कंसीडर दिस एज ए केस ऑफ काउंटर फ्लो ओनली। काउंटर फ्लो मान के करेक्शन फैक्टर यू कैन यूज, यू कैन हैव फॉर दिस अरेंजमेंट आल्सो द LMTD, okay, LMTD easily you will have, so you need not to worry about 2 shell 4 passes because he is giving you correction factor, so you need to consider this case as a counter flow only, you will get the answer for the LMTD, then if you will multiply it with the correction factor you will get the LMTD actual, and using that you will get the area which is equal to 4.75 meter square। मैंने जो एरिया निकाला था, you can also match, area will come out close to, you can match your answer, I'm not sure because there is no such option given by them, they are asking you area but they are giving you options in heat transfer kilowatt, okay। तो इसको मैं लिख रहा हूँ wrong data, इसका जो डेटा है वो गलत है, इस क्वेश्चन का जो डेटा है वो क्या है, गलत है, तो आप इसको नहीं सोल्व कर पाओगे। नेक्स्ट क्वेश्चन मूव करते हैं। चलिए, identify the incorrect statement, identify the incorrect statement regarding fouling and corrosion, identify the incorrect statement for fouling and corrosion, which one is the incorrect statement। ये अच्छा क्वेश्चन है बच्चों, ट्राई टू आंसर, ये MSQ है, दिस इज MSQ। अभी देखो गेट में तो अब आने शुरू हुए हैं पिछले साल से, in assignments, in those NPTEL assignment they are asking you MSQ from the year 2017-18, बहुत पुरानी असाइनमेंट है बच्चों, ऐसा नहीं कि आजकल की असाइनमेंट है, 17 18 19 की असाइनमेंट है। MSQ they started from year 2021, so you can get the idea कि what kind of relationship is there in those NPTEL assignments and GATE, ठीक है। numerical answer type question, first they start asking those numerical answer type question in those NPTEL assignment, then we will have, you know, now we are having those numerical answer type question also। पहले तो गेट में ऑब्जेक्टिव ही आते थे, बट अभी तो 3 तरह के क्वेश्चन आते हैं, ऑब्जेक्टिव आते हैं, न्यूमेरिकल आंसर टाइप आते हैं, मोस्ट ऑफ द क्वेश्चंस आर नाउ न्यूमेरिकल आंसर टाइप, और तीसरे कौन से आते हैं अपने MSQ, तो ये MSQ टाइप है। व्हाट यू विल फील व्हिच स्टेटमेंट्स आर रॉन्ग। अब इसमें मैं आपको एक हिंट दे देता हूं, एक स्टेटमेंट भी गलत हो सकती है, एक भी गलत हो सकती है, दो भी गलत हो सकती है, तीन भी गलत हो सकती है, और सारी भी गलत हो सकती है, ठीक है। यू विल गेट मार्क्स ओनली इफ यू विल आंसर इट राइट। तो मनोगुमा ने आंसर किया सबसे पहले BCD। BCD में देखो, इस क्वेश्चन में देयर इज नो नेगेटिव मार्किंग, इन दिस क्वेश्चन देयर इज नो नेगेटिव मार्किंग, बट BCD इज नॉट राइट। चलिए, ट्राई टू अगेन थिंक, other I'm waiting for response of some other students also, try to think guys, identify the incorrect statement regarding fouling and corrosion। देखो आपको कंफ्यूजन क्या हो रहा है कि सर दे आर अनरिलेटेड फिनोमिना, दे आर नॉट अनरिलेटेड, देयर इज कोरोजन फाउलिंग आल्सो ना, कोरोजन फाउलिंग भी तो होती है, फाउलिंग इज ऑफ डिफरेंट टाइप, देयर इज बायोलॉजिकल फाउलिंग, देयर इज स्केलिंग, देयर इज कोरोजन फाउलिंग आल्सो, सो corrosion is also a kind of fouling, you cannot say they are unrelated phenomena, they are related phenomena, are you getting the idea? corrosion and fouling they are related, corrosion की वजह से तो fouling होगा ना बच्चों, the phenomena will be different, the phenomena for scaling, for corrosion, okay, for kind of particulate matter deposition, the phenomena will be different, so this is what regarding identify the incorrect statement। तो ये statement तो सही है, this statement is right, ये statement क्या है, सही है, okay। आइडेंटिफाई द इनकरेक्ट स्टेटमेंट आपने को निकालना है, कोरोजन अकर्स ओनली ऑन लिक्विड साइड, आपने को इनकरेक्ट स्टेटमेंट निकालना है, क्या निकालना है, इनकरेक्ट स्टेटमेंट, इनकरेक्ट स्टेटमेंट निकालना है, ओके। सो आइडेंटिफाई द इनकरेक्ट स्टेटमेंट निकालना है अपने को, कोरोजन एंड अकर्स ऑन द लिक्विड साइड, दिस इज रॉन्ग, ये स्टेटमेंट दिस इज नॉट राइट, दिस इज आल्सो इनकरेक्ट, दिस इज आल्सो इनकरेक्ट, दे आर अनरिलेटेड फिनोमेना, गलत है बच्चों, दे आर रिलेटेड फिनोमेना, so means this statement is incorrect, पहली statement क्या है, incorrect है, they are not unrelated, they are related phenomena। corrosion occurs on the liquid side, क्या liquid side पे ही corrosion होता है, no, that is also not right, why, because corrosion can occur on the air side also, due to the moisture present in the air, the corrosion can be takes place on the outside also, so this statement is also incorrect। Though operating temperature influence fouling, fluid velocity does not affect fouling. क्या fluid velocity से fouling पे फर्क नहीं पड़ेगा? It is going to affect. Why? If the fluid velocity is very high, the fouling will be less. The scaling will be less. You know, in high pressure boiler, why we use high pressure, high velocity fluid? Because using high velocity fluid, high pressure fluid, the chances of scaling will be very less. If a fluid is flowing in the pipe at a very slow rate, देखो कहीं आपका जो कोई you know, like suppose if you are having a kind of river or some drainage where water is flowing at a very slow rate, very slowly it is flowing, so the biological fouling will be very high, the chances of fouling will be high. But if water is flowing at a slow rate पे अगर flow कर रहा है, then fouling will be high. If it is flowing at high speed, then fouling will decrease. So if the fluid is moving at high velocity, the fouling chances will be right. So this is also incorrect. ये भी incorrect है. Chemical cleaning of fouling deposits are avoidable as it weaken the heat exchanger. This is also wrong. तो ये सारी की सारी incorrect है. All are incorrect. You are getting the idea, guys? सभी की सभी जो statements है, all are incorrect. All statements are incorrect. Why? Because fouling, corrosion, they are related. There are different type of fouling. Fouling is nothing but, guys, it is the accumulation of unwanted material on the solid. Accumulation of some kind of unwanted deposition, unwanted material on the solid surface, that is known as fouling. There are different type of fouling, guys. Okay, so it may be scaling also, it may be you know, particulate fouling, it may be corrosion fouling, it may be biological fouling. So you cannot say those are unrelated. All are the incorrect statement. So all are incorrect. So A B C D is the right answer. इसके लिए A B C D आपको सबको क्लिक करना पड़ेगा. सबको क्लिक करोगे, then only you are going to get marks for this question. Otherwise you will not get marks. Scales developed. ठीक है बच्चों, इज दैट क्लियर? ये क्वेश्चन क्लियर है? नेक्स्ट क्वेश्चन में मूव करते हैं. क्वेश्चन नंबर 43. Oil at 120 degrees Celsius is used to heat water at 30 degrees Celsius in a 1-1 counter current shell and tube type heat exchanger. The available area is S1. The exit temperature of the oil and water are these respectively. Co-current heat exchanger by 1-1 counterflow heat exchanger is having area S2. For the heat exchanger, the exit areas, exit temperature and the net heat transfer are same. Overall heat transfer coefficient for the case S1 by S2 are same. What is the ratio of S1 by S2? तो आपसे एरिया का रेशियो पूछ रहा है बच्चों. क्वेश्चन बड़ा सिंपल है, थोड़ा सा लग रहा है डिफरेंट है. So he is asking you these ratios. मैं दोबारा आपको एक बार ब्रीफ कर देता हूं. So there is oil at 120 degrees Celsius which is used to heat water in a co-current shell and tube type heat exchanger which is having area S1. तो हम बना देते हैं, यहाँ पे एक co-current है. Co-current means parallel flow. ओके, तो यहाँ पे तो oil है, ऑयल जा रहा है 120 पे, कितने पे एग्जिट कर रहा है अपने को नहीं पता. ये यूज कर रहे हैं फॉर हीटिंग द वाटर. कोकरंट मतलब सेम फ्लो, 30 डिग्री सेल्सियस पे अपना क्या कर रहा है, वाटर फ्लो कर रहा है. ओके, यहाँ पे जो एरिया है, एरिया इज S1. एग्जिट टेम्परेचर इसका अच्छा दिया है अपने को. दिस इज हैविंग 90, दिस इज हैविंग टेम्परेचर 90 एंड दिस इज हैविंग टेम्परेचर TCE, दिस इज 60. These temperatures are also given to us. Okay, the co-current heat exchanger is replaced by counter current. Co-current को आपने replace कर दिया counter current से. So this arrangement will be something like this. So this is 120, this is 90, this is 30, this is 60 because remaining things are same. Remaining things are same. Okay, बाकी चीजें क्या है, same है बच्चों. This is 60 degree Celsius. Okay, so what is saying? If for this case the area is S1, for this case the area is S2. If U is same, U same है आपका, temperature difference, all things are same. He is asking you the ratio of these S1 and S2. तो बहुत अच्छा क्वेश्चन है बच्चों, but very simple. And he is asking you the ratio of S1 by S2. Can you answer this question, guys? Everything is same. Available areas are different. Available areas are different. Temperature difference, U value are same. So from where you are going to get the idea? Guys, as you can see, mass flow rate of the hot fluid, mass flow rate of the cold fluid, mass flow rate of hot fluid, mass flow rate of cold fluid, those are same. Temperature difference, hot fluid, temperature difference, cold fluid, those are same. What it means? It means you are only changing the arrangement. Okay, the area you are changing, arrangement you are changing, Okay, but the heat transfer is same. The heat transfer Q is same. Q क्या है दोनों केसेस के लिए सेम है. Okay, Q is same. What it means? It means you can say, suppose this is case 1, so U1 A1 which is equal to S1. Okay, U1 A1 delta Tm parallel, that is equal to U S2 delta Tm counter. Yes or no? Because Q is same. How you can say such Q is same? Because there is no change in the mass rate. He has not mentioned anything about that mass flow rate. He has not mentioned anything about the temperature change. Temperature change is same in here also. Like, what is Q, guys? Q is nothing but m dot Cph Thi minus The. This is equal to m dot C for the Tce minus Tci. Yes or no? There is no change in the temperature. There is no change in the mass rate. So Q is same. There is no change in the Q. Okay. So if you will equate this Q, this idea if you will have, अगर ये दिमाग में आपके आ गया, then easily you will get the answer. This both are same. It means if you want this ratio S1 by S2, sir, S1 by S2 is nothing but it is a ratio of delta Tm counter divided by delta Tm parallel. So you need to calculate delta Tm for these two cases and then you need to take that ratio. Yes, try to answer, guys, which answer you are getting. बच्चे अभी भी मिस्टेक कर रहे हैं यार. आप कैसे हाउ यू कैन डू दीज काइंड ऑफ मिस्टेक्स. देयर इज नो ऑप्शन विद ln3. ओके, 0.91 इज आल्सो रॉन्ग. आप 0.91 आपका इसलिए आ रहा है बच्चों बिकॉज दैट ऑप्शन इज आल्सो देयर. आई थिंक यू आर टेकिंग दिस रिवर्स. आप इसका रिवर्स ले रहे हो. ओके, आप इसका रिवर्स ले रहे हो. काउंटर फ्लो LMTD, इट विल कम आउट 60. इट विल कम आउट 60. इट विल कम आउट 54.614. अब आप इसका आप रिवर्स लोगे then obviously you will get 0.9, which is wrong actually. You will get negative marks. So man, make easy. You need to check. Okay, 0.91 is not right. 1.1 is the right answer. 1.1 is the right answer because this S1 by S2 will come out 1.098, which is very close to 1.1. Okay, तो इस तरह की चीजों को बोलते हैं सिली मिस्टेक. यही आपको अवॉइड करनी है बच्चों. You need to avoid these kind of silly mistake. Okay, chaliye. So I think these things are like very much clear how to calculate LMTD. You can mention, guys, there is no such don't take any kind of you don't not to be hesitate in asking me, sir, how you are calculating those LMTD. So I'm not discussing here because those things are very much simple, very much direct. If you're preparing for GATE, I think you're having that kind of basic understanding how to calculate LMTD. तो टेम्परेचर प्रोफाइल आपके पास है, तो आप यही सेम फार्मूला अगर आप लगाओगे, डेल्टा टीएम इज इक्वल टू डेल्टा टी आई माइनस डेल्टा टीई डिवाइड बाय ln ऑफ डेल्टा टीआई बाय डेल्टा टीई. एंड ऑब्वियसली वी नो फॉर द सेम काइंड ऑफ टेम्परेचर चेंजेस LMTD ऑफ काउंटर इज ऑलवेज मोर. LMTD काउंटर का क्या होता है, ज्यादा होता है. दैट्स व्हाई द एरिया रिक्वायर्ड फॉर द काउंटर इज लेस. काउंटर के लिए एरिया क्या होता है, ज्यादा होता है. अभी ये S1 by S2 है. S1 by S2 is coming out more. Why? Because S1 is the area of the parallel flow, S2 is the area of the counter flow. ठीक है बच्चों. So for this question, this is the right answer. B is the right answer for this question. Next question में move करते हैं बच्चों जल्दी से. Try to answer this question, guys. Let me read it for you. ln3 आएगा. Webber, how you are getting ln3? ln3 कैसे आ जाएगा बच्चों? अच्छा, ln3 आप उसको अगर आप कैलकुलेट करोगे हो सकता है वो इतना ही आ जाए. यू कैन चेक. ओके, यू कैन चेक. Yes, that will also coming out 1.1 only. ठीक है, तो ln3 भी लोगे, but there is no such option with ln3 ना. That's why I'm saying. ठीक है, ऑप्शन तो अपने को दिया है 1.01. तो अब ln3 ढूंढते रहोगे तो उससे तो नहीं होगा ना वैभव. You need to check the options. So options are given 1.1. ठीक है, चलिए, तो B is the right answer for this question. बिल्कुल सही, वैसे आपका मैथमेटिकली बिल्कुल सही है. Let us move to next question 44. काउंटर फ्लो हीट एक्सचेंजर है बच्चों, आपको NTU पूछ रहा है. सिंपल क्वेश्चन है, तो डायरेक्ट क्वेश्चन है. NTU इक्वल टू UA बाय m डॉट Cp स्मॉल. U दिया आपको, डायरेक्टली दिया U 200, एरिया दिया है 32.5, m डॉट Cp स्मॉल. चेक कर लो कौन सा यार. दोनों को मैथमेटिकली कैलकुलेट करके चेक करो एंड टेल मी व्हाट NTU वैल्यू यू आर गेटिंग. व्हाट इज द NTU वैल्यू यू आर गेटिंग? Yes, the area required in the parallel flow is more as compared to the counter flow because LMTD is for counter flow is more. always as compared to the LMTD of parallel flow. Okay, counter flow heat exchangers, they are more efficient as compared to parallel flow heat exchangers. So what NTU value you are getting guys? M dot Cp small, कौन सा आ जाएगा M dot Cp small? देखो इसको इसके साथ मल्टीप्लाई करोगे तो ये तो कुछ 8000 से बड़ा बनेगा. 41802 इट इज कमिंग आउट नो मोर देन 8000. इसको इससे करोगे तो ये 5000 की रेंज में आएगा. मींस दिस इज स्मॉल, यही स्मॉल है तो इसको लिख दो यहाँ पे. सो 2200 मल्टीप्लाई बाय 32.5 डिवाइड बाय m dot cp small means this 1030 मल्टीप्लाई बाय 5.25. यूनिट चेक कर लेना, जूल पर केजी and kg per second. If you will solve this, you will get NTU equal to 1.26. NTU, which is known as number of transfer unit. Number of transfer unit 5407 कहां से आ गया बच्चों? NTU is number of transfer units. It tells us about the size of heat exchanger. Okay. It tells us about the effectiveness of heat exchanger. NTU of a heat exchanger decides the effectiveness of a heat exchanger. If more is the NTU, more is the effectiveness of a heat exchanger. More is the area also, and more is the heat transfer from the heat exchanger. More NTU, more area, more heat transfer, more effectiveness. Okay, number of transfer units, which is equal to NUA by m dot Cp small. So first you need to check which one is m dot Cp small. In a counter flow heat exchanger, this certain heat exchanger, both fluids have identical mass flow rates. दोनों का mass flow rate same है. M dot Cp equal to m dot H Cph. Both are same. It means heat capacity rate ratio is 1. Heat capacity rate ratio is 1. Okay. He is asking you the effectiveness. अरे तो बड़ा आसान क्वेश्चन है. Effectiveness क्या हो जाएगा? कोई भी ले लो यार. अभी तो क्या है, नीचे आएगा सर THI minus TCI. ऊपर जिसका टेम्परेचर दिया है सर उसको ले लो. जिसका टेम्परेचर चेंज दिया है उसको ले लो. किसका दिया है? हॉट फ्लूइड इज चेंजिंग फ्रॉम 70 टू 47, इसी को ले लो. 76 टू 47, इसी को ले लो. ओके, बिकॉज दोनों का टेम्परेचर डिफरेंस विल कम आउट सेम. इफ यू विल चेक दिस 76 माइनस 47, इसको अगर आप चेक करोगे दिस विल कम आउट 55.26. दोनों सेम आएंगे. दोनों को इफ यू विल चेक द डिफरेंस इट विल कम आउट सेम. ओके, 26 और 3 29 आएगा, ये भी 29 आएगा, एंड दिस विल आल्सो कम आउट 29. ठीक है बच्चों, चलिए. सो एनीवन यू कैन टेक, कोई भी आप ले लो, दोनों क्या आएंगे? सेम आएंगे. सो दिस इज 29 डिवाइड बाय हॉट फ्लूइड इन टेम्परेचर. हॉट फ्लूइड इन कितना है बच्चों? हॉट फ्लूइड इन इज 76, कोल्ड फ्लूइड इन इज 26. तो 29 डिवाइड बाय 50. 29 डिवाइड बाय 50, दिस इज योर इफेक्टिवनेस. 29 by 50, this is your effectiveness. Okay, and yes, the answer is 0.58. 0.58 is the right answer for this question. 0.58 is the right answer. So B क्या हो जाएगा बच्चों? This is the right answer for this question. बिल्कुल सही. चलिए, let us move to next question. Which of the following statements are correct regarding NTU? Which of the following statements are correct regarding NTU? एनटीयू के रिगार्डिंग कौन सा स्टेटमेंट है जो सही है? All statements are right. Why? Because NTU depends the size of the heat exchanger. It determines the surface area. More is the NTU. NTU is more. The surface area is more. The heat transfer is more. Effectiveness is more. You know, there is some relationship for the NTU and effectiveness. Okay. NTU में और इफेक्टिवनेस में हीट एक्सचेंजर में क्या रिलेशन होता है बच्चों? दे आर डायरेक्टली प्रोपोर्शनल. जैसे जैसे NTU बढ़ता है आपका इफेक्टिवनेस भी बढ़ता है. ओके, बट effectiveness is inversely proportional to C. Effectiveness is inversely proportional to C. C, when C is 0, the effectiveness will be more. At C equal to 1, the effectiveness is less. So effectiveness is directly proportional to NTU. Okay, but effectiveness is inversely proportional to 1 by C. What is C? C is the heat capacity rate ratio. C is heat capacity rate ratio. Okay, heat capacity rate ratio. All are right. So we can say all are the above are right for this question. Let us move to next question, guys. Question number 47. जल्दी से करते हैं, and then we will take some 5-10 minutes break and again we will move. Radiation के बच्चों बहुत अच्छे अच्छे क्वेश्चन सोल्व करने वाले हैं. You are having the workbook with you. You can answer, you can realize the beauty of those questions. At the end, surely you are going to appreciate those, the beauty of those questions made by IIT professor for those NPTEL assignments. बहुत अच्छे क्वेश्चन हम डिस्कस करने वाले हैं रेडिएशन से भी. Which of the following are correct for reference to the effectiveness? इफेक्टिवनेस काउंटर का सबसे ज्यादा होता है, क्रॉस का उससे कम होता है और पैरेलल का सबसे कम होता है। ऑप्शन ए क्या हो जाएगा? दिस इज द राइट आंसर फॉर दिस क्वेश्चन। ओके, कुछ रिलेशनशिप भी होते हैं, वो भी आप याद रख सकते हो। इफेक्टिवनेस ऑफ पैरेलल इज 1 माइनस सी इंटू 1 प्लस सी 1 प्लस ई की पावर NTU डिवाइड बाय 1 प्लस सी। This is the relationship for effectiveness of a parallel flow heat exchanger. Effectiveness for parallel flow heat exchanger 1 minus c 1 minus e की power minus 1 minus c 1 plus c NTU divided by 1 plus c. This is a relationship for parallel flow heat exchanger. Okay, similarly you can write it for counter flow also. counter के लिए भी लिख सकते हो आप, आपको याद रखना पड़ेगा। So 1 minus e की power minus 1 minus c NTU divided by 1 minus c e की power minus 1 minus c NTU. Okay, this is the relationship for effectiveness of counter flow heat exchanger, and this one is the effectiveness for the parallel flow heat exchanger. Both expressions are very important for us. Okay, yes, and there are some more conclusion. दोनों से कुछ conclusion भी हम निकालते हैं बच्चों। दोनों से conclusion क्या निकालते हैं? When c equal to 0, when c equal to 0, c equal to 0 means phase change. जब भी फेज चेंज होता है, फेज चेंज जब होगा, इफेक्टिवनेस क्या हो जाएगा? सेम हो जाएगा। इफेक्टिवनेस ऑफ पैरेलल इक्वल टू इफेक्टिवनेस ऑफ काउंटर। इफ c equal to 0 means phase change, for the phase change c will be 0. Okay, and for that case effectiveness of parallel equal to effectiveness of counter, this is equal to 1 minus e की power minus NTU. This also you need to remember, very very important case. Effectiveness of parallel equal to effectiveness of counter, which is equal to 1 minus e की power minus NTU for the case of phase change. Phase change means for the case of condenser or boiler. For condenser and boiler, the effectiveness for parallel flow and counter flow are same, and that is equal to 1 minus e की power NTU. There are two more relationship, guys. When c equal to 0, c equal to 1, c equal to 1 means m dot h CPH, this is equal to m dot c CPC. Both hot and cold fluid, they are having same heat capacity rate. Okay, this is for this case, guys. For this case, if both the fluid are having same heat capacity rate, means c equal to 1. For parallel flow, effectiveness of parallel will be NTU divided by 1 plus NTU. Sorry, this is for counter, guys. This is for counter. Okay, this is for counter. Effectiveness of counter is equal to NTU divided by 1 plus NTU. Okay, similarly for parallel flow effectiveness equal to 1 minus e की power minus NTU divided by 2. You can put the value c equal to 1 and you will easily get this answer. ठीक है, ये जो रिलेशनशिप है, in this relationship if you will put c equal to 1, so e की 1 minus e की power minus 2 NTU divided by 1 divided by 2, 1 plus 1 you will have 2. So this is the relationship, 1 minus e की power minus 2 NTU by 2. This is a case when both the hot fluid and cold fluid, they are having same heat capacity rate. Okay, this is the counter flow. For counter flow, if c equal to 1, guys, this term will be what? This will be cancelled out, this will be cancelled out. The case will become undetermined case. And for that case, we are having some, Al hospital using that, we use effectiveness relationship, which is equal to NTU by 1 plus NTU. Okay, from this case the case will become undetermined. Okay, but direct formula you need to remember. For the counter flow, if c equal to 1, this is the formula. For parallel flow, if c equal to 1, this is the formula. And if c equal to 0 means phase change, boiler or condenser, effectiveness are same. Okay, and I hope all these formulas are very much clear to you because they are required. चलिए नेक्स्ट, एक नंबर का क्वेश्चन है। चलिए प्लीज ट्राई टू मैच दिस नाउ। मैं ऑलरेडी आपसे डिस्कस कर चुका हूं। कैन यू मैच दिस एंड कैन यू टेल मी व्हिच वन इज द राइट ऑप्शन, गाइस? व्हिच वन इज द राइट ऑप्शन? यस, बिल्कुल सही, बी इज द राइट आंसर। बिल्कुल सही, अभी हमने डिस्कस किया बी क्या हो जाएगा बच्चों? बी इज द राइट आंसर। पैरेलल फ्लो सी इक्वल टू, पैरेलल काउंटर दोनों के लिए यही होगा बच्चों। पैरेलल के लिए भी सी इक्वल टू 0 है, काउंटर के लिए भी सी इक्वल टू 0 है, दोनों के लिए यही हो जाएगा बिकॉज दिस इज सेम फॉर बोथ पैरेलल काउंटर फ्लो। पैरेलल फ्लो हीट एक्सचेंजर सी इक्वल टू 1, तो क्या हो जाएगा? पैरेलल फ्लो है तो ये हो जाएगा, आर जेड के साथ मैच कर रहा है एंड एस इज मैचिंग विद एक्स। ठीक है, तो बी इज द राइट आंसर फॉर दिस क्वेश्चन। चलिए नेक्स्ट क्वेश्चन में मूव करते हैं। अगेन काइंड ऑफ मैच ऑफ द फॉलोइंग क्वेश्चन, मैच ऑफ द फॉलोइंग क्वेश्चन बोल रहा है आपको। सिंपल क्वेश्चन है। चलिए ट्राई टू आंसर। ये कुछ हलवा क्वेश्चन है बच्चों, इसके बाद लास्ट के जो कुछ क्वेश्चन आएंगे दोज आर न्यूमेरिकल बेस्ड आल्सो। वी विल एंड दिस हीट एक्सचेंजर। हीट एक्सचेंजर पे अपने को ज्यादा टाइम नहीं लगेगा बच्चों, हीट एक्सचेंजर पे ज्यादा टाइम नहीं लगेगा। रेडिएशन क्वेश्चन आल्सो यू नो दोज आर नॉट दैट मच लेंथी, उतने ज्यादा लेंथी क्वेश्चन नहीं होते रेडिएशन के भी, तो टाइमली वी विल बी इजीली एबल टू कंप्लीट दिस सेशन। ठीक है। कैपेसिटी रेशियो क्या होता है? दिस इज कैपेसिटी रेशियो, सी मिनिमम बाय सी मैक्सिमम। इफेक्टिवनेस क्या होता है बच्चों? इफेक्टिवनेस ऑफ पैरेलल पूछ रहा है, इफेक्टिवनेस ऑफ पैरेलल। ठीक है, तो क्या हो जाएगा? दिस इज इफेक्टिवनेस ऑफ पैरेलल। ठीक है। इफेक्टिवनेस ऑफ काउंटर, दिस इज इफेक्टिवनेस ऑफ काउंटर। नंबर ऑफ ट्रांसफर यूनिट, दिस इज नंबर ऑफ ट्रांसफर यूनिट। डी इज द राइट आंसर फॉर दिस क्वेश्चन। नेक्स्ट पे मूव करते हैं। ये क्वेश्चन रिपीट हो गया था, डबल है, एक ही क्वेश्चन है ऐसा। ठीक है, तो ये क्वेश्चन वही है, आप इफेक्टिवनेस कैलकुलेट करना, इफेक्टिवनेस विल कम आउट 0.58। आई थिंक दिस इज वेरी मच सिमिलर टू द अर्लियर क्वेश्चन। एक क्वेश्चन हमने डिस्कस किया था ना, क्वेश्चन नंबर 45, क्वेश्चन 45। तो एक क्वेश्चन है, कई बार हो जाता है ऐसा, तो ये क्वेश्चन बिल्कुल सेम है ना, दिस इज वेरी मच सिमिलर टू क्वेश्चन नंबर 45। ठीक है, क्वेश्चन 45 के सिमिलर है, तो एक और करते हैं सो दैट 50 पे आ जाए, बिकॉज इन दिस सीरीज वी आर हैविंग टोटल 105 क्वेश्चन है हमारे पास। ठीक है, तो 105 104 क्वेश्चन है, तो इस तरह के क्वेश्चन हमारे एक आध अगर ऐसा होगा तो हम 100 प्लस ही फिर भी कर पाएंगे, है ना। तो टोटल क्वेश्चंस इन द वर्कबुक आर 104। ठीक है, चलिए। सो नेक्स्ट क्वेश्चन मैं आपके सामने लगा रहा हूं, एंड नाउ आई एम गिविंग यू सम काइंड ऑफ टाइम, कुछ टाइम लो, एंड वी विल अगेन मीट आफ्टर 5-10 मिनट्स। ठीक है, 5-10 मिनट के बाद हम दोबारा मिलने वाले हैं। ठीक है बच्चों, सो देयर इज ए 5 मिनट्स ब्रेक, क्लोज टू 5:50 अगेन वी विल मीट। 6 to 7 मिनट्स के बाद बच्चों, आफ्टर 6 to 7 मिनट्स अगेन वी विल मीट एंड वी विल सोल्व सम मोर क्वेश्चंस। ठीक है, so please be with me, and definitely guys you are going to enjoy this session. We are going to solve some very good question from the radiation heat transfer also. ठीक है, और हीट एक्सचेंजर को भी खत्म करेंगे। वर्कबुक आई थिंक यू ऑल आर हैविंग, इफ यू आर नॉट हैविंग, इफ यू लाइक लेट join this session, you can go to our website, you can download that workbook, okay, and then you can start solving those questions. Session, ये you know guys, there is some limitation, okay, we cannot uh, make that file, this video, we cannot keep this video public for all the times. So if you are watching this session live, then only you will be able to see, otherwise at the end we are going to make it private only. Okay, so please be with me, and again we will meet after 5-6 minutes. Thank you. So have a break. Chaliye. रिंकू जी एक बार ना गुरविंदर सर को बोलना जो पीडीएफ फाइल है ना जो वर्कबुक का उसका लिंक शेयर कर दें चैट बॉक्स में. वो लिंक शेयर कर देना वो जो पीडीएफ जाएगा ये 8 10 7 50 हो. Okay guys, so let's start again. Please join again those who are enjoying that lunch break. Okay, so please join it again guys. Let's start with the question number 51. Yes, I think there is some link is there. You can use that link to download the workbook. So we are sharing some link with you. If you are unable to download that workbook, you can follow the instruction. You can click on that link and definitely easily you will be able to download the workbook. Okay, chaliye. So guys, let's start. So this is question number 51. Cp of the water is this: at 70 degrees Celsius enters a counterflow heat exchanger with the mass flow rate 0.5 kg per second. If air having Cp this enters at this with the mass flow rate this, what is the effectiveness of heat exchanger? This he is asking you LMTD. देखो आपको LMTD निकालना है. LMTD logarithmic mean temperature difference ये आपको निकालना है और इसको निकालने के लिए आपको चारों टेम्परेचर पता होना चाहिए. Then only you will be able to calculate the LMTD. If you don't know those four temperature, then you will not be able to calculate those LMTD. So first you need to find out all four temperature. So only two temperatures are known to us. Okay, अभी देखो कितने टेम्परेचर दिए हैं. इफेक्टिवनेस दिया है और क्या दिया है, दो टेम्परेचर दिए हैं. हॉट water is entering at 70 degrees Celsius, counter flow है, so this is water entering at 70. air enters at 30, air enter कर रहा है 30 पे, this is TCI, this is THI. okay, this is THI. इसका मास फ्लो रेट दिया है, वाटर का मास फ्लो रेट दिया है 0.4, इसका मास फ्लो रेट दिया है. सो एक टेम्परेचर हम इफेक्टिवनेस से निकाल पाएंगे. ओके, सो इफेक्टिवनेस क्या होता है बच्चों? इफेक्टिवनेस इज 0.8. Okay, then you can check which one is having lower heat capacity rate. C for water क्या हो जाएगा बच्चों? C for water like अगर मैं निकालूं यहाँ पे m dot cp water, m dot cp hot means water. What is hot fluid? So for water, m dot cp is mass rate of the water is 0.5, 0.5 into 4.2, so it will come out 2.1. It will come out 2.1. Similarly, you can calculate m dot cp for cold. M dot cp for cold means air. This is for water, this is for air, and this is equal to 1 into mass rate is what? Mass rate is 4, so it is coming out 4. So air के लिए this is more, for water it is small, so effectiveness for water is what? THI minus THE divided by THI minus TCI. Okay, so effectiveness is 0.8. M dot Cp for the water is small, that's why I'm writing the change in temperature for the water. The fluid which is having lower heat capacity rate, for that you need to write the change in the numerator, and in the denominator all the times you will have THI minus TCI. Numerator you need to write the temperature change for the fluid which is having lower heat capacity rate. That you need to understand. ऊपर किसको लिखना पड़ेगा? टेम्परेचर चेंज फॉर द फ्लूइड विच इज हैविंग लोअर हीट कैपेसिटी रेट. डिनोमिनेटर में ऑलवेज यू विल हैव THI माइनस TCI. तो तीन टेम्परेचर यहां से अपने को एक टेम्परेचर आ जाएगा. THI इज 70, THE यहां से आ जाएगा 70 minus 30. Okay, तो यहां से you will get THE. From this you will get THE. Okay, this will come out 38 degrees Celsius. 38 degrees Celsius. Okay, this will come out 38 degrees Celsius THE. Fourth temperature you will get from the energy balance very easily. चौथा टेम्परेचर कहां से आ जाएगा बच्चों? एनर्जी बैलेंस से. What is energy balance? M dot C you know water into change in temperature for water, that is equal to M dot C for air into change in temperature of the air. Okay, तो इसको यूज कर लो and you can use it here. M dot Cp of the water is what? This we multiplied, this is coming out 2.1 into change in temperature of the water is 70 minus 38, so this is 70 minus 38, this is 4 into change in temperature of the air is Tc, means this is the cold fluid, Tc cold fluid exit temperature TCE minus 30 cold fluid inlet temperature. तो यहां से आपके पास क्या आ जाएगा? You will get the air exit temperature also. This is air exit temperature. This is air exit temperature you are going to get from this. Okay, which will come out 46.8, which will come out, and that is possible in counterflow. It is possible. Counterflow mein TCE can be more than the THE. 48.6, 46.8 guys, 46.8. This is possible. अब आपको कहेगा सर इसमें तो नहीं लग रहा, because I have drawn initially something like this. This temperature is more than this. This is quite possible in counterflow. In parallel flow it is not possible. In parallel flow in no case you cannot have exit temperature of the cold fluid more than exit temperature of the hot fluid. It is not possible in parallel flow. But in counterflow the exit temperature of the cold fluid can be more than this. वो इससे ज्यादा हो सकता है. Okay. So solving this you will get the LMTD. Now can you tell me what LMTD you are getting guys? Delta TM कितना आ जाएगा आपका? What delta TM you are getting guys? Because in this case he asked you about delta TM. Yes, what delta TM value you are getting? Delta TM बताओ बच्चों जल्दी से. Tell me the delta TM value. 4 options are there in front of you. 4 options हैं आपके सामने. अभिनव बिल्कुल सही आपका ये 46.8 तो आपका ये हो जाएगा TCE. TCE is 48, 46.8. Now tell me delta TM, because he is asking you delta TM. Can you carry out that calculation guys? Can you tell me which option is matching? तो बहुत टिपिकल विश्वनाथ कुछ मिस्टेक किया आपने. 17.1 is not right. 17.7 is also not there in the option. Vishwanath, 14.27 is the right answer. B is the right answer. So Vishwanath, again check your calculation part. B is the right answer. Abhinav, Ashish, Abhinav, Janish, your answers are right guys. बिल्कुल सही. तो बिल्कुल टिपिकल गेट लेवल का क्वेश्चन है बच्चों, और आपको इतना अवेयर होना चाहिए कि हाउ टू फाइंड आउट दीज क्वेश्चंस. ओके, अभी क्वेश्चन क्या था? LMTD पूछ रहा था आपसे. दीज एक्चुअली ही कैन आस्क यू एरिया आल्सो. आप कहोगे सर दो ही टेंपरेचर है तो एरिया कैसे निकालेंगे? For first you need to find out LMTD only. For finding out LMTD you require all 4 temperature. This is actually known as LMTD method. And in these LMTD method guys, first we calculate the third unknown temperature. In these LMTD method, NTU method, these are known as NTU method. In those NTU method guys, if two temperatures are known to you, hot fluid inlet temperature, cold fluid inlet temperature, then using that effectiveness relationship you can find out the third temperature. Fourth temperature you can find out using the energy balance, and if all four temperatures are known to you, you can find out delta Tm. If delta Tm is known to you, area is given to you, temperatures you know, mass rate you know, then easily you will get Q also, and you will be easily able to find out the area of heat exchanger also. That is known as NTU method. So there are two methods we use, LMTD and NTU method. ठीक है, तो मेरे ख्याल से आपको ये समझ में आया होगा, बहुत सिंपल क्वेश्चन था. So everybody you need to answer these type of question guys. These are simple direct question. अब इस तरह के क्वेश्चन भी नहीं करोगे then surely you will face difficulty. प्रैक्टिस करो बच्चों, डोंट मेक एनी काइंड ऑफ मिस्टेक. साइकत का आंसर भी वेरी राइट. आशीष, योर आंसर इज आल्सो राइट. नेक्स्ट क्वेश्चन है क्वेश्चन नंबर 52. There is a double pipe heat exchanger using oil which is having specific heat 1.88 at an initial temperature 205 degrees Celsius. Cp of the water is this. Change in temperature of the water are given. वाटर के दोनों टेम्परेचर दिए हैं, मास रेट दिया है, ऑयल का आपको फ्लो रेट भी दिया है. एंड व्हाट इज द हीट ट्रांसफर एरिया रिक्वायर्ड for the overall heat transfer coefficient, also determine the number of transfer unit and effectiveness. तीनों चीजें पूछ ली आपसे. देखो अच्छा क्वेश्चन बन गया है तो यार, है तो सिंपल क्वेश्चन, but all these three things he is asking you guys. In GATE heat exchanger question also, like if you will check the previous question, he asked you most of the time these type of questions only. तो बहुत अच्छे क्वेश्चन है ये NTU NPTEL असाइनमेंट में से. अब जैसा क्वेश्चन अपने को असाइनमेंट का है, लाइक कन्वेक्शन में से तो बहुत अच्छे क्वेश्चन थे, ये भी बहुत अच्छे हैं, but as such those kind of lengthy questions are not there, and even those kind of questions are not there in GATE also. Radiation के different question you are going to find out, but they are also very good for practice purposes. ठीक है, तो try to answer this question. He is asking you the NTU, आपसे पूछ रहा है हीट ट्रांसफर पूछ रहा है, एरिया पूछ रहा है. पहले एरिया बताओ, NTU बताओ और इफेक्टिवनेस बताओ. तीनों ही चीजें पूछ लिया आपसे. यस, ट्राई टू आंसर दिस क्वेश्चन. ठीक है, चलिए देखो, पहले तो अगर आपको एरिया निकालना है तो फोर्थ टेम्परेचर निकालना पड़ेगा. फोर्थ आप निकाल सकते हो एनर्जी बैलेंस से, तो एनर्जी बैलेंस लगा दो ऑयल के लिए. सीपी ऑफ ऑयल कितना है 1.88 सीपी ऑफ ऑयल. मास रेट ऑफ ऑयल कितना है, ऑयल का मास रेट रहता है 270 केजी पर सेकंड. ऑयल का टेम्परेचर चेंज कितना हो रहा है, इनलेट तो हो रहा है 205 पे, एग्जिट कितने पे हो रहा है, ऑयल का एग्जिट, ऑयल एग्जिट, दिस वी डोंट नो, ये अपने को नहीं पता. दिस इज इक्वल टू सीपी ऑफ द वाटर व्हिच इज 4.178. mass rate of the water is 225. unit conversion की जरूरत नहीं है because here both side we are balancing only, so there is no need to carry out any kind of unit conversion. 44 minus 16, इसको करोगे तो आपके पास oil का exit temperature आ जाएगा, oil exit temperature. okay, oil का क्या आ जाएगा, exit temperature. and now if you know all four temperatures, चारों temperatures अगर आपके पास हैं, then easily you can draw the temperature profile. oil के लिए हो जाएगा 205, ये हो जाएगा 205, और ये आपका ऑयल का एग्जिट टेम्परेचर ये यहां से आ जाएगा आपका फ्रॉम दिस. डबल पाइप पैरेलल फ्लो है, डबल पाइप पैरेलल फ्लो, तो इस तरह की मिस्टेक मत कर देना. डोंट कंसीडर इट एज काउंटर फ्लो. तो पैरेलल फ्लो है तो यू नीड टू ड्रॉ पैरेलल फ्लो प्रोफाइल ओनली. दिस इज 16 and this is 44 degree Celsius, and if you from this you will get the TOE, hot oil exit temperature या hot fluid exit temperature. putting it here you will get delta TM. okay, so this difference here, this is delta Ti, this is delta Ti, and this difference here, this is delta Te. okay, and LMTD is nothing but delta Ti minus delta Te divided by ln of delta Ti by delta Te. okay, so what LMTD you are getting guys, LMTD कितना आएगा? Solving this you will get LMTD 145.436 degree Celsius. This is LMTD you are going to get. okay, 145, बच्चे मिस्टेक कर रहे हो आप कुछ. 145.436 is the delta TM you are going to get. 153 is not right. 145.436, this is the delta TM you are going to get. okay, ऑयल का एग्जिट टेम्परेचर भी देख लो, ये आएगा आपका 153.145. 153.43, this is yes, this is exit temperature. ठीक है जनिश, ये ऑयल का एग्जिट है but not LMTD. LMTD आएगा आपका. okay, and then if you will use the relationship Q equal to UA delta TM, easily you will get the area of the heat exchanger. okay, area of heat exchanger. yes, tell me what area you are getting guys, what area of the heat exchanger you are getting. In a single question he is asking you area of the heat exchanger, NTU, effectiveness of a heat exchanger. So easily we will be able to revise multiple concepts: how to calculate LMTD, how to calculate fourth unknown temperature, how to calculate area, how to calculate effectiveness. Please answer what area you are getting, guys. So area आपका आ जाएगा if you will carry out the calculation 0.1478 meter square. The area will come out this 0.1478 meter square. 0.1478 meter square. This is the area you are going to get. Okay. NTU is nothing but UA by m dot Cp small. अभी U अपने को दिया है, U कितना दिया है? U is given to us. U is 340 watt per meter square. So this is 340. Area already we calculated 0.1478. M dot Cp small you need to check. अभी आपको इसको चेक करना पड़ेगा which one is having more m dot Cp. तो देख लो इसको, इसका मास फ्लूइड कितना है बच्चों? ऑयल का कितना है? m dot Cp for the oil, hot fluid. For hot fluid it is 1.88 into 270. M dot Cp for the cold fluid, this is 4.178 into 225. Obviously this will come out more. मेरे ख्याल से ये ज्यादा आएगा. You can check. M dot Cp for the cold will come out more. Okay. M dot Cp for the cold will come out more. You can check. You need to check, guys. इसको calculate करके check करना पड़ेगा. Which one is coming out more? जो कम आ रहा है अपने को वो लेना पड़ेगा. दोनों में से जो कम है that we need to take. Okay. So we need to take M dot Cp small. Put it here. M dot Cp small. M dot hot fluid का कम है. M dot Cp for the hot fluid is less or cold fluid is less. Which one is coming out less? If you put it here, you will get the NTU value. ठीक है. बिल्कुल सही बच्चों. LM effectiveness आएगा. This NTU will come out. NTU will come out 0.3563. 0.3563. 0.3563. शायकत आप कुछ चेक करो. मिस्टेक कर रहे हो बच्चे आप. 0.3563 is the right answer. अभिनव का आंसर बिल्कुल सही है. शायकत, you need to check your calculation. Okay, effectiveness is nothing but, अभी किसके लिए कम है बच्चों? This you are getting less for what? I think you are getting this less for this hot fluid. For hot fluid I think you are getting it less. तो hot fluid के लिए लिख दो यहाँ पे. Hot fluid का in temperature, hot fluid in temperature is 270. Let me check. It is 205. It is 205 hot fluid in temperature minus hot fluid exit temperature. Hot fluid exit temperature which is 153.145 divided by hot fluid in 205 minus cold fluid in. Cold fluid in is what? Cold fluid in is 16. Okay, cold fluid is in 16. तो इसको करोगे you will get the effectiveness also. Okay, you will get the effectiveness also. Yes, obviously for the hot fluid it is less. For the hot fluid, because from this only you are going to get the idea. This is 1.88, this is 270. So obviously this will come out less. ये क्या आ जाएगा? कम आ जाएगा. ओके, बट जब इसको यहाँ पे पुट करोगे ना बच्चों, तो आपको यूनिट कन्वर्जन करना पड़ेगा. आपको यूनिट कन्वर्जन करना पड़ेगा बच्चों. जब आप यहाँ पे पुट करोगे, यू नीड टू पुट इट हियर समथिंग लाइक दिस. आपको यहाँ पे पुट करते हुए कन्वर्जन करना पड़ेगा 1.88 into 10 की पावर 3. दिस इज फर्स्ट कन्वर्जन. मल्टीप्लाई बाय 270 ना. इसका कितना था? 270. Yes, I think this is 270 oil के लिए. So 270 kg per hour. So 270 divided by 3600. ये वैल्यू आपको पुट करनी पड़ेगी. You need to use the SI units. Okay, just to get the idea which one is more, because both are having same unit. This both are having same unit. So from this only you will get the idea. But when you are going to put this value here, okay, you need to use the SI units. First you need to convert this Cp into joule per kg Kelvin. This is your Cp. Mass fluid is 270 kg per hour. So that also you need to convert in kg per second. Okay, so kg per second 270 divided by 3600, and this is your Cp. Okay, like this if you will put, then only you are going to get this effectiveness. So unit तो ध्यान रखना पड़ेगा बच्चों. Okay, SI units you need to use. Yes, ठीक है. Effectiveness will come out 0.2742. 0.2742 तो आपका जो आंसर हो जाएगा बच्चों ऑप्शन ए क्या हो जाएगा? दिस इज द राइट आंसर फॉर दिस क्वेश्चन. Option A is the right answer for this question. Although just by only calculating the area only you will get the answer, but here that is not our purpose. Our purpose is not to just answer. Our purpose is to get the idea for each and every related concept. Okay, so even just by observing the area you can go with option A. Janice is saying area is coming out 0.53. 0.53 बच्चे चलो ओके लेट मी राइट इट हियर. आप मिस्टेक पता क्या कर रहे हो बच्चों? मेरे ख्याल से द मिस्टेक विच यू आर डूइंग, आप क्यू को देखो, आपको जब क्यू लिखना पड़ेगा, दिस क्यू आई थिंक यू आर राइटिंग अगेन विदाउट यूनिट्स. अभी देखो लाइक लेट मी राइट इट फॉर ऑयल. ऑयल के लिए लिखता हूं मैं. सो ऑयल का सीपी इज 1.88. सो 1.88 into 10 की पावर 3. दिस इज सीपी ऑफ द ऑयल. Mass rate for the oil is 272. 270 divided by 3600. Okay, multiply by change in temperature of the oil. So it is 205. This is inlet temperature, and exit temperature for the oil is 153. Okay, 153.14. Okay, so this is Q. This is Q. I am writing this Q in terms of hot fluid. You can write this in terms of cold fluid also. आप चाहो तो इसको cold fluid की term में भी लिख सकते हो. You can write this Q in terms of cold fluid also. Like cold fluid का mass rate कितना था? I think that was cold fluid water is having mass rate for 225, 4.178. Yes. So 4.178 into 10 की power 3 into 225 divided by 3600 into change in temperature. The change in temperature is from 16 to 44. 16 to 44 the temperature change is 24. उसको क्या होगा? 24 plus 4 it is 28. This is the temperature change for the cold fluid. तो दोनों में से किसी को भी यूज कर लो, you will get the same idea, same answer. Okay. Yes, Janish, तो वो आपको केयरफुल रहना पड़ेगा बच्चों. This you need to observe है ना. If you will miss this, then definitely you will not get the idea. You will not get the answer. ठीक है, तो आपको ध्यान रखना पड़ेगा SI यूनिट बच्चों. अब मैं हर एक चीज यहां लेकर आऊं, but you also you need to be aware. Okay, you need to check. So SI unit Q is Cp m dot Cp dt. So m dot is in joule per kg Kelvin. Mass rate is in kg per second. Okay, चलिए. Let's move to next question. Question number 53. So he's saying there is a counterflow heat exchanger operating under steady state condition. Counterflow है, both hot and cold fluid are equal, means C is equal to 1. M dot Cp of the hot, M dot Cp of the cold, both are same. Okay, that's why he has given you this relationship also. Effectiveness equal to NTU by 1 plus NTU. He is giving you the relationship. Okay, आपको relationship भी दे रहा है. Enter the heat exchanger at this. Cold fluids enters at this. Okay, overall heat transfer coefficient is 1 kilowatt. And the corresponding heat transfer area is this. Neglecting heat transfer, the heat exchanger characterized by this relationship is asking you the where E is the effectiveness of the heat exchanger and NTU is the number of transfer unit, is asking the cold fluid exit temperature. Okay, आपसे पूछ रहा है cold fluid exit temperature. He is giving you the hint also, guys. Two hints he has provided you in this question. One is both hot and cold fluid, they're having same heat capacity rate, means this is the effectiveness relationship which you can use. Okay, and also this is equal to what? ये किसके इक्वल है बच्चों? कोल्ड फ्लूइड का एग्जिट निकालना है. वी आर इंटरेस्टेड इन फाइंडिंग आउट कोल्ड फ्लूइड एग्जिट. कोल्ड फ्लूइड का एग्जिट निकालना है बच्चों. तो here you can write it as, because both are same, so in the numerator you can write THI minus THE or TCE minus TCI. Why? Because m dot Cp is same for both the cases. So numerator any one you can write, because here you need to write cold fluid terms. Why? Because we want to find out cold fluid exit temperature. So here I'm writing TCE minus TCI divided by THI minus TCI. Okay, तो यहां से आपके पास कोल्ड फ्लूइड का एग्जिट टेम्परेचर आ जाएगा. कोल्ड फ्लूइड एग्जिट माइनस कोल्ड फ्लूइड इनलेट. इनलेट कितना है? 15. दिस इज कोल्ड फ्लूइड इनलेट. हॉट फ्लूइड इनलेट इज 102 minus 15. Okay, this is the effectiveness relationship. And also we know this also. NTU निकालो यार, NTU निकाल के effectiveness निकालो. NTU क्या होता है सर? NTU is UA by m dot Cp small. Okay, UA by m dot Cp small. What is U? U is 1 kilowatt. अब 1 kilowatt है तो उसको 1000 करना पड़ेगा. SI unit you need to use. Area is 5 meter square. M dot Cp small. Check करो which one is small. Okay, which one is small? Hot fluid and cold fluid are equal. दोनों का equal है और उसने आपको hot का दे दिया है, तो use anyone. आपको सोचना ही नहीं है. Both are equal, तो use it for hot fluid. Hot या cold कोई भी. 1 into 4 kilojoule, so 4000. Okay, this will cancel out. 5 by 4, it will come out 1.25. Okay, NTU will come out 1.25. Okay, NTU is 1.25, and if you'll put it here 1.25 NTU, so effectiveness will get 1.25 divided by 2.25, so 125 बटा 225 हो जाएगा, so it will become 5 by 7. Okay, so it will become 0. कितना हो जाएगा, 5 by 7 ही रखते हैं चलो इसको, है ना, so it will become 5 by 7. Effectiveness will become 5 by 7. ठीक है, तो चलो this 5 by 7 you can put it here. 5 by 7 equal to TCE minus 15 divided by 102 minus 15, ये कितना हो जाएगा 87. Okay, this will be 87. Solving this, you will get TCE. Now can you tell me guys what answer you are getting? D you are saying, and yes, it is exactly right. 62.85 is the right answer. D is the right answer. 62.85 डिग्री सेल्सियस. ओके बच्चों, अपने हाथ से क्वेश्चन करने बहुत जरूरी है, बिकॉज देखो अभी जेनिश ने एक मिस्टेक किया, बिकॉज इफ यू आर प्रैक्टिसिंग देन ओनली यू आर गोइंग टू गेट द आइडिया वेयर यू कैन मेक द मिस्टेक. यू नो मोस्ट ऑफ द टाइम स्टूडेंट मेक दोस काइंड ऑफ सिली मिस्टेक, उसको सिली बोल देते हैं, बट एक्चुअली में वो सिली नहीं रह जाती, वो हमारा कैरियर खराब कर देती है. व्हाई? बिकॉज यू नो earlier also I mentioned, if you are very clear with the whole concepts, okay, but you are making those kind of silly mistakes, then there are chances you may drop from 75 to 50. So you need to be very careful in GATE at least. Why? Because in this examination, particular examination, they are going to give you options something like that, and they are going to confuse in those units only data only, so that you will answer wrong. Okay, so very careful you need to have. Okay, हाँ ये 5/9 हो जाएगा, बिल्कुल बिल्कुल सही बच्चों, ये जो होगा 5/9 होगा, 5/7 नहीं, ये होगा 5/9. ठीक है, सो दिस इज 5/9. वेरी गुड, थैंक यू. दिस इज 5/9. यस थैंक्स सूर्या. शाहरुख सिद्दीकी. चलिए लेट्स मूव टू गाइस नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 54. चलिए जल्दी जल्दी से करते हैं, कुछ क्वेश्चन तो बहुत हलवा आएंगे हमारे सामने, जल्दी से खत्म करते हैं सो दैट वी विल बी एबल टू मूव क्विकली टू द रेडिएशन पार्ट. कंसेंट्रिक काउंटर फ्लो हीट एक्सचेंजर है. Water flows in the inner tube 30, leaves at 45. Engine cooling enters at 120 in the annular process. The exit of the engine cooling is 60. Mass rate of the oil is 2 and 1. Specific heat are these. The effectiveness of the heat exchanger. अभी मैं इसको आंसर जल्दी से कर दो आप बस. Effectiveness of the heat exchanger. What is THI guys? जल्दी से ऑब्जर्व करो इसको. What is THI? THI is 120. What is TCI? TCI is 30. Which is having more smaller heat capacity rate, hot or cold? This is 2 into this is this. So कौन सा कम है? कम किसके लिए है? Less is for oil. For oil it is less. Okay. Engine oil के लिए ये है. Okay, this is less. So oil का लिख लो. What is the exit temperature? Exit temperature of the oil is 60. Oil enters at 120. Okay, ये तो oil है. Oil तो hot हो जाएगा. हाँ yes. So oil is entering at 120. So 120 minus 60. Okay, so 60 by 90 ये आपका हो जाएगा आंसर. 6/9 चेक कर लेना एक बार. 6/9 दिस इज द आंसर फॉर दिस क्वेश्चन. मतलब आंसर हो जाएगा आपका 0.666. okay, then you can go with this answer, option C. I hope this is very clear. Directly I'm answering this question guys. How actually I'm writing, because if you'll observe this data you can answer, sir, m dot cp for the oil is less as compared to m dot cp for the water. Okay, that's why I'm writing it here. Temperature of the exit, temperature of the oil, temperature exit minus oil minus temperature inlet, because oil is the hot fluid. Oil क्या आपका hot fluid है. Oil is the hot fluid. This is hot fluid. Okay, this is cold. For hot it is more, so it is THI minus THE divided by THI minus TCI. Numerator तो हमेशा यही होता है बच्चों. Numerator will also be same, always be same. For effectiveness only, quickly you need to analyze which fluid is having lower heat capacity rate. The fluid which is having lower heat capacity rate, for that temperature change you will write in the numerator, and in the denominator always you will have THI minus TC. So in seconds you can write the effectiveness formula. Okay, effectiveness formula in seconds you can write. चलिए next move करते हैं question number 54. Choose the correct option. Okay, choose the correct option. Specific heat of a cold fluid is larger in comparison to the hot fluid. for condensation process. Specific heat of the cold fluid is small in comparison to the hot fluid for condensation process. Specific heat of the cold fluid and hot fluid both are comparable for the condensation process, and there is no particular constraint for the specific heats for the cold and hot fluid. हलवा क्वेश्चन है बट बहुत अच्छा क्वेश्चन है, एंड आई नो लाइक ऑल विल नॉट बी एबल टू आंसर दिस क्वेश्चन. जल्दी नहीं करनी, यू नीड टू थिंक एंड यू नीड टू आंसर. Please read this question and try to answer. People are saying C. C. Lots of students are saying C. Abhinav is saying C. Shahrukh is saying C. चलिए इसको एक बार आंसर करते हैं. देखो, specific heat of the cold fluid is large in comparison to hot fluid for the condensation process. Condensation means he is talking about condensation. तो condensation का temperature profile बनाओ. Condensation में this is hot fluid, this is cold fluid. ऊपर क्या होता है बच्चों? दिस इज हॉट ना, दिस इज कोल्ड. ओके, तो हॉट फ्लूइड का फेज चेंज होता है, कोल्ड का फेज चेंज होता है. फेज चेंज इज देयर फॉर हॉट और कोल्ड. कंडेंसेशन में, कंडेंसर में फेज चेंज इज देयर फॉर हॉट फ्लूइड और कोल्ड फ्लूइड. कंडेंसेशन इन कंडेंसर द फेज चेंज इज देयर फॉर द हॉट फ्लूइड. इन बॉयलर द फेज चेंज इज देयर फॉर द कोल्ड फ्लूइड. बॉयलर में फेज चेंज किसका होता है? कोल्ड फ्लूइड का. ओके, और हॉट फ्लूइड, बिकॉज हॉट फ्लूइड का फेज चेंज हो रहा है, सो हॉट फ्लूइड का हीट कैपेसिटी रेट ओके m डॉट cp ये कितना हो जाएगा? ये हो जाएगा इनफाइनाइट. फेज चेंज हो रहा ना, दिस इज इनफाइनाइट. ओके, कोल्ड के लिए क्या होगा? ऑब्वियसली दिस इज लेस. ये क्या होगा? लेस. यहां पे तो क्या हो रहा है? फेज चेंज हो रहा है. ओके, फेज चेंज में cp क्या होता है? इट इज इनफाइनाइट. ओके, तो सी गलत हो जाएगा बच्चों. बी इज द राइट आंसर. व्हाई? स्पेसिफिक हीट ऑफ द कोल्ड फ्लूइड इज स्मॉलर. Specific heat is the cold fluid is smaller in comparison to the hot fluid. मैंने आपको कहा भी था, read this question entirely. हर क्वेश्चन को इतना हलवा भी मत समझो कि यू विल थिंक कि सर यस, उसको रीड करो, पूरा पढ़ो, देन ओनली यू विल एबल टू आंसर. ठीक है, क्वेश्चन आसान है बट यू नीड टू रीड इट थोरोली, देन ओनली यू आर गोइंग टू गेट द आइडिया. ठीक है, देखो अगर मैं इसी क्वेश्चन को ऐसे बोलता फॉर द बॉयलर, अगर ये बॉयलर का केस होता बच्चों, अगर ये बॉयलर का केस होता, सो फॉर बॉयलर द कोल्ड फ्लूइड के लिए क्या होगा? ऐसा होगा. हॉट फ्लूइड के लिए क्या होगा? ऐसा होगा. ओके, हॉट फ्लूइड से हीट लेंगे ना यार. बॉयलर का मतलब क्या होता है? हॉट से हीट लेंगे, इधर हीट लेंगे, इसका फेज चेंज कर देंगे, कोल्ड का टेम्परेचर चेंज हो जाएगा. दिस इज योर बॉयलर. यस और नो? तो बॉयलर के लिए तो कोल्ड का क्या होगा? बॉयलर के लिए तो क्या होगा? कोल्ड का ज्यादा होगा. स्पेसिफिक हीट ऑफ द कोल्ड फ्लूइड एंड हॉट फ्लूइड आर कंपेरेबल. कंपेरेबल कहां से हो गया यार? कंपेरेबल नहीं होता, फेज चेंज में कंपेरेबल नहीं होता. सी इज नॉट राइट. फेज, तो उस केस में आंसर क्या हो जाएगा? और अगर ये बॉयलर होता तो तब आंसर हो जाएगा ए. ओके, इसके लिए आंसर क्या हो जाएगा बच्चों? ए. ओके, बॉयलर के लिए द आंसर इज ए. व्हाई? बिकॉज फॉर बॉयलर कोल्ड फ्लूइड का क्या हो रहा है? फेज चेंज हो रहा है, एंड कोल्ड फ्लूइड विल हैव लार्जर हीट कैपेसिटी रेट एज कंपेयर टू द हॉट फ्लूइड. तब आंसर हो जाएगा ए. बट फॉर कंडेंसर द आंसर इज बी. यू गॉट द पॉइंट गाइस? इज दैट क्लियर? यस, इज दैट क्लियर गाइस? चलिए, तो अभी आंसर क्या होगा? बी इज द राइट आंसर फॉर दिस क्वेश्चन. नेक्स्ट क्वेश्चन मूव करते हैं. Water flowing at the rate of 78 kg per minute is heated from 35 to 75 degrees Celsius by an oil having specific heat 1.9 kilojoule per kg Kelvin. The fluids are used in counterflow concentric tube heat exchanger where oil enters at 110, leaves at 75. So all four temperatures are known, CPs are given, U is given, CP of water is given. He is asking the heat transfer area. तो आसान क्वेश्चन है, आंसर करो इसको. व्हाट इज द एरिया यू आर गोइंग टू गेट? सो फर्स्ट, ऑल फोर टेम्परेचर्स आर नोन एज इट इज गिवन. इट इज अ काइंड ऑफ कैसा हीट एक्सचेंजर है? कंसेंट्रिक ट्यूब, काउंटर फ्लो कंसेंट्रिक ट्यूब. काउंटर फ्लो है, सो इट विल बी, अरेंजमेंट विल बी समथिंग लाइक दिस. ओके, दिस इज हॉट एंड दिस इज हॉट, दिस इज कोल्ड. ओके, हॉट के लिए कितना है? हॉट कौन सा है बच्चों? hot is your water flowing at the rate is heated from 35 to 75. so water is your cold fluid. water क्या है आपका? cold है. इसको आप heat कर रहे हो by using the heat of the oil. so oil is entering at this and this. okay, so this is 40 THE, this is delta TE. okay, this is delta TI 35 delta TI. okay, तो LMTD क्या हो जाएगा? delta TM equal to 35 minus 40 divided by ln of 35 divided by 40. From this you will get LMTD, and easily you will get the area also. So please answer what area you are getting for this question. What area you are getting for this question, guys? Please answer. Delta Tm will come out 37.44. 37.44 degrees Celsius. Is asking you the area. Please answer. U is given. Delta Tm we calculated. Q you will get from the energy balance equation. Q कहां से आ जाएगा? Q you are going to get energy balance equation. M dot Cp किसके लिए लिख लो? वाटर के लिए लिख लो. वाटर का मास रेट इज 78. So 78 divided by 60 kg per second. kg per second mass flow rate of the water. वाटर के लिए Cp कितना है? 4.18. Okay. वाटर के लिए change in temperature कितना है? 35 to 75 means change in temperature is 40. This is your Q. Okay. You can write it for in terms of hot fluid also, cold also, anyone. Okay. Anyone you can use. If you will calculate, guys, you will get area 18.14 meter square. Option A is the right answer. बिल्कुल सही. A is the right answer for this question. ठीक है, 3-4 क्वेश्चन और आएंगे न्यूमेरिकल एंड देन सम डायरेक्ट क्वेश्चन विल आल्सो बी देयर. तो जल्दी से हम इसको खत्म करते हैं, देन वी विल मूव टू द रेडिएशन क्विकली. आई विल ट्राई टू कवर दिस क्वेश्चन वेरी क्विकली बिकॉज आई कैन ऑब्जर्व कि इतने ज्यादा लंबे क्वेश्चन नहीं है हीट एक्सचेंजर में. चलिए, दिस इज नेक्स्ट क्वेश्चन गाइस इन फ्रंट ऑफ यू. प्लीज आंसर. सिमिलर काइंड ऑफ पैटर्न इज देयर. हीट एक्सचेंजर है, OLCP is the given, flowing through the tube, 15, 18, 85, two temperatures are given. पैरेलल फ्लो है. ओनली द डिफरेंस इज, अभी देखो इससे क्या है, प्रैक्टिस है. इन दिस केस ही हैज गिवन यू अ केस ऑफ काउंटर फ्लो. ओके, इन दिस केस ही इज गिविंग यू अ केस ऑफ पैरेलल फ्लो. दोनों तरह के केसेस अपने को सोल्व करने आने चाहिए ना. दिस इज अ केस ऑफ पैरेलल फ्लो. ओके, तो हीट एक्सचेंजर हीट्स यूज्ड टू हीट्स ऑयल. ऑयल को आप हीट कर रहे हो. सो ऑयल यू आर हीटिंग फ्रॉम 15 टू 85. ओके, दिस इज ऑयल. ओके, ऑयल यू आर हीटिंग. तो यहां पे क्या हो जाएगा आपका, यूजिंग दी ऑयल है ना, इसको हम हीट कर रहे हैं. तो इसको मैं पैरेलल बनाना है अपने को. पैरेलल फ्लो अरेंजमेंट वी नीड टू ड्रॉ. तो मैं कुछ ऐसा कर देता हूं. सो दिस इज योर ऑयल 15 to 85. Okay, this is your oil and this is your another hot fluid which is entering at 130. Okay, leaving at 110. So delta TE in this case is 25. Okay, delta TI in this case is 125. This is delta TI is 125 degree Celsius. Easily you can calculate LMTD. Delta TM equal to 125 minus 25 divided by ln of 5. Okay, so 100 divided by ln of 5, you will get the LMTD. Okay, you will get the LMTD for this case also. अच्छा, ये 115 आएगा ना. दिस इज नॉट 125, दिस इज 115. ओके, दिस इज 115. ओके, 130 minus 15. ओके, 135 minus 15, दिस इज 115. ओके, तो यहां भी करेक्ट कर लेना एक बार. दिस इज 115. so 115 minus 25, so it is 90 by ln of 5. 5 नहीं आएगा नीचे भी. so in denominator also you will have ln of 115 divided by 25. चलिए, so what value of the area you are getting, guys? Yes, Surya, thank you. What value of the LMTD you are getting? What value of the area actually you are getting? अभी डायरेक्टली मेरे को एरिया बताओ जल्दी से. एरिया बताओ, फास्ट हो जाओ, जल्दी से बताओ. टेल मी क्विकली what area you are getting, guys. सही है. 58.975 is right for LMTD. LMTD will come out 58.97. 58.97 is right for LMTD. Okay, area, quickly tell me the area. What value of the area you are getting? D, बिल्कुल सही. D is the right answer, guys. 11.01 is the right answer for this question. 11.01 is the right answer for this question. Okay, next question I am not solving this because similar line पे question है. डिफिकल्ट नहीं है, बहुत सिमिलर क्वेश्चन है. बाद में आप इसको प्रैक्टिस कर लेना. 100% आप इसको आंसर करोगे बिकॉज टाइम इज वेरी वेरी इंपॉर्टेंट फॉर अस, गाइस. तो ये आप आंसर करना इसको. डी यू आर गोइंग टू गेट. ओके, यू कैन चेक, जस्ट रीड इट. अभी क्विकली इसको कुछ सेकंड्स में रीड कर लो सो दैट यू विल गेट द आइडिया कि यस दिस क्वेश्चन इज वेरी वेरी इजी. ओके, a hot water stream flows at 1 kg per second cooled from 95 to 60. Heat exchanger in a contact of a large stream cold water 2 kg per second, inlet temperature 40. Calculate the area of the heat exchanger. Cp is given, U is given, so similar pattern easily you will be able to answer. Please carry out the calculation, you will get the answer D as the right answer. Next पे move करते हैं बच्चों. This is comparatively good question and we are going to solve this also. चलिए, so let's move to 59 question guys. क्वेश्चन नंबर 59 इन फ्रंट ऑफ यू. ये अच्छा क्वेश्चन है, थोड़ा सा लेंदी रहेगा बट आप इसको आंसर कर पाओगे इजीली इफ यू विल फॉलो द बेसिक स्टेप. ओके, चलिए. देयर इज अ काउंटर फ्लो हीट एक्सचेंजर व्हिच इज हैविंग एरिया 10 मीटर स्क्वायर, overall heat transfer coefficient 500 watt per meter square Kelvin. It is used to cool 1.5 kg of oil initially at 115 degrees Celsius by 0.5 kg stream of water with inlet temperature 15 degrees Celsius. Cp value of oil and waters are given. Calculate the outlet temperature in degree Celsius for the stream and total heat transfer rate. दोनों फ्लूइड्स के लिए हॉट फ्लूइड एग्जिट टेम्परेचर पूछ रहा है, हॉट फ्लूइड एग्जिट पूछ रहा है आपसे, कोल्ड फ्लूइड एग्जिट पूछ रहा है आपसे, और आपसे पूछ रहा है हीट ट्रांसफर. अभी कौन सा मेथड लगाना पड़ेगा बच्चों? Which method you need to apply? Only two temperatures are known. Hot fluid in temperature, hot fluid in is given, THI is given, which is 150, 115 degrees Celsius. TCI is given to you, which is 15 degrees Celsius. Only two temperatures are known. तो क्या लगाना पड़ेगा आपको? You are having the option of what? You cannot apply LMTD method because all four temperatures are not known. For LMTD, three temperatures are required, guys. If you know the three temperature, then you can follow LMTD approach and you can answer. But here, only two temperatures are known, so that's why you need to use NTU method. आपको लगाना पड़ेगा यहाँ पे NTU method. ओके, तो अभी आप क्या करो बच्चों, इफेक्टिवनेस उसने आपको नहीं दिया. इफेक्टिवनेस से अपने के पास फोर्थ टेम्परेचर आ जाता है, इफेक्टिवनेस से अपने पास आ जाता है फोर्थ टेम्परेचर, बट इफेक्टिवनेस इज नॉट गिवन. व्हाट इज गिवन? काउंटर फ्लो हीट एक्सचेंजर. काउंटर फ्लो हीट एक्सचेंजर. So you know, counter flow heat exchanger, effectiveness for counter flow heat exchanger is nothing but 1 minus e की power minus 1 minus c NTU divided by 1 minus c e की power minus 1 minus c NTU. Okay, so NTU you need to calculate first. NTU निकाल लो. Okay, c निकाल लो, heat capacity rate ratio m dot cp small m dot cp big. ये ऐसा क्वेश्चन अभी तक हमने नहीं किया था. m dot cp small, m dot cp big. Calculate c also. First you need to calculate NTU. पहले NTU निकालो, फिर c निकालो, m dot cp small, m dot cp big. You will get the heat capacity rate ratio. Okay, then put all these values here. उन सबको यहाँ put करो. Calculate effectiveness. Calculate the effectiveness of the counter flow heat exchanger. And then using the effectiveness, calculate here the fourth unknown temperature. Calculate fourth unknown temperature. Yes or no, guys? Are you getting the idea? How to calculate fourth unknown temperature? Fourth unknown temperature you will get from effectiveness, but you need to calculate effectiveness first. Effectiveness relationship, you know, for the counter flow, NTU, these things easily you will be able to calculate. कैसे देखो? What is NTU, guys? NTU equal to UA by m dot cp small. U check करते हैं, U कितना है? U is given. U is 500. Area is 10. So this U is given to you, area is given to you. M dot cp small. Check kar lo which one is smaller. So for oil, it is used to cool oil which is flowing at this rate. Okay, oil का इतना है and oil का cp is this. So इसको इससे multiply करोगे, you will get a value more than 2.25. इसको इससे करोगे for water. This is for water. Water का इसको इससे करोगे for water, you are going to get 2.09 something like that, which is very less as compared to this. वो इससे कम है. तो for water you can observe this is small. Okay, so you can write it here 0.5 into 4.18 into 10 की power 3. Okay, solving this you will get NTU. You can ask me, sir, why you are writing it for water? You can check because I am observing this data. This is 2.25 multiplied by 1.5. So this value will come out more as compared to 0.45 multiplied by 4.18. Okay, so from this you will get NTU for the heat exchanger. Okay, you will get NTU of the heat exchanger. You can write it here also, guys. M dot Cp water is equal to 0.5 multiplied by 4.18. M dot Cp for the oil is equal to 1.5 multiplied by 2.25. You can check which one is coming out smaller. ठीक है बच्चों, चलिए NTU will come out 2.39. ये कितना हो जाएगा आपका 2.3923. 2.3923 बिल्कुल सही. सूर्या सिंह, योर आंसर इज राइट फॉर NTU. ओके, बट इज नॉट आस्किंग यू NTU. आपसे पूछ रहा है एग्जिट टेम्परेचर. वो आपसे पूछ रहा है एग्जिट टेम्परेचर. तो NTU को यूज करो, NTU को यूज करो, C का यूज करो. अभी C क्या हो जाएगा बच्चों? C इज इक्वल टू वाटर. फॉर वाटर इट इज यू नो m डॉट Cp स्मॉल. तो ये था वाटर के लिए. फॉर वाटर इट इज 0.5 इंटू 4.18 डिवाइड बाय 1.25 इंटू 1.25 1.5 into 2.25 है ना. 1.5 2.25. okay, so this is C. This is heat capacity rate ratio. This will come out 0.61925. 61925. This is C, and we are having NTU also. Putting all these things, you will get the effectiveness. Okay, putting all these things, guys, you will get the effectiveness. Now can you tell me, guys, what fourth temperature you are getting? What fourth temperature you are getting, guys? Now we know effect the heat m dot Cp is small for the cold water. Water के लिए वो क्या है? कम है. So here we can write water is a hot fluid or cold fluid. Water is a kind of what? Water is entering at 15. Okay, so water is not the hot fluid. Water is the cold fluid. Okay, and for water the cold fluid is TCE minus TCI, which is 15 divided by 115 minus 15. Okay, easily you will get cold fluid exit temperature. Cold fluid exit means this is nothing but water exit temperature. Cold fluid exit or water exit temperature. Why? Because water is the cold fluid. Water is the cold fluid. How we can check? How we can say? Because water is entering at 50, oil is entering at 115. So oil is the hot fluid, water is the cold fluid. So, and for water heat capacity it is small. That's why in the numerator I am writing the change in temperature for the fluid which is having lower heat capacity rate, and for water the change in temperature is TCE minus TCI, which is 15 divided by THI minus TCI. You will get TCE from this. यहां से TCE आ जाएगा. Then if you will use the energy balance, उसके बाद अगर आप energy balance use करोगे, m dot Cp cold delta T for cold, that is equal to m dot Cp for the hot delta T for the hot. मतलब कोल्ड क्या है? हमारा वाटर है. तो वाटर के लिए क्या हो जाएगा? ये हो जाएगा मास फ्लो जो भी अपने को दिया है 0.5 इंटू 4.1718. 4.18 टेम्परेचर हो जाएगा अपना TCE minus 15. दिस इज इक्वल टू 2.25 into 1.5, okay, into 115 minus THE. okay, तो ये तो अपना यहां से आ जाएगा बच्चों. TCE we are getting from this. TCE we are getting from this. If you will put it here, you will get THE also. Means oil ka exit temperature. Oil exit temperature also you will get from the energy balance. So you need to have idea how to get all those for temperatures using NTU method. So this is NTU method, guys. Till now we solved some problems using LMTD method only. So this is the NTU method. अभी हमने इस formula को apply किया and we calculated first NTUC and then we are getting the answer for this question. Okay. So B will come out the right answer, guys. B आपका क्या आ जाएगा? Right answer आ जाएगा. Hot fluid out temperature आएगा आपका 65. This is hot fluid exit temperature. Oil का exit temperature आएगा 65. Cold के लिए, water के लिए आएगा exit temperature 94.62, and the heat transfer rate will come out 116.364 kilowatt. B is the right answer for this question. Please check. Is that fine, guys? Is that clear? Very good, Janish. Chaliye. I hope you all are, answering those type of questions. अभी ये क्वेश्चन है वो, हालांकि आप करेक्ट कर लेना, बिकॉज दे आंसर्ड wrong actually for this question, but अपने को पता होना चाहिए. in a tube pass one shell fluid flow exchange, hot fluids enters at this, leaves at this. so hot fluid enter कर रहा है 310 पे, लीव कर रहा है 190 पे. ओके, कोल्ड फ्लूइड एंटरिंग एट 50, कोल्ड फ्लूइड एंटर कर रहा है 50 पे, लीव कर रहा है 180 पे. ओके, दिस इज योर पैरेलल फ्लो अरेंजमेंट. काउंटर के लिए अरेंजमेंट कैसा हो जाएगा? फॉर काउंटर फ्लो द अरेंजमेंट विल बी समथिंग लाइक दिस, 310, 190, okay, 50 and 180. ये वाला अरेंजमेंट है आपका. दिस इज फॉर काउंटर and this is for parallel. Can you answer this question, guys? Please try to answer. Yes, Jerish, thank you. चलिए रिंकू जी, तो पानी देना रिंकू जी, मिक्स करके थोड़ा. एक्चुअली फॉर दिस क्वेश्चन दे आंसर्ड, उन्होंने जो आंसर किया, both arrangements transfer equal amount of heat. Okay, both arrangements transfer equal amount of heat. Okay, which is right. अब आपको इसमें कंफ्यूजन क्या होगा? बहुत सारे बच्चे आंसर करेंगे, सर दिस इज पैरेलल फ्लो, दिस इज काउंटर फ्लो, शो डेल्टा टीएम तो ज्यादा बेटर होता है. तो बोलेगा कि सर काउंटर फ्लो विल ट्रांसफर मोर हीट. सो व्हाट यू विल आंसर? अभी इसको आंसर करो पहले. तो आप देखो अभी बच्चों ने आंसर करना शुरू कर दिया, दे आर आंसरिंग बी. तो आपको अभी आंसर करो बच्चों. एक्चुअली आई हैव नॉट गिवन यू टाइम, मैंने आपको टाइम नहीं दिया. प्लीज ट्राई टू आंसर दिस क्वेश्चन. व्हाट डू यू थिंक, बी, सी और ए? व्हाट इज द राइट आंसर फॉर दिस क्वेश्चन? देखो, एरिया इज नॉट सेम, ही इज नॉट मेंशन. व्हाट यू हैव टू अंडरस्टैंड, दीस आर एक्चुअली वेरी गुड क्वेश्चन. कैसे अच्छा क्वेश्चन करते हैं? देखो, मोस्ट ऑफ द स्टूडेंट दे आर आंसरिंग बी एक्चुअली. अभी व्हाट यू विल थिंक कि सर बी में हीट ट्रांसफर ज्यादा होगा, हीट ट्रांसफर विल बी मोर. How you can say that? Like if the heat transfer is more, the temperature change will also be different. Yes or no? Temperature change दोनों में क्या होगा? Different होगा. Okay. Heat transfer will be more. कब होगा heat transfer will be more? When suppose you are using the more area, equal amount of area. If you are having counter flow, parallel flow, equal amount of area, then the heat transfer will be more in what? Counter flow heat exchanger. Because delta Tm, if you will check it here, delta Tm of counter will come out more. Delta Tm counter will be more than delta Tm parallel. ये इससे ज्यादा आने वाला है. So, but you cannot say कि heat transfer is more. Why you cannot say heat transfer is more in counter flow? Because he has not mentioned anything about area. He is giving you the temperature change. Temperature change जो hot का है, temperature change hot का in counter, that is equal to temperature change of hot in parallel. Temperature change of cold in counter, that is equal to temperature change of cold in parallel. Mass rate is also he is not mentioned, means we are assuming कि both are same. Mass rate of hot in parallel, that is equal to mass rate of hot in counter. Cp भी लिख लो यार, Cp तो वो तो प्रॉपर्टी है, वो तो चेंज होगा ही नहीं. Cp तो चेंज ही नहीं होगा. m dot h Cph in parallel, that is equal to m dot h Cph in counter. Both are same. ओके, तो ये कंफ्यूजिंग क्वेश्चन हो जाता है. बहुत सारे बच्चे इसको गलत आंसर करेंगे. m dot c Cpc parallel, that is equal to m dot c Cpc counter. Both are same. We are not changing the mass flow rate. We are not changing mass flow rate. We are not changing changing temperature. Changing temperatures are also same. What it means? It means the heat exchanger which we are using parallel counter, they are having different area. उनका area different है. But heat transfer is same. How we can say the heat transfer is same? Sir, heat transfer क्या होता है? Heat transfer from the energy balance, we know this is nothing but m dot h Cph into change in temperature of the hot fluid. This is equal to m dot c Cpc into change in temperature of the cold fluid. Yes or no? क्या इन दोनों में टेम्परेचर में डिफरेंस है? यहाँ पे हॉट का फ्लूइड जो चेंज हो रहा है, यहाँ पे हॉट का फ्लूइड जो टेम्परेचर चेंज है, बोथ आर सेम. Whatever change in temperature change is there for the hot fluid, that is same here. Whatever mass flow is there, that is also same. Whatever specific heat, that is also same. It means the heat transfer is same in both the cases. दोनों केसेस में heat transfer क्या हो जाएगा? सेम हो जाएगा. So for this question, option C is the right answer, guys. तो आपको बड़ा क्लियर रहना पड़ेगा. Lots of the student initially they will think and they will answer B. Counter flow है सर, ज्यादा efficient होगा. He is not asking you about the efficiency. He is not asking you about the delta TM. वो आपसे delta TM वगैरह नहीं पूछ रहा है. He is asking you in which case heat transfer will be more. Heat transfer will be same in both the cases, guys. Is that clear? तो बिल्कुल एक नंबर का हलवा क्वेश्चन लग रहा था ये, बट दिस क्वेश्चन इज वेरी वेरी यूनिक, डिफरेंट ऑल्सो. इज दैट क्लियर गाइस? ठीक है, बताओ मेरे को जल्दी से बताओ. इज दैट क्लियर? दिस क्वेश्चन इज क्लियर गाइस? व्हाई एक्चुअली आई एम गोइंग विद ऑप्शन सी. देखो किसी ने भी इसका आंसर नहीं किया. नोबडी आंसर्ड दिस क्वेश्चन. यू कैन ऑब्जर्व. देखो यहां पे कितना चेंज हो रहा है. 310 से 190 पे जा रहा है. 310 से 190 पे जा रहा है. देखो दोनों में फर्क क्या होगा? दोनों में फर्क क्या होगा? एरिया ऑफ पैरेलल विल बी मोर एरिया ऑफ द काउंटर. ओके, तो होगा क्या? देखो Q इक्वल टू यू ए डेल्टा टी एम. ये मान लीजिए ये पैरेलल है. यू ए डेल्टा टी एम काउंटर है. अरे तो प्रोडक्ट सेम है ना बच्चों. दिस इज सेम, दिस इज सेम, प्रोडक्ट इज सेम, प्रोडक्ट इज सेम. डेल्टा टीएम पैरेलल का कम होगा तो एरिया ज्यादा होगा. डेल्टा टीएम यहां पे ज्यादा है तो एरिया कम होगा. दैट इज ओनली डिफरेंस, बट देयर प्रोडक्ट हीट ट्रांसफर विल बी सेम. यू गॉट द आंसर गाइस? इज दैट क्लियर? Flow has more. Is that clear guys? Flow has more heat transfer than counter flow, but counter flow has more heat transfer than PK. Let me clear again. देखो मैं आपको दो चीजें बोलता हूं. What you need to understand, what you need to understand, parallel counter for the same heat transfer, you cannot make it that single observation. एक single observation मत बनाओ कि सर heat transfer will be more in counter. Don't make that observation. Delta TM counter is more than parallel. That observation you can make all the times. वो ऑब्जर्वेशन आप बनाओ. अब देखो दो केसेस हो सकते हैं. डेल्टा टीएम काउंटर विल बी मोर देन द डेल्टा टीएम पैरेलल. तो देयर आर टू केसेस. फर्स्ट केस, फॉर द सेम हीट ट्रांसफर area required for the counter will be less as compared to the area of the parallel flow. This is first conclusion. For the same area, heat transfer will be more in the counter flow. That conclusion you need to make. But in this case, he has not mentioned anything about the area. He is giving you the temperature changes. Both are same for both the cases. Mass varieties are also same. Then we need to go with option C, same heat transfer. तो ये तो बड़ा कंफ्यूजिंग बना दिया आपने इस क्वेश्चन को. सिंपल क्वेश्चन को यू आर कंफ्यूज्ड. लोट्स ऑफ स्टूडेंट दे आर कंफ्यूज्ड इन दिस क्वेश्चन. इज दैट क्लियर गाइस? जैनिश, विश्वनाथ, पीके, इज दैट क्लियर गाइस? फ्यूज हो गया है मेरे ख्याल से. बहुत बच्चे सोच रहे हैं कि सर यस पीके गोट कर गया. चलो बढ़िया, गुड. अभी विश्वनाथ को अभी भी कंफ्यूजन चल रहा है. तो विश्वनाथ अभी इसको देखो, एक बार दोबारा देखो. यू नो टाइम इज वेरी वेरी प्रीशियस फॉर अस. तो मैं आपको डिस्कस किया, एक बार दोबारा मैं बीच में टाइम लगा के डिस्कस करूंगा. ठीक है? यस विश्वनाथ, ठीक है. चलिए, साइकत इज ऑल्सो सेइंग यस, गुड. बच्चे hot and cold are not same. Hot and cold fluid are not same. What I am saying, what you need to understand, what is the temperature change for the hot fluid? Temperature change for the hot fluid, delta T for the hot fluid is what? This is 300 minus 190, it is 120. 120. What is the temperature change for the hot fluid here? यहाँ पे भी hot fluid का temperature change कितना है? That is again 120. So this 120, this 120, this 130, this 130, this 130, these are same. Okay, I'm not saying these are same. वो कैसे same हो सकते हैं बच्चों? ठीक है, चलिए. So please try to answer this also. For a phase change heat exchanger, heat capacity ratio R क्या होता है बच्चों? What is R? R is what? Phase change के लिए क्या होगा? R is infinite. बच्चे infinite आंसर कर रहे हैं. Very good विश्वनाथ. देखो R is m dot Cp. यहाँ पे R क्या है? Heat capacity rate ratio. This is heat capacity rate ratio. M dot Cp small. This is m dot Cp small by big. अभी जो फेस चेंज हो रहा है मतलब बिग कितना है? बिग तो इनफाइनाइट है. ये तो कुछ भी हो, कुछ फाइनाइट वैल्यू. फाइनाइट है, ये कुछ फाइनाइट है, और ये क्या है? इनफाइनाइट है. तो फाइनाइट बाय इनफाइनाइट क्या हो जाएगा? जीरो. तो हीट कैपेसिटी एट जीरो होता है किसके लिए, बहुत बार बता चुका हूं मैं, दिस इज फॉर फेज चेंज। फेज चेंज मतलब बॉयलर और कंडेंसर, तब भी बच्चे आंसर गलत कर रहे हैं। दिस इज फॉर बॉयलर एंड कंडेंसर, बॉयलर एंड कंडेंसर। ओके, फॉर बॉयलर एंड कंडेंसर फेज चेंज C is equal to 0. You got the point, guys? So don't say C, Vipul. C गलत हो जाएगा. B is the right answer for this question. B is right. Okay. B is the right answer for this question. Let's move to next question quickly. According to surface component beta, liquid to liquid compact heat exchanger. Okay. There are some heat exchanger, guys, which are known as compact heat exchanger, and those compact heat exchanger, they are having very large area. कॉम्पैक्ट हीट एक्सचेंजर क्या होता है बच्चों, कॉम्पैक्ट से नाम से ही पता चल रहा है, सरफेस एरिया लार्ज, लार्ज सरफेस एरिया, लार्ज सरफेस एरिया एज कंपेयर टू वॉल्यूम, as compared to volume, because you want to make those heat exchanger compact. आपको compact बनाना है, but surface area you want to keep large. Why? So that if heat transfer area is more, the heat transfer will also be more, NTU will be more, effectiveness will be more. So we want more heat transfer area. Area तो अपने को ज्यादा चाहिए, but area बढ़ने से कई बार volume भी बढ़ जाता है ना. So we want more area, but at the same time we want to compact the heat exchanger so that it will occupy lesser space. If heat exchanger is occupying larger sizes, larger spaces, then obviously it is going to create some kind of problems in industry. So we use some kind of heat exchanger which are known as compact heat exchanger, plate and fin type heat exchanger. There are various different types of compact heat exchanger. So those heat exchangers, they are having very large surface area. तो उसके लिए जो ये amount होता है ना, एक term होती है जिससे हम define करते हैं बीटा, it is a ratio of the surface area divided by volume. तो ये बहुत लार्ज होता है, सरफेस एरिया टू द वॉल्यूम इज वेरी लार्ज, इट इज मोर देन 400, इट इज मोर देन 400. सो सी क्या होता है बच्चों, राइट आंसर. व्हाई? बिकॉज फॉर कॉम्पैक्ट हीट एक्सचेंजर एरिया इज वेरी हाई, वॉल्यूम इज लेस. So this term is minimum, it is required to be 400. Okay, it is required to be minimum 400. If this ratio of the area to the volume of heat exchanger minimum it is 400, then only you can say, you can categorize that heat exchanger as a compact heat exchanger. Otherwise, if this value is less, then you will say that heat exchanger is not compact. If it is more than 400, then only you can say that heat exchanger is a compact heat exchanger. In this case, he is asking you C. आपसे सी पूछ रहा है बच्चों. ये तो अगेन, ये तो इजी क्वेश्चन है बच्चों, एक नंबर का क्वेश्चन है. दिस इज 1 मार्क्स क्वेश्चन. प्लीज आंसर दिस, प्लीज आंसर दिस 1 मार्क्स क्वेश्चन. तो ये तो आप इजीली निकाल सकते हो बच्चों. m डॉट cp हॉट डेल्टा th हॉट m डॉट cp कोल्ड डेल्टा t c कोल्ड. हॉट देख लो, हॉट कौन सा है, 200 माइनस 170. सो ये कितना है, दिस इज 30. कितना है, दिस इज 30. hot fluid heat exchanger, hot liquid enters at 200, leaves at 170. So for the hot fluid the change in temperature is 30. For the cold fluid the change in temperature is what, the change in temperature is this is 70. Okay, so as this is more, from this equation you can analyze, this is less, this is more, it means this term is more, this term is less. Okay, so easily we can conclude that this is less, this is more. So if this is less, m dot cp less means small divided by m dot cp big, and this is nothing but m dot cp hot divided by m dot cp cold. How we can say this is small, guys? इसको हम small कैसे बोल सकते हैं? This is big, guys. is big है, मैंने उल्टा लिख दिया. Okay, this is big. Okay, small by big, so this is small, m dot cp cold divided by m dot cp hot. For hot it is high, why? Because this is 30, this is 70. Okay, this is 30, this is 70, means if this amount is less, so this amount will be more, and if this amount is high, so this amount will be less. Okay, so the answer will be what, guys? Answer will be 30 by 70. ओके, तो इसको आंसर करोगे, यू विल गेट द आंसर. ठीक है, तो 0.42 आपका क्या हो जाएगा, आंसर हो जाएगा. दिस इज वेरी सिंपल क्वेश्चन. ऑप्शन ए क्या हो जाएगा, दिस इज द आंसर फॉर दिस क्वेश्चन. ठीक है, आंसर फॉर दिस क्वेश्चन. नेक्स्ट क्वेश्चन में मूव करते हैं. Yes. LMTD पूछ रहा है बच्चों, he is asking you LMTD. So just read it and try to answer quickly. आपसे पूछ रहा है LMTD ने काउंटर फ्लो हीट एक्सचेंजर 1000 फ्लूइड, इतना जो फ्लूइड है आपका जा रहा है, कितना फ्लूइड है 1000 kg per hour. So 1000 divided by 60, 600. This is mass flow rate which is having CP 20. Okay, इसका CP कितना है 20 है, into change in temperature. It is cooled from 150 to 50, though the change in temperature is 25. The change in temperature is 25 for the hot fluid. The change in temperature for the hot fluid is 25. For the cold fluid, the heat transfer is, the mass flow rate is this. This will cancel out. CP is 16, so 16 Joule. Okay. Change in temperature is fluid leaves at this, so 75 minus TCI. This is energy balance equation. Very simple energy balance equation. Okay. Solving this energy balance equation, you will get TCI, cold fluid inlet temperature, which will come out 50 degrees Celsius. Cold fluid inlet temperature, you will get 50 degrees Celsius. Okay. Now you are having all four temperatures. चारों को चारों temperatures हैं. You need to draw the temperature profile for the counter flow, and easily you can calculate delta Tm counter. Okay. Temperature profile कैसा बनेगा बच्चों? It will look like something like this. Counter है, so it will be something like this. Hot fluid is entering at 150. This is 150. This is 125. Cold is entering at 50, leaving at 75. Okay. So the difference will come out what 75 only, because delta Ti will come out delta Te, and that is equal to delta Tm, and that will come out 75 degrees Celsius. Both are same. Delta Ti that is equal to delta Te. Both are same. That's why that will become the what? LMTD only. If delta Ti equal to delta Te, both are equal, then that only delta Ti or delta T, that will become the LMTD. ठीक है बच्चों? चलिए, let us move to next question. Please answer this also. So in a condenser, water enters at 32 degrees Celsius, flows at the rate of 14 kg per hour. The condensing steam is at a temperature of 120 degrees Celsius, and cooling water leaves the condenser at 90 degrees Celsius. The specific heat of water is 4.2 kilojoule per kg Kelvin. Overall heat transfer coefficient is 2000 watt per meter square Kelvin. He is asking you the area of the heat exchanger. Yes. Please calculate. Tell me what answer you are getting. कंडेंसिंग स्टीम है, तो देखो पहले तो आपको टेम्परेचर प्रोफाइल बनाना चाहिए कंडेंसर के लिए. कंडेंसिंग स्टीम क्या होती है? वो हमेशा हॉट फ्लूइड होता है. सो कंडेंसिंग स्टीम इज एट अबव, बिकॉज यहीं से तो हीट निकलेगी बच्चों, और इसकी हीट को कौन लेगा? द कोल्ड फ्लूइड इज गोइंग टू टेक हीट फ्रॉम दिस. कोल्ड फ्लूइड इज गोइंग टू टेक हीट फ्रॉम दिस कंडेंसिंग स्टीम व्हिच इज एट हायर टेम्परेचर. कोल्ड फ्लूइड एंटर कर रहा है 32 पे, लीव कर रहा है 90 पे. सो दिस डेल्टा टी इज 30, दिस इज 30, एंड दिस इज डेल्टा टी आई. डेल्टा टी आई इज व्हाट? ये कितना हो जाएगा? इट विल बी 88. ओके, सो डेल्टा टीएम हो जाएगा आपका 88 minus 30 divided by ln of 88 by 30. You will get the LMTD. Then you can use this formula. Q equal to m dot Cp, 14 by 60. This is here mass flow rate of the water. Cp of the water is 4.18. You can use 4.18. Change in temperature of the water is 32 to what? 90. 32 to 90. So it is 58. 58 is the change in temperature of the water. 58 is the change in temperature of the water. So 14 by 60 multiply by 4.18. This is m. दिस इज m kg per second, दिस इज cp of the water multiply by 10 की पावर 3, वो भी करना पड़ेगा बच्चों, नहीं तो आंसर नहीं आएगा, आंसर आएगा गलत, ठीक है, इनटू 10 की पावर 3, that is equal to UA delta TM, that is equal to UA delta TM. So U is given to us, U कितना है बच्चों आपका, U is 2000 area into delta TM, delta TM यहां से आ जाएगा, it will come out 53.89 degree Celsius, 53.89 degree Celsius. Solving this area you will get, solving this area you will get in meter square 0.00878 meter square. 0.00878 meter square means option C is the right answer for this question. Option C is the right answer for this question. Okay bachcho, so you need to be very careful about drawing the temperature profile, how to draw the temperature profile for condenser, how to draw the temperature profile for boiler, and then how to calculate LMTD for boiler condenser. बिल्कुल सही सूर्या, आपका आंसर बिल्कुल सही है बच्चे. Let's move to next question, question number 66. Can you answer this question guys? This type of similar question asked in GATE also. Abhi I don't know, like they picked that assignment question from the GATE, ठीक है. Here I am solving because I found all these questions in NPTEL assignments, ठीक है. तो हो सकता है बाद में गेट में आया हो सकता है इन्होंने गेट से पिक कर लिया, आई डोंट नो, but this similar type of question, okay, similar type of question was asked in GATE also. Okay, I don't know the year, but somewhere I observed. Hot oil is cooled from 80 to 50 in an oil cooler which uses air as the coolant, and air temperature rises from 30 to 40 degrees Celsius. Designer uses the LMTD value of 26. Designer ने LMTD use किया 26. He is asking you the heat exchanger is of which type? Heat exchanger कौन सा है? Parallel flow है, counter flow है, cross flow है, या data insufficient है? What you will answer? What you will answer for this case, guys? डिजाइनर इज यूजिंग एलएमटीडी वैल्यू 26. आपको इसको अभी इसको 26 यूज कर रहे हो तो यार दोनों अरेंजमेंट के लिए निकाल लो एलएमटीडी, यहाँ पे पैरेलल बना लो, यहाँ पे काउंटर बना लो, दोनों के लिए डेल्टा टीएम निकाल लो. इसका क्या हो जाएगा, हॉट ऑयल है तो 80 पे आ रहा है बच्चों, 50 पे जा रहा है, ठीक है. कोल्ड है, अभी पैरेलल बनाते हैं, पहले बनाते हैं पैरेलल, यहाँ पे कोल्ड है 30 पे आ रहा है, 40 पे जा रहा है, तो ये हो जाएगा 10, दिस इज 10, ओके, एंड दिस इज 50. तो यहाँ पे LMTD कितना हो जाएगा, डेल्टा TM पैरेलल दैट इज इक्वल टू 50 माइनस 10 डिवाइड बाय ln ऑफ 5. ओके, तो यहाँ से आ जाएगा आपके पास डेल्टा TM पैरेलल. सिमिलरली काउंटर के लिए भी बनाओ, डेल्टा TM निकालो, ये हो गया 80, दिस इज 50, ओके, काउंटर है सो दिस इज 30, दिस इज 40, सो दिस टेम्परेचर डिफरेंस इज 40 and this temperature difference is 20. So the delta TM will be 40 minus 20 divided by ln of 2. Okay, ln of 2. अभी बच्चों ने आंसर भी कर दिया है, बहुत सारे बच्चे they are saying C is the right answer, and that is right. C is very right for this question because parallel के लिए अगर आप counter LMTD निकालोगे, for parallel you will get LMTD 24.85 degree Celsius. This is LMTD for parallel. Counter के लिए निकालोगे बच्चों, same case, काउंटर के लिए if you will calculate it will come out to 28.853. जो डिजाइनर यूज कर रहा है डेल्टा टीएम, जो डिजाइनर यूज कर रहा है बच्चों, डिजाइनर जो यूज कर रहा है दैट इज 26 डिग्री सेल्सियस. इट मींस दिस इज मोर देन द डिजाइनर, the LMTD which is it is using, it is less than delta TM counter and it is more than delta TM parallel. अभी पैरेलल का भी नहीं है, काउंटर का भी नहीं है, इट मींस इट्स इन बिटवीन, सो इट इज अ क्रॉस फ्लो हीट एक्सचेंजर. ये क्या हो जाएगा आपका, क्रॉस फ्लो हीट एक्सचेंजर. अगर पैरेलल वाला होता तो पैरेलल को आंसर कर देते, काउंटर वाला होता तो काउंटर को आंसर कर देते, बट वी आर गेटिंग द LMTD लेस देन काउंटर, मोर देन पैरेलल, मींस the heat exchanger which that designer is using, it is of cross flow heat exchanger. You know, we answered also cross flow heat exchanger, they are having performance effectiveness less than counter, more than parallel. Counter flow heat exchanger effectiveness are highest, okay, in comparison to cross or parallel. ठीक है बच्चों, तो slightly different manner this question was asked. अभी अपने बचे हैं सिर्फ 4 क्वेश्चन, because 70 questions we are going to solve from heat exchanger. मैंने आपको बताया था हीट एक्सचेंजर पे ज्यादा टाइम नहीं लगेगा बच्चों. And then after 70 71 question will be from radiation. 4 क्वेश्चन बचे हैं कंडेंसर से, सॉरी हीट एक्सचेंजर से, and we are going to complete those also quickly. If you will answer, then I will be able to cover those very quickly. चलिए, based on the information provided 67 और 69, 67 से 60, अभी देखो 3 कॉमन डेटा दे दिए, मतलब ये तो बहुत आसान क्वेश्चन हो गया, तो इसको हम बहुत जल्दी निपटा देंगे. 67 से 69 जो है कॉमन डेटा है, तो एक क्वेश्चन बचेगा, उसको तो बड़ी जल्दी निपटा देंगे. चलिए, तो क्विकली यू कैन आंसर गाइस. देयर इज अ कंडेंसर required for organic vapor having latent heat of vaporization is this. Okay, latent heat of vaporization HFG is given to you 300 kilojoule per kg. Condenser is cooled by site cooling water 30 डिग्री सेल्सियस एंटर कर रहा है, 50 डिग्री सेल्सियस पे लीव कर रहा है. ठीक है. Overall heat transfer coefficient is 790. Overall heat transfer coefficient is also given to you. In first question he is asking you determine the ratio of the mass flow rate of vapor to the mass flow rate of cooling water. If the organic water is saturation temperature for the organic vapor is 100 degree Celsius. Okay, so in first part he is only asking you the ratio. Okay, in first part only he is asking you the ratio. साइकत कंडक्शन के मैंने 30 क्वेश्चन डिस्कस किए थे, in this in those NPTEL assignments. I don't know the date. First I covered 30 questions from the conduction only. I don't know you attended that session or not. I think you have not attended. That's why you are asking me. Conduction, that lecture is private now. Okay, that cannot be available this time. But yes, fins का एक lecture पढ़ा है YourPedia YouTube channel पे. If you will go to playlist, channel पे जाओगे playlist पे, you will find some lecture related to fins, transient heat conduction, unsteady state and fins. One lecture you will find 30 question, close to 30 question you will find from the fins. Conduction का भी also I covered 30 questions. So I'm covering more than 150 questions from the NPTEL assignments only, guys. So here I'm covering 100 questions from convection, radiation and heat exchanger. ठीक है, तो उसके लिए आपको लेक्चर देखना पड़ेगा साइकत. यू कैन वॉच दैट लेक्चर, बिकॉज 100 का सीरीज हमने लेट शुरू किया था. इनिशियली वी स्टार्टेड दोज 25-30 लेक्चर्स क्वेश्चंस ओनली फ्रॉम एनपीटीएस, बट आप लोगों का रिस्पॉन्स मिला एंड वी गोट द कॉन्फिडेंस ऑल्सो वी कैन टेक दोज काइंड ऑफ बिग लॉन्ग क्लासेस. तो दैट्स व्हाई वी गोट दैट आइडिया कि यस इट इज गुड. All we are conducting under the guidance of Dr. Vijender sir only. So every time sir came up with unique ideas. So this is also one of that 100 question NPTEL assignment series. ठीक है, and I hope this will help you. Surely it is going to help you, that we believe actually. Okay, you will be easily able to recall all those concepts, and definitely in your GATE examination, on your day of examination, guys, we are again going to meet through this live system only, and definitely we will discuss yes how many questions you got from those NPTEL assignment, because we are not covering a single subject, we are covering each and every subject, guys. From thermodynamics we covered application, more than 150 questions I covered. For Rankine cycle I covered more than 30 questions. Similar for Brayton cycle, similarly for Otto cycle, diesel cycle, VCRS individually I covered 30 questions from NPTEL assignments. Okay, cyclometry I covered more than 50 questions from NPTEL assignments only. So entire part we are covering. Okay, chaliye, and different mentors, they are taking classes for each and every subject. Production also, and strength of material, fluid mechanics, Vijender sir only covered. So in first case he is asking you the mass rate of vapor to the mass flow rate of water. ये आपसे पूछ रहा है. कूलिंग वाटर ये आपसे पूछ रहा है, तो बड़ा आसान है यार. एनर्जी बैलेंस लगा दो यार, यहाँ पे लगाओ एनर्जी बैलेंस. व्हाट इज एनर्जी बैलेंस? मास रेट ऑफ वेपर इनटू HFG, दैट इज इक्वल टू mass rate of cooling water into Cp of the cooling water into change in temperature of the cooling water. Yes or no? तो mass rate कितना है कूलिंग वाटर का? mass rate कितना है कूलिंग वाटर? ये निकालना है, रेशियो अपने को निकालना है. So we want to find out this ratio, mv by m dot c. So this is equal to cpc. Cpc of the cooling water is what? Cpc of the cooling water is 4.178 into mass rate of the cooling water is you can check what is the mass flow rate of the cooling water. ये तो यहाँ चला गया mass rate. तो delta t कितना है? delta t for the cooling water is 30 and 50. It is entering at 30, leaving at 50, so it is 20. Divide by HFG. HFG कितना है? 300. So this is also in kilojoule kg, this is also in kilojoule per kg. That will be cancelled out easily. You will get the answer for the first question. This ratio will be this: 4.178 multiplied by 20 divided by 30. Okay, Janish, this time I cannot ensure you because two broader stream we are covering this time, civil and mechanical only. And yes, this subject I know this is common for chemical and mechanical engineering student. So this time we are not covering actually. Okay, but yes, definitely in future we will try. We will try to cover each and every domain of engineering. Okay, chaliye. So this ratio will come out 0.2785. सो आंसर क्या हो जाएगा इसके लिए? डी. डी इज द राइट आंसर. डी क्या हो जाएगा आपका? आंसर हो जाएगा दिस डी. इसमें गैप नहीं है बच्चों, थोड़ा सा गैप नहीं है ऑप्शंस में, तो डी इज द राइट आंसर. लोगरिथमिक मीन टेम्परेचर भी निकाल लो. आपसे पूछ रहा है एलएमटीडी भी निकाल दो. एलएमटीडी क्या है? देखो सैचुरेशन टेम्परेचर कितना है वेपर के लिए, बिकॉज इट्स अ काइंड ऑफ कंडेंसर. So this saturation temperature is what, 100 degrees Celsius. This is 100 degrees Celsius saturation temperature. You can take it as parallel counter anyone, because in both the cases you are going to get same delta Tm. So don't think sir I need to take parallel or counter. You can draw the temperature profile for parallel, counter, anything, because delta Tm parallel, that is equal to delta Tm counter. So don't worry about the arrangement. Okay, don't worry about the arrangement. So this is saturation temperature 100 degrees Celsius, and for the water it is 30, this is 50. So the delta Tm will be 70 minus 50 divided by ln of 70 by 50. 70 minus 50 divided by ln of 70 by 50. Okay, and if you'll calculate, you will get 59.44 degrees Celsius. 59.44 degrees Celsius. yes, आइकत, बहुत सारे वीडियोस आपको मिल जाएंगे. Some videos are there in the playlist. Playlist में हीट ट्रांसफर का एक लेक्चर मिल जाएगा. ओके, वो रहेगा आपके लिए अवेलेबल. सो यू कैन वॉच दैट लेक्चर हीट ट्रांसफर का. उसमें 30 क्वेश्चंस आई कवर्ड फ्रॉम द ट्रांजिएंट हीट कंडक्शन एंड फ्रॉम फिन्स आल्सो. ओके, तो वो कर लोगे, कंडक्शन बचेगा, कंडक्शन को भी आप प्रैक्टिस कर सकते हो, है ना. चलिए, डेल्टा टीएम. सो डी इज द राइट आंसर. नेक्स्ट क्वेश्चन में मूव करते हैं बच्चों. क्वेश्चन नंबर 68. Find out the value of the heat transfer area, length of the condenser tubes. आपसे लेंथ पूछ रहा है, लेंथ ऑफ द ट्यूब्स. ओके, अगर ऑर्गेनिक वेपर का जो मास फ्लूइड है, मास फ्लूइड ऑफ द ऑर्गेनिक वेपर इज 7 kg per second एंड द डायमीटर ऑफ द ट्यूब इज 50 mm. अभी इस केस में आपसे पूछ रहा है लेंथ ऑफ ट्यूब, इज आस्किंग यू द लेंथ ऑफ ट्यूब एंड इज आस्किंग यू द सरफेस एरिया. ओके बच्चों, क्यू आपको पता है, देखो क्यू आप इजीली निकाल सकते हो. मास फ्लूइड ऑफ द वेपर इनटू एचएफजी. मास फ्लूइड ऑफ वेपर इज 7, एचएफजी कितना था बच्चों? एचएफजी इज 300. दिस इज 300. दिस इज क्यू. मास फ्लूइड ऑफ द वेपर इनटू एचएफजी, दिस इज योर क्यू. ओके, केजी पर सेकंड है. यस, इट इज इन केजी पर सेकंड. 7 kg per second मल्टीप्लाई बाय 10 की पावर 3 करना पड़ेगा, बिकॉज दिस इज इन किलो जूल पर केजी. सो दिस इज 10 की पावर 3. This is your Q. ये ध्यान रखना पड़ेगा बच्चों, इसको मिस मत करना. This is 10 की पावर 3. SI units we need to use. This is equal to UA delta TM. Delta TM already we calculated 59.44. U is given to us. Overall heat transfer coefficient it is 790. Okay, 790. Solving this, you will get the area of the heat exchanger. You will get area of the heat exchanger. So guys, area you will get 44.72 meter square. Area equal to 44.72 meter square. हालांकि इससे आप आंसर कर सकते हो. From this only you can answer. Okay, but let's find out how to find out this length. Guys, ये area क्या होता है? This is area of the tubes. Like ये अगर आपकी heat exchanger की tubes हैं, these are the tubes of the heat exchanger. So what is area? Area क्या होता है? This is surface area. हीट एक्सचेंजर के लिए दिस इज नथिंग बट द सरफेस एरिया ऑफ द हीट एक्सचेंजर। और ये क्या होता है, दिस इज पाई डी इंटू एल, this is pi d into L. So the area of the heat exchanger is nothing but pi d L. So pi diameter is given to us 50 mm. So 50 into 10 to the power 3 L we want to find out. Comparing this, you will get a length of the tubes. Comparing this length of the tube required for the required heat transfer. For that required heat transfer, how much length of the tube is required? आपको सर डायमीटर कहां से पता चलता है? बच्चों डायमीटर पता चलता है मार्केट में जो अवेलेबल ट्यूब्स हैं, किस डायमीटर के ट्यूब हम रखना चाह रहे हैं, ये जनरली डिजाइनर डिपेंड करता है। स्पेस लिमिटेशन कितना है, कितना मास फ्लो रेट चाहिए, कितना हमें मास फ्लो रेट चाहिए, बहुत सारे कंस्ट्रेंट होते हैं। अब आप ऐसा भी नहीं कि डायमीटर को आपने एक डायमीटर निकाल लिया, मान लीजिए 1.23 सेंटीमीटर, मार्केट में उस डायमीटर का सपोज ट्यूब इज नॉट अवेलेबल, देन व्हाट यू विल डू? Generally, based on different criteria, which diameter tubes are available in the market, what mass rate or other things we need to keep, depending on that we fix the diameter, and based on that area we calculate, and after that easily you can calculate the length of the tube required. कितना आपको लेंथ रखना पड़ेगा इफ यू वांट टू हैव दैट हीट ट्रांसफर। ओके, तो इसको सोल्व करोगे इजीली, यू विल गेट द लेंथ ऑफ द ट्यूब। जो आंसर आपका आएगा इट विल कम आउट 284.7027 7027 284.7। चलो इसको इतना ही लिखते हैं, इतना बड़ा लिखने की जरूरत नहीं है। 284.7 मीटर, 284.7 मीटर। ओके, एंड नाउ यू कैन मैच। यस, 284.7 बिल्कुल सही, दोनों ऑप्शन हमारे मैच कर जाएंगे। बी इज द राइट आंसर। ओके, बी इज द राइट आंसर फॉर दिस क्वेश्चन। चलिए 5 घंटे में हमने कर दिया, तो मींस एटलीस्ट वी कैन अभी एक्सपेक्ट कर सकते हैं कि 6 साढ़े 6 घंटे में वी विल कवर दोज 100 क्वेश्चन। ठीक है, नेक्स्ट पार्ट में देखो क्वेश्चन नंबर 69 में, बिकॉज दीज आर कॉमन डेटा क्वेश्चन थे, तो 67 से जो 69 थे कॉमन डेटा क्वेश्चन थे। अभी आपसे पूछ रहा है एनटीयू। इन दिस क्वेश्चन ही इज आस्किंग यू एनटीयू। ऑब्वियसली स्मॉल किसके लिए होगा बच्चों? दिस स्मॉल विल बी फॉर वाटर ओनली ना, बिकॉज अदर फ्लूइड्स जो था आपका, फॉर दैट द एम डॉट सीपी इज इनफाइनाइट, बिकॉज उसका क्या हो रहा था, कंडेंसेशन हो रहा था। ओके, तो इसमें तो सोचने की जरूरत ही नहीं है। वन ऑफ द फ्लूइड विच इज हैविंग वेपर, उसका तो कंडेंसेशन हो रहा है। सो दूसरे के लिए मास फ्लो रेट कितना बच्चों? फॉर वाटर द मास फ्लो रेट इज दिस 20 kg per second. Let me check. Mass flow rate for the water is yes, mass flow rate for the water is where is the data? Okay, let me check, let me observe it again. Condenser, latent heat of this condenser, cooling water is this, outlet is this, overall heat transfer. Determine the, okay, that we directly we know, but we calculated the ratio. अभी हम जहां से हम निकाल सकते हैं mass rate of the coolant. Mass rate of the coolant is nothing but mass rate of vapor divided by 0.2785. Okay, mass rate of vapor was given in the earlier question, तो यहां से आप निकाल लो यार। yes or no? ठीक है, so these are common data question. So directly he has not given you mass rate of the coolant. कूलिंग वाटर का नहीं दिया आपने को, वेपर का दिया है 7, and this ratio we calculated in the first part only. From that you will get m dot c. okay, और m dot c आ जाएगा, so cp for that coolant, cp for the coolant is 4.178 because that is water only. वो क्या है, वाटर ही है। so ua divided by m dot cp for the water. तो वाटर का m dot c निकाल लो यार, and cp of the water is 4.178 किलो जूल पर kg केल्विन। यूनिट्स का ध्यान रखना पड़ेगा आपको। 4.178 बिल्कुल सही, सही है। ठीक है, टेल मी व्हाट एनटीयू वैल्यू यू आर गेटिंग गाइस, व्हाट एनटीयू वैल्यू यू आर गेटिंग? कोई आंसर बच्चों आपकी तरफ से? व्हाट एनटीयू वैल्यू यू आर गेटिंग? बिल्कुल सही बच्चे, सी इज द राइट आंसर। सी इज द राइट आंसर फॉर दिस क्वेश्चन। तो एनटीयू आपका आ जाएगा 23.55। ठीक है बच्चों? अच्छा 1.5 गिवन है, ठीक है, चेक कर लेना यार। अच्छा ये यहां दे दिया है इसने, यस इन दिस पार्ट ही इज गिवन, ठीक है, सही है। m dot c is given 1.5, but also if it is not given, अगर ये नहीं भी देता, then you can calculate this from there here, तब आप इसको यहां से निकाल लेते। ठीक है, चलिए, इट इज गिवन। अच्छा मिनिमम हीट कैपेसिटी रेट ही दे दिया उसने अपने को। दिस इज नॉट मास फ्लूइड, दिस इज नॉट मास फ्लूइड गाइस, दिस इज नॉट मास फ्लूइड, दिस इज m dot cp entire for the water. This is given to us 1.5 into 10 की पावर what, मल्टीपल, यस मास रेट मल्टीपल, बट इसका यूनिट गलत है बच्चों, यूनिट गलत है ना, दिस इज नॉट किलो जूल, बिकॉज यूनिट क्या होगा, यूनिट विल बी केजी पर सेकेंड into kilojoule per kg Kelvin. So the unit will be kilojoule per second means kilowatt per Kelvin. The unit will be kilowatt per Kelvin. The units are wrong. Kilojoule per kg second. This units are not right, guys. So units गलत हो जाएंगे. So unit will be 1.5 kilowatt per Kelvin. या kilojoule per second Kelvin. ये kg ना होके Kelvin होना चाहिए था. ये ऐसा होना चाहिए था. Kilojoule per Kelvin into second. ठीक है, चलिए. Chaliye, let's move to next and last question from the heat exchanger. This is last question, guys, from the heat exchanger. Then we will move to the radiation part. उसके बाद हम radiation पे move करने वाले हैं बच्चों. So be ready for that. Determine overall heat transfer coefficient. आपसे overall heat transfer coefficient पूछ रहा है. Liquid to liquid heat exchanger, जहां पे जो ट्यूब्स हैं आपकी, जो ट्यूब्स हैं, वो ट्यूब्स का जो थिकनेस है, ट्यूब्स थिकनेस इज 0.003 मीटर. Tube thickness is 0.003 meter. Okay, something like this. So this is R1, this is R2. Okay, आपसे पूछ रहा है overall heat transfer coefficient, U पूछ रहा है आपसे. You know guys, there is a relationship 1 by UI AI that is equal to 1 by UO AO that is equal to summation of all thermal resistances. Summation of all thermal resistances. You know this relationship, guys? So sometimes students think sir UI UO both are same. Guys, UI and UO both are not same. This is the overall heat transfer coefficient inside, this is overall heat transfer coefficient outside, they are not same. But what is same? Sir, the product of UI AI that is equal to UO AO, they are same. UI AI that is equal to UO AO, that's why you can write Q equal to UI AI delta Tm, or you can write it as UO delta Tm. Okay, so you need to be very careful. Don't replace UI by UO, because UI and UO both are not same, they are different. UI is the overall heat transfer coefficient considering the internal area. UO is the outside heat transfer coefficient, they are different. Okay, but the product of UI equal to UO both are same. Now what is summation of total resistance, guys? Summation of total resistance से क्या मतलब है? Summation of total resistance means first there will be convection resistance inside, so 1 by UI AI that is equal to 1 by UO AO that is equal to convection resistance. First convection resistance is 1 by HI. This is inside convection resistance. Then after convection resistance you will have conduction resistance, which is ln of R2 divided by R1 divided by 2 pi KL, where K is the conductivity of the tube of heat exchanger. This is convection, internal convection. This is conduction resistance of the tube. Okay, plus external convection 1 by HOAO. Okay, this is our UI. Sometimes we add some kind of fouling factor also. इसमें हम क्या करते हैं, फाउलिंग फैक्टर भी क्या कर देते हैं, ऐड कर देते हैं. Okay, so we, because in new heat exchanger everything will be clean, there will be no fouling, but in old heat exchanger there will be some kind of scale formation, so we need to add some kind of factor which is there to compensate additional resistance offered by scaling. There is a factor which is known as fouling factor, which is there to compensate additional resistance offered by scaling or deposition. Okay, due to scaling or deposition there will be additional conduction resistance. ये जो आपकी ट्यूब्स है ना, ये ट्यूब्स में क्या होती है, अंदर गंदगी जम जाती है यहाँ पे, that is known as scaling or fouling. So that scaling is also going to offer some resistance That's why we cannot calculate that resistance easily. That's why we take some kind of fouling factor. हम एक fouling factor ले लेते हैं. Okay, fouling factor. Okay, that fouling factor we take just to compensate the additional resistance. कौन सा resistance guys? Additional कौन सा? Conduction resistance. Fouling is going to offer conduction resistance only. Fouling is going to offer additional conduction resistance. Okay, fouling से conduction resistance बढ़ जाएगा, pressure drop बढ़ जाएगा, because area will be less for the flow of the fluid, area will be less. So आपका pumping power will increase due to scaling. Pumping power will increase, pressure drop will increase, so pumping power आपको ज्यादा लगाना पड़ेगा, and heat transfer will decrease due to the increase in additional resistance. Okay, and ये होता क्या है बच्चों? This fouling factor is nothing but 1 by U dirty. यहाँ पे इसको क्लीन करते हैं ना, बिकॉज दिस विल बी मोर. यस, दिस विल बी यू डर्टी बाय 1 बाय यू क्लीन. 1 by u clean. So fouling factor is equal to 1 by u dirty, means overall heat transfer coefficient. When your heat exchanger is new, there is no such scaling in the heat exchanger, that is known as u dirty. उसे हम क्या बोलते हैं? u dirty. When there is scaling guys, when there is no such scaling, new heat exchanger, आपका heat exchanger कैसा है? New heat exchanger without scaling, without fouling or scaling. Okay, so that is known as u clean. And when the heat exchanger is dirty, that is known as u dirty. So 1 by u dirty minus 1 by u clean, that difference is known as fouling factor. So generally ये directly अपने को given होता है बच्चों. Okay, and if you will take all those things, you will get the overall heat transfer coefficient. Okay, अब इस क्वेश्चन में सिर्फ एक ही दिक्कत है, हर चीज गिवन है आपको. देखो, एवरीथिंग इज गिवन टू यू. आपसे पूछ रहा है कि लेंथ भी 1 ले लो, यू कैन टेक द प्लेट लेंथ, ट्यूब लेंथ 1, थिकनेस भी दिया आपको, ठीक है. ओके, कंडक्टिविटी भी दी है, फाउलिंग फैक्टर भी दे दिया, HI भी दे दिया, HO भी दे दिया, एवरीथिंग ही हैज गिवन यू. फर्स्ट थिंग, ही हैज नॉट आस्क्ड यू लाइक आपको ओवरऑल हीट ट्रांसफर कोएफिशिएंट इनसाइड पे निकालना है या आउटसाइड पे निकालना है. This is first information he has not given. Second, he has not given what is the internal radius, because internal radius अगर दे देता तो external तो हम लिख सकते हैं internal radius plus thickness of the tube. Internal radius plus thickness of the tube, because इसको आप remove नहीं कर पाओगे किसी भी तरह से, because if you are not considering that conduction resistance, because clearly he has mentioned, note that conduction resistance is also considered. आपको conduction resistance को consider करना है, और अगर आपको कंडक्शन रेजिस्टेंस को कंसीडर करना है, देन यू विल नॉट बी एबल टू रिमूव दिस टर्म. आप इस टर्म को रिमूव नहीं कर पाओगे बच्चों. ln of r2 by r1. So r2 is required, या r1 is required, any one is required. If you having r1, then you can write r1 plus the thickness of the tube. Okay, and if you are having r2, then r2 minus thickness of the tube, you will get r1. But he has not given you this data. I think somewhere he missed that kind of data. वो data उससे miss हो गया है, and that's why you will not be able to get the right answer for this question. But this concept is very very important. That's why I considered this question in the last so I hope all these questions are very much clear. तो अगर आपको ट्राई करना होगा बाद में कर लेना. I think concepts are very clear. So they answered option B as the right answer. 820 watt per meter square Kelvin. Is that clear guys? Yes. तो उसको बताना चाहिए था कि आपको इनसाइड पे निकालना है, आउटसाइड पे निकालना है, या आपको एटलीस्ट radius is required, because without radius you will not be able to calculate, you will not be able to remove these terms. AI को कैसे remove करोगे? मैंने दोनों तरह AO ही लिख दिया. This is AI. Okay, UI AI UO. ठीक है बच्चों? Is that clear guys? I think these things are clear to you. The concepts related to these heat exchanger. So now we can move to the radiation part guys. बहुत अच्छे क्वेश्चन हम सोल्व करने वाले हैं बच्चों from radiation. Okay, we are starting with very simple question, but you are having, all of you are having workbook with you. If you will refer to another questions like question number 73, 74, 75, you will be surprised, and definitely at the end you are going to appreciate, sir, these questions are very much wonderful, beautiful. So we are going to solve each and every question guys, so be patient. Okay, like till now in these 5 hours we have covered 70 questions, 35 questions from the convection we have covered, 35 questions from the heat exchanger we have covered, and now we are entering into the radiation. Okay, so this is first question from the radiation. अच्छा, प्लेट बोला है, देखो इस बार देख लो, अगर ये प्लेट है ओवरऑल हीट ट्रांसफर कोफिशिएंट थिक स्टील प्लेट, हाँ ठीक है, आप इसको थिक स्टील प्लेट मान सकते हो। अगर थिक स्टील प्लेट मानते हो बच्चों, देन हेयर यू कैन रिमूव दिस टर्म, तब आप इसको रिमूव कर सकते हो, एंड देन यू कैन राइट इट हेयर, तब आप इस पे क्या लिख सकते हो, बी बाय के ए, ओके, बी बाय के ए, ओके, बी बाय के, एंड इन दैट केस हम इसको रिमूव कर पाएंगे इजिली, वी विल बी एबल टू रिमूव AI, because plate केस में अगर ये प्लेट है, इट्स अ काइंड ऑफ प्लेट हीट एक्सचेंजर, if it is a kind of plate heat exchanger, AI equal to AO, that will be same, both will be same, okay, AI AO both will be same, तो आप इसको आप reduce कर पाओगे, let me write it here, 1 by UO, because if areas are same, this and this both are same, then 1 by UO, then they are equal, तब ये दोनों क्या हो जाएंगे same, but what is the case, AI equal to AO, okay, for the case of AI equal to AO, 1 by UO, that is equal to 1 by UI, then I think there is no such need of mentioning, you need to find out U considering the internal area or external area. So somewhere, because initially we have not discussed this, but it is there is a thick steel plate, okay, means he is talking about kind of plate heat exchanger, plate heat exchanger. So I think the concepts are very much clear, the formula is in front of you, and easily if you will apply, you will get the answer B, ठीक है, so this is equal to 1 by HI plus 1 by HO, okay, plus अभी क्या हो जाएगा, this will be plus B by KA, so B is the thickness 0.003, conductivity of the plate into fouling factor, okay, तो यहां से निकालो and easily you will be able to match your answer, ठीक है बच्चों, how many of you are getting the answer, बिल्कुल सही बच्चों, those are getting 820, they are very right, तो बिल्कुल सही है, 820 is our answer. I mentioned also कि they have given that answer because initially I have not observed this. Generally, because you know in the heat exchanger we are having tubes only, so I missed that data. And one of the student he analyzed Raja Pani. Very good Raja. देखो आपने एक क्वेश्चन सोल्व करवा दिया, which is very good. It's a kind of very good team effort. So thank you Raja. चलिए, so this is the right answer, option B. Is that clear guys? The concepts are clear. I hope you all are getting answer. Raja ने सबसे पहले आंसर दिया है 820, and I think you all others are also getting the answer for this question. They also mentioned option B as the right answer for this question. 820. विश्वनाथ कह रहे 5 मिनट का ब्रेक, चलो अभी 5 मिनट का ब्रेक बच्चों ज्यादा हो जाएगा विश्वनाथ, चलिए, सो नेक्स्ट यू नो टाइम इज 7:30, वी विल ट्राई टू कवर इट क्विकली, बहुत जल्दी अपने को करना पड़ेगा, वी आर हैविंग नो अदर ऑप्शन, एक ही ब्रेक था तो हमने वो ले लिया है. नाउ इज सेइंग देयर इज अ जनरल सरफेस which is having for a opaque surface. Opaque surface क्या होता है बच्चों? Opaque surface is having transmittivity 0. Opaque surface. For opaque surface transmissivity is 0. It means for a opaque surface the sum of absorptivity plus reflectivity, that is equal to 1. Absorptivity plus reflectivity, that is equal to 1 for a opaque surface. So B is the right answer. Okay. Black surface क्या होता है बच्चों? Black surface. Okay. For a black surface absorptivity equal to 1. Black surface absorptivity equal to 1. What is white surface? White body or white surface? White body which is having transmissivity equal to 1. Okay. White body transmissivity equal to 1. Opaque surface transmissivity equal to 0. And for a general surface, for any general surface, the sum of absorptivity, reflectivity plus transmissivity, that is equal to 0. Okay. Reflectivity, मैंने यहाँ पे transmissivity नहीं, यहाँ पे लिखना था reflectivity. For white body they are ideal reflector. Okay, they are ideal reflector. Transmissivity equal to 1 for ideal transparent body. Transparent, ideal transparent body. Okay, this is for transparent body. White body is ideal reflector. Okay, so white body reflectivity will be 1, black body absorptivity will be 1. For any general surface, the sum of absorptivity, reflectivity, transmissivity will be 1. For an opaque surface, transmissivity is 0. That's why alpha plus rho, that will be equal to 1. Let's move to next question, guys. This is question number 72. There is a spherical cavity. And in that cavity, he mentioned has a small opening. That cavity has a small opening. The rate of emission of radiation flux through that opening is this. So there is an opening. There is a small cavity, spherical cavity, which is having small opening. इसके अंदर क्या है? एक बहुत small opening है. The rate of emission of radiation flux through this opening is 5.67 kilowatt per meter square. What is the temperature in decimal of the inner surface? आपसे surface temperature पूछ रहा है. What is the surface temperature? What is the surface temperature, guys? So as he has given you, this is kind of small spherical cavity. So guys, every radiation which are going to enter, they're going to be absorbed by this surface. Okay, all radiation which are going to enter, they are going to be absorbed by this surface. Okay, so we can consider this small cavity, spherical cavity with a small opening, that can be considered as a black body. This is considered as black body. Okay, and if you got that idea, okay, this is a black body, then easily you can write this radiation 5.67 into 10 to the power 3 kilowatt per meter square. This is nothing but EV sigma T surface ki power 4. Okay, sigma T surface ki power 4, where sigma is the Stefan Boltzmann constant, which is 5.67 into 10 to the power minus 8. Surface temperature we want to find out. Solving this easily, you will get the surface temperature. Okay, so this will cancel out. You will have surface temperature की power 4, that is equal to 10 की power 11. Okay, तो इसको solve करोगे, you will get the surface temperature. Okay, so guys, solving this you will get the answer in degree Celsius. अभी इसको solve करोगे तो you are going to get the answer in Kelvin. With this relationship, the temperatures are in Kelvin, so surface temperature you are going to get in Kelvin 562.34 Kelvin. But he is asking you the answer in degree Celsius. So degree Celsius you need to subtract 273.15. So you will get this answer. This is the answer in degree Celsius, because he is asking you answer in degree Celsius. So this answer you need to mention. Kelvin से degree Celsius के लिए बच्चे subtract करना पड़ेगा. You are adding actually. Okay. 562.34, you need to subtract 273.15, you will get 289.19. 289.19. Yeah, yes, they mentioned in the range of 289 to 290. If you're getting answer in the range of 289 to 290, your answer is right. Let's move to next question, guys. This is next question number 74 in front of you. 73 actually. There is a large isothermal enclosure maintained at a surface temperature of 4000 Kelvin. The maximum spectral emissive power, EB lambda max. The maximum spectral emissive power. The maximum spectral emissive power in megawatt per meter square micrometer for the radiation emerging out of a tiny aperture at the surface is EB lambda. You know, guys, there is a plot between EB lambda and lambda plot. So here you can take spectral emissive power. This is known as spectral emissive power. And here if you will take lambda plot, so for a black body you will have a curve something like this. Black body के लिए कुछ आपको ऐसा curve मिलता है. Okay. This can deviate also. It is not like that कि this will be symmetric only. It depends on the temperature. ये temperature पे depend करेगा what kind of temperature profile you are having. So you will have different type of curve. कुछ ऐसे मिलेगी. Okay. You will have a curve something like this also. Okay. Then you can have a curve something like this also. Okay, as you will increase the temperature, जैसे temperature बढ़ाओगे, this curve will shift towards right. Curve क्या करेगी? This curve will shift towards right. Okay, are you getting the idea, guys? So this is curve with a different temperature. This is temperature T1, this is T2, this is T3, and this is T4. And T4 is the highest temperature. T4 is more than T4 is more than T3, T3 is more than T2, T2 is more than T1. As you are increasing the temperature, this curve is going to shift towards left. ये curve कहाँ shift करेगी? It will shift towards left. Okay, this curve will shift towards left. So this is a point where you are getting the wavelength, where you are getting the maximum spectral emissive power. Okay, that is known as lambda max 1. This is lambda max 1. Similarly, this is lambda max 2. Okay, this is lambda max 3. This is lambda max 4. The wavelength corresponding to maximum spectral emissive power. The wavelength lambda was, what is lambda max? This is wavelength corresponding to maximum spectral emissive power. Wavelength corresponding to maximum spectral emissive power. Corresponding to maximum spectral emissive power. Okay. Spectral emissive power. ठीक है बच्चों, this is known as lambda. And what, there is some law which is known as Planck's law. What that law says, the product of lambda max into temperature, the product of lambda max into temperature, that is a kind of constant. Okay, the product of lambda max 1 into T1, that is equal to lambda max 2 into T2, that is equal to lambda max 3 into T3, that is equal to lambda max 4 into T4. The product of lambda m into temperature is always constant. That is known as Wien's displacement law. The product of lambda max into temperature, that is always constant. Okay, and what is that constant, guys? वो constant कितना होता है? That constant is equal to 2898 micrometer Kelvin. 2898 micrometer Kelvin. As you can observe from this graph also, guys, यहाँ से भी आप observe कर सकते हो. This is lambda max 1, this is lambda max 2, this is lambda max 3, this is lambda max 4. Okay, so the lambda max 1 multiply by temperature T1. This will be more, this is more, temperature is less. Lambda m1 is more, temperature is less. So the product of this and this are constant. Lambda max 2 T2, lambda max 3 T3, lambda max 4 T4. That product is constant. Okay, and that product is equal to 2898 micrometer Kelvin. Now the temperature of the body is given to you guys. Temperature of the surface is, I think, 4000 Kelvin. So now can you tell me lambda max corresponding to that? Can you find out lambda max? Yes, very easily. 2898 divided by 4000, you will get the lambda max, maximum spectral maximum wavelength. Are you getting that lambda max, guys? क्या lambda max आ रहा है आपको? Because he has given you the temperature of the body is 4000. He has given you the temperature of the body is 4000. So corresponding to that, you will get lambda max. Okay, और वो lambda max कितना आएगा बच्चों? That lambda max will come out 0.7245 micrometer. 0.7245 micrometer. This will you will get. Okay, now he is asking you the spectral emissive power corresponding to that only. तो उसके लिए क्या करना पड़ेगा आपको? You need to use the Planck's law. आपको क्या करना पड़ेगा? Planck's law use करना पड़ेगा. EB lambda, it is a function of lambda into T. You know, spectral emissive power is a function of lambda and T. Spectral emissive power is a function of lambda and T, and there is one relationship which was given by Planck's, and that relationship is C1 by e की power C1 by lambda की power 5 into e की power C2 by lambda T minus 1. Okay, this is the relationship which we are having. This is known as Planck's law. C1 by lambda की power 5 into e की power C2 by lambda T minus 1. ठीक है बच्चों? Okay, so there is some table also, guys. Table को, like if you will refer to some table data book radiation में, then also you will get the answer. Okay, but you can use this Planck's law also. आप इसको भी use कर सकते हो. Otherwise you can refer your data book also. Radiation में you will find some data book, and from that also you can get some answer. तो यहाँ पे C1 क्या होता है बच्चों? SI यूनिट में लिख देता हूँ. C1 is equal to 3. He is going to give you all those things. ये आपको देगा 7.43 into 10 की power 8. Okay, a micrometer की power 4 divided by meter square. Micrometer power 4 divided by meter square. Okay, C2 equal to 1.4387 into 10 की power 4 micrometer Kelvin. Okay, micrometer Kelvin. These are the units for C1 and C2. These are the values of C1 and C2. You can but actually, you know, that 2 pi I included in these C1 C2 only. Are you getting the idea, guys? So don't worry about that 2 pi. 2 pi भी होता है, but that is also a constant. तो ये इसमें already include हो गया. That's why you are not having this here. मैंने इसको mention नहीं किया. Are you getting the idea, guys? There is 2 pi also, but if you are writing here 2 pi, then this C1 value will be different. C1 value क्या हो जाएगा? It will be different. Okay. And if you are not writing this 2 pi, it means it is included in this value. ये जो हमने लिखा है ना, ये इसमें include हो गया है. Are you getting idea? Yes, is that clear? Janish. Okay. Is it clear, Janish? So you need to have, you need to get idea. Okay. Why actually I'm not writing 2 pi? So that value is already included in those constant. Okay, so using these values, lambda already we calculated. लैम्डा तो ऑलरेडी हमने कैलकुलेट कर लिया है बच्चों. लैम्डा ऑलरेडी हमारे पास है, टेम्परेचर हमारे पास है, C1 C2 हमारे पास है. सो यू विल गेट दिस स्पेक्ट्रल एमिसिव पावर corresponding to maximum, corresponding to a temperature 4000 degrees Celsius and corresponding to maximum wavelength this 7245. ठीक है, तो कैलकुलेट करना एंड टेल मी व्हाट आंसर यू आर गेटिंग. प्लीज कैरी आउट दिस कैलकुलेशन, टेल मी व्हाट आंसर यू आर गेटिंग. चलिए, थोड़ा सा लेंदी रहेगा. इस तरह का क्वेश्चन कभी गेट में आज तक पूछा नहीं गया है, प्लैंक्स लॉ से ऐसा पूछा नहीं गया है, बट फॉर द सेफर साइड यू कैन कन्वर्ट. ही इज गोइंग टू प्रोवाइड यू दिस फॉर्मूला गाइस, डोंट वरी. कन्वेक्शन के जब वो हमें फॉर्मूला देता है तो डेफिनेटली फॉर प्लैंक्स लॉ इज गोइंग टू प्रोवाइड यू द फॉर्मूला. तो यू नीड नॉट टू रिमेंबर एनीथिंग, यू नीड नॉट टू रिमेंबर द फॉर्मूला, you need to remember the coefficient value C1 C2. Definitely 100% is going to provide you that data, but what you need to remember how to utilize, how to use that formula. वो तो आपको सीखना पड़ेगा बच्चों. फॉर्मूला कैसे यूज करना है वो आपको सीखना है. मेगावाट में पूछा है बच्चे उसने आपसे, मेगावाट में. he asked you the answer in megawatt. Okay, so he is asking you the maximum spectral emissive power. वो उसने आपसे पूछी है मेगावाट पर मीटर स्क्वायर माइक्रोमीटर. ठीक है, दैट्स व्हाई द C1 C2 व्हिच आई एम पुटिंग. देखो, इसके बहुत सारे अलग अलग लोग इसको अलग अलग तरह से यूनिट पुट करते हैं. इसका ऐसा यूनिट भी पुट कर सकते हो आप. अभी तो मैं माइक्रोमीटर स्क्वायर में पुट कर रहा हूं ना, बट दे कैन यूज दोस SI यूनिट्स आल्सो. सो डिपेंडिंग ऑन दैट, इन व्हाट यूनिट यू वांट टू फाइंड आउट दैट, देयर मे बी डिफरेंट यूनिट्स. ठीक है, अलग अलग इसकी यूनिट्स हो सकती हैं. Because why actually I'm using those values? Because with these values only you are going to get this EB in watt per meter square micrometer. Okay, and then you need to multiply that, you need to divide that by 10 to the power 6, so that you will get EB lambda in this. Yes, अभी जिसका 13 points कुछ आया ना, that is right. When I calculated, I got the answer 13.16. तो आप एक बार चेक करना, मेरे ख्याल से 13 point something, that is the right answer for this. Okay, 13 point is the right answer for this. विश्वनाथ का आंसर ठीक है, बाकी ऑल्सो दे कैन मैच. ठीक है, थोड़ा सा लेंदी है, डोंट वरी अबाउट ऑल दोस थिंग्स. तो इस तरह के क्वेश्चन असाइनमेंट में थे, दैट्स व्हाई आई पिक्ड, एंड दैट इज इंपॉर्टेंट फॉर अस आल्सो, बिकॉज़ फ्रॉम दिस we are getting the idea about Wien's displacement law, we are getting the idea how to calculate wavelength corresponding to a particular temperature, and we are getting idea how to use that Planck's law. And what is Planck's law? So multiple concept guys, actually we are realizing, that's why we are discussing these type of problems. चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं. कंसीडर ए ब्लैक स्फेरिकल बॉल. अभी ब्लैक बोल दिया, एक बॉल बोल रहा है, एक बॉल है ब्लैक स्फेरिकल बॉल. इट मींस एमिसिविटी कितना है इसका 1 है, एब्जॉर्टिविटी कितना है 1 है. ओके, इसका डायमीटर कितना है बच्चों? इसका जो डायमीटर है फॉर दिस बॉल, द डायमीटर इज 30 सेंटीमीटर. द डायमीटर इज 30 सेंटीमीटर. इट इज सस्पेंडेड इन ए रूम. इसको आपने सस्पेंड कर दिया है कहीं पे, कहीं रूम में लटका दिया आपने इसको रूम में. ओके, इट इज सस्पेंडेड इन ए रूम. द सरफेस टेम्परेचर ऑफ द बॉल शुड बी मेंटेन्ड इन ऑर्डर. आपसे पूछ रहा है सरफेस टेम्परेचर कितना रखें. व्हाट सरफेस टेम्परेचर यू नीड टू मेंटेन? What surface temperature of this bowl you need to maintain if you want to heat 10 kg of air, 10 kg of air from 20 to 30 degrees Celsius in a duration of 5 minutes. 5 मिनट की ड्यूरेशन में आपको एयर को हीट करना है from 20 to 30 degrees Celsius, 10 kg एयर को. So what surface temperature you need to maintain? तो बड़ा अच्छा क्वेश्चन है, डिफरेंट वे में पूछ रहा है. देखो कितना हीट आपको देना पड़ेगा, हाउ मच हीट यू नीड टू सप्लाई, कितना हीट लॉस करना पड़ेगा आपको, इस बॉल से कितना हीट लॉस करना पड़ेगा. दैट इज इक्वल टू इंक्रीज इन एनर्जी ऑफ द एयर. कितना एयर है बच्चों? 10 kg है, 10 kg. सीपी कितना होता है एयर का? दैट इज 1008. सीपी एयर फॉर एयर एट कांस्टेंट प्रेशर स्पेसिफिक इट इज 1.005. चलो 1.005 ले लेते हैं. इट इज 1.005. सो 1005 जूल पर केजी केल्विन. दिस इज मास ऑफ द एयर, दिस इज सीपी ऑफ द एयर. हाउ मच टेंपरेचर चेंज वी वांट? दिस इज द टेंपरेचर चेंज वी वांट. ओके, सो दिस इज क्यू लॉस्ट. इतना आपको क्यू लॉस्ट करना है बॉल से, इतना क्यू लॉस्ट आपको करना है. सो दिस इज इनडायरेक्टली इज गिविंग यू दिस आंसर. और आपको सरफेस टेम्परेचर कितना रखना पड़ेगा बच्चों? सरफेस टेम्परेचर कितना रखना पड़ेगा? ओके, So then how much heat is coming out from this? कितना heat यहाँ से आएगा? It is a black body. ये क्या है? Black body है बच्चों. This is a kind of black body. Okay. And he is not actually in this question. He has not considered the radiation from the air. Air से radiation इसने consider नहीं किया. So he is not writing Q net 1 to 2. He's not writing Q net 1 to 2. He is considering there is no back radiation from the air. He's only considering the radiation from this ball only. Okay. And which is nothing but sigma EB की power 4. Sigma EB की power 4. Why? Because this is a black surface. ये क्या है? Black surface है. So 5.67 into 10 की power minus 8 into EB is what? This is yes. This is sigma into EB की power 4. So मैं इसको लिख देता हूं यहाँ पे EB hemispherical emissive power. So EB hemispherical emissive power is equal to sigma T की power 4. Okay. Hemispherical emissive power EB for a black body is equal to sigma T की power 4. Why? Because for a black body emissivity equal to 1. So 5.67 into 10 की power minus 8 into surface temperature of the ball की power 4, which is equal to, which you can equate with what? 10 into 1005 into 10. Comparing this easily, you will get the surface temperature of the ball. Okay. So what you need to mention it here, not considering radiation, not considering radiation from the air. Radiation from air. Okay. Because अगर आप radiation से भी air से भी radiation consider करोगे, then you need to write it here Q net between 1 and 2. Ball को आप 1 मान लो, this is 1, air is your 2, then there will be Q net between 1 and 2. Okay, and it's a kind of small body in large enclosure, then you will have sigma into T1 की power 4 minus temperature T2 की power 4, then there will be ये तो watt per meter square है. Okay, this is in watt per meter square, तो इसको multiply कर दो area से भी. You need to multiply here area also. Okay, this is area of the ball. Okay, area से भी आपको multiply करना पड़ेगा बच्चों, because from this is in what? This is in watt, this is in joule. ये joule में है, इसको भी watt बना लो. You need to multiply it with 5 into 60. Okay, इतना heat अपने को divide करना पड़ेगा. You need to divide it by 5 into 60. Because this is in what? This is in joule. ये किसमें आपका joule में है. हमें इसको बनाना है watt में. 5 मिनट में air को heat करना है. So you need to divide it by 5 into 60. So this is the amount of heat required in joule. This is in joule. Okay. Watt में कितना करना पड़ेगा? कितना watt पे heating करना पड़ेगा? So this amount of heat you need to transfer in 5 minutes. अपने को इतना heat transfer करना है 5 मिनट में. Okay. So divide करना पड़ेगा आपको. So that you will get this in what? Joule per second. ये किसमें आ जाए आपका? Joule per second में means this you will get in watts. So you need to divide it by 5 minutes. 5 into 60. And here you need to multiply by the area, so that watt per meter square multiply by the surface area of the ball in meter, you will get this in watt, because then only you will be able to balance the units and you will get the answer. So area of the ball you need to write. And what is the area of the ball, guys? The surface area of the ball is nothing but 4 pi r square. Okay, ये इसको आप क्या लिख सकते हो? R is d by 2. Okay, so it will be pi d square. Okay, R is d by 2. D by 2 हो जाएगा. So d square divided by 2 square, it will be 4. So pi d square is your surface area. Pi d square is surface area. Diameter is given to you 30 centimeter, but you need to use the SI unit. SI unit use करोगे, surface area you will get in meter square. This is your hemispherical emissive power. Sigma into T की power 4. Okay, this is T की power 4, surface temperature की power 4. Then easily you will get surface temperature. Surface temperature आपका यहाँ से आ जाएगा. Can you tell me, guys, what answer you are getting? What answer you are getting? Because why actually I have written that we are neglecting the heat transfer between air and that. 380 is the right answer, guys, because they mentioned 380 to 379 to 381. They mentioned 379 to 381 as the right answer. So if you are getting exactly 380, it is very right. It is mid. Okay. So this is the answer, guys, for this question. 370 to 381. 370 to 381. This is the right answer. Okay. When I actually initially calculated, मैंने इसको initially कैसे calculate किया? I consider the net radiation heat exchange, और net के लिए अपने को क्या लिखना पड़ेगा? Q net between 1 and 2, that is equal to sigma temperature surface की power 4 minus temperature air की power 4. Okay, temperature of air या room air में जो है room air की power 4 into emissivity, which is equal to 1. ये तो 1 हो जाएगा into area. Okay, this formula I am writing for small body in large enclosure. Small body in large enclosure, small body in large enclosure. Okay, because every body, like whether it is gas, it is liquid, or it is solid, all are going to radiate. Okay, ठीक है बच्चों? Yes. Actually air temperature is also changing. Air temperature भी आप change करो, there is no such fixed temperature. तो इसलिए ये case लेना is not compatible, right? That's why I'm considering this. We are considering neglecting the radiation heat exchange from the air. That's why in place of Q1 and 2, I'm only writing Q1. How much is the radiation emitted by body? Black body, that is sigma T की power 4. Okay, and exact answer we are getting from that. ठीक है बच्चों? Is that clear? Why actually we are not writing the heat transfer 1 and 2? We are only writing heat transfer from 1. ठीक है? Okay. चलिए. Let us move to next question, guys. 75. There is a newly built microfluid optical sensor for droplet sorting responded differently to light source. Okay, with different spectral distribution during the device characterization protocol, assuming the source of daylight as a black body at the effective surface temperature of 5800 Kelvin, calculated the fraction of radiation emitted within the visible spectral range of this. This is a slightly different question, and when you need to know the process. देखो आपको पता है बच्चों, the plot which we are having for the EB lambda versus lambda plot. Okay, suppose for a black body you are having a plot something like this. Okay, this is EB maximum, this is for a particular wavelength lambda max. Okay, this is EB max, EB lambda max. Corresponding to that you will have some lambda max also, lambda m max. Okay, so guys, this entire area in this, under this curve, this is going to give us the total hemispherical emissive power, EB. Total hemispherical emissive power of a body is nothing but integration 0 to infinity EB lambda d lambda. The total area under this curve from 0 to infinity, that gives us the total hemispherical emissive power. This is total hemispherical emissive power. This is spectral emissive power. What do you mean by spectral emissive power, guys? Hemispherical emissive power at a particular wavelength, corresponding to particular wavelength. How much radiation a body is emitting, that is spectral emissive power, or also known as monochromatic emissive power. At a particular wavelength, how much is the radiation emitted? Okay, because a body is not going to emit radiations of a single wavelength. There will be different radiation ranges emitted by a body. Okay, so in that case he is asking you, in this range how much is the fraction of the energy emitted, कितना fraction आप emit करोगे. ओके तो बच्चों एक यहां से अगर मैं आपसे पूछूं व्हाट इज ईबी टोटल, टोटल कितना हो जाएगा, व्हाट इज ईबी टोटल, टोटल हेमिस्फेरिकल एमिसिव पावर. टोटल हेमिस्फेरिकल एमिसिव पावर इज नथिंग बट सिग्मा टी की पावर 4. What is sigma? Sigma is 5.67 into 10 की power minus 8 into the temperature of the body, temperature of this body which is 5800. So this is total hemispherical emissive power. Okay, this is total hemispherical emissive power. इसको solve करोगे it will come out 64.164 into 10 की power 6 वोट पर मीटर स्क्वायर. ओके, अब देखो इसमें आपको करना क्या था, वो आपको ऐसे एक चार्ट देगा. ही इज गोइंग टू गिव यू ए टेबल. अगर ऐसा क्वेश्चन पूछता है गेट में, पूछ सकता है बच्चों, देयर आर चांसेस. ओके, इन गेट ही कैन गिव यू सम डेटा something like this. This is product of lambda t, the product of lambda into t. He is going to give you some data for the product of lambda into t. So for lambda t, suppose 2322. Okay, this is lambda t 4408. Okay, ये कहां से आया बच्चों, ये कहां से आ रहा है, दिस इज सपोज सीरियल नंबर 1 एंड सीरियल नंबर 2. This is 1, this is 2. From where we are getting, guys? He is asking you how much is the fraction of radiation emitted in this range. इस range में कितना fraction of radiation the body is emitting. So this is lambda 1, this is lambda 2. The temperature is same. Temperature कितना है? 5800. Okay. This is also 5800. Okay. So in this range, if you will calculate the product of lambda 1t, okay, in this range also if you will calculate the product of lambda mt, okay. अभी हम एक ही बॉडी की बात कर रहे हैं बच्चों, वी आर टॉकिंग अबाउट सेम बॉडी की हम बात कर रहे हैं, तो टेम्परेचर इज सेम बट इट इज एमिटिंग रेडिएशन ऑफ डिफरेंट वेवलेंथ. You can say कि सर these products are same. These products are same when you are changing the temperature of a body at a particular temperature पे the wavelength is going to change. The wavelength, the body will emit radiations of different wavelength. तो उसने कुछ radiations emit की, suppose 0.4 micrometer की. Some radiations are emitted in the range of what, 0.6 micrometer. The radiations which we are getting from the sun, those are not of single wavelength. They are of different wavelength. Some lies in the UV region, some lies in the visible region. Okay, some lies in different regions also. So those radiations are of different wavelength. Are you getting? So EB lambda, this plot we are having, and different wavelength a body is emitting. Okay, the bodies are emitting of energies of different wavelength. Okay, that's why the entire area under this curve is EB. Okay, so I think you are not actually confused in this. Why actually I'm writing this product lambda t. Okay, this is for a same body at a fixed temperature, single temperature. We are not changing the temperature, but if you will change the temperature, that is lambda max. There is a difference between this lambda and that lambda max. What is that? The product of lambda max. The product of lambda max into T is constant. That is constant. What is lambda max, guys? Abhi lambda max kya hoga? Lambda max is the wavelength corresponding to maximum spectral emission power. That idea you need to have. Wavelength corresponding to maximum spectral emission power, that is lambda max into T, that is constant. So these are not lambda max. Okay, चलिए, I hope this is very clear. So यहाँ से अगर आप इसको निकालोगे, it will come out this product. इन दोनों का जो product आएगा, it will come out 2320, और इन दोनों का जो product आएगा, it will come out 4408. Okay, this is this product you are going to get. Okay, guys, the product here lambda T is this. The product here is this. What I mentioned, Akash, the Planck's law, which we are having, the product of lambda into T, that is constant. The lambda is not any ordinary wavelength. That is a wavelength corresponding to maximum spectral emissive power. So wavelength corresponding to maximum spectral emissive power into temperature, that is constant, and that is equal to 2898 micrometer Kelvin. But a body is going to emit radiations of different wavelength. Body तो क्या करेगी? अलग-अलग radiations की क्या करेगी? अलग-अलग wavelength का radiations क्या करेगी? Emit करेगी. So for that, I am calculating the product of lambda into T. So for particular wavelength, this wavelength 0.4, I think this is 0.4 micrometer. इसको convert कर लेना. This is micrometer only. This is 0.4 micrometer. This is 0.6 micrometer. Because 0.4 mm तो आपको range में नहीं मिलेगा. Okay. So please correct this. These are in mm. Micrometer. This is micrometer. This is also micrometer. Okay. So this you are going to get this 2328 micrometer Kelvin. This is micrometer Kelvin, and this is also micrometer Kelvin. Okay. So then he is going to provide you some data, something like this. The product of lambda mt and here. Okay. तो आप चाहो तो इसको यहां पे भी लिख सकते हो. आप इसको यहां से हटा देता हूं मैं. Okay. चलिए. Lambda t. Okay, this is product of lambda t. These are serial number 1 and 2. 1, 2. Lambda t, product of lambda t. For this case, he is going to give you fraction of the radiation from 0 to lambda 1. Okay, fraction of the radiation from 0 to lambda 1. Something like this. Fraction of the radiation from 0 to lambda. He is going to give you something like this. Fraction of the radiation from 0 to lambda. Okay. So from this, if you refer to your data book, if you refer to your book, any standard textbook, if you refer, you will find for a product of 2320, this fraction of the radiation emitted from 0 to 4. How I can say 0 to 4? Why? Because this first wavelength I have taken what? First wavelength I have taken 4 micrometer. So from 0 to 4 micrometer, for the body which is having lambda t 2320, from the directly value table, from table you are going to get that value, which is equal to 0.54877. Okay, 0.54877. These are the fraction of radiation emitted by the body from 0 to 4 micrometer, guys. Something like this. Suppose this is 0, this is 0, and suppose this is 4 micrometer. Okay, and this area is saying, this area is nothing but, suppose for example, this is 54% of the total area. So that idea is giving you, that data is going to provide you. If like some changes he will the examiner will make in those GATE question, there are chances for asking those type of question, because these are there in their NPTEL assignments. Okay, so what idea you need to have, guys? From 0 to 4 micrometer, what is the area, what fraction of area is covered, that area is going to give you. Okay, so fraction of the radiation emitted from 0 to lambda means 0 to 4 micrometer is this. Okay, similarly the fraction of radiation from 0 to what is that another value, 0 to 7, 0 to 0.76, 0 to 0.76 micrometer. Okay, this is 0 to 4 micrometer, this is 0 to 476 micrometer, and this fraction is nothing but, okay, ये fraction कितना है बच्चों? Okay, this fraction he is giving you, yes, from 0 to 4, let me correct this, from 0 to 4 this is not 0.54, this is 0.12002. Okay, from 0 to 4 this is this value, and from 0 to 76 the value, because wave reason is increasing, so this is 0.54877. Are you getting the idea, guys? Okay, from 0 to 4 micrometer, this area is what, only 12% of the entire area. This is only 12%. From 0 to 7 micrometer, the area, suppose this is 7 micrometer, for example, this is suppose 7 micrometer, 7 point something, कितना था हमारा 7.6, okay, 0.76 वो कितना था 4 था, अच्छा वो 4 ज्यादा है ना, हाँ ये वो 0.4 है, so this is 0.4, this is 0.4, this is 0.76 micrometer. Okay, and this area is what, this area is 54. For the total area, this area is covering 54, so these values here he is going to provide you. So you need to aware what is mean by this F04. So F0 lambda, it means fraction of the radiation, fraction of radiation emitted from 0 to lambda wavelength, from 0 to lambda wavelength, fraction of radiation emitted from 0 to lambda wavelength. Is that clear, guys? Now he is asking you the hemispherical emissive power in this range. तो आपको क्या करना पड़ेगा बच्चों? EB lambda in the range of 0.4 to 0.76. तो इसके बीच का कितना एरिया बच्चों? What is the area? What fraction of the radiation are emitted between this and this? इसके बीच में कितना radiation emit किया है बच्चों? From 0 to 7, you are emitting this fraction 0.54877. From 0 to 4.4, this is 0 to 0.4, not 4, because 4 तो कम हो जाएगा. This is 0 to 0.4. From 0 to 0.4 micrometer, the area covered is only 12%, 0.12002. Okay, from 0 to 7, this is the area. What is their difference, guys? दोनों का difference क्या होगा? The radiation, the fraction of radiation emitted between 0.4 to 0.76. You got the idea, guys? So this table, if it is given to you, then easily you can answer कि the fraction of radiation emitted between this and this. So this is fraction only. This is fraction. But इसका आंसर क्या आ जाएगा? This you need to multiply by EB. इसको किससे multiply करना पड़ेगा आपको? EB से. So EB is the total radiation, guys. EB is the total radiation emitted from 0 to lambda, 0 to infinite. From 0 to infinite, the total radiations emitted are EB. And the fraction of radiation emitted in the range 0.4 to 0.6 is this. तो दोनों का डिफरेंस लोगे, इससे मल्टीप्लाई करोगे, you will get the answer. ओके, बट इस केस में तो उसने आपसे सिर्फ ऑप्शन पूछा है, उसने पूछा कितना परसेंट. अगर आपको ये पूछता तो ये आंसर आपका यहां से आएगा. EB को क्या लिखोगे? EB is sigma T की power 4. So I discussed both the cases. So he can ask you EB lambda in some domain range. He can ask you EB lambda in some domain range, but here he is only asking you the percentage. तो percentage क्या आ जाएगा बच्चों? Percentage will be only difference. इन दोनों का अगर आप difference लोगे, that difference will come out 0.42875. Okay. So what percent of the radiation emitted in this range, guys? इस रेंज में कितना परसेंट रेडिएशन आप एमिट कर रहे हो? The body is emitting only 42% of the radiation. Close to 42.875% are emitted in this range. Okay. तो इस रेंज के बीच का जो एरिया बच्चों, this area, the area between this 0.4, suppose this is 0.4, this is 0.4, 0.4, this is 0.7, and this entire area, guys, this entire area, green color area, this is 42% of the entire area. You got the answer, guys? 42% of the entire total area is 100%. The total area is 100%. So the fraction of the radiation emitted by these body in the domain range, in the range of this 0.4 micrometer to 0.76 micrometer, the answer is 42%. Okay, is that clear, guys? So they answered for this question, the answer is in the range of 42.4 to 42.8. if you are getting in this range, your answer is right. ठीक है बच्चों? तो मैंने इसको डेटा बुक से सोल्व किया एंड दे आर ऑल्सो गोइंग टू प्रोवाइड यू दिस डेटा. ठीक है, आई होप दिस यूनिक डिफरेंट कंसेप्ट इज क्लियर टू यू. ओके, क्लियर है बच्चों? ये कुछ नया था एंड आई होप दिस इज क्लियर टू यू नाउ. ठीक है, चलिए लेट अस मूव टू नेक्स्ट क्वेश्चन. कुछ एक दो क्वेश्चन हैं ऐसे तो हमें वो डिस्कस करने पड़ेंगे. सो यू कैन रेफर, आपको अगर आपके पास कोई बुक है, लाइक इफ यू आर हैविंग एनी स्टैंडर्ड बुक, जेपी होलमैन है या कोई भी और अच्छा बुक है आपके पास, you can go to the radiation chapter, you will find some data, और जो values मैंने put की है, all those values you are going to get. ठीक है? So next question he is asking you, there are concentric cylinders, something like this. There are concentric cylinders. Okay, दो cylinders हैं. Okay, there are two concentric cylinders having diameter d1 and d2. d1 d2, इसका मान लेते हैं डायमीटर है d1, बाहर वाले का मान लेते हैं चलो d2 है. ओके, दिस इज d2. Consider the long cylindric concentric cylinder with diameter d1 and d2, surface area a1 and a2. surface area कितना है? a1 and a2. surface areas are a1 and a2. express the view factor f22. f22 आपसे पूछ रहा है. means suppose this is 1, जो अंदर वाला है इसको मैं लिख रहा हूं 1, this is 1, बिकॉज अगर मैं इसको 2 लिखूंगा, अगर मैं इसको 2 लिखूंगा अंदर वाले को, तो 0 हो जाएगा. देयर इज नो ऑप्शन विद 0. ओके, सो दिस इज नॉट 2, दिस इज 1, एंड जो बाहर वाला है दिस इज इंसुलेटेड फ्रॉम आउटसाइड, सो दैट इज दिस इज 2. ओके, दिस इज 2 एंड ही इज आस्किंग यू f22. आपसे क्या पूछ रहा है? f22, द फ्रैक्शन ऑफ द रेडिएशन एमिटेड बाय द आउटर सिलेंडर व्हिच आर रीचिंग टू दैट सेम आउटर सिलेंडर. ओके, तो बहुत आसान क्वेश्चन होता है बच्चों, इस तरह का गेट में ही पूछा जाता है, because you know inner cylinder hai, so f11 will be 0. Why? Because the radiations which are emitted by these, they are not going to reach to that surface directly, so f11 is a 0. This is actually a convex surface. kaisa surface hai? Convex surface. For any convex surface or flat surface, self shape factor is 0. This is known as self shape factor. This will be 0 for any flat surface or convex surface. So if it is 0, you know f11 plus f12, this is equal to 1. It means we can conclude, if it is 0, we can say f12 equal to 1. All the radiation which are emitted by these, they are going to reach to the second surface. And second thing, we are having the reciprocity relationship a1 f12, that is equal to a2 f21. Okay, so from this a2 f21, okay, from this you will get answer for f21. f21 aa jayega, so f2 will come out a1 by a2. Why? Because f12 is 1. This is equal to a1 by a2. Why? Because this f1 by f12 is 1. Okay, so f21 you will get, guys, f21 आपका आ जाएगा f21 equal to a1. a1 is nothing but pi d1l, a2 is nothing but pi d2l. So pi will cancel out, length are same because both are infinite, so f21 is d1 by d2. And now you want to calculate f22, so f21 plus f22, summation rule for the second body, f21 plus f22, that is equal to 1. So f22 equal to 1 minus f21, which is equal to 1 minus d1 by d2. Okay, sorry, 1 minus d2 by d1 by d2. So which one is matching, guys? कौन सा मैच कर रहा है? f22 equal to 1 minus d1 by d2. C is the right answer, guys, for this question. Question number 76. C is the right answer. ठीक है बच्चों, चलिए नेक्स्ट आपसे टिपिकल केस पूछ रहा है जो गेट में भी बहुत बार पूछा गया है. ओके, सो देयर आर टू plane walls. Okay, there are two enclosures, large plane parallel to each other. Large plates हैं, two large parallel opaque plates. The plates are gray and capped at uniform temperature. तो मान लेते हैं this is plate 1 at a temperature T1, this is plate 2 at a temperature T2. T2 दिया है आपको कितना? दिया है कुछ टेम्परेचर, T1 is 800 Kelvin, T2 is 600 Kelvin. T1 is 800, T2 is 600 Kelvin. Both are kind of gray bodies. Epsilon 1 equal to 0.2, epsilon 2 equal to 0.8. Both are having same emissivities. Sigma दिया है, आपको पूछ रहा है what is the net radiation heat exchange between 1 and 2. This is 1, this is 2. आपसे पूछ रहा है net radiation heat exchange, because heat exchange will be there. From this to this also there will be heat radiation. From this to this there will be heat radiation. He is asking you Q net between 1 and 2. दोनों के बीच में नेट बताओ, यहां से कितना रेडिएशन जाएगा बच्चों, दैट इज सिग्मा ईबी, इसका ईबी जितना है सिग्मा टी की पावर 4, यहां से कितना जाएगा सिग्मा टी2 की पावर 4, यहां से जाएगा सिग्मा टी1 की पावर 4, यहां से जाएगा सिग्मा टी2 की पावर 4, बट दोनों में नेट कितना होगा, व्हाट इज नेट रेडिएशन हीट एक्सचेंज बिटवीन 1 and 2. नेट रेडिएशन हीट एक्सचेंज बिटवीन 1 and 2, बिल्कुल सही है बच्चों, डायरेक्ट फार्मूला यू कैन यूज, दिस इज सिग्मा T1 की पावर 4 माइनस T2 की पावर 4 डिवाइड बाय 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This is the formula, direct formula you need to use for this case. Okay, यहाँ पे तो थोड़ा सा और simplification है, because both are at same, both are having same emissivities. So sigma 5.67 into 10 की power minus 8 into 800 की power 4 minus 600 की power 4 divided by 2 by emissivities are same, 2 by 0.8 minus 1. Solving this you will get your answer, and yes, those are getting C. They are very right. Option C is the right answer for this question, because answer will come out approximate बोला उसने, option close to the answer. Choose the option close to the answer. Exactly you are going to get Q net. Q net जो आपका आएगा 1 and 2, it will come out 10,584 watt per meter square. Okay, 10,584 watt per meter square. So C क्या हो जाएगा बच्चों? C is the right answer for this question. चलिए next question move करते हैं. Consider two black bodies with surface area S1 and S2 exchanging heat only by radiation. 50% of the energy emitted by S1 is received by S2. The fraction of energy emitted by S2 that is received by S1. तो क्वेश्चन वही है बट अलग तरह से पूछा गया क्वेश्चन. Okay, the question is similar based on the shear factor only but asked in different way. So can you answer this question guys? अभी एक बच्चे ने आंसर भी कर दिया है, point one sir B. चलिए others also guys please try to answer. बिल्कुल सही है विपुल. Okay, so what is saying, indirectly saying कि 50% उस पे पहुंच जाता है 1 से 2, तो कह रहा है राइट F12 इक्वल टू 0.5. अरे भाई 1 से जितना निकल रहा है 50% 2 पे पहुंच रहा है. The radiation which are leaving from 1, 50% of that is reaching to 2, means F12 is 50, F12 is 0.5, फ्रैक्शन में लिख सकते हैं. आपसे पूछ रहा है F21, F2 तो बड़ा इजी है, क्या क्या करोगे, यू विल अप्लाई द रेसिप्रोसिटी रूल, A1 F12 equal to A2 F21, so F21 equal to A1 by A2 into F12. A1 कितना है बच्चों, A1 is 1, A2 is 5 into 0.5, तो कितना हो जाएगा, it will be 0.1. So those are saying B, they are very right. B is the right answer for this question. B क्या है, बिल्कुल सही क्या है, इसका आंसर है. ठीक है, चलिए let us move to next question 79. Determine the view factor F31 for the following geometry. From the base area a circular cylinder, एक circular cylinder है बच्चों, something like this. There is a circular cylinder. Okay, there is a circular cylinder something like this. बोल रहा है कि determine the view factor F31. base को बोल रहा है 1 है, base is 1, जिसका रेडियस है r, सर्कुलर रेडियस इज r, हाइट l, हाइट है इसका l, height is L, the radius is R, and R is equal to L. R क्या है, equal to L. तो चलो थोड़ा छोटा कर देते हैं इसको, so that it will look like सही है ना. चलिए, so it is something like this. Okay, so this is L and this is R. Now they are looking comparable. So R is equal to L. He has given you R equal to L. ठीक है, R is equal to L. Next, what is saying कि top surface is 2, top surface क्या है 2 है, and the cylindrical surface is 3. Cylindrical surface is 3 and given is F12 is 1. f12 equal to 0.4, and now he is asking you f31. आपसे पूछ रहा है f31. Can you calculate guys? Can you calculate f31? अभिनव ने सबसे पहले आंसर किया है बच्चों, बाकी ट्राई करो एंड लेट मी चेक कि दिस इज राइट और रॉन्ग. 0.3. अभिनव इज सेइंग सर 0.3. देखो 0.3 अभी आप सोल्व करो. लेट मी सोल्व दिस फर्स्ट. f11 plus f12 plus f13 equal to 1. Yes or no? So f11 is a flat surface, so this is 0. f12 is given to you, which is 4. So can I say f13 equal to 0.6? Yes or no? f13 equal to 1 minus f12. So f12 is given to you 0.4. So we can conclude f13 equal to 0.6. Okay. Now you want f31. तो कुछ नहीं, 1 और 3 के बीच में रेसिप्रोसिटी लगा दो बच्चों. We got the answer for f13 and we want f31. So you can apply the reciprocity rule between 1 and 3. So a1 f13 equal to a3 f31. Okay. So f31 equal to a1 by a3 into f13. Yes or no? Okay. So f31 equal to, what is a1 guys? a1 is pi r square. a1 is pi r square. Okay. What is a3? a3 क्या हो जाएगा? It is 2 pi r into l, and l is equal to r only, so it will become 2 pi r square because r is equal to l. Okay. R is equal to l, so 2 pi r into l. 2 pi r is the perimeter. 2 pi r into l, that is the area, surface area of the body 3. So the area will become 2 pi r square. So pi r square, it will cancel out. And here you are having f13, which is equal to 0.6. So 0.6 divided by 2, you will have 0.3 as the right answer. So option C क्या हो जाएगा बच्चों? This is the answer for this question. बहुत अच्छा क्वेश्चन है. Many times these type of similar question asked in GATE. Very good, Sanjay, Akash, Roshan, Gurpreet, good. गुड टू ऑब्जर्व गाइस, लोट्स ऑफ स्टूडेंट दे आर आंसरिंग. अभिनव ने सबसे पहले आंसर किया, विपुल ने फिर किया, एंड संजय, अक्षय, रोशन, गुरुप्रताप, साइकत इज आल्सो आंसरिंग. गुरप्रीत आपका आंसर गलत हो जाएगा बच्चे. 0.4 इज रॉन्ग. आई डोंट नो वेयर यू आर मेकिंग द मिस्टेक. आपने क्या इसी को आंसर कर दिया है क्या? इसी को आंसर कर दोगे क्या? गलत है बच्चे. प्लीज चेक योर कैलकुलेशन पार्ट. 0.3 कोना भी आ गया अभी हमारे बीच में. कोना इज आल्सो सेइंग. कोना आपका नाम याद हो गया मेरे को, है ना? आशी रेड्डी कोना. वेरी गुड कोना, कीप इट अप. चलिए, so let's move to next question guys. 80 and 81, these are the common data question we are having. 80, 81 common data question we are having. Okay, so there is a kind of, he is saying there is a opaque horizontal plate. कोई opaque horizontal plate है, insulated from the back side. Okay, बैक साइड से आपने इसको इंसुलेट कर दिया है, मतलब ट्रांसमिसिविटी नहीं होगी इससे. ट्रांसमिसिविटी जीरो, काइंड ऑफ ओपेक सरफेस आल्सो ही हैज मेंशन्ड. इसके ऊपर जो रेडिएशन पड़ रहा है वो कितना है? 2500 वाट पर मीटर स्क्वायर. ये वाट पर मीटर स्क्वायर कर लेना बच्चों. दिस इज वाट पर मीटर स्क्वायर. ओके, 2500 watt per meter square. These are the radiation falling on this. 2500 watt per meter square. So these are actually what? These are irradiation. इसे हम क्या बोलते हैं? Irradiation. लिखा भी है उसने, these are irradiation. The total radiation falling on a surface, those are known as irradiation. The total radiation falling on a surface, those are known as irradiation. So irradiation is given to us 2500 watt per meter square. Okay, the plate is at temperature. प्लेट किस टेम्परेचर पे बच्चों? द प्लेट इज एट ए टेम्परेचर 227 डिग्री सेल्सियस, व्हिच इज नथिंग बट 273 ऐड करोगे इट इज 500 केल्विन. द प्लेट इज एट 500 केल्विन. ओके, द प्लेट इज एट 500 केल्विन. ही इज सेइंग द एमिसिव पावर इज दिस. इसका जो एमिसिव पावर है, कितना एमिसिव पावर है इसका? E is 1200 watt per meter square. This is irradiation. This is emissive power. Emissive power is 1200 watt per meter square Kelvin. These are the irradiation, and he is asking you the total hemispherical emissivity. आपसे पूछ रहा है emissivity. He is asking you the emissivity. Can you answer this question, guys? अच्छा क्वेश्चन है. गेट में इस तरह के पूछ सकते हैं. There are very good chances of asking those type of question. He is asking you the emissivity. Yes. Can you answer this question, guys? What is the emissivity? In first part he is asking emissivity. तो दो क्वेश्चन है बच्चों, दो क्वेश्चन है कॉमन डेटा. फर्स्ट पार्ट ही इज आस्किंग emissivity. इन सेकंड पार्ट ही इज आस्किंग यू एब्जॉर्टिविटी. सेकंड पार्ट में आपसे पूछ रहा है एब्जॉर्टिविटी. फर्स्ट पार्ट ही इज आस्किंग यू emissivity. इन सेकंड पार्ट ही इज आस्किंग यू एब्जॉर्टिविटी. You need to answer both. 80, 81, these are the common data question. Okay guys, so please start answering. I'm waiting for your response. 81 पे आ गए बच्चों. नाउ इजिली आई फील यस, जल्दी हम इसको खत्म कर पाएंगे, है ना? एंड यस, वेरी गुड गाइस. आपका जो रिस्पॉन्स है, आप टिके हुए हैं यहाँ पे, इट्स वेरी गुड. ओके, यू आर वेरी मच सीरियस. एंड यस, वी आर डिस्कसिंग मोर एंड मोर इंपॉर्टेंट क्वेश्चन. सम मोर क्वेश्चन, यस डेफिनेटली यू विल फाइंड ब्यूटीफुल. अभी कुछ और क्वेश्चन आने वाले हैं बच्चों रेडिएशन के, विच आर रियली वेरी वेरी ब्यूटीफुल. So try to answer. So guys, he's asking you emissivity. You know EB, hemispherical emissive power for a black body is what? Sigma T ki power 4. Can you calculate EB, hemispherical emissive power of a body, black body? So sigma is 5.67 into temperature is 500 की power 4. So this is EB. EB यहाँ से आ जाएगा. EB you will get it from here. So emissivity is nothing but hemispherical emissive power of a body in comparison to hemispherical emissive power of a black body at the same temperature. What is the hemispherical emissive power of a body in comparison to hemispherical emissive power of a black body at the same temperature? So this is given to us 1200 and this we calculated. इसको 10 की power minus 8 भी तो करना पड़ेगा ना. This is into 10 की power minus 8. Okay, so 5.67 into 10 की power minus 8 into 500 की power 4. Solving this, you will get the emissivity. So emissivity of a body in comparison to emissivity of a black body. Hemispherical emissive power, sorry, hemispherical emissive power of a body in comparison to the hemispherical emissive power of a black body at the same temperature, that is known as emissivity. कितना emission एक body emit कर रहा है in comparison to black body, that is known as emissivity. कितना आ जाएगा? It will come out to 0.3386, तो which is very close to 0.34. तो इसके जो आंसर है ऑप्शन A is the right answer. Okay, option A is the right answer for this question. Can you answer next question also guys? Absorptivity. क्या absorptivity भी बता सकते हो इसके लिए? What is absorptivity? आपको कोई सर यहाँ तो कोई 0.34, तो there is no such option. So how to calculate? What is absorptivity? Guys, generally we assume in equilibrium, Kirchhoff's law tells us the body is in thermal equilibrium, absorptivity equal to emissivity. A good absorber is also a good emitter of radiations and heat. Okay, but it doesn't mean कि a body is having same absorptivity and emissivity. They are different because in real case a body is not going to be in equilibrium. तो absorptivity कहाँ से निकालोगे बच्चों? Absorptivity के लिए आपको एक relation यहाँ पे लगाना पड़ेगा. What is that relationship? Relationship क्या है? देखो, you know the irradiations are 2500 watt per meter square. The hemispherical emissive power is 1200 watt per meter square. तो एक रिलेशनशिप क्या होता है? रेडियोसिटी का J, टोटल अमाउंट ऑफ रेडिएशन एमिटेड बाय सरफेस, टोटल अमाउंट ऑफ रेडिएशन एमिटेड बाय सरफेस. तो क्या होगा? देखो, पार्ट तो ये है, अभी इसका ट्रांसमिसिविटी 0 बट इट इज हैविंग सम रिफ्लेक्टिविटी ना, तो कुछ ना कुछ ये रिफ्लेक्ट भी तो करेगा. व्हाट इज दैट? That is reflected radiation, QR, reflected radiation. And can I write this QR equal to rho times G? जो कितना रेडिएशन रिफ्लेक्ट करेगा, हाउ मच रेडिएशन ए बॉडी इज गोइंग टू रिफ्लेक्ट, दैट इज इक्वल टू प्रोडक्ट ऑफ रिफ्लेक्टिविटी इनटू जी. हाउ मच इज आर फॉलिंग? The irradiation which are falling on a surface are 2500. The reflectivity of the surface is rho. So how much radiations will be reflected? That is equal to rho into G. So radiosity is the total amount of radiation leaving from a surface, that is equal to QR plus E. Okay, QR plus G, total radiations emitted from a surface, that is known as J, radiosity. इसे बोलते हैं radiosity. ओके, रेडियोसिटी तो एफएम वाला नाम हो गया ना. चलिए, रेडियोसिटी. चलिए, सो J इक्वल टू व्हाट इज QR गाइस? QR इज नथिंग बट रो टाइम्स G प्लस E. ओके, रो टाइम्स G इनटू E. एंड यू नो गाइस, फॉर एनी सरफेस, अभी इसको हम क्या लिख सकते हैं? फॉर दैट वी कैन राइट, अभी यहां से हम क्या लिख सकते हैं बच्चों? यहां पे अपने पास आइडिया क्या आएगा? सो 2500 आर फॉलिंग. So how much are reflecting? कितना रिफ्लेक्ट हो रही है? रिफ्लेक्टिंग आर व्हाट? 1300 वाट पर मीटर स्क्वायर. Out of 2500, hemispherical emissivity is this. So these are the emission absorbed, because after absorbing only a body is going to emit those radiations. After absorbing only a body is going to emit those radiations. Absorbing के बाद ही क्या करेगा? इसको emit करेगा. Okay, these are the reflected radiations. So can I write it here? How much is the radiation absorbed by the body? कितना body absorb करेगी? The absorbed will be what? अच्छा, ये 500 था, कितना था? These are 12 or 500. Yes. Okay, 500 are reflected. These are already given to us. The reflected radiations are 500. These are given to us, guys. In the data, these are given to us. देखो ये देखोगे अगर आप the radiations, the reflected radiations are 500. 500 are reflected. 500 watt per meter square are reflected. Okay, so this is already given to us. ये already अपने को given दिया है. 500 are the reflected radiations. ओके सो एब्जॉर्ब कितना हो जाएगा बच्चों? एब्जॉर्ब कितना हो जाएगा? मैंने ये गलत लिख दिया बिकॉज दिस इज ऑलरेडी गिवन टू अस. दीज आर द रेडिएशंस फॉलोइंग, दीज आर द रिफ्लेक्टेड. ओके, दीज आर द एमिसिविटी. ये क्या है आपका एमिसिव पावर? दिस इज एमिसिव पावर. तो एब्जॉर्ब कितना हुआ? एब्जॉर्ब इज दिस 2000. कितना एब्जॉर्ब कर रहा है बॉडी? बॉडी इज एब्जॉर्बिंग 2000 आउट ऑफ टोटल 2500. 2000 वी आर एब्जॉर्बिंग. Okay, 2000 are the radiations absorbed by the body. So easily then you can write the absorptivity. Absorptivity is nothing but radiation absorbed by the radiation falling. How much are the radiation absorbed by the radiation falling? So it is nothing but 2000 divided by 2500. तो इसका आंसर हो जाएगा 0.8. ओके, 0.8 क्या हो जाएगा बच्चों? दिस इज द आंसर फॉर दिस क्वेश्चन. बट ये चीजें भी अपने समझ ली बिकॉज दीज आर गोइंग टू हेल्प. ये अपने को हेल्प करने वाली है बच्चों. ये जो रिलेशनशिप है मैं यहां लिख देता हूं. दिस रिलेशनशिप इज वेरी वेरी इंपॉर्टेंट फॉर अस. J equal to rho g plus E. Okay, so this relationship is very very important for us. J equal to 1 minus emissivity G plus E. Okay, this relationship is very very important for us. J equal to 1 minus emissivity into G plus E. Okay, चलिए तो हमने चलो इस रिलेशन को डिस्कस कर लिया बिकॉज दिस इज गोइंग टू हेल्प यू इन अदर क्वेश्चंस. Absorptivity directly you can write because he has given you reflected radiations. Reflected radiations are what? 500. Okay, so absorption radiation will be 2500 minus 500. You will have 2000. So out of 2500, 2000 you are absorbing. It means absorptivity is 0.8. Okay, चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं बच्चों. लेट्स मूव टू नेक्स्ट क्वेश्चन. This is question number 82. Consider two infinite long concentric cylinder. बोल रहा है दो infinite long concentric cylinder ले लो. The case of two infinitely long concentric cylinders, something like this. Okay, so I'm drawing something like this. These are the two infinitely long concentric cylinders. ये बाहर अंदर से insulated है. So this is body 1 and the outer is insulated from the outside. Okay, this is body 2. So in this case, because when he is mentioning consider two infinitely long cylinders, okay, assuming both the cylinders are isothermal and black at a temperature T1 and T2. अब इसके लिए कंडीशन क्या है? R2 is equal to 2R1. This is R2. Okay, suppose from the center this is R2 and R2 is equal to 2 times of R1. Okay, ये डेटा इसमें नहीं है but I am writing. Why? Because इससे पहले एक क्वेश्चन था that I skipped. Why? Because in that case in first part he asked you to find out the shape factor. For that case, guys, already we solved one problem and we obtained the expression to find out the shape factor. Okay, तो ये 1 है, ये 2 है. अभी हमने F22 निकाला था. F22 कैसे निकाला था? हमारा कितना आया था? 1 minus d1 by d2. मेरे ख्याल से यही आया था. You can check. Okay, 1 minus d2 by d1. Okay, चलिए. So it is also a similar kind of case, 1 minus d2 by d1. So that's why I'm not solving it for shape factor. So I'm giving you this data because that data was there in the first part, first question. Okay, but that I'm not considering these 100 questions. That's why I'm providing you this data. R2 equal to 2 times of R1. So internal is, this radius is R1. This is R1 and R2 is 2 times of R1. Okay. So this is Q21, net radiation heat exchange between 1 and 2. Net radiation heat exchange between 2 and 1. This is not 1 to 2, this is 2 and 1. Why? Because 2 is at high temperature, 1 is at low temperature. The T2 is 500. T2 किस पे है बच्चों? T2 is at 500 Kelvin. Okay, आपसे T1 पूछ रहा है. He is asking you the surface temperature T1. If Q12 is 200 watt per meter square. The net radiation heat exchange between 2 1, not 1 2. This is 2 1. Okay, 2 1. This is 200 watt per meter square. He is asking you the surface temperature 1. Okay, can you solve this, guys? अभी दोनों बोल रहा है ब्लैक हैं, दोनों सरफेस क्या है, ब्लैक हैं, तो इसका सरफेस रेजिस्टेंस उसका सरफेस रेजिस्टेंस दैट विल बी जीरो, देयर विल बी नो सरफेस रेजिस्टेंस। तो अगर मैं लिखूं Q21 इट विल बी सिग्मा T1 की पावर 4 माइनस T2 की पावर 4 डिवाइड बाय इसका सरफेस रेजिस्टेंस ऊपर वाले का जीरो, नीचे का सरफेस रेजिस्टेंस जीरो, देयर इज ओनली स्पेस रेजिस्टेंस। और स्पेस रेजिस्टेंस क्या होता है बच्चों, 1 बाय F21 into A2, 1 by F21 into A2, this is space resistance between 2 and 1. We are writing Q21, okay, we are writing Q21, this is space resistance between 2 and 1, okay. और ये कितना हो जाएगा बच्चों, for this case R2 equal to this, so अगर यहां से अगर आप F22 निकालते हैं, so F222 कितना हो जाएगा, it will be 1 minus D1 by D2, this is 2 times of this, ये इसका 2 times है, so it will be 0.5, so it will be 0.5, okay. F22 is 0.5, so F21 भी कितना हो जाएगा बच्चों, F21 will also be 0.2 0.5. For this case, for the case of R2 equal to 2 times of R1, F22 will become 0.5, F21 will also become 2.5. ठीक है, 50% of the radiation will reach to other surface, 50% will reach to the same surface. Okay, ये उसने आपको दिया है वॉट पर मीटर स्क्वायर में, देन एरिया डायरेक्टली यू कैन पुट 1 मीटर स्क्वायर, एरिया को क्या पुट कर सकते हो आप, 1 मीटर स्क्वायर. ओके, नाउ इफ यू यूज इट हियर, 200 equal to 5.67 into 10 की power minus 8, where temperature of 1 is 500 की power 4 minus temperature T2 की power 4 into F21 which is 0.5. 0.5 कहां चला जाएगा, it will go up. Okay, solving this easily you will get T2. इसको solve करके आपके पास T2 आ जाएगा. Can you tell me what T2 value you are getting, guys? What is the T2 value you are getting? There will be no surface resistance for 1 and 2. Why? Why there will be no surface resistance, guys? Because clearly he has mentioned those surfaces are isothermal black surfaces with temperature T1 and T2. That's why out of those three resistances, I am only writing the space resistance. Okay, I'm only writing space resistance. Is that clear, guys? What answer you are getting? What is the temperature answer you are getting? यहां पे बस ये ठीक कर लेना है, T2 है, दिस इज T2, बिकॉज यहां पे ये 1 हो जाएगा, बिकॉज दिस इज 1, हम तो 2 to 1 लिख रहे हैं ना, दिस इज 2 to 1 एंड दिस इज 2, दिस इज 1. ओके, 2 इज नोन टू अस 500, दिस इज T1, तो यहां से T1 आएगा बच्चों. फ्रॉम दिस यू आर गोइंग टू गेट T1 बिकॉज T2 इज ऑलरेडी गिवन टू अस 500 केल्विन. 485, very good guys. If you are getting answer 485 means this is the right answer for this. Option C is the right answer. Those are getting option C 485. This is very right for this question. बिल्कुल सही. 485.27, 485.25, 485.27 both are right. ठीक है बच्चों, तो ये क्वेश्चन भी था, टिपिकल गेट के लेवल का ही क्वेश्चन है. 485.27 केल्विन. चलिए, लेट अस मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 83. Consider a small cubical black walled enclosure with, there is a black walled enclosure with a side of 10 centimeter. Consider a small cubicle, cubicle है तो cubicle बनाते हैं. So there is a small cubicle enclosure है something like this, which is having side 10 centimeter, 10 centimeter, कुछ ऐसा cubicle enclosure है. There is an enclosure, cubicle enclosure something like this, which is having side 10 centimeter. Okay, 10 centimeter, 10 centimeter. The bottom surface is electrically heated to 1500 Kelvin. जो उसका bottom surface है ना बच्चों, ये जो bottom surface है, this bottom surface is electrically heated and it is maintained at 1500 Kelvin. Bottom surface is maintained at 1500 Kelvin. Bottom surface is maintained at 1500 Kelvin. Other sides walls are insulated. दूसरी जो sides हैं, these are insulated. ये जो side walls हैं, side walls are insulated, means there is no heat transfer from the side wall. Top surface is maintained at 500 Kelvin. Bottom surface तो 1500 पे है, top surface 500 Kelvin पे है. The heating requirement to the bottom surface, बोल रहा है इसको कितना heating देना पड़ेगा. How much is the heating requirement? Bottom surface को कितना heat requirement है, कितना heat supply करना पड़ेगा बच्चों. How much is the heating requirement to the bottom surface? Okay, हाउ मच इज द हीटिंग रिक्वायरमेंट टू द बॉटम सरफेस। तो बच्चों क्वेश्चन तो बहुत आसान है, कितना रिक्वायरमेंट है, कितना हीट देना पड़ेगा, दैट इज इक्वल टू क्यू नेट बिटवीन 1 and 2। और जितना 1 से 2 पे जाएगा, द हीट विच इट इज रेडिएटिंग, because there is no such conduction, convection bhi nahi hoga, because we are not considering any kind of fluid inside this, only if you will consider the radiation effect. So how much heat we need to supply in steady state? In steady state, if you want to maintain that constant temperature 1500 degrees Celsius, so the heat which you need to supply, that is equal to q net between 1 and 2, and that is nothing but sigma T1 की power 4 minus T2 की power 4। okay, T1 की पावर 4 माइनस T2 की पावर 4। स्मॉल क्यूबिकल ब्लैक मोल्ड surfaces है, so this is also black, this is also black, there is no surface resistance of 1 and 2, surface resistance of 1 and 2 both are 0, there will be only space resistance। so if you will consider this as 1, this as 2, so it will be 1 by f1 to a1, it will be 1 by 2 1 by f1 to a1। okay, तो इसको आप इजीली सोल्व कर सकते हो इफ आई विल प्रोवाइड यू दिस इंफॉर्मेशन, बिकॉज ये आप निकाल नहीं पाओगे। okay, because this is not directly you will not be able to find this, ये आपको मिलेगा टेबल से। okay, so this data I am providing you, ये आपको एक टेबल से मिलेगा। अगर आपके पास दो प्लेट्स है ना, कुछ ऐसे, if you are having two plates they are exchanging heat, suppose ऐसे कुछ है, तो अगर आप टेबल रेफर करोगे, some data sheet if you will refer, so suppose this is y, okay, and this is the distance between them d, this is d, and this is x, okay, this is x। you know guys, in this case, cubical case, x by d equal to y by d both are equal to 1। तो कुछ इस तरह का एक चार्ट आपको मिलता है, यहाँ पे मिलेगा शेप फैक्टर, ओके, f12, this is 1, this is 2, okay, this is shape factor f12 you are going to get। और यहाँ पे आपको अलग अलग से चार्ट मिलेंगे, कुछ ऐसे ऐसे आपको क्या होंगी, कर्व्स होंगी, डिफरेंट डिफरेंट क्या होंगी, कर्व होंगी। एंड हियर यू विल गेट रेशियो ऑफ x by d, और यहाँ पे आपको रेशियो मिलेगा y by d का, x by d and y by d। So you need to reach to a point where x by d is 1, and you need to choose the curve where y by d is also 1। this is y by d equal to 1, this is the curve where y by d equal to 1, and this is the point where x by d equal to 1। तो उस पॉइंट को अगर आप मीट करोगे, उसके कोरस्पोंडिंग इफ यू विल चेक द शेप फैक्टर, you will get this value। otherwise for this cube case directly you can remember, ये जो होता है ना क्यूब केस के लिए, साइड वालों पैरेलल बोलो कोई भी हो, ये 0.2 के आसपास होता है। for the cube guys, कोई भी क्यूब है ना बच्चों, for the cube, any cube, for any cube f12 will be 0.2। any surface you can take, this may be this आप ये और ये भी ले लो, because in this case also the ratio of y by d that will come out 1। you can refer to your data sheet, आप देखो book refer करो, you will find that idea। for this case also, if you are having two plates, one this, okay, and they are having same length, they are having same width, so that ratio is equal to 1। so for that also f12 equal to 0.2, and for these cases also f12 equal to 1 by 2। तो कोई भी क्यूब के लिए any two surfaces you can take, ऊपर वाला लो, नीचे वाला लो, दाएं वाला लो, ये वाला लो। for these two surfaces also f12, this is 1, this is 2, f12 equal to 0.2, close to 0.2, exactly not 0.2, roughly it is close to 0.2। ठीक है बच्चों, so this data I am providing you, okay, ये डेटा मैं आपको दे रहा हूं बच्चों, because without this you will not be able to answer this question। ठीक है, इसके बिना आप इसको आंसर नहीं कर पाएंगे। ठीक है बच्चों, ठीक है बच्चों। सो हाउ मेनी ऑफ यू गोट द आंसर, कितने बच्चों को आंसर आ रहा है, हाउ मेनी ऑफ यू गेटिंग आंसर डी, बिल्कुल सही, डी जिनका आ रहा है ना दे आर राइट। आपका जो आंसर आएगा डी आएगा, इसको चेक करो एंड अगेन कैरी आउट योर कैलकुलेशन, दिस इज द राइट आंसर फॉर दिस क्वेश्चन। ठीक है, साइकत आपने एक जीरो लगाया, 17,000 यू आर आंसरिंग, नोट 17,000, इट विल कम आउट क्लोज टू 1700, ओके, क्लोज टू 1700। एरिया भी लेना पड़ेगा ना बच्चों, अभी हमने ये देखो एरिया भी तो है, ये एरिया, आई थिंक यू आर नॉट टेकिंग दिस एरिया, एरिया तो लोगे ना आप, एरिया कितना हो जाएगा, एरिया इज व्हाट, बिकॉज ही इज आस्किंग यू इन व्हाट्स, तो एरिया हो जाएगा आपका, ये वो साइड है 10 into 10, सो 10 into 10 into 10 की पावर -4 मीटर स्क्वायर, द एरिया इज 10 into 10 into 10 की पावर -4 मीटर स्क्वायर। ओके जेनिश, नो नॉट ए प्रॉब्लम जेनिश। Janish, for that I cannot ensure you because that is not in my hand, Okay, that I cannot ensure you कि this video will remain available up to tomorrow. That I cannot ensure you. Sorry for this, Janish. Okay, चलिए ठीक है बच्चों. तो area also you need to put, then only you will are going to get this answer. Let us move to next question, guys. चलो जल्दी से करते हैं, इसको खत्म करते हैं. An isothermal plate, temperature this with emissivity this exposed to solar radiation 10,000, the radiosity of the plate. Is asking the radiosity. आपसे रेडियोसिटी बोल रहा है बच्चों J. सो J क्या होता है? रो G प्लस E. Isothermal plate at a temperature this 300, emissivity 0.5, normal solar radiations are this. So normal solar radiation means this is G. ये कितना है? G है. So G is giving you 1000. G आपको दे दिया 1000. E पता है आपको emissivity into EV होता है बच्चों. E equal to emissivity into EV, which is nothing but 0.5 into sigma T की power 4. So this is also he is giving you. This also you know. This also you know. And reflectivity is nothing but 1 minus emissivity. This is equal to 1 minus absorptivity for a opaque surface. For any opaque surface, reflectivity equal to 1 minus absorptivity, because absorptivity plus reflectivity, that is equal to 1 for any opaque surface. Okay, and you know in equilibrium using Kirchhoff's law we can say alpha equal to emissivity. So then we can replace this alpha with emissivity. So this relationship you will have J equal to 1 minus emissivity G plus E. Okay, so you need to solve this. 1 minus 0.5 into 1000 plus E, which is emissivity 0.5 into sigma 5.67 into 10 की power minus 8 into T की power 4. The temperature of the body is what? 300 Kelvin. So 300 की power 4. Solving this, you will get the answer for radiosity. Solving this, guys, you will get the answer for radiosity. Please tell me how many of you are getting the answer for radiosity. What is radiosity? Total amount of radiation emitted from a surface, total amount of radiation which are going from a surface, that is known as radiosity. Total amount of radiation falling on a surface, that is known as irradiation. So in this equation, G is the irradiation, J is the radiosity, E is the emissive power, emissive power. Total hemispherical emissive power of a body is E. J is the total radiation leaving from a surface, G are the total radiation falling on a surface. Yes, 729.635 is the right answer. 729.635. So J will come out 729.635 watt per meter square. Bilkul sahi. Those are getting B. They are very right. B is the right answer for this question. Very good. Okay बच्चों, तो इस तरह के क्वेश्चन भी गेट में पूछता है. You need to aware. ठीक है, तो बोल रहा टोटल रेडिएशन इतना है, तो मतलब इतना रेडिएशन फॉल कर रहा है ना बच्चों, इतना फॉल कर रहा है, इट मींस दिस इज जी. ये आइडिया अगर आपको हो गया, देन देयर इज नो सच ट्रबल इन दीस टाइप ऑफ क्वेश्चंस. चलिए लेट अस मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 85 नाउ. There is a spherical aluminum shell of an inside diameter 2 meter is evacuated and used for a radiation test. If the inner surface is coated with carbon black maintained at 600 Kelvin, what is the radiation on small test surface placed in the chamber? So there is a spherical shell, something like this. Okay, there is a spherical shell, something like this. In this spherical shell, some kind of small test body you have placed. Okay, the diameter of this spherical shell is 2 meter. Okay, it is carbon black, so means it is having emissivity 1. And this surface temperature of this body, surface temperature is 600 Kelvin. Okay, so he is asking you what are the irradiation on this. इसके ऊपर कितना irradiation होगा? कितना irradiation होगा? Can you answer this question, guys? How much is the irradiation on this surface? बच्चों जितना ये emit करेगा, वही क्या होगा? irradiation होगा. कितना emit करेगा बच्चों? So G will be energy emitted by that black body. कितना irradiation होगा यहाँ पे? कितना radiation are going to fall on this body? Okay, this is a small kind of chip or surface placed on a kind of large enclosure, which is a kind of black body. So this is equal to G, the radiation falling on a surface is nothing but EB. This is equal to sigma T की power 4. So you can write it here 5.67 into 10 की power minus 8 into the surface temperature, which is 600 की power 4. Okay, watt per meter square only. You are going to get this answer in watt per meter square only. Okay, so ये सारा watt per meter square कर लेना बच्चों. These all answers in watt per meter square, watt per meter square, watt per meter square. Okay, so these answers are in watt per meter square. So which one is you are matching? Gurpreet, we will try to share the PDF of this. Okay, मैं कोशिश करूंगा. I will discuss with the team. I will discuss with Vijender sir. And yes, if we are able to provide, definitely we will email to all those students. We will discuss. ठीक है, चलिए. So this EB will come out 7348.32 watt per meter square. So B क्या हो जाएगा बच्चों? This is the right answer for this question. So some kind of idea you need to have, some basic idea you need to have कि how you need to approach these kind of questions. So आपसे पूछा कितना रेडिएशन फॉल करेगा, कितना फॉल करेगा? जितना इसे एमिट कर रहा है. ओके, तो इसका तो कोई टेम्परेचर नहीं दिया है. सो ओनली द रेडिएशन विच आर एमिटेड फ्रॉम दिस आर दिस. एंड यहाँ पे क्या है? इट्स अ काइंड ऑफ ब्लैक बॉडी. ये कितना आपका? इट्स अ काइंड ऑफ ब्लैक बॉडी. ठीक है, so that is equal to EB, hemispherical emissivity power of this black body. Those are the radiation, irradiation falling on this watt per meter square. But कितना एक्चुअल में फॉल करेगा, कितना एक्चुअल में फॉल करेगा, that कितना अब इसके ऊपर कितना रेडिएशन फॉल करेगा, that will equal to EB into area of this. वो इसके एरिया पे भी डिपेंड करेगा ना, कितना इस पे एक्चुअली फॉल करेगा, दैट विल बी इक्वल टू ईबी इनटू एरिया ऑफ दिस. इसका कितना एरिया है. ओके, बट कितना इरेडिएशन है. लाइक सपोज सोलर से कितना इंटेंसिटी है. व्हाट इज सोलर इंटेंसिटी ऑफ सोलर रेडिएशन? सपोज दैट इज क्लोज टू 1300 watt per meter square. So that is in watt per meter square, but it doesn't mean those are the radiation falling on you. This depends on the area. Like what is the panel area? So the solar radiation, like suppose 1300 watt per meter square multiply by the panel area, that is going to give you the radiations falling on the panel. I think you got the idea. So area से multiply करके आपको मिलेगा. ठीक है, चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं बच्चों 86 पे. एंड दिस इज कंपैरेटिवली सिंपल क्वेश्चन है, बट आपको थोड़ा सा दिमाग लगाना पड़ेगा. क्वेश्चन आसान है. कंसीडर ए क्यूबिकल एनक्लोजर साइड. अभी क्यूबिकल को मैंने ऑलरेडी आपसे डिस्कस कर लिया. मैंने क्यूबिकल के लिए ऑलरेडी आई डिस्कस विद यू व्हाट इज F12. ओके, दिस इज क्यूबिकल सरफेस व्हिच इज हैविंग साइड 1 सेंटीमीटर. क्यूबिकल है जिसका साइड कितना है 1 सेंटीमीटर. ऑल साइड्स आर 1 सेंटीमीटर. क्यूब है तो हर साइड कितना है 1 सेंटीमीटर. द रेडिएटिव स्पेस रेजिस्टेंस बिटवीन पैरेलल फेसेस. ओके, दो पैरेलल फेसेस के बीच में बोल रहा है रेडिएशन कितना है. सपोज दिस इज 1, दिस इज 2, दिस इज 2, दिस इज 3. ओके, सो इज आस्किंग यू रेडिएटिव स्पेस रेजिस्टेंस मींस 1 3. 1 3 क्या है? आपसे 1 by 1 3 by A1. ये स्पेस रेजिस्टेंस है. अगर ये आपके ध्यान नहीं आया then you will not be able to answer this question. This is space resistance. Any parallel two parallel surfaces, कोई भी दो parallel surfaces के बीच में, between any two parallel surfaces you can mention this as 1 इसको 2, कोई भी कुछ भी ले लो. Any two surfaces, parallel surfaces you need to take. So I am taking this parallel surfaces and this parallel surfaces. I am naming this as 1, this as 3. So the space resistance between 1 and 2, space resistance guys, he is not asking you shape factor, he is asking you space resistance. तो कितना हो जाएगा बच्चों space resistance between any two parallel surface कितना हो जाएगा 1 by F13 A1. तो 1 by F13 कितना होता है अभी बताया था मैंने 0.2. एरिया कितना है? एरिया इज 1 into 1. ओके, 1 into 1. आपको इसको सेंटीमीटर में ही रखना है. व्हाई? बिकॉज ही हैज गिवन यू द आंसर इन सेंटीमीटर ओनली. उसने आपको आंसर किसने दिया है? सेंटीमीटर में. सो इफ यू विल सोल्व दिस यू विल गेट 5 per centimeter square. 5 per centimeter square. This is the space resistance between any two parallel surfaces of a cube. Now you can ask me, sir, from where you are writing this 0.2? मैंने अभी बताया था बच्चों क्यूब के लिए if you are having a cube F12 equal to F13, those are approximately equal to 0.2. बिल्कुल मजे से उसको लो, कोई भी दिक्कत नहीं है. Okay, you do not to worry guys. For a cube or between any two surfaces F12 F13 those are approximately equal to 0.2. तो अगर इसको आप पुट करोगे easily you will enjoy this question. ठीक है, चलिए let us move to next question 87. 87 क्वेश्चन इज द प्लेट इन द अबव प्रॉब्लम. इन द अबव प्रॉब्लम में क्या है देखो मैं आपको बता देता हूं. अबव प्रॉब्लम में क्या है, देयर आर टू प्लेट्स. ये दो प्लेट्स हैं. देयर आर टू प्लेट्स समथिंग लाइक दिस. ओके, these are the two plates something like this. This is suppose 1, this is 2. Okay, they are having width w. इनका width कितना है बच्चों? Width is w. Okay, width is w. इनफाइनाइट लॉन्ग प्लेन. तो ये जो लेंथ है, लेंथ इज इनफाइनाइट. ओके, ये जो लेंथ है इज इनफाइनाइट. दिस इज इनफाइनाइट. ओके, लेंथ तो इनफाइनाइट है बट विड्थ कितना है दोनों का? विड्थ इज w. ओके, विड्थ इज w एंड दे आर सेपरेटेड बाय डिस्टेंस. दोनों के बीच में जो डिस्टेंस है, दे आर सेपरेटेड बाय डिस्टेंस व्हिच इज इक्वल टू h इक्वल टू 2w. तो ये इससे पहले वाले क्वेश्चन में था. इफ द प्लेट्स इन द अबव प्रॉब्लम, ये जो अबव प्रॉब्लम में बच्चों मैंने हटा दिया था. ओके, that above problem I have not considered because that is required, because without that you will not be able to solve this. So in the above problem, what he has given you, he has given you two infinitely long plates. What I'm saying guys, in the above problem he has given you two infinitely long parallel plates which are having width w spaced by distance 2w. If the both plates are specular and they are having emissivity, this is having emissivity 0.2, this is having emissivity 0.4. These data are given in the problem 1, earlier data. Okay, earlier problem 1 data. Are you getting this guys? So that data I am providing you so that you will be able to solve this problem. Okay, so in the earlier problem he has mentioned because shape factor के बहुत सारे क्वेश्चन हो गए थे, that's why I skipped that problem. But उसके बिना इसको करना is not easy. Okay, not possible because that data is required. So there are two plates, infinitely long plates, width w separated by distance 2w, emissivity these, and if the temperature T1 का temperature कितना है 1000, so this T1 is 1000 Kelvin, T2 is 2000 Kelvin, then he is asking you the calculate the heat transfer to the cold plate. Okay, फिर आपसे पूछ रहा है Q2. Okay, he is asking you Q2. हालांकि कोल्ड प्लेट लिखा है, सो दिस इज एक्चुअली काइंड ऑफ कंफ्यूजन. तो अभी देखो इसमें इस क्वेश्चन में व्हाट यू नीड टू अंडरस्टैंड, दिस इज आल्सो अ केस ऑफ पैरेलल प्लेट. दो पैरेलल प्लेट है. ओके, दो पैरेलल प्लेट है, विड्थ सेम है उनका, लेंथ सेम है, लेंथ सेम विड्थ सेम, बट दोनों के बीच में डिस्टेंस कितना है? डिस्टेंस इज 2 टाइम्स ऑफ देयर विड्थ. सो अगेन इफ यू विल रेफर टू सम ग्राफ इन रेडिएशन, इजीली यू आर गोइंग टू फाइंड आउट दैट ग्राफ. और उस ग्राफ में अगर आप रेफर करोगे, सो यहाँ पे जो 1 f12 होता है फॉर दिस रेंज, f12 is 0.29. f12 that is equal to f21. Both are same. Why? Because this is also having width w, this is also having length infinite, this is also having width w, length infinite. So f12 equal to f21, that is equal to 0.129. And because they are having same area, दोनों का area भी क्या है? That is same. So this information you are going to get from the graph. तो इस तरह से आपको एक ग्राफ मिलेगा. दो प्लेट हैं, ये कुछ ऐसे प्लेट है which are having length तो इनका infinite है, width कितना है बच्चों? w. The width is w. Okay, this is plate 1, this is another plate something like this. The plates are infinite. Plates क्या है? Infinite है. So this is also having width w and they are separated by distance w equal to distance h equal to 2w. Okay, this distance between the plate is 2w. Okay, तो इसको अगर आप यूज करते हो and if you refer to the data book, so the f12 you will get this 0.29. ठीक है, then you can solve this problem because आपको इसके बीच में नेटवर्क बनाना पड़ेगा बच्चों. आपको इसके बीच में नेटवर्क बनाना पड़ेगा. तो नेटवर्क कैसे बनेगा? You can write it here. Suppose अगर मैं लिखता हूँ Q21, so Q21 equal to sigma T2 की power 4 minus T1 की power 4 divide by surface resistance of body 1 minus epsilon 1 divided by epsilon 1 A1 plus 1 minus epsilon 2 A2. This is surface resistance of 1, this is surface resistance of 2 plus space resistance between 1 and 2, F21 A2. Okay, A2 A1 you can take it common, you can take it outside because all are same. A1 A2 all are same, you can take it outside and then you can find out this in watt per meter square. आप इसको वोट पर मीटर स्क्वायर में निकालो. ओके, यू कैन फाइंड आउट दिस इन वोट पर मीटर स्क्वायर. सो वी आर फाइंडिंग आउट नेट रेडिएशन हीट एक्सचेंज बिटवीन 1 and 2 in watt per meter square. You got the idea guys? This is surface resistance of 1, this is surface resistance of 2, this is space resistance between 2 and 1 because I am writing it here 2 1. 2 is at high temperature, this is at 1 temperature. 1 से 2 लिखोगे you will get this value negative. आपके पास ये वैल्यू क्या आएगी? नेगेटिव आएगी because net radiation will not be from 1 to 2. Net radiation will be from 2 to 1. Okay, so directly I'm writing it as 2 to 1. Okay, you got the idea, guys? Okay, now here all these things are given to you, emissivities are given to you. Okay, F is given to you, temperatures are given to you. Easily you will get this Q2 to 1. ठीक है बच्चों? तो हालांकि इसने कोल्ड प्लेट का बोला है, दैट्स व्हाई यू विल गेट आंसर इन नेगेटिव. ठीक है, तो आंसर नेगेटिव में आएगा एंड ही हैज गिवन दैट नेगेटिव आंसर ओनली. उसने नेगेटिव दिया बिकॉज ही हैज आस्क्ड यू द कैलकुलेट द हीट ट्रांसफर ऑन द कोल्ड प्लेट. ठीक है, बट दैट वे ही इज राइटिंग दिस इज नॉट राइट. कैलकुलेट द हीट ट्रांसफर ऑन द कोल्ड प्लेट. अगर हीट ट्रांसफर ऑन कोल्ड प्लेट अगर सीधा लिखता है तो ये तो हमें सीधा ऐसा लिखना चाहिए, बट बिकॉज द इंफॉर्मेशन विच यू आर गेटिंग फ्रॉम दिस, हाउ मच इज द हीट ट्रांसफर ऑन द कोल्ड प्लेट, दैट इज नथिंग बट सिग्मा into emissivity of the body 2, because this is hot plate is 2 into emissivity of the 2 into sigma into T2 की power 4. okay, this is what, these are the radiations emitted from the 2. okay, multiply by F12. so this is what, this is the Q1 to 2, this is Q which are reaching to 1, Q1 जो 1 पे क्या कर रही है, रीच कर रही है. तो अगर मैं इस डेटा के साथ में जाऊं, if you will go with this data, calculate the heat transfer on the cold plate. cold plate पे कितना हीट ट्रांसफर होगा? सो कोल्ड प्लेट पे कितना हीट ट्रांसफर होगा? कितना हीट ट्रांसफर यहां से आएगा बच्चों? देखो इससे कितना आएगा, यहां से कितना आएगा, सिग्मा इनटू दिस T2 की पावर 4. अगर ये ब्लैक बॉडी होता, बट दिस इज नॉट ए ब्लैक बॉडी, सो यू नीड टू मल्टीप्लाई इट विद इट्स एमिसिविटी. ओके, एमिसिविटी से मल्टीप्लाई करना पड़ेगा, व्हिच इज E2 मल्टीप्लाई बाय व्हाट, फ्रैक्शन, शेप फैक्टर. इससे कितना फ्रैक्शन यहां पे पहुंचेगा, दैट इज F12. सो इसको अगर मैं करूंगा देन यू विल गेट दिस. ओके, बट दोनों ही तरह से आई थिंक द वे ही इज राइटिंग दिस, दैट इज नॉट अप्रोप्रिएट, दैट इज नॉट राइट. ओके, तो मैंने दोनों तरह से इसको ट्राई किया. सो यू कैन ऑल्सो ट्राई एंड यू कैन टेल मी इफ यू आर गेटिंग सम आंसर. ठीक है, सो बट व्हाई एक्चुअली आई कंसिडर दिस प्रॉब्लम, because we are getting some concept, we are getting the concept of how to find out the space resistance between two plates which are separated by some distance, how to draw the radiation network. okay, so I hope as a teacher you can student only you can understand why a teacher is picking these type of questions. okay, chaliye let's move to next question. aap isko karna and if you got the answer you can tell me. any problem if you face, then also you can shoot your query in the comment section. next question है बच्चों, ये टिपिकल गेट लेवल का क्वेश्चन है, थर्मोकपल का क्वेश्चन है एंड ही इज आस्किंग यू द एक्चुअल थर्मोकपल टेम्परेचर. okay, so there is a thermocouple with 0.5 mm diameter. spherical bead is used to measure the local temperature of hot radiative non-participating gas flowing through an isothermal gray diffuse tube. TW equal to 800 Kelvin. emissivity 1, thermocouple is a diffuse emitter and reflector, EB equal to 0.5. for the thermocouple heat transfer coefficient is 30, H value is also given to you. real temperature of the gas is this. generally most of the time he asks you this real temperature. अभी real temperature दिया है, आपसे temperature measured पूछ रहा है. okay, but that is the only difference. most of the time he gives you the temperature measured by the thermocouple and he asks you the real temperature. आपसे error पूछता है, he asks you the error in temperature measurement, he asks you the real temperature, but in this case he is giving you the real temperature and he is asking you the actual temperature. okay bachcho, so there is a relationship, very good relationship we are having. Tg, temperature of the gas, temperature of the thermocouple, this is actual temperature, this is actual temperature of the gas, this is temperature measured by the thermocouple. so actual temperature is what, this is real temperature of the gas which is 1000 Kelvin. this is temperature measured by the thermocouple and the difference of these two, this is known as error in temperature measurement. इसे क्या बोलते हैं बच्चों, इस difference को बोलते हैं error in measurement. error in measurement, guys, Tg is the actual gas temperature, Tc is the temperature measured by the thermocouple and the difference is what, the difference is error in temperature measurement. so there is a direct formula and I hope you all know about this, from where actually I'm writing this. temperature of thermocouple की power 4 minus temperature of duct की power 4 divided by H into emissivity of the thermocouple, okay, into area of the thermocouple. okay, if you remember this formula, if you are remembering this formula then you will easily get the answer. area तो कट जाएगा बच्चों, area तो दोनों तरफ कट जाते हैं, so there will be no this term, area नहीं होगा, this is the only term here. okay, so all these things if you will check here, देखो, emissivity is given to you 0.5. This is emissivity of the thermocouple 0.5. H is also given to you 30 watt per meter square Kelvin. Sigma already you know. Temperature of the thermocouple, this we want to find. Abhi, this is a confusion kind of thing, because how you will solve this? अभी इसको कैसे mathematically solve करोगे? That is a kind of difficulty. Okay, because you will not be able to solve. आपको option put करने पड़ेंगे. That is the only option which you are having. Okay, otherwise without putting options you will not get TC. ठीक है? TC आपके पास बिना ऑप्शन पुट करे नहीं आएगा. Guys, actually this we are writing in a steady state, you know, in steady state. Q convection from the thermocouple, Q convection from thermocouple. Okay, कितना convection हो रहा है? That is equal to Q loss by radiation. Loss from thermocouple by radiation. कितना कन्वेक्शन से आएगा? कन्वेक्शन से कितना हीट आएगा? दैट इज इक्वल टू H इनटू एरिया ऑफ द थर्मोकपल इनटू टेम्परेचर ऑफ गैस माइनस टेम्परेचर ऑफ थर्मोकपल. ओके, H convection heat transfer, Newton's law of cooling, HA Tg minus Tc. This is the Q convection on the thermocouple. This is equal to Q lost by the thermocouple. That is nothing but small body in a large enclosure, which is sigma into temperature of thermocouple की power 4 minus temperature of duct wall. This is duct wall, guys. This is TD, or even write it as T wall. This is duct wall temperature. Duct wall temperature. Because this thermocouple is going to radiate its heat, duct wall temperature, to the duct wall. Okay, so sigma Tc की power 4 minus Td की power 4 into emissivity of the thermocouple into area of the thermocouple. Okay, so this area will cancel out. area तो कट जाएगा आपका. Okay, from that only we are getting this formula. वहीं से अपने पास formula आ रहा है Tg, actual temperature of the gas, temperature of the thermocouple, and the difference is what? The error in temperature measurement. This is equal to sigma. ओके, चलिए बच्चों, थोड़ा सा आपको नेक्स्ट हाफ एन आवर कोऑपरेट करना पड़ेगा, बिकॉज इसमें कुछ सेटिंग मैंने की हुआ है कि ताकि ये जो आपका आई पे जोड़ना पड़े. 9 बजे के बाद ये ऐसा हो जाता है, तो मैं कोशिश करता हूं अगर मैं इसको ठीक कर पाता हूं. ठीक है, बट अदरवाइज आई थिंक दिस इज विजिबल टू यू. डेटा मेरे ख्याल से सब कुछ क्लियर है ना? प्लीज कमेंट, प्लीज टेल मी गाइस, ऑल दिस थिंग्स आर विजिबल. ओके, इफ देयर इज एनी प्रॉब्लम इन विजिबिलिटी देन यू कैन शूट योर क्वेरी. ठीक है, मैं कोशिश भी करता हूं, मैं कहीं से अगर इसका कुछ चेंज कर पाता हूं. ओके, ब्राइटनेस मैं देखता हूं कहां से इसका कुछ चेंज कर पाते हैं. चलिए, मेरे ख्याल से नाइट विजन होगा इसका, और मैं उसको बंद कर देता हूं नाइट विजन को. यस, अभी सही है. ओके, गुड, फाइन. तो यस, चलिए बच्चों, तो नाइट विजन था, मैंने उसको बंद कर दिया. आई थिंक नाउ इट विल बी क्लियर टू ऑल ऑफ यू. No problem, very good. चलिए, so guys, this difference, this is temperature of the gas, this is temperature of the thermocouple. Okay, the difference is this is nothing but error in temperature measurement. This is T into temperature of thermocouple की power 4 minus temperature of duct wall की power 4, emissivity of the thermocouple divided by H, convection heat transfer coefficient. So the H which you are asking me from where it is coming, this is coming out from here. Why actually we are having error in temperature measurement? Why there are error in temperature measurement? That temperature measurement error is there. Why? Because the heat which that thermocouple is taking from the gas, that it is radiating to the duct wall. So there is radiation heat exchange between the thermocouple and the duct wall. That's why there is a temperature difference. Okay, बिल्कुल सही बच्चों. Those are getting option B, they are right. ऑप्शन बी क्या हो जाएगा? 863 केल्विन इज द राइट आंसर. बिल्कुल सही, अभिनव का आंसर सही है. 863 केल्विन इज द राइट आंसर. ठीक है, ऑप्शन बी, दे हैव गिवन दैट ऑप्शन बी एज द राइट आंसर. ठीक है बच्चों, सो प्लीज अदर्स आल्सो यू कैन कैरी आउट योर कैलकुलेशन. सो वी डिस्कस दिस कांसेप्ट आल्सो, थर्मोकपल. चलिए, लेट अस नाउ मूव टू नेक्स्ट क्वेश्चन 89. So sun radiates maximum radiation at this. So this is lambda max. This is lambda max. If the temperature of the surface of the sun is 6000 Kelvin, and the temperature of the earth is 300 Kelvin, the wavelength at which the earth maximum radiates, earth किस पे maximum radiate करेगा? So very simple question, you know, lambda max into T, that is a kind of constant. ये क्या होता है? Constant होता है. So for sun, if sun is emitting at 0.5 micrometer and the sun temperature is 6000, this is equal to lambda max for the earth. This is for the earth multiplied by temperature of the earth. So the lambda max for the earth is nothing but 0.5 into 6000 divided by 300. So this will be 10. Okay, kitna 10 nahi aayega. This will be 20. So it will be, yes, it will be 10 only. 10 micrometer. Okay. So the radiation, you know, low temperature body emits radiations of the higher wavelength. High temperature body like sun, they emit radiations of the shorter wavelength. That is the reason, you know, the radiations which are coming out from the sun, those are easily able to pass through our atmosphere. So the greenhouse gases, majorly CO2, they are not, you know, restricting those short wavelength radiations coming from the sun, but those greenhouse gases like CO2, they are resisting the high wavelength radiations emitted by the earth. The earth is absorbing radiations, and after absorbing, it is again emitting those radiations, but those radiations are not going out of the earth enclosure, earth atmosphere. Why? Because greenhouse gases, they are not allowing that. Why? Because they are transparent for the short wavelength, but they are not transparent for the high wavelength radiation. Like your glass of your window, glass of your car. The car ka glass kya hota hai? The car glass, they glasses of the car, they allows high short wavelength radiations coming up from the sun, but the radiations which are emitted by the interior of your car, those are high wavelength radiation. So the glass does not allow those high wavelength radiation. That's why if you will put if you will just park your car in some kind of open atmosphere under direct sunlight, the temperature inside the car will be even more than the outside temperature. That is the reason of what greenhouse gases. So greenhouse effect is what? That is only the greenhouse effect. Due to greenhouse effect, the earth temperature is day by day, it is continuously increasing. It is increasing at a very slower rate, like 1 degree Celsius in a year. 1 degree Celsius in a kind of century. In a period of 100 years, the temperature of the earth atmosphere is average increased by 1 degree Celsius. But that is also a kind of major concern, because very single 1 degree Celsius change can melt a huge amount of ice. You know, only 1 degree temperature change is sufficient for melting ice from 0 degree Celsius to 1 degree Celsius water. So due to that, greenhouse gases, only due to the accumulation of heat, continuous accumulation of heat inside the earth atmosphere, the earth atmosphere is increasing day by day, and that is causing concerns, because the water level is increasing day by day and the temperature of the earth is also increasing. That is known as greenhouse effect. ओके तो मेरे ख्याल से इस क्वेश्चन को आपने आंसर किया होगा. 89th क्वेश्चन, ऑप्शन ए इज द राइट आंसर फॉर दिस क्वेश्चन. ठीक है, नेक्स्ट मूव करते हैं. 90th क्वेश्चन, 90th भी थोड़े ही क्वेश्चन बचे हैं बच्चों. चलिए, assume an electric flat plate square heater side 10 centimeter provides 100 watt power from each side. If the heater is assumed to be black, its temperature. बहुत आसान क्वेश्चन है. EB कितना हो जाएगा? ब्लैक है, इट इज इक्वल टू सिग्मा टी की पावर 4. 100 वॉट्स प्रोवाइड कर रहा है, बस इसको एरिया से मल्टीप्लाई कर देना. एरिया से मल्टीप्लाई करना पड़ेगा. 100 इक्वल टू 5.67 इंटू 10 की पावर -8. टेम्परेचर तो अपने को निकालना है. एरिया कितना हो जाएगा? स्क्वायर हीटर है, सो 10 सेंटीमीटर साइड, तो 10 इंटू 10 इंटू 10 की पावर -4 मीटर में लेना पड़ेगा. सो टेम्परेचर यू विल गेट. कैन यू टेल मी गाइस व्हाट टेम्परेचर ऑफ द हीटर यू आर गेटिंग? What temperature of the heater you are getting? Okay. Can you answer this question, guys? रिंकू जी, थोड़ा सा पानी देना. Yes, 648, बिल्कुल सही. 648 is the right answer for this question. 648 Kelvin is the right answer. Let's move to next question, guys. Guys, this is the question which actually I am like discussing with you initially. So he is going to provide you some data, something like this. गेट में अगर चेंजेस होते हैं और होने भी चाहिए, these are the kind of data he is going to provide you. तो ये आपको इसने यहां से मिस कर दिया है. This is F0 to 2 micron, 0 to 2 micron. Okay, 0 to 2 micron, F0 to 2 micron is 0.00213. Okay, and F from 0 to 6 micron, this is this. So now, like I discussed these type of concepts. Now, can you answer this question, guys? I discussed in very detail. I discussed these type of questions earlier. तो ब्लैक बॉडी है जिसका सरफेस टेम्परेचर इतना है, आपसे टोटल एमिसिव पावर पूछ रहा है, तो एमिसिव पावर तो इजी है. एमिसिव पावर कितना हो जाएगा? ब्लैक बॉडी है इज इक्वल टू सिग्मा टी की पावर 4, सो 5.67 into 10 की पावर -8 into 600 की पावर 4. दिस इज टोटल एमिसिव पावर. ये तो हो जाएगी टोटल एमिसिव पावर. ओके, although from that only you will be easily able to answer, but अपने को दोनों आंसर चाहिए बच्चों. We want both the answers. अपने को दोनों आंसर चाहिए. पूछ रहा है दूसरे केस में क्या पूछ रहा है? फ्रैक्शन ऑफ द टोटल एमिशन दैट अकर्स बिटवीन दिस वेवलेंथ. अभी उसने फ्रैक्शन पूछ लिया, कितना फ्रैक्शन इन दोनों वेवलेंथ्स के बीच में होगा? कितना फ्रैक्शन इन दोनों के बीच में होगा बच्चों? कैन यू आंसर दिस वेरी इजीली? बिकॉज कितना होगा बच्चों? देखो फ्रैक्शन जो होता है लाइक फ्रॉम 0 to, like suppose this is 0, for example this is 0 to 6 micron, 0 to 6 micron, something like this. 0 to 6 micron, ये जो एरिया है this is 0.4360. okay, from 0 to 2 micron, this is the area 0 to 2 micron. Suppose this 0 to 2 micron, this is 2 micron. okay, and this area 0 to 2 micron, this fraction is 0.00213. is asking you ये वाला फ्रैक्शन कितना है, ये वाला फ्रैक्शन कितना है बच्चों? व्हाट इज दिस फ्रैक्शन? तो मैंने क्या